Hello everyone, welcome to this data science course by Intellipaat. Ronald Coase, a famous economist and a Nobel Prize laureate, has famously quoted that torture the data and it will confess to anything. And you know what? Every company, be it MNC or a startup, believes in this. I mean, just think about this. Every other company is tracking where you are clicking on the website, how much time you are spending on their pages, which product page you are visiting multiple times. And by churning all this data, they are sending recommendations, WhatsApp messages, or even once in a while advertisement that you see on your social media feeds. And how all of this is happening? All of this is happening by churning out vast amounts of user data. Without a doubt, on an absolute note, data science is one of the strong reasons behind why companies are able to make big fat money. That is the reason why the science of dealing with data or making sense out of it has become one of the best career opportunities with lakhs of jobs available on the job boards worldwide. But what exactly do people do with this job? Let's consider that you are working in a company and they want you to understand what their sales will look like in the upcoming 3 months. Now, you do have monthly sales data of around last 10 to 15 years. So the first thing as a data scientist you'll do is you'll understand your data and clean it for further processing. Once cleaned, you'll do multiple processes and extract the pattern within data. Next, you'll feed details like monthly marketing budget for the next few months, sales personnel count, etc., and you land at a prediction that tells you what your business will make within the next few months. This is also called as predictive modeling or analytics. Now, during this entire process, lots of small tasks have to be done. All of them are done using Python programming language and its different libraries. How? That is something we are going to understand and decode within this complete data science course designed for beginners. This course has been taught by India's best data science trainers and is designed to make you job ready. Within this course, you'll not only learn the fundamentals of data science, but you'll also understand how to apply data science algorithms to different problems end to end. So make sure to stay tuned till the end of this particular course. Now, let me take you through the agenda for this particular course. We'll start this course by getting ourselves introduced to data science. Then we'll see the difference between the role of data analyst versus data scientist. This is important because most often people consider skills for data analyst and data scientist equivalent. But once you'll see the process life cycle, you'll realize that's not the reality. Next up, we'll cover important pillars of data science that you must master. That is statistics and probability. After that, we'll cover basics of machine learning and important machine learning algorithms like linear regression and its hands-on implementation, and logistic regression as well as decision tree alongside their Python programming implementation. Next up, we'll cover random forest and the concept of clustering. We will cover k-means and hierarchical clustering completely. Once we are done with these topics, you'll have a solid understanding of most of the data science algorithms and how to approach the problems. After this phase, I would recommend you visit Kaggle and start practicing on multiple datasets. Solve a lot of problems and that will give you an edge over the competition. After that, you can visit this video again and look into the data science interview questions that are required to fulfill your preparation. I hope this is clear. So without wasting any time, let's start with the very first topic.
Data science has been a trending field of study in recent times. This is because of the amount of data that we create constantly and the computing power that is available with advancements in technology. But what is data science? Think about what happens when you book a ride on Uber. You open the Uber app on your phone and tell the app where you want to go. Uber tries to find the nearest cab, sends them the directions to come pick you up, and take you to your destination. That was simple. But in the background, the seemingly simple task is carried out by collecting mountains of data from various sources, like the phones, the map, and historic trends of traffic and demand for rides. With this data, modern-day computers are programmed to calculate the nearest driver to you, the best route to your location and destination, the time it will take, and what you should pay. In other words, this is made possible with data science. Data science has countless other applications as well, and is at the intersection of statistics, data analysis, and machine learning. It is a combination of scientific methods, models, and algorithms working together to extract actionable business insights from data. The U.S. faces a shortage of 140,000 to 190,000 people with deep analytical skills and 1.5 million managers who can analyze big data to make effective decisions. The average salary of a data scientist is around $118,000. So, still interested in data science as a profession? Continue on to learn more about who can become a data scientist, why data scientists matter, what is the data science life cycle, how big data is driving the data science revolution, the career prospects for data science. Data is the oil of our generation. Data science is becoming indispensable in today's digitally driven world, helping businesses understand consumer behavior, fine-tune its messaging, and capture new market share. To become a data scientist, you don't need to have a technical background to be a data scientist. What you do need is in-depth knowledge in mathematics, analytical reasoning, the ability to work with large amounts of data. It would also help to have a strong intellectual quest, knowledge of data engineering, visualization ability, and excellent business acumen. If you do come from a non-technical background, you will likely use R. If you are from a technical background, then you could use Python and R. It is all about understanding the possibilities and asking the right questions, all in the search for the best answers. Every company is flooded with data, and they have more data than they know what to do with. So, regardless of the industry vertical, data science is likely to play a key role in your organization's future success. Data scientists help find new ways of reducing costs, entering new markets and customer demographics, and launching new products or services. Data science also has found social and medical applications, such as child welfare and predictive diagnosis as well. So, what does the typical data science lifecycle look like? The data discovery step includes the search for different sources of relevant data, structured or unstructured data. Then, you make a decision to include specific data sets into your analysis. The data preparation includes converting data from different sources into a common format. You will standardize the data, look for anomalies, and make it more appropriate to work with. The data science models are built using statistics, logistic and linear regression, differential and integral calculus, among other mathematical techniques. You could use tools like R, Python, SAS, SQL, Tableau, and so on. Getting things in action phase includes checking the data models for its effectiveness and ability to deliver the results. You will have to verify the model works. If not, you have to rework on your model. A data scientist needs to liaison with the various teams and be able to seamlessly communicate his findings to key stakeholders and decision makers in the organization. Another critical element of data science are algorithms, which are a process of set of rules to solve a certain problem. Some of the important data science algorithms include regression, classification and clustering techniques, decision trees and random forests, machine learning techniques like supervised, unsupervised, and reinforcement learning. In addition to these, there are many algorithms that organizations develop to serve their unique needs. Big data is driven by the data science revolution. Big data is the engine propelling the rise of data science. Hadoop is a popular big data framework used by most organizations. Hadoop works in a distributed manner wherein both the processing and storing of data is distributed on commodity hardware. Hadoop is easily scalable, highly economical, fault-tolerant, and secure. Hadoop consists of Hadoop Distributed File System, or HDFS, for storing data and uses MapReduce for processing data. Another emerging framework is Apache Spark, which is touted to be up to 100 times faster than MapReduce. Spark stores the data in the RAM, so iterative processing is fast and efficient. It also deploys Direct Acyclic Graph, or DAG, for processing of data. There is a huge demand and supply mismatch when it comes to data scientists. Due to this, salaries of data scientists are among the best in the industry. Top companies like Amazon, Google, Facebook, Microsoft in the tech space To others like ExxonMobil, Visa, Boeing, General Electric, and Bank of America are actively hiring data scientists. Now that you have learned about data science, why data science is indispensable, the data science life cycle, how it relates to big data, it is time you start your journey in this promising domain and see your career soar.
Starting with why do we need to handle data? So we'll understand the need of handling data with the help of an example, a real life example of Google Maps. So you all must have used Google Maps in your day-to-day lives for traveling from one place to another, for knowing the destination, for knowing the route for the destination, the distance, the time that you would require to reach the destination. Also, this Google Maps shows us the transportation system. It gives us the fare for different transports, different modes of transports. So it is a wonderful application of data science and machine learning that helps us in our day-to-day lives. So how do this application predicts so accurately? So this is all with the help of real-time data. So you can understand that how important data is. So if you have an Android phone or an iPhone with Google Maps open and services enabled on it, then your phone or the application sends real-time data back to Google. Then Google uses this information or data to calculate how many cars or vehicles are there on the road and how fast they are moving. So as more number of people start using this app, the traffic becomes more accurate. Google also collects the data of traffic from various applications that monitors the traffic reports from the local Department of Transportation. Then it also keeps a history of traffic patterns on a specific road so that it can predict the traffic at a specific time and on a specific location. So this application majorly uses data, rely on data to show us the best results it can. So Google Maps suggests a faster route to reach our destination on time if the traffic is more. So it uses real-time location. If you are feeling like Google is monitoring and tracking your every move, then you can opt out anytime by turning off the location services. But what if everyone did that? Well, Google would be in trouble then, as the data and the result might not be accurate. And this is the reason why at some places where Google Maps is not so accurate. So the world all it revolves around data, which helps us to get the experience of such wonderful applications. Now, who is a data analyst? So going on to the definition of data analysis. So data analysis is a process of inspecting, cleansing, transforming and modeling data with the goal of discovering useful information from it, informing conclusions and supporting decision making. So basically data analysts collect, process and perform statistical analysis of the data, and their skills may not be as advanced as data scientists, but their goals are same: to discover how data can be used to answer the questions and solve problems. So a data analyst job is to take the data and use it to help companies make better business decisions. And this could mean figuring how to price a new material for the market, how to reduce transportation cost, solve issues that cost the company. So a data analyst basically looks at some data and try to make sense out of it. So for example, if sales are going down, so what do? You check through the dashboards or query data from your database using SQL and find out which category suffered the most. Then going deeper and find out other factors is the task of a data analyst. They perform analytics on the data to know what is going wrong and then talks to the product manager with the evidence to how to fix that problem. So this is majorly the task of a data analyst.
Okay guys, a quick info. Intellipaat provides an end-to-end training on data science with R and Python, and if you're looking for it, you can check out the details in the description. Now let's continue with this session.
Now we'll look at the roles and responsibilities, starting with designing and maintaining the data systems. So they collaborate with the data engineers to design the architecture that efficiently helps them to fetch the data and the information from the database. then mining data from primary and secondary resources for the organization, and they extract relevant information or relevant data for the organization. Then using statistical tools to interpret data sets, they perform statistical analysis on the data to analyze the data. Then analyzing and visualizing the data are the majorly one of the important tasks of a data analyst. Then finding trends and patterns in the data to know the insights of the data. Then preparing reports that effectively shows the trends, patterns and predictions using the data. Then implementing business analytics to understand and optimize the business by making effective strategies. Then collaborating with programmers, maybe they can be machine learning engineers, data engineers, or data scientists or software developers to make them understand the business requirements. Then recommend system modifications and improvements by analyzing all the conditions and situations of the business. Then develop policies for data governance. Now moving on to the next part, we'll look at who is a data scientist. So going on to the definition, a data scientist is a professional who extensively works with large data sets in order to derive valuable business insights from it. So data science is basically an interdisciplinary field that uses scientific methods, processes, algorithms and systems to extract knowledge and insight from many structural and unstructured data. So the field of data science is majorly related to data mining, machine learning, deep learning, big data and artificial intelligence. So talking about data scientists, so data scientists are big data wranglers and gathering whose task is to gather and analyze large sets of data that can be structured or unstructured. So data scientist role combines computer science, statistics and mathematics majorly. So they analyze and process the model, they model the data, then interpret the results to create actionable plans for companies and other organizations. And also data scientists are analytical experts who utilize their skills in both technology and social science to find trends and manage data. They use industry knowledge, contextual understanding, skepticism of existing assumptions to uncover solutions to business challenges. And a data scientist work typically involves making sense of messy and unstructured data from various sources such as smart devices, social media feeds, and emails that don't neatly fit into a database. So data scientists are the game changers. So all the applications, all the interesting applications such as Google Maps or recommendation systems of various websites that you can see, these all are applications of data science and these are created by data scientists. So now we'll look at the roles and responsibilities of data scientists. So starting with collecting large amounts of data and analyzing it, then using data driven techniques for solving business problems, then communicating the results to business and IT leaders, spotting the trends, patterns and relationships within the data, then converting the data into compelling visualizations so that they can understand the trends and behavior of the business, where it is going, then deals with the clients for gathering requirements for their business, designing algorithms for machine learning models. So they collect the data from various sources or maybe from data analyst and look into the data in the context of creating a machine learning or automated model using various machine learning algorithms. Then they are also involved in deploying machine learning models with the help of machine learning engineers, and they are involved in the task of iteratively improving the model by providing them the quality data that the model needs to learn, and working with artificial intelligence and machine learning techniques are the basic and very important role of a data scientist.
Okay guys, a quick info. Intellipaat provides an end-to-end training on data science with R and Python, and if you're looking for it, you can check out the details in the description. Now let's continue with this session.
Now we'll understand the difference between a data analyst and a data scientist. So starting with data analyst, so we already know data analysts collect data from various sources or they can be primary or they can be secondary sources. They pre-process the data, they clean the data, manipulate and also visualize the data. They performs big data analytics on the data. They create reports. Then a data scientist collects the analyzed data and looks it with an angle of creating such a process that helps in building automated models, that helps in the prediction for the business. And also the task of a data scientist is to analyze and visualize the data and decide about which algorithm should be used. So this is the major difference between a data analyst and a data scientist. Now moving on to the next part, that is we will look into the skill set of data scientist and data analyst. So starting with data scientist, so a data scientist should have knowledge of SQL, that is the structured query language used for databases, then Tableau or Power BI, that is used for data visualizations. So they must have knowledge of these two tools, and Microsoft Excel. Then going to the programming languages, they should have a comprehensive knowledge of Python as well as R. So there are various libraries in Python and R both, various libraries and packages that are specifically used in data science, machine learning and artificial intelligence to analyze and visualize the data, to create machine learning models, create automated models. So they should have knowledge of both these languages. Then mathematics, a data scientist must have a thorough knowledge of mathematics, especially statistics and probability, linear algebra, calculus, differential equations, because these are used for creating machine learning models. Then data pre-processing, manipulation and visualization, these are the basic tasks of a data scientist. So they should be thorough with data pre-processing, manipulation and visualization tasks. Then machine learning algorithms, so they should be an expert and in implementing various machine learning algorithms on the data sets, so that they can create models, predictive models out of that. Then they should have knowledge of artificial intelligence, which includes neural networks and deep learning. The knowledge of neural networks and deep learning is very important for a data scientist to know. Then obviously software engineering, they should have a knowledge of software engineering as to build work on various softwares, creating softwares. Then finally they should be a good problem solver. Now moving on to the next part, that is skills of a data analyst. So they also should have knowledge of SQL, that is structured query language, then Tableau, that is used for data visualization, then Microsoft Excel. Then programming languages, they should have knowledge of Python or R, that is used by data analysts to perform various analytics techniques. Then statistical knowledge is must for a data analyst, as statistics is used for analyzing the data and applying statistical techniques to understand the insights of the data. Then a data analyst should also be a good problem solver to analyze the business problems, to solve the business problems and make effective strategies for increasing the revenue generation of a business. Then ability to analyze, model and interpret the data. Then they should also have basic knowledge of data science, then machine learning algorithms, so that they can collaborate with data scientists and ML engineers for building predictive models. Then comes creating dashboards and reports for the organization, so that everyone can understand about the trends and patterns of the business data, to know the insights of the data and to understand in which direction the business is actually going. Now we will see the job scope and salary of data analyst and a data scientist. So starting with data analyst, according to Forbes, in India there are 5,000 plus jobs available for a data analyst in 2020. And talking about United States, the number of jobs are more than 12,000. So you can see there are a plethora of career opportunities in the field of data analytics. Talking about average salary, so in India the average salary of a data analyst is 7,50,000 per annum, and in the United States it is $1,15,500. Then moving on to the data scientist, talking about number of jobs. According to Forbes, in India there are 10,000 plus jobs available for a data scientist in 2020, and in the United States the number of jobs are more than 25,000. So there is a wide scope of opportunity in data science field also. So people who are willing to become a data scientist, so there are a plethora of opportunities that you can grab. So talking about average salary, a data scientist earn an average salary of 9,35,000 in India, and in the United States it is $1,32,000. In this video, we understood why we need to handle data, what is the importance of data with the help of the example of Google Maps. Then we looked into the roles and responsibilities of data analyst and data scientist. Then what are the skill set that makes a data scientist and data analyst. After that, we understood the difference between a data scientist and data analyst. And finally, we looked into the job scope and salary of both these profiles. So this is all you need to know about the difference between a data analyst and a data scientist.
Guys, I have a special announcement for all of you. For all of you dedicated individuals who are looking forward to master data science, we are offering a straightforward 20% discount on our data science course, which is in collaboration with iHub IIT Roorkee. So do make sure to check the link given in the description and fill the inquiry form. Shortly, our team of course advisors will get in touch with you to activate the offer. Don't miss this chance and take your career to the next level. Click on the link given in the description right now.
So the first question that arises in our mind is, what is the need for statistics? So let me make it absolutely clear that statistics is one of the key fundamental skills required for data science. Now, when you try to get into the depth of data science and decide to implement any kind of algorithm, then primary knowledge in statistics is quite important. Actually, statistics and probability are considered as a base knowledge, and they're very essential for building any machine learning algorithm. So let's look at some of the most commonly used statistical terminology in data science. So let's begin with our understanding about population and sample. Now, our population includes all the elements from a set of data. So the whole data set where we have all data of our interest is defined as population. And the sample consists of one or more observations drawn from the population. So we can also say that the population is the collection of all items of interest to our study and is usually denoted with an uppercase N. And the numbers we've obtained when using the population are called as parameters. And a sample is a subset of the population and is denoted with a lowercase n. And the numbers we've obtained when working with the sample are called as statistics. Now let's say we want to conduct a survey of the marks of 100 students. Then 100 students will represent our entire population. So from here, if we take some data, then that data will be a sample. So how do we extract this data from the entire population? Now we cannot just randomly pick it, right? So in a simplified way, we can say that this sample is like an understandable form of the whole population dataset. There are different kind of sampling techniques which we can use to extract the sample data. And we can say that our whole population can be inferred in the sample and we can derive a solution out of it. Now we'll understand what is census and what is survey. So census is something where we gather data from the whole population of interest. So for example, elections or any 15-year census can be considered as a census data. And survey is the gathering of data from the sample in order to make conclusions about the population. So for example, a survey can be opinion polls or quality control checks in manufacturing units. So these two are very general terms which we can mostly hear or see in the newspapers. Now we have already discussed parameter and statistic while discussing population and sample. Now we'll look at them in detail. So a parameter is a descriptive measure of the population. So here any kind of analysis related to population is called as parameter. And some common examples of parameters are population mean, population variance and population standard deviation. So anything related to population data is defined as a parameter. And a descriptive measure of the sample is known as statistic. And the sample data can be sample mean, sample variance and sample standard deviation. So anything related to sample data is defined as statistic. So how are these terminologies actually notated? So here the population parameter is denoted as mu for mean, sigma square for variance, and sigma for standard deviation. And the sample statistic is denoted as x bar for mean, s square for variance, and s for standard deviation. So these are the standard ways to represent this terminology. Now we'll understand what is sampling. So data sampling is a statistical analysis technique used to select, manipulate, and analyze a representative subset of data points in order to identify patterns and trends in the larger data set being examined. So sampling basically allows data scientists, predictive modelers, and other data analysts to work with a small, manageable amount of data in order to build and run analytical models more quickly, while still producing accurate findings. So sampling can be particularly useful with data sets that are too large to efficiently analyze in full. So now we'll be moving to an important topic, which is sampling techniques. So as we know, sampling helps a lot in research. It is one of the most important factors which determines the accuracy of your survey result. So if anything goes wrong with your sample, then it will be directly reflected in the final result. And there are a lot of techniques which help us to gather sample data depending upon the need and situation. So to start with, let's have a look on some basic techniques. So what is random sampling? So it is a sampling technique where every item in the population has an even chance and likelihood of being selected in the sample. And here the selection of items completely depends on chance or by probability, and therefore this sampling technique is also sometimes known as method of chances. Here we can take an example of sampling a marble from a vase. We record one or more of its properties, perhaps its color, number or weight, and put it back into the vase. We repeat this procedure n times for drawing a sample of size n, and the idea is illustrated by this figure on the screen. Now when sampling the first marble, each marble has the same chance of 0.1 for being sampled. When sampling the second marble, each marble still has a 0.1 chance of being sampled. This generalizes to all subsequent marbles being sampled. So each time we sample a unit, all units have similar chances of being sampled. This is precisely what we meant with our definition of simple random sampling. So I hope all of you are clear with this. Alright, now if you look over here, it may surprise you that marble 5 occurs twice in our sample. This may happen because we need to replace each marble we sampled. So this technique is known as simple random sampling without replacement. Now let's see how that works. Right, so for the first marble we sample, each marble has a 0.1 chance of being sampled. So far so good, right? So if you don't replace it before sampling a second unit, the first unit we sampled has a 0 chance of being sampled. The other 9 units each have a chance of 1 in 9, which is equal to 0.11 of being sampled as a second unit. So this is how simple random sampling without replacement violates a definition of simple random sampling. And note that this violation gets worse as we sample more units from a smaller population. The next technique is stratified sampling. So with stratified sampling, the researcher divides the population into separate groups called strata. Then a probability sample is drawn from each group. So let's consider a situation where a research team is seeking opinions about religion amongst various age groups. So instead of collecting feedback from 320 million US citizens, random samples of around 10,000 can be selected for research. So these 10,000 citizens can be divided into strata according to the age. That is groups of 18 to 29, 30 to 39, 40 to 49 and so on. And here each stratum will have distinct members and number of members will also be distinct. So next we have cluster sampling. Now cluster sampling is a sampling technique that divides the main population into various sections or clusters. In the sampling technique, analysis is carried out on a sample which consists of multiple sample parameters such as demographics, habits, background or any other population attribute which may focus on conducted research. It is usually used when groups that are similar yet internally diverse form a statistical population. Instead of selecting the entire population of data, cluster sampling allows the researchers to collect data by dividing the data into small, more effective groups. Now let's consider a scenario where an organization is looking to survey the performance of smartphones across USA. Now they can divide the entire country's population into cities, that is clusters, and further select cities with the highest population and also filter those using mobile devices. Now this multi-stage sampling is known as cluster sampling. So next we'll look at categories of statistics. So as we have already discussed, statistics is concerned with developing and studying different methods for collecting, analyzing and presenting the empirical data. The field of statistics is composed of two broad categories. So the first category is descriptive statistics and the second category is inferential statistics. And both of them give us different insights about the data. One alone doesn't help us much to understand the complete picture of our data, but using both of them together gives us a powerful tool for description and prediction. So let's get the basic idea of what they are. So what is descriptive statistics? Now, descriptive statistics is the analysis of data that helps to describe, show or summarize data in a meaningful way. And data can be summarized and represented in an accurate way using charts, tables and graphs. It does not allow us to make conclusions beyond the data which you have analyzed or reached conclusions. And with descriptive statistics, will not receive any uncertainty because we are describing only the people or the items that we actually want to measure. So here we are not inferring the properties of a larger population. Now descriptive statistics is actually very important because if we have not presented our data in this way, then it would be very hard to visualize the data. So descriptive statistics help us to present the data in a more meaningful way by which it allows us to make simple interpretations of the data. For example, if we have marks of 1000 students and we may be interested in the overall performance of those students and the distribution as well as the spread of the marks. Now descriptive statistics provides us the tools to define our data in a most understandable and appropriate way. So in a nutshell, descriptive statistics just describes and summarizes data but does not allow us to draw conclusions about the whole population from which we took the sample. And inferential statistics is about using data from sample and then making inferences about the larger population from which the sample is drawn. Now the goal of inferential statistics is to draw conclusions from a sample and generalize them to the whole population. So it is very important that our sample accurately reflects the population. The reason why sampling techniques are very important is the sample data set reflects the whole population and then only we do any kind of inferential statistics. Like the mean of sample could be similar to the mean of the whole population, and in case if our sample is not correct or not actually reflecting the whole population, then if we do any kind of inference, that would be wrong because our sample is not reflecting the whole population. For example, suppose we are interested in the exam marks of all the students in UK, but it is not feasible to measure the exam marks of all the students. So now we'll measure the marks of a smaller sample of students. So let's say that can be 1000 students. Now this 1000 student sample will now represent the large population of UK students. And we would consider this sample for our statistical study for studying the population from which it's inferred. And this is the reason that our sample should accurately represent the whole population. And sometimes inferential statistics is also called as inductive statistics. So in a nutshell, inferential statistics makes inferences about populations using data drawn from the population. And instead of using the entire population to gather the data, the statistician will collect a sample and make inferences about the entire population using the sample.
In this module, we'll discuss different kinds of data, that is categorical, numerical and ordinal data. Then we'll learn how to describe data through statistics. Later we'll discuss in detail about central tendencies, and at last we'll focus on variability and spread. So let's get started. When working with statistics, it's important to recognize the different types of data. So the first one is numerical data and the second one is categorical data. For example, if you ask 5 of your friends how many pets they own, they might give you the following data: 0, 2, 1, 4 and 18. Now you need to keep in mind that not all data is numerical. Let's say you also record the gender of each of your friends and you get the following data: male, male, female, male and female. So most of the data falls into one of these two groups, numerical or categorical. So what is numerical data? So numerical data mostly has measurements such as a person's height, weight, IQ or blood pressure, or their account such as the number of stock shares a person owns or how many teeth a dog has. And sometimes this numerical data is also known as quantitative data. Now, this numerical data can be further broken into two types, discrete and continuous. So, discrete data represents all of those items that can be counted, or in other words, they take on possible values that can be listed out. So, the list of possible values may be fixed, also called finite, or it may go from 0 to infinity, making it countably infinite. For example, the number of heads in 100 coin flips takes on values from 0 through 100, and this is nothing but a finite case. On the other hand, the number of flips needed to get 100 heads takes on values from 100, and it goes up to infinity if you never get to that 100th head. So its possible values are listed as 100, 101, 102, and it goes up to infinity, making it a case of countably infinite. And while continuous data represent measurements, their possible values cannot be counted and can only be described using intervals on the real number line. For example, the exact amount of gas purchased at the pump for cars with 20-gallon tanks would be continuous data from 0 gallons to 20 gallons. Now you might pump 8.4 gallons or 8.41 or 8.414863 gallons or any other possible number from 0 to 20. So in this way, continuous data can be thought of as being uncountably infinite. So another type of data is categorical data. So it represents characteristics such as a person's gender, marital status, hometown, or the types of movies they like. And categorical data can also take on numerical values such as 1 indicating male and 2 indicating female. But those numbers don't have any mathematical meaning, like you can't add them together. And this categorical data is also known as qualitative data. Now, categorical data can be further broken into two types, ordinal and nominal. So, ordinal data mixes numerical and categorical data. Now, this data falls into categories, but the numbers placed on the categories have meaning. For example, rating a restaurant on a scale from 1 as lowest to 5 as highest stars gives ordinal data, and this ordinal data is often treated as categorical data. However, unlike categorical data, the numbers do have mathematical meaning. For example, if you survey 100 people and ask them to rate a restaurant on a scale from 1 to 5, taking the average of the 100 responses will have meaning. But this would not be the case with categorical data. And on the other hand, nominal scales are used for labeling variables without any quantitative value. So nominal scales could simply be labels. So here are some examples on the screen. So notice that all of these scales are mutually exclusive and none of them have any numerical significance. So a good way to remember all of this is that nominal sounds a lot like name and nominal scales are kind of like names or labels. So next we'll understand how can we describe data through statistics. So collecting data can be easy and fun, but sometimes it can be hard to tell other people about what you found, and that is why we use statistics. And there are two kinds of statistics frequently used to describe data. So they are measures of central tendency and measures of spread. So these are often called descriptive statistics because they can help you to describe your data. So measures of central tendencies are ways of describing the central position for a group of data. Or in other words, it is a summary statistic that represents the center point or typical value of a dataset. And these measures indicate where most values in a distribution fall and are also referred to as the central location of a distribution. Now you can think of it as the tendency of data to cluster around a middle value. So in statistics, the three most common measures of central tendency are the mean, median, and mode. And each of these measures calculate the location of the central point using a different method. So they basically help summarize a bunch of scores with a single number. And measures of spread, sometimes also called as measures of dispersion, are basically ways of summarizing a group of data by describing how spread out the scores are. Suppose a mean score of 100 students is 65 out of 100. However, not all the students would have scored 65 marks. So the score will be spread out and some will be higher and other might be lower. And to describe and measure spread, we have number of statistics like range, quartile, variance, and standard deviation. And these help us to know the spread of scores within a bunch of scores. So let's discuss about the measures of central tendencies in detail. So the mean is the most popular and well-known measure of central tendency. Now it can be used with both discrete and continuous data. So the mean is equal to the sum of all the values in the data set divided by the number of values in the data set. So let's say to calculate the mean of the set of numbers 1, 2, 3, 4, 5, first we need to add up the numbers and then divide by 5, which will give us a mean of 3. So in statistics, the mean is denoted as x bar for a set of numbers x1, x2, x3 till xi, and the mean or average is the sum of all x divided by I. So another type of mean is trimmed mean, which is a variation of the original mean. Now, many a times it is noticed by statisticians that the mean is influenced by extreme values. So consider this example of the marks of 5 students with the value 67, 15, 75, 72 and 85. Now the mean of this population is distorted by the influence of one very small value. So we calculate a trimmed mean by dropping the highest and lowest values, which will be equivalent to dropping the lowest and highest 20% of values. So the trimmed mean is calculated as 67 plus 75 plus 72 by 3, which is equal to 71.3. So the value of 71.3 is much closer to the typical values in the distribution than 62.8. And of course, we seldom would be working with a population with only 5 values. But the same principle applies to large populations as well. So another variation of mean is a weighted mean, which we can calculate by multiplying each data value xi by a weight wi and dividing their sum by the sum of the weights. So the formula for a weighted mean is here on the screen. So here are two main reasons for using a weighted mean. Some values are intrinsically more variable than others, and highly variable observations are given a lower weight. For example, if you are taking the average from multiple sensors and one of the sensors is less accurate, then we might lower the weight of the data from that sensor. And in such kind of scenarios, we can put different weights as per the business needs. So in this case, we are manually giving the weights based on our business knowledge, and then we go ahead and calculate the mean. And in the second scenario, the data collected does not equally represent the different groups that we're interested in measuring. For example, let's say there was an experiment conducted and the data obtained could not reflect all the groups in the user base. So to correct that, we can give higher weight to the values from the groups that were underrepresented. And in such cases, weighted mean would give more meaningful sense to the data than in comparison to trimmed mean or normal mean. So that's all about mean, guys. So now we'll go ahead and implement mean in R. So this is our studio, guys. So now to implement mean, all we have to do is use the mean function. And I'd like to get the mean value of the monthly charges column over here. So I'd want to find out the mean of monthly charges. So all I have to do is use the name of the data set. I'll use a dollar symbol and I'll select the column which is monthly charges and I'll get the mean of it. So the mean of this monthly charges is $64. Okay. Now we'll look at median. So the median of a data set is the middle value on the sorted list of data. And in order to calculate the mean, first we have to order our data in ascending or descending order. So the median of the data set is the number at position n plus 1 divided by 2 in the ordered list, where n is the number of observations. So if n equals 7, the middle value is the 7 plus 1 by 2 position value, that is, the fourth value is a median. Now it's actually very simple when we have odd number of observations, but if there's even number of values, the median is the average of two middle values. So this is formally defined as the average of the n by 2th and n by 2 plus 1th value. So if there are 6 values, the median is the average of 6 by 2th and 6 by 2 plus 1th value, or the third and fourth values. Now let's understand the difference between mean and median. So let's say you run a customer satisfaction survey with a sample of 9 members and rate their overall satisfaction score on a scale of 1 to 10. And you get an average of 5.22. And you know that in general, you tend to retain customers with a score over 3. So you're satisfied because this indicates that you're still above where you want to be. But then suddenly you lose 6 of those 9 customers. So now You go back to look at your data and you find these scores. So the median of this group is 3, indicating that at least half of the customers were unhappy. So the scores became lopsided because of the unexpected tens, and this made us miss out on an important part of our data. So in this case, the average can be slightly influenced by few values, making it a bad representative of the majority of the values in the dataset. So under these circumstances, median gives us a better representation of the central tendency than mean. So if you have more outliers in a data set, then it is better to use median than mean because mean will give poor central tendency. Now let's implement median in R, right? So to implement median, we have the median function. So again, I'd like to get the median value of this monthly charges column. Again, I'll take the dataset customer churn, I'll give the dollar symbol, I'll give the name of the column which is monthly charges. So the median value of monthly charges is $70. Now we'll look at mode. So mode is the most frequently occurring data point. Now, if you consider all of the data we have, then it's not necessary for mean and median to be in the dataset. But the mode definitely has to be in it as it is the highest occurring data point in a dataset. So next we'll look at variability and spread. So here on the screen we have scorecard of 3 players in a game. So they have played 10 games and these are the frequencies of each player in each game. So in one game, player 1 scored 7, in another he scored 8, and in 2 games he scored 9. Similarly for player 2, in one game he scored 7, and in 2 games he scored 9, and in another 4 games he scored 10. And likewise player 3, in 2 games he scored 3, in one game he scored 6, and he scored 7 in 2 games. So here the mean, median and mode for all the 3 players is 10. So on the basis of this, can we say that the performance of all the 3 players is same? Actually no, because in such a scenario the mean, median, mode are not accurate and we have to use different techniques to understand the variability and spread of data. So one method to calculate variability and spread is range. So range is simply defined as difference between the maximum and minimum observations. So in our example, the range for player 1 can be calculated as 13 minus 7. And for player 2 also, it will be 13 minus 7. And for player 3, it will be 30 minus 3. So range is a difference between the largest and the smallest values in the data. Now we'll implement range in R. So now to implement range, R gives the range function. So range, again I'll give the data set. I'll select the monthly charges column. So this is the range guys. So this is the minimum value and this is the highest value. Okay. Then we have quartiles. So quartiles tells about the spread of a data set by breaking the data into quarters. So here we have the lower quartile Q1, which is the point between the lowest 25% of values and the highest 75% of values. And it is also called the 25th percentile. And the second quartile, that is Q2, is the middle of the data set. It is also called the 50th percentile or the median. Then the upper quartile, that is Q3, is the point between the lowest 75% and the highest 25% of values. And it is also called the 75th percentile. And the interquartile range is the difference between Q3 and Q1. That is the upper quartile minus lower quartile, and it describes the middle 50% of values when ordered from lowest to highest. This interquartile range is often seen as a better measure of spread than the range as it is not affected by outliers. So if you remember, there is one specific type of graph that is very useful when it comes to describing center, variability and detecting outliers. That graph is a box plot. Now the box plot shows you at a glance Q1, Q2, Q3 along with the outliers. So if we go back to our example, here the third player has scored 30 in one game, which is good, but it is actually an outlier. So if you make a box plot, we can easily point out such outliers. So to get a hang of Q1, Q2, Q3 and outliers, the box plot is the best. So the box plot itself stands for the central 50% of the distribution. That is, the length of the box represents the interquartile range. And the horizontal line inside the box is the median, or in other words, Q2. Now let's implement interquartile range in R. So R provides the IQR function. Let's use it to find out the interquartile range. Again, I want to find out the IQR for monthly charges. So it'll be customer churn dollar monthly charges. So guys, this is the interquartile range for the monthly charges column. Next, we have variance and standard deviation. So variance is something which will tell us how far away is each value in the data from the mean. So first, we subtract the mean from each value in the data, and this gives us a measure of the distance of each value from the mean. So basically, calculating variance involves squaring deviations. So it does not have the same unit of measurement as the original observations. For example, lengths measured in meters have variance measured in meters squared. And taking the square root of the variance gives us the units used in the original scale. And that is actually the standard deviation. So the standard deviation is actually the square root of variance. So here is the formula for variance. So x is the data point and x bar is the sample, and we are calculating how far is the data point from the mean. And standard deviation is just the square root of the variance. So standard deviation is the measure of spread most commonly used when mean is used to calculate central tendency. Thus, it measures the spread around the mean. And because of its close links with the mean, standard deviation can be greatly affected if the mean gives a poor measure of central tendency. So standard deviation is influenced a lot by outliers. So just one value could contribute largely to the results of the standard deviation, and this makes standard deviation a very useful measure of spread for symmetrical distributions with no outliers. And standard deviation is also useful when comparing the spread of two separate data sets that have approximately the same mean. So the data set with the smallest standard deviation has a narrower spread of measurements around the mean and therefore usually has comparatively fewer high or low values. So an item selected at random from a data set whose standard deviation is low has a better chance of being close to the mean than an item from a data set whose standard deviation is higher. And generally, the more widely spread the values are, the larger the standard deviation is. For example, imagine that we must separate two different sets of exam results from a class of 30 students. So the first exam has marks ranging from 31% to 98%, and the other ranges from 82% to 93%. So given these ranges, the standard deviation would be larger for the results of the first exam because the spread is more from 31% to 98%. Whereas in other, standard deviation will be less as it ranges from 82% to 93% and the data is not widely spread. So now we'll implement variance and standard deviation in R. So R provides VAR and SD functions to get the variance and standard deviation. So again, I do want to find out the variance with respect to the monthly charges column. So I'll type customer churn dollar monthly charges. So this is the variance, guys, 905. Now I'll also calculate the standard deviation. So I need to put SD over here. So I'll select the monthly charges column again. Right, so this is the standard deviation, guys. And these are some properties of standard deviation. So standard deviation is only used to measure spread or dispersion around the mean of a data set. And it is never negative. And standard deviation is sensitive to outliers. So single outlier can raise the standard deviation and in turn distort the picture of spread. And for data with approximately the same mean, the greater the spread, the greater the standard deviation. And if all the values of a data set are the same, the standard deviation is 0 because each value is equal to the mean.
We'll discuss what is probability. Then we'll look at the difference between probability and statistics. Later we'll discuss in detail about the probability terminology and its rules. Then we'll look at conditional probability. And at last we'll focus on the probability distribution. So let's begin. Now learning about probability helps us make informed judgments on what is likely to happen based on a pattern of data collected previously. So let's explore probability. Now probability seeks to answer the question, what is the chance of an event happening? And an event has some outcome of interest. To calculate the chance of an event happening, we also need to consider all the other events that can occur. So as we can see in the formula, probability of an event happening, that is P of V, is equal to times of an event occurred divided by a total number of opportunities for the event to have occurred, which means the number of ways it can happen divided by the total number of outcomes. Now let's look at an example of probability. So Emma here owns a large fish store with many colors of fish. She keeps all of the fish in a large aquarium. So in her main aquarium, she has 5 orange fish, 6 purple fish, 14 blue fish and 5 green fish. Now, a customer comes into the store and wants to buy a purple fish. So what is the probability that Emma will reach in and scoop out a purple fish on a first scoop? So to calculate this probability, Emma needs to find out the total number of fish in her aquarium. So Emma needs to add the 5 orange fish plus 6 purple fish plus 14 blue fish plus 5 green fish, which is equal to 30 in total. Now Emma must also know the number of favorable outcomes. So in her tank there are only 6 purple fish, and that makes the number of favorable outcomes to be 6. And the formula to calculate probability is the number of favorable outcomes over the number of total outcomes. So the number of favorable outcomes is 6 and the number of total outcomes is 30. So the probability of Emma scooping a purple fish the first time is 6 out of 30. And also remember, all fractions must be in simplest form. So 6 over 30 will reduce to 1 over 5, and hence the probability that Emma will scoop out a purple fish on a first try is 1 by 5. So now we'll look at the major difference between probability and statistics. So probability and statistics are related areas of mathematics which concern themselves with analyzing the relative frequency of events. Still, there are some fundamental differences. So probability deals with predicting the likelihood of future events, while statistics involves the analysis of the frequency of past events. And probability is primarily a theoretical branch of mathematics which studies the consequences of mathematical definitions, while statistics is primarily an applied branch of mathematics which tries to make sense of observations in the real world. Now we'll look at the key terms used in probability. So an experiment in probability is a test to see what will happen in case you do something. So simple example is flipping a coin. So when you flip a coin, you are performing an experiment to see what side of the coin you'll end up with. And an outcome in a probability refers to a single result of an experiment. So in the example of experiment, one outcome would be heads and the other outcome would be tails. Then we have event. So event is the set of group of different outcomes of an experiment. Suppose you flip a coin multiple times, then an event would be getting a certain number of heads. And the sample space is the total number of all the different possible outcomes of a given experiment. So if you flip the coin multiple times, all the different combinations of heads and tails would make up the sample space. So a sample space is also defined as the universal set for the outcomes of a given experiment. Next, we'll focus on a couple of rules which we'll need to follow in probability. So here, this is the total sample space we have, and the probability of this area is 1. Here, if any event occurs, then the probability of an event lies between 0 and 1. So if an event is certain to occur, it will have a probability of 1, and if there is no chance of the occurrence of an event, then the probability will be 0. So the area of the rectangle denotes sample space, and since the probability is associated with the area, it obviously cannot be negative. So now we'll look at mutually exclusive events. So here the events cannot occur at the same time. If event A occurs, then event B cannot. So if A and B are mutually exclusive events, then the probability of A and B happening together is 0. And here the probability that A or B will occur is the sum of the probability of each event. That is, probability of A or B equals probability of A plus probability of B. And there is also a possibility that if event A and B are not mutually exclusive, then we will be removing this intersection part. So when they are mutually exclusive, to calculate probability, we are just adding event A and B. And when they are not mutually exclusive, then the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now, two events are known to be independent events if the occurrence of one event will have no effect on the probability of the other one. So if A and B are two independent events and probability of A and probability of B be their probabilities, then probability of both A and B occurring would be probability of A into probability of B. For example, the probability of rolling a dice and getting a 2 for the first time and also for the second time. So those events are independent, right? So next we'll discuss different types of probability. So mainly probability can be defined in two categories, frequent and conditional probability. So frequent probability is used to find the chance of a particular outcome. Now let's say we toss a fair coin with the outcome of tail as 1 and head as 0. Suppose if we repeat this experiment 1000 times and after completing this experiment we receive the outcome as 600 times tails and 400 times heads. And if we count how frequent the heads or tails have come in the past, then we'll get the result as 60% tails and 40% heads. And this frequency can be considered as probabilities for fair coin coming up as head or tails, and this is the frequent probability. And then we have conditional probability of an event, which measures the probability of an event if another event has already occurred. So in other words, we can say that the conditional probability of an event is the probability of that event given that another event has already taken place before it. So let A and B be two events associated with an experiment. Then the occurrence of B is restricted by the fact that A will have occurred before B and will affect B. And this is how we can get the occurrence of B given that A has taken place. So let's consider these two events, A and B. So A is the probability for rain and B is the probability that the league game is cancelled. Now from these definitions, you might quickly realize that the two events are not mutually exclusive. That is, both A and B could occur simultaneously. Also, the two events are not likely to be independent of one another. That is, the event of rain will greatly increase the likelihood that the league game is cancelled. So what is the probability that the league game is cancelled given that it rains today? So this probability is called as conditional probability because we are given the condition that it is raining. In other words, event B is no longer a what if. We already know that it has occurred and it may or may not have an impact on the probability of event A. Therefore, given that event B has already occurred, what is the probability of A? Is our conditional probability. So the conditional probability of A given B is denoted by P of A given B, which is equal to P of A and B divided by P of B. And here probability of B should be greater than 0. And if we cross multiply, then probability of A and B becomes probability of B into probability of A given B. And similarly, the conditional probability of B given A is denoted by probability of B given A equals probability of P and B divided by probability of A. And over here, probability of A should be greater than 0. And again, if we cross multiply, then probability of A and B becomes probability of A into probability of B given A. And again later, when we equate these two equations, then probability of A given B into probability of B is equal to probability of B given A into probability of A. And if we take probability of B from LHS to RHS, then probability of A given B is equal to probability of B given A into probability of A divided by probability of B. And this is the base theorem of conditional probability. So next we'll discuss probability distribution. So the probability function for a discrete random variable is the probability mass function. It shows the exact probabilities for a particular value of the random variable. So suppose you're a teacher in a university and after checking assignments for a week, you graded all the students. Now you gave these graded papers to a data entry guy in the university and told him to create a spreadsheet containing the grades of all the students. But the guy stores only the grades and not the corresponding students. And he also made another blunder. He missed a couple of entries in a hurry and we have no idea whose grades are missing. So let's find a way to solve this. So one way is that you visualize the grades and see if you can find a trend in the data. So the plot here is frequency distribution of the data, and you see that there is a smooth curve like structure that defines our data. But do you notice an anomaly? So we have an abnormally low frequency at a particular score range. So the best guess would be to have missing values that remove the dent in the distribution. And this is how we would try to solve a real life problem using data analysis. So for any data scientist, student or a practitioner, distribution is a must-know concept. It provides the basis for analytics and inferential statistics. And while the concept of probability gives us the mathematical calculations, distributions help us to actually visualize what's happening underneath. And we have different types of distributions like Bernoulli distribution, binomial distribution, normal distribution, exponential distribution, and so on. In this module, we'll learn about covariance and correlation. Then we'll look at their importance. And later we'll discuss about the correlation coefficient. Now, covariance and correlation are two concepts in the field of probability and statistics. Both are concepts that describe the relationship between two variables. And also, both are tools of measurement of a certain kind of dependence between variables. So what is correlation? Now when you say that two items correlate, you're basically saying that the change in one item affects a change in another item as well. You'll always talk about correlation as a range between -1 and 1. For example, if you say that two items have a correlation of 0.9, you're basically saying that a change in one item results in a similar change to another item. So for example, all the stock market indexes tend to move together in similar directions. When Dow Jones loses 5%, S&P 500 would also lose around 5%. And when Dow Jones gains 5%, S&P 500 would also gain around 5%. And that is because they are highly correlated. Now there could also be negative correlation where you might observe that as Dow Jones loses 5% of its value, gold might gain 5%. Alternatively, if Dow Jones gains 5% of its value, gold would in turn lose 5% of its value. And in addition, correlation values are dependent on units of measure of x and y. So what is covariance? Now if you say that two items tend to vary together, then you're talking about the covariance between the two items, which can be positive or negative covariance. To simplify, covariance tries to look into and measure how much variables change together. So positive covariance indicates that higher than average values of one variable tend to be paired with higher than average values of the other variable. And negative covariance indicates that higher than average values of one variable tend to be paired with lower than average values of the other variable. And covariance is not standardized unlike the correlation coefficient. Therefore, covariance values can range from negative infinity to positive infinity. Both covariance and correlation have distinctive types. So covariance can be classified as positive covariance, which means two variables tend to vary together, and negative covariance means one variable is above or below the expected value while compared to another variable. On the other hand, the correlation has three categories: positive, negative, or zero. So positive correlation is indicated by a plus sign, negative correlation is indicated by a minus sign, and zero is for uncorrelated variables. Another notable difference is that correlation is dimensionless. So in contrast, covariance is in units, which is formed by multiplying the unit of one variable to another unit of another variable. So covariance provides a measure of the strength of the correlation between two or more sets of random variates. So the covariance for two random variates x and y, each with sample size n, is defined by the expectation value. So in this formula, x represents the independent variable, y represents the dependent variable, n represents the number of data points in the sample, x bar represents the mean of the independent variable, and y bar represents the mean of the dependent variable. So now we'll look at the formula for correlation. Here, COV of xy is the covariance between the x and y, sigma of x is the standard deviation of x, and sigma of y is the standard deviation of y. Now let's look at some differences between covariance and correlation. So the measure used to indicate the extent to which two random variables change in tandem is known as covariance. And the measure used to represent how strongly two random variables are related is known as correlation. Now covariance is nothing but a measure of correlation. On the contrary, correlation refers to the scaled form of covariance. And the value of correlation lies between -1 and +1. Conversely, the value of covariance lies between -infinity and +infinity. And covariance is affected by the change in scale. As against this, correlation is not influenced by the change in scale. So that's the reason we mainly use correlation instead of covariance, because it is the most standardized version. Now let's take an example to understand correlation. In a particular concert, the number of attendees is dependent on how many hours the sunlight is there. Here we have a distribution of sunlight and concert attendance. So here the number of attendants depends upon the sunshine. So if we plot it out, then we'll understand how the sunlight is impacting the concert attendance and whether they are correlated or not. So let's check it out. Now, whenever we are plotting any particular scatter plot, we need to make sure that on the x-axis, we'll always have the independent variable and the y-axis will always be the dependent variable. So over here, our independent variable is sunshine, and based on that, we would like to see what is the relationship with the concert attendance. So concert attendance is nothing but the dependent variable. So here we have made a scatter plot of this data set. We have sunshine on the x-axis, which ranges from 0 to 8 hours. And on the y-axis, we have the concert attendance in hundreds. So you can see that as the duration of sunlight increases, the concert attendance also increases. So yes, there is a correlation between sunlight and concert attendance. Now there could be different cases in correlation, such as positive linear correlation, negative linear correlation, and there could even be no correlation at all. Here in positive linear correlation, we see that if the independent variable is increasing, then the dependent variable is also increasing, and they are positively correlated to each other. In case of negative linear correlation, as the independent variable increases, the dependent variable decreases. And in the third case, there is absolutely no correlation between the dependent and the independent variables. So now we'll focus on the correlation coefficient. As we know that correlation is a relationship between two sets of variables used to describe or predict information. Therefore, the correlation coefficient is the degree in which the change in a set of variables is related. This means that we are trying to find out if the two variables have a correlation at all, how strong the correlation is, and if the correlation is positive or negative. And to find the exact correlation between variables, you'll need to use the correlation coefficient equation. So when solved, the correlation coefficient equation will give you a number between -1 and 1. The closer the number is to a positive 1, the stronger the positive correlation. A change in the value of one variable will predict a change in the same direction in the second variable. And the closer the number is to a negative 1, the stronger the negative correlation. A change in the value of one variable predicts a change in the opposite direction in the second variable. And the closer the number is to 0, the weaker the correlation. 0 means there is no correlation between the two variables. So coefficient of 0 indicates there is no discernible relationship between fluctuations of the variables. So this is the formula for calculating correlation coefficient, where R denotes the correlation coefficient, which is equal to the covariance of x and y divided by standard deviations of x and y. So here if R equals 1, that means for every positive increase in one variable, there is a positive increase of a fixed proportion in the other. It is associated with perfect positive correlation. That is, with the increase in x-axis, the y-axis will also increase. For example, shoe sizes go up in perfect correlation with foot length. And if R equals -1, this means that for every positive increase in one variable, there is a negative decrease of a fixed proportion in the other. It is associated with perfect negative correlation moving opposite to each other. For example, the amount of gas in a tank decreases in perfect correlation with speed. And when it is 0, this means that for every increase, there isn't a positive or negative increase. The two just aren't related to each other. So now a lot of times we have heard correlation does not cause causation, or correlation does not imply causation, or correlation is not causation. But what does this actually mean? As we know, correlation describes the size and direction of a relationship between two or more variables, while causation indicates that one event is the result of the occurrence of the other event. That is, there is a causal relationship between the two events. This is also referred to as cause and effect. The classic causation versus correlation example that is frequently used is that smoking is correlated with alcoholism but doesn't cause alcoholism, while smoking causes an increase in the risk of developing lung cancer. Now we'll look at different relationship causes, like A causes B, which is known as direct causation, or B causes A. So this is reverse causation. Then A and B both are the consequences of the common cause, but they both do not cause each other. Or A and B both cause C, which is another condition. Or A causes C, which causes B. So this is an indirect causation. Thus, there can be no conclusion made regarding the existence or the direction of a cause and effect relationship only from the fact that A and B are correlated. So, determining whether there is an actual cause and effect relationship requires further investigation. Even when the relationship between A and B is statistically significant, a large effect size is observed or a large part of the variance is explained. For example, the faster windmills are observed to rotate, the more wind is observed to be. Therefore, wind is caused by the rotation of windmills. So in this example, the correlation between windmill activity and wind velocity does not imply that wind is caused by windmills. It is rather the other way around, as suggested by the fact that wind doesn't need windmills to exist, while windmills need wind to rotate. So wind can be observed in places where there are no windmills or non-rotating windmills. And there are obviously good reasons to believe that windmills existed before the invention of windmills, right?
In this module, we will learn about hypothesis testing. Then we'll look at the different types of statistical hypothesis. Going ahead, we'll understand the types of decision errors, and finally, we will look at some decision rules for rejecting the null hypothesis. So let's explore. Now, when you conduct a quantitative research, you are inevitably attempting to answer a research question or hypothesis that you've set. So one method of evaluating this research question is via a process called as hypothesis testing, which is sometimes also referred to as significance testing. And there are many facets to this. So a statistical hypothesis is an assumption about a population parameter, and this assumption may or may not be true. So hypothesis testing refers to the formal procedures used by statisticians to accept or reject statistical hypotheses. But the best way to determine whether a statistical hypothesis is true would be to examine the entire population. Since that is often impractical, researchers typically examine a random sample from the population. And if the sample data is not consistent with the statistical hypothesis, the hypothesis is rejected. So now we'll look at the types of statistical hypothesis. So mainly there are two types of statistical hypothesis: null hypothesis and alternative hypothesis. So the null hypothesis is denoted by H0 and is usually the hypothesis that the sample observations result purely from chance. And the alternative hypothesis is denoted by H1 or HA and is the hypothesis that the sample observations are influenced by some non-random cause. For example, suppose you wanted to determine whether a coin was fair and balanced. So a null hypothesis might be that half the flips would result in heads and half in tails. And the alternative hypothesis might be that the number of heads and tails would be very different. So symbolically, the hypothesis would be expressed as for H0, P equals 0.5, and for H1, P is not equal to 0.5. So suppose we flip the coin 50 times, resulting in 40 heads and 10 tails. Now, given this result, we would be inclined to reject the null hypothesis, and we would conclude based on the evidence that the coin was probably not fair and balanced. So hypothesis testing is about testing to see whether the stated hypothesis is acceptable or not. And during our hypothesis testing, we want to gather as much data as we can so that we can prove our hypothesis one way or another. So statisticians follow a formal process to determine whether to reject a null hypothesis based on sample data. And this process is called as hypothesis testing, consisting of 4 steps. So the first step is to state the hypothesis. Now this involves stating the null and alternative hypothesis. So the hypotheses are stated in such a way that they are mutually exclusive. That is, if one is true, then the other must be false. Next step is to formulate an analysis plan. So the analysis plan describes how to use sample data to evaluate the null hypothesis. And the evaluation often focuses on a single test statistic. And then in the next step, we will analyze the sample data. So here we will find the value of the test statistic like mean score, proportion, t statistic, and z score described in the analysis plan. And the last step is to interpret the results. And here we apply the decision rule described in the analysis plan. And if the value of the test statistic is unlikely based on the null hypothesis, we will reject that null hypothesis. So for example, a cleaning company can publish information that proves that their cleaning product kills 99% of all germs. So if they perform a hypothesis test that has data that proves their hypothesis that their cleaning product kills 99% of the germs. And while these tests can be very helpful, there is a danger when it comes to interpreting the results. It is possible to make two different kinds of errors when interpreting the results. Next, we'll look at the types of errors that can result from a hypothesis test. Now, hypothesis testing in statistics involves deciding whether to reject or not reject a null hypothesis. There are problems that can occur when making decisions about a null hypothesis. And mainly two types of errors can result from a hypothesis test. So it can be either a type 1 error or a type 2 error. So a type 1 error occurs when the researcher rejects a null hypothesis when it is actually true. So this error happens when you say that the null hypothesis is false when it is actually true. Our null hypothesis is the hypothesis for our expected outcome. So if our null hypothesis is that dogs live longer than cats, it would be like saying dogs don't live longer than cats when in fact they do. And to help you remember this type 1 error, think of it as having just one wrong. So you are wrongly thinking that the null hypothesis is false. And in statistics, we label the probability of making this kind of error with this symbol. So it's alpha over here. Now usually it is 0.05, which means that you're okay with a 5% chance of making a type 1 error. Now the lower the alpha number, the lower the risk of you making such an error. And the tricky part with setting the alpha number is that if you set it too low, it may mean that you won't catch the really small differences that may be there. The other type of error is called a type 2 error. So a type 2 error occurs when the researcher fails to reject a null hypothesis that is false. So this type of error happens when you say that the null hypothesis is true when it is actually false. And for a null hypothesis that dogs live longer than cats, it would be like saying that dogs do live longer than cats when in fact they don't. Now to help you remember a type 2 error, think of two wrongs. So you're basically wrongly thinking that the null hypothesis is wrong. And the probability of making a type 2 error is labeled with a beta symbol. So this type of error can be decreased by making sure that your sample size, the number of tests, and the number of subjects you have is large enough so that the real differences can be spotted. So for the dogs and cats, this would mean that you need to gather data about enough dogs and cats to see real difference between them. So if you have information about just one dog and one cat, you can't say for sure that the statement that dogs live longer than cats is true or not. And if the dog lives longer than the cat, then you might make the mistake of saying that dogs do live longer than cats, even though the opposite were true. So your sample size isn't large enough for you to see the difference. And if you take this beta value and subtract it from 1, that is 1 minus beta, you will get what is called the power of your test. So the higher the power of your test, the less likely you are to make a type 2 error. So with this, we can easily identify the type 1 and type 2 errors. So type 1 error is false positive and telling a man is pregnant, and type 2 error is false negative and telling pregnant woman is not pregnant. So here is the metrics to understand this example in a better way. So let's look at true positive. So here the interpretation is you predicted positive and it's actually true. That is, you predicted that a woman is pregnant and she actually is. Then we have true negative. So here the interpretation is you predicted negative, but it's actually true. That is, you predicted that a man is not pregnant and he actually is not. Then we have false positive. That is type 1 error. So here the interpretation is you predicted positive, but it's false. That is, you predicted that a man is pregnant, but he actually is not. And finally, we have false negative. That is type 2 error. So here interpretation is you predicted negative and it's false. That is, you predicted that a woman is not pregnant, but she actually is. Now we will look at some of the decision rules for rejecting the null hypothesis. So a z-value is a measure of standard deviation. That is, how many standard deviations away from the mean is the observed value. For example, if the z-value is plus 1.8, it can be interpreted as the observed value is plus 1.8 standard deviations away from the mean. And the p-values are just the probabilities. So both these statistical terms are associated with the standard normal distribution. So a z-score can be calculated from the following formula. So z equals x minus mu upon sigma, where z is the z-score, x is the value of the element, mu is the population mean, and sigma is the standard deviation. For example, let's say you have a test score of 190 and the test has a mean of 150 and a standard deviation of 25. And assuming a normal distribution, your z-score would be 190 minus 150 upon 25, which should be equal to 1.6. So you could say that our score is 1.6 standard deviations above the mean. And this is how we can interpret the z-scores. So a z-score less than 0 represents an element less than the mean. A z-score greater than 0 represents an element greater than the mean. And a z-score equal to 0 represents an element equal to the mean. And a z-score equal to 1 represents an element that is one standard deviation greater than the mean. Similarly, a z-score equal to 2 represents an element 2 standard deviations greater than the mean, and so on. And a z-score equal to minus 1 represents an element that is one standard deviation less than the mean. Similarly, a z-score equal to minus 2 represents an element which is 2 standard deviations less than the mean, and this goes on. So if the number of elements in the set is large, about 68% of the elements have a z-score between minus 1 and 1, and about 95% have a z-score between minus 2 and 2, and about 99% have a z-score between minus 3 and 3. Now we'll look at p-values. So in simple terms, when you perform a hypothesis test in statistics, a p-value helps you determine the significance of your results. And the p-value or calculated probability is the probability of finding the observed or more extreme results when the null hypothesis of a study question is true. So the definition of extreme depends on how the hypothesis is being tested. Now p can also be described in terms of rejecting h0 when it is actually true. However, it is not a direct probability of the state. And the term significance level is used to refer to a pre-chosen probability, and the term p-value is used to indicate a probability you can calculate after a given study. And if your p-value is less than the chosen significance level, then you reject the null hypothesis. That is, you accept that your sample gives reasonable evidence to support the alternative hypothesis, though it does not imply a meaningful or important difference, and that is for you to decide when considering the real-world relevance of your result. And the choice of significance level at which you reject h0 is arbitrary. Now, the evidence in the trial is your data and statistics that go along with it. All the hypothesis tests ultimately use a p-value to weigh the strength of the evidence. That is, what data is telling you about the population. Now, the p-value is just a number between 0 and 1, and it can be interpreted in the following way. So, a small p-value, typically equal to or less than 0.05, indicates strong evidence against the null hypothesis. So, you reject the null hypothesis. Large p-value, which is greater than 0.05, indicates weak evidence against the null hypothesis. So, you fail to reject the null hypothesis. And p-values which are very close to the cutoff, 0.05, are considered to be marginal. Now, you always have to report the p-values so your readers can draw their own conclusions. So, for example, suppose a pizza place claims the delivery time is 30 minutes or less on average, but you actually think it's more than that. Now, you conduct a hypothesis test because you believe the null hypothesis h0, that is, the mean delivery time being 30 minutes max, is actually incorrect. So, your alternative hypothesis HA is that the mean time is greater than 30 minutes. So, you randomly sample some delivery times and run the data through the hypothesis test, and your p-value turns out to be 0.001, which is much less than 0.05. So in real terms, there is a probability of 0.001 that you will mistakenly reject the pizza place's claim that their delivery time is less than or equal to 30 minutes. And since typically we are willing to reject the null hypothesis when this probability is less than 0.05, you conclude that the pizza place is wrong and the delivery times are in fact more than 30 minutes on average. So both z-scores and p-values are associated with the standard normal distribution. So the table on the screen shows the uncorrected critical p-values and z-scores for different confidence levels. Now consider an example. The critical z-score values when using a 95% confidence level are minus 1.96 and plus 1.96 standard deviations. So the uncorrected p-value associated with the 95% confidence level is 0.05. So if your z-score is between minus 1.96 and plus 1.96, your uncorrected p-value will be larger than 0.05, and you cannot reject your null hypothesis because the pattern exhibited could very likely be the result of random spatial processes. And if the z-score falls outside the range, for example,
minus 2.5 or plus 5.4 standard deviations, the observed spatial pattern is probably too unusual to be the result of random choice, and the p-value will be small to reflect this. So in this case, it is possible to reject the null hypothesis and proceed with figuring out what might be causing the statistically significant spatial structure in your data. So key idea here is that the values in the middle of the normal distribution represent the expected outcome.
Now let's understand what exactly is hypothesis testing. So now before we start up understanding what exactly is hypothesis testing, I got a question for you folks. So tell me what you understand by hypothesis. So when it comes to statistical analogy, hypothesis basically is a premise or a claim which has to be tested or it has to be investigated. So let's say I just make a claim that whenever I wear a blue shirt, it will definitely rain on that particular day. So this is a claim which I'm making, and now in statistical analogy, this claim has to be tested. So this is the premise of hypothesis testing. So as it is written over here, hypothesis testing is basically an assumption about a population parameter, and this assumption may or may not be true. So I'll just make a claim that if I wear a blue shirt, then it will definitely rain on that particular day, right? So there is a very good chance for this claim to be not true, or there is also a very good chance for this claim to be true. Right, now there are two things which we have to learn when it comes to hypothesis testing. So we have something known as null hypothesis, and then we have alternate hypothesis. So when you hear the term null, you basically think of, let's say, zero or empty. So what is null hypothesis? So null hypothesis is basically the claim which you make. So this is your initial claim, right? And when it comes to null hypothesis, we assume that the sample observations result purely from chance. So there is no non-random cause influencing this particular data set or these particular observations. And then we'll head on to alternate hypothesis. So when it comes to alternate hypothesis, this is basically we are stating that no, null hypothesis is wrong, and there is a very good possibility that there is something else which exists apart from the null hypothesis. So as it is stated over here, alternate hypothesis basically states that the sample observations are influenced by some non-random cause. And I'll give an example to make this clear. So let's take the time when an apple hit Newton's head, right? And on the basis of this, he developed calculus and all of the gravitational theory. Now this would be your null hypothesis. And after, let's say, hundreds of years later, Einstein came in and he said that, no, this is not right. So there is a lot more than what is going on in Newton's philosophy of gravitation. So there is time and space involved, and there are a lot of other factors which come into the picture. So this would be the alternate hypothesis. So over here, Newton's theory would be the null hypothesis, and then Einstein's theory would be the alternate hypothesis. And Einstein would give his postulates to make sure that the null hypothesis is removed. And these are the symbols to denote null hypothesis and alternate hypothesis. So null hypothesis is denoted by H0, and alternative hypothesis is denoted by either H1 or HA. Right, now let's understand hypothesis with this example. So let's say you have a coin and you assume that this is an unbiased coin. So there is a 50% probability of getting head, and there is also a 50% probability of getting tail. So this is your null hypothesis. So your null hypothesis is that there is a 50% probability of getting head, and there is also a 50% probability of getting tails, right? But what happens is when you actually go ahead and toss this coin 100 times, you get 99 heads and only one tail. So don't you think there is something wrong with this? So you had assumed that you actually have a unbiased coin, but you are dealing with an unbiased coin where you have 99 heads and just one tail. So there is something which is making this coin give you more heads. So with the help of this test, you understand that the probability of getting heads and tails is actually not exactly 50%. So your null hypothesis stated that there is 50% probability for getting both heads and tails. So on the basis of these experiments which you had conducted, you can disprove the null hypothesis, and you're saying that it is not actually 50% probability to get heads and tails. So there is actually a greater probability of getting more heads and less tails, and hence you go ahead and reject the null hypothesis. Right, so this is the structure of the hypothesis test. So you start off by stating the hypothesis, which is basically your null hypothesis, and then your alternate hypothesis, and then you go ahead and formulate an analysis plan. Now after you have an analysis plan, you will go ahead and analyze the sample data, and once you have your results, you have to interpret the results. So this is the basic structure of all of your hypothesis tests.
Alright, now there are different types of hypothesis tests useful for different hypothesis scenarios and data samples. So as your data changes, then you'd have to use a different hypothesis test for your different data sets. And these are some of the most frequently used hypothesis tests. So you've got t-test and chi-square test for independence. So let's start off with the first one, which is t-test. So a t-test basically checks if the averages or means of two groups are reliably different from each other. Or in other words, it lets you know if these differences could have happened by chance. Now this definition seems to be complicated. So let's again understand this with the help of an example. So let's say we've got a drug company which wants to test a new cancer drug to find out if it improves life expectancy. So we've got two groups over here, and one group is actually given the actual drug and the other group is given a placebo, right? So we've got this blue color group over here and all of the people in this group are given the actual drug, and we've got the second group over here and all of the people in the second group are given the placebo. Now the first group shows an average life expectancy of plus 6 years after taking the actual drug, while the second group shows an average life expectancy of plus 5 years after taking the placebo. Now on the basis of this experiment, can you actually say that the drug works? So this is the question which you're facing, right? So on the basis of this particular experiment, you have actually seen that the first group, which was given the actual drug, has a greater life expectancy than the second group, which was given a placebo. Now, let's say if I take a different population and give them an actual drug, or if I increase the number of people in the first group, then will it work with the other groups as well? Right? So this is what we actually want to know. And this is where t-test comes in. Right, so now when it comes to t-test, we have something known as a t-score. And t-score is the ratio between the difference between two groups and the difference within the two groups. Now, if we take these two groups over here, we actually want to understand if these two groups are same or they are actually different, right? Now, when it comes to the t-score, so if the t-score is very large, then it would mean that these two groups are very different. And if the t-score is very small, then it would mean that these two groups are actually very similar in nature. And t-score is basically signal upon noise, or in other words, it is the variance between the groups upon variance within the groups. Now let's say we go ahead and calculate the t-score. So the difference between the groups comes out to be around 6 and the difference within groups comes out to be around 2. So when you divide 6 with 2, you get a ratio of 3. So this means that the first group is 3 times more different than the second group. Now this actually tells you that there is quite a bit of difference between the first group and the second group. And on the basis of this, you can actually conclude that this drug might actually work. So that was t-score. Now let's go ahead and understand the next hypothesis test, which is chi-square test for independence. So the chi-square statistic is commonly used for testing relationships between categorical variables. Now the null hypothesis of the chi-square test is that there is no relationship existing on the categorical variables in the population. So they are absolutely independent. So over here, we are trying to determine if there's a relationship between the gender of a student and the result of the exam. So over here, the null hypothesis would state that there is absolutely no relationship between the gender of a student and the result of the exam. Right. Now let's take this example to understand chi-square test in a better way. So we've got 500 students in total again, and out of those 500 students, we've got 300 boys and 200 girls. And all of them are asked what is their favorite color. Is it blue, green, or pink? Now, we'd have to determine is there a relationship between gender of the student and the favorite color. So we go ahead and tabulate this. Now this is the formula to calculate chi-square. So O minus E whole square upon E. So over here, O is the observed value of the categorical variables. E is the expected value of the categorical variables. And this symbol which you see, this is basically chi-square test of independence. Right. So these are all of the steps which you would have to perform while implementing chi-square test. So you'd have to start off by defining the null and alternate hypothesis, and then you'll go ahead and state a value for alpha, following which you will calculate the degrees of freedom, and then you'll state your decision rule. Going ahead, you'll calculate the test statistic, and finally you will state the results and the conclusion. So we'll start off with our first step where we'd have to define the null and the alternate hypothesis.
So over here, H naught is the null hypothesis, and the null hypothesis for this data would be that gender and the favorite color of the student are not related. And the alternate hypothesis would be for this particular population, gender and favorite color are actually related. So this is your first step where you have defined your null and alternate hypothesis. Then you'll go ahead and do the second step where you're stating the alpha. So before we run any statistical test, we must first determine the alpha level, which is also called the significance level. And by definition, alpha level is the probability of rejecting the null hypothesis when the null hypothesis is true. So let's say the null hypothesis is actually true and the alpha value is 0.05. So this means that there is a 5% of risk of actually stating that there is a difference which exists when actually there is no difference between the categories. Right, so and over here we are taking the alpha level to be 0.05 for this particular example. Going ahead, we'll calculate the number of degrees of freedom. So number of degrees of freedom is obtained by multiplying number of rows minus 1 into number of columns minus 1. So we've got 2 rows over here, it would be 2 minus 1, and we've got 3 columns over here, it would be 3 minus 1. And when you multiply 1 with 2, you get 2 degrees of freedom. And then we'll go ahead and state the decision rule. Now before we state the decision rule, we'd have to find out the critical value. And we can get the critical value using this chi-square table. So this chi-square table has the number of degrees of freedom denoted over here on the rows. And then we've got the alpha value stated over here on the column side. And since we have 2 degrees of freedom and the alpha value is 0.05, our critical value would be 5.991. And on the basis of this, we can state the decision rule that if chi-square is greater than 5.99, we'll go ahead and reject the null hypothesis. Right, now it's time to calculate the test statistic. So to calculate the test statistic, we already know the formula. So it is O minus E whole square upon E. And over here, we'd actually have to calculate the expected value. So these are the observed values over here, but we would also have to calculate the expected value. So expected value would be frequency of number of columns into frequency of number of rows upon total number of records over here. So let's say if I want to determine the frequency of all of the boys whose favorite color is blue. So that would be frequency of columns since the color is blue. So we'd have to take this column over here, which would be 120. And then we'd have to take the frequency of rows, which is boys over here. This would be 300. So 120 into 300. And then we'll divide this with the total number of records over here, which is 500. So 120 into 300 divided by 500 would give you an expected value of 72. Similarly, let's say if you want to calculate the expected value of boys green, it would be 180 into 300 divided by 500. For boys and pink, it would be 200 into 300 divided by 500. And when it comes to girls and blue, it would be 120 into 200 divided by 500. When it is girls and green, it would be 180 into 200 divided by 500. And finally, when it comes to girls and pink, it would be 200 into 200 divided by 500. So when we perform all of this, we'll get the expected values over here. So these are our observed values and these are the expected values which we have calculated using the above formula. Now we'll get the final table where we have the observed values and the expected values in the same table. Right, so this is the actual values and then in the parenthesis, we've got the expected values over here. And then we'll go ahead and use our formula and then calculate the chi-square value. So it'll be observed minus expected whole square upon the expected value. So it'll be 100 minus 72 whole square plus 72 and similarly it'll go on. And we calculate the entire thing, we'll get a chi-square value of 276.37. Right, so it's finally time to state our result. Now our decision rule stated that if chi-square is greater than 5.99, we'll go ahead and reject the null hypothesis. And over here, after performing all of our calculations, we've got a chi-square value of 276.37, and that is why we'll go ahead and reject this null hypothesis. Right, so the conclusion is this. In this population, there is actually a relationship which exists between the gender of the student and the favorite color of the student.
In this module, we will discuss different types of rescaling, that is standardization and normalization. Then we will look into the different scenarios where standardization and normalization are used. And finally, we will discuss which is more efficient among standardization and normalization. So let's begin. Now, data pre-processing plays a crucial role in data mining. So whenever you're dealing with parameters of different units and scale, it is important to understand the data pre-processing and scaling methods. So scaling or rescaling is nothing but changing the type of data measurement that you are using in your data. And there are two types of rescaling methods commonly used, which are standardization and normalization. Now let us say we have a list of student heights. So some of the data is in centimeters, while some of the data is in the form of feet. Now the data has to be scaled either to centimeters or feet. So this scaling of data is used in a lot of scenarios. And one such application where this technique is used is in machine learning algorithms. So there is a lot of math involved in machine learning, and that is why standardization and normalization is used a lot. So now first understand what is standardization. So standardization is also called z-score normalization, and in standardization features will be rescaled so that they'll have the property of any standard normal distribution with mean 0 and standard deviation of 1. So this is the formula to calculate the z-score: x minus mu divided by sigma, where x is the particular variable, mu is the mean, and sigma is the standard deviation. So standardizing the features so that they are centered around 0 with the standard deviation of 1 is not only important if you are comparing measurements that have different units, but it is also a general requirement for many machine learning algorithms. For instance, consider a shampoo bottle on an online store. Now different websites may describe the weight of this one bottle as, let's say, 20 oz, 20 ounces, 1.25 lb, 567 gms or 567 grams. So the challenge here is to recognize that all of these are units of weight and they are all the same quantity. So once this is determined, the value can be standardized according to a preset dictionary. So intuitively we can also think of gradient descent as a prominent example of this. Now it is an optimization algorithm used in linear regression, perceptron and neural networks as well. So in the case of gradient descent, the different scales and weights get updated rapidly. That is, future value stays rolling with the updates, and that is why data is normalized in gradient descent. And other examples are k nearest neighbors and k means clustering algorithms. So these use Euclidean distance measure to standardize the data. And there are also some machine learning algorithms which don't use standardization at all, such as the tree-based classifiers which don't use standardization. So these tree-based algorithms such as decision tree or random forest use scale variant, and hence they don't need the standardization method. And these are the algorithms which require feature scaling or standardization. So k nearest neighbors algorithm needs standardization because it uses the Euclidean distance measure. Now linear regression, logistic regression and neural networks use the gradient descent optimization method. And as we have already discussed, gradient descent algorithm updates the weight, so that is why it requires standardization. So if it is not standardized, then a few weights will be updated faster and few are not. That is why standardization is important for these algorithms. So another example which you would take would be the dimension reduction algorithm, such as principal component analysis. So principal component analysis uses standardization as the pre-processing step to reduce the number of dimensions so that all the features are on the same scale. Now we'll see what normalization is. So normalization is another rescaling method which we have as an alternative to standardization. And normalization is also called as min-max scaling. Now what happens in standardization is it just scales from 0 to 1. But in normalization, it will have a smaller standard deviation which helps in compressing the effect of outliers if there are any present. So this is the formula for normalization. So we take any particular variable x and subtract it with the minimum variable and then divide it by range. So what we get is a standard variable in the range of 0 to 1. So for example, consider a credit card data set having two variables. Let's say credit cards and income. So now you intend to cluster these records to find similar applicants based on these attributes. Now as you can well imagine, these two will be on different scales, and income being on a much higher scale will influence the distance measure much more than credit cards. And thus normalization is done to avoid this. So another example would be if you're studying the brand effectiveness of some brand and there are several columns which are on the scale like very good, good, average, and bad. So in these cases, normalization is performed before doing regression. So now you might be thinking, which one is better, normalization or standardization? So let us see. So depending on the application, we can either go for standardization or normalization. So there is no correct way to define whether to go for normalization or standardization. Or we can actually go for both, and based on the results, we can choose the best of those. For example, in clustering analysis, standardization may be especially crucial to compare the similarities within the features based on any feature distant measure. And another prominent example for standardization would be principal component analysis, as we are interested in the components that maximize the variance. Whereas in the case of image processing, for example, the pixel intensity, normalization would be the best choice. So depending on the application, you can choose which is best for you. Now, there is actually a thumb rule that if your data varies a lot, we should choose standardization over normalization. And if you have outliers in the dataset, the normalization would work better when compared to standardization. So we can conclude that both standardization and normalization work best with its features depending on the application. It is actually up to you whether to go for standardization or normalization.
So have you ever shopped online? Let's say you're searching for a mobile phone on Amazon. Now you would have noticed that the site recommends you mobile phones which are in the same price range or by the same brand. Now if you leave the site without purchasing the product, then you'd be getting ads recommending you to purchase the same product on almost all the websites that you visit. So how is this really happening? Well, all of this is possible because of machine learning. Now there are thousands of real-life applications of machine learning which you use on a daily basis, either knowingly or unknowingly. Confused? Well, let's go through some of the examples. So all of you would have a Gmail account. Now, how do you think Gmail is able to segregate your emails into different folders such as primary, promotions, social, spam, and so on? Or let's say you're sitting on your couch and happily browsing Netflix. So you get a list of movie recommendations which are very similar to your past watch history. So have you ever wondered how is this possible? Does the machine know you personally to suggest movies similar to your interest? And even while driving, Google Maps suggests you which route has more traffic, which route would be faster for you, and how long will it take to reach the destination if you continue on that route. So how do you think Google Maps does this? Well, all of these are just applications of machine learning. Well, all of which arises over here is, what exactly is machine learning? So it's not just about robots. Machine learning is a sub-branch of artificial intelligence which focuses mainly on machines learning from their experience. Let me explain this to you with an analogy. So consider a newly born child who initially knows nothing. So he goes to school to learn. Now, the teacher starts with the alphabets. The teacher shows picture of letter A to the child and tells him it's A. He repeats the process again and again till the student learns all the alphabets. So here the student is being trained. Once the training is complete, teacher conducts a test to verify how well the student has learned. Now, we'll use the same analogy to a machine. So initially we have a machine which knows absolutely nothing. So we start training the machine in a similar way. So the machine has no idea about what is A or what is B. So we start by showing our machine various pictures of the letter A and teaching it that it's A. Once the training is complete, we test the machine by showing it the letter A of different fonts and styles. And if the machine is able to identify the letters accurately, then it means that the machine was trained well. If not, then in order to increase the efficiency, we have to train a machine with more images of A of different fonts and styles and again test it and check its accuracy. So the more training we give, the more accurate our machine would become. So this is the concept of machine learning. Now, machine learning can be broadly classified into three categories. So we have supervised learning, unsupervised learning, and reinforcement learning. So when it comes to supervised learning, we teach the machine using data which is labeled. Let's say we have a basket of fruits and each fruit is tagged with a label. Now the machine is trained on this label data. So once the training is done, it is given test data or new data to determine how well the training has been done. Now let's take another case where the training data doesn't have any labels associated with it. Here the machine understands the underlying structure of the data to identify similar patterns. And the data which is similar in nature is grouped together. So here the machine understands that all the apples are similar in nature and thus they are grouped together. Same is the case with bananas and mangoes. So this type of machine learning is known as unsupervised learning. And finally we have reinforcement learning, where the algorithm learns through a system of rewards and punishment. Let's say if we feed the machine the image of apple and it labels it as an apple, then it will be rewarded. But on the other hand, if it labels the apple as pineapple, then it will be given negative points. So the greed of getting more and more reward points lets the machine make thousands of decisions, and this is how the machine is trained.
Guys, I have a special announcement for all of you. For all of you dedicated individuals who are looking forward to master data science, we are offering a straightforward 20% discount on our data science course, which is in collaboration with iHub IIT Roorkee. So do make sure to check the link given in the description and fill the inquiry form. Shortly, our team of course advisors will get in touch with you to activate the offer. Don't miss this chance and take your career to the next level. Click on the link given in the description right now.
Imagine you have a data set like this. You have weeks and sales, right? So week, W-E-E-K, week. Okay. This is the first week, the second week, the third week, the fourth week, and the fifth week. Example. You have 5 weeks. Okay. And the number of cars you have sold so far is like this, right? So the number of cars you have sold could be n number, right? So you have let's take it like this, right? You have week in one of the variables and the number of cars you have sold so far in those weeks could be 2, 4, 5, 4, 5, some numbers, right? This is the data that has been given to me. Sir, can we mathematically understand in depth how does linear regression work? What does it actually do? And how does it make our life easier? Okay. In order to understand how linear regression works, first we need to plot this data. Okay. We need to take the data and we need to plot it in the XY graph. How do we do that? In a very simple sense, I'm going to take the variable like this. I'm going to take a straight line and I'm going to pass it like this. Okay. I'm going to have this. So this is my X axis and this is my Y axis. Okay. I'm going to point it out like this. So what is going to be my X axis? Will week be on the X axis? Can I say this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. Can I say it like this? This is the 5-week data. So this is 5, week is X. Okay. What is going to be my Y? The number of cars sold. So can I say this is 1, 2, 3, 4, and 5. So 0, 1, 2, 3, 4, and 5. Anybody has any confusion in what graph did I plot? No, right? It's a simple graph. Nothing complicated. Very good. So in the first week of my graph, how many cars did I sell? I sold 2 cars. So can I have the red pointer point like this? Good. In the second week, I sold 4 cars. So this is 4 cars. In the third week, I sold 5 cars. Okay. So I sold 5th car like this. In the fourth week, I sold 4 cars. So this is 4th car again. And in the 5th week, I have sold 5th car or 5 cars. So, like this. Is this the data that has been given to me with the weeks versus the car sold part? This is the data that has been given to me. Okay. My people, let me ask one question to all of you. Isn't it possible that there is infinite number of lines possible for this particular data? Meaning a line like this is also possible, 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 meaning to solve this problem, infinite number of lines are possible that will pass through the data point. Agree or disagree? I want to identify which line is the best line. which line represents the best line for this particular data. In the previous example, I said line will pass, but what line? Which line? How do we identify that? We don't know anything. So in order to solve this problem logically, isn't it best to first understand where the line would pass from? Meaning, I'll give you guys an example. Listen to me. Suppose I have a point like this, a single point in a three-dimensional space. Is this line possible in a 3D space? Is this line possible? Is this line possible? Is this line possible? Is this? Basically, infinite number of lines are possible through one single point. Yes or no? Okay. But will the point move if I fix the point? Meaning, if I tell you this is the fixed point, the point won't move, correct? Only the lines are possible through that point. Agree? Yes or no? Okay. So listen to me. Can I not do one thing that is a guaranteed good point? I mean, the point that I'm recommending right now is a good point. What do you mean? In your x-axis, what is the mean of your x-axis? Can somebody tell me what is the mean of x-axis? Basically, the mean x bar of mean and x bar or y bar of this. What is the mean of x-axis? Is it going to be 3, the number 3? And what is y bar? What is the mean of y bar? 4. Agree, disagree? The minute you plot the data, the first thing you should do is take the mean and take the mean of x and take the mean of y. So can I say that the mean of x is 3? So it is going to pass here. I'm going to take a different color. Give me 1 second. I'll choose purple. I'll choose peach. Yeah, peach is good. Okay. So control C. Give me 1 second. Is this the mean of x-axis? This peachy line that you see? Very good. What is the mean of y? Is this the mean of y? The minute you took the mean of x and mean of y, did you get a point for reference where the line should pass from? The minute you took the mean of x and the mean of y, you kind of got a reference via which a line could pass. Agree, disagree? But in this scenario also, listen to me. In this scenario also, isn't this line possible? Isn't this line possible? Isn't this line possible? Oh, it's complicated. So many lines are possible, but it's okay. We'll solve a problem one step at a time. Is this step clear to everybody? Take the mean of x and the mean of y. Step number 1. Take the mean of x and take the mean of y. Okay. Now, what you need to do is this. Okay. Your weak data, I'm going to take it as x. So what is the x data that has been given to me? 1, 2, 3, 4, and 5. Everybody agrees this is my x-axis data? Very good. What is the y data? It is 2, 4, 5, 4, and 5. Okay. This is my x-axis data and this is my y-axis data. Okay. What you need to do right now, the minute you calculate this part, x and y. So can we take first data point and try align with connect points? You will calculate something called x minus x bar. Hey, what is x minus x bar? Is this data point called x? This particular data point called 1 minus 3. From the perspective of 3, I want you to understand from the perspective of the number 3. Is this number 1 called x value and this is the x bar? This point is called x bar and this point is called y bar, yes or no? So basically, aren't you calculating that 1 is deviating from 3 by how much? 2 is deviating from 3 by how much? 4 is deviating from 3 and 5 is deviating from 3 by how much? Are you calculating this exactly? Yes or no? So tell me, x minus x bar meaning 1 minus 3. What is 1 minus 3? What is 1 minus 3? Minus 2. Very good. What is 2 minus 3? Minus 1. What is 3 minus 3? 0. What is 4 minus 3? 1. What is 5 minus 3? 2. So tell me, from the mean value, is this 1 point not in the negative 2 direction? Isn't from the mean this point 2 in the negative 1 direction? From mean, the mean itself is at 0 distance, meaning it is within calculation of itself. Then this number at 4 is 1 positive distance, and this number to 5 is a 2 positive distance. Did it not give me the spread? The information, not exactly spread, but did it not give me the information of the deviation I have in the data? -2, -1, 0, 1, and 2 with the number format. Is everyone clear? We kind of got the idea of how much is this part. Okay, because you did this with x, don't you need to do this with y also? So you need to calculate something called y minus y bar. Y minus y bar. So tell me, what is 2 minus 4? What is 2 minus 4? Minus 2. What is 4 minus 4? Is it 0? What is 5 minus 4? Is it 1? What is 4 minus 4? Is it 0? And what is 5 minus 4? It is 1. Is everybody clear what we did here with the calculation of x minus x bar and y minus y bar? What did we do with this? Why did we do it? To understand how far off my data lies from the actual mean value. Are we clear? Are we clear until here? Okay, good. The next thing that we do, okay, is there any reason to take x equals to 3? What you have to do next is x minus x bar, the whole square. You know why should you take the whole square? Because isn't -2 and +2 cancelling each other out? If I want to add them together, will I be able to add them together? Will I be able to add them directly together mathematically? The minus will nullify the plus value. Agree or disagree? So that the nullification does not happen, what do? We take x minus x bar the whole square. Doing squaring of a number, what does it make sure? That the number is always positive. Agree, disagree? If you take -3 and if you square it, won't the answer will be 9? And if you take 4 square, the answer is 16. So squaring will make sure that the number is never negative. So nobody will get cancel each other out, right? So what is x minus x bar the whole square? -2 square. Can I say that is 4? -1 square. Can I say it is 1? 0 square. Can I say it is 0? 1 square. Can I say it is 1? And 2 square. Can I say it is 4? Yes. Now, if you take the summation of all the values, what do you mean by summation? Addition of all the number. So tell me, what is 4 plus 1 plus 0 plus 1 plus 4? 8, 9, 10. Can I say it is 10? Can I say that the summation of x minus x bar into y minus y bar is this? Okay. Until here is everybody clear. Until here is everybody clear. The next thing you calculate is what we called as x minus x bar into y minus y bar. Now listen to me carefully. Can I say that this data point and this data point distance is called as x minus x bar? From this data point to this data point is called x minus x bar. Now listen to me carefully. Listen to me carefully. Can I call this also x minus x bar? This distance can be called as x minus x bar. Yes, good. Can this distance be called as y minus y bar? If I multiply x minus x bar into y minus y bar, essentially what I'm doing is, this is x minus x bar, this is y minus y bar. Multiplying them together gives me this answer. If I have an area of a rectangle, length into breadth gives me the entire area. Yes or no? This point, this line is nothing but x minus x bar. This line is y minus y bar. Am I not doing x minus x bar into y minus y bar? If I do x minus x bar into y minus y bar, can somebody tell me what is x minus x bar? Is it minus 2? Is the answer x minus x bar going to be minus 2? Yes or no? Multiplied by, what is y minus y bar? Minus 2. What is the answer? Is it 4? Very good. X minus x bar is minus 1. Multiplied by y minus y bar is 0. Is the answer 0? Okay. What is x minus x bar? 0. What is y minus y bar? 1. Is the answer 0? What is x minus x bar? 1. What is y minus y bar? 0. Is the answer 0? What is x minus x bar? 2. What is y minus y bar? 1. Is the answer 2? If you sum the numbers together, 4 plus 2, what is the answer? 6. Are you clear so far? What did you do here while the calculation of this x minus x bar, y minus y bar? You have a line equation called y is equal to mx plus c. Yes or no? This is the line equation. Everybody agrees? Do you know the value of m so far and the value of c so far? Are you clear with the value of m and c? The answer is no. Isn't this the first thing you need to calculate? What is the m, what is the c, so that we can find out the line that can cross? Okay. To calculate the value of m, to calculate the value of m, using mathematical derivations. Do you understand what is derivation? You start with the base equation, you solve, and you get some answer. So, mathematically speaking, to get the value of y-intercept, or sorry, to get the value of slope, the formula is summation of x minus x bar into y minus y bar divided by summation of x minus x bar the whole square. Do we have the values for this? What is the value of summation of x minus x bar into y minus y bar? What is the answer? Is it 6 divided by summation of x minus x bar the whole square? Can I say it is 10? So the answer is 0.6. Did you just get the value of m, the slope of your line? We just calculated the slope of the line. Now listen to me carefully. Sir, how did we get this formula? Did someone calculate it? Yes. Somebody has already calculated this using mathematical derivation. If you want, so first of all, I don't think you should learn derivations, because somebody has taken enough effort to solve the derivation. Me teaching you the derivation is only going to take time, but it is not going to be important for you to know. What's important for you to know is to remember the formula. I can teach you derivation also. It's not a very complicated thing. It's a simple mathematical process. But the problem is that derivation will have no importance to you. Am I making sense? What formula it is, you need to understand that clearly. How you arrived at it can always be learned eventually over a period of time. But first, you need to understand what is linear regression, how it is applied, how can I practically implement it, then giving your energy to how did the derivation occur, who wrote it for the very first time, what is the history. I think you should focus on your priorities slightly differently. So did you understand why I wrote down the formula straight up for you so that you don't get confused? It is arrived using a derivation. This mathematical derivation is slightly complicated, slightly simple, but we have the formula. Okay. Here we are squaring the number and denominator. Yeah, I mean, this is the summation value. We are not squaring anything. It's summation of x minus x bar into y minus y bar by the summation of x minus x bar, the whole square. This will give you the y-intercept. The logic is pretty simple, but in the derivation, you will see why we do the division, because this goes on the left side of the equation. So we put it in the bottom. Okay. Anyways, this is the value of y. Now, between y is equal to mx plus c, what did we calculate? Did we calculate the value of y? It is now calculated. But do we have the value of c? No. We don't have the value of c. So to calculate the value of C, how do we calculate it? The formula to calculate the value for C, you have to use this equation. Y bar is equal to mx bar plus C. Now tell me, in this formula or in this equation, do we have the value of x bar and y bar already given to us? What is the value of x bar? X bar is equal to 3 and y bar is equal to 4. Yes or no? So you have this equation called y bar is equal to mx bar plus C. Okay. To calculate slope of any line, mathematically, you have to calculate the delta, the difference. Meaning, if you have a line here, right? This difference in y and this difference in x will help you calculate this. And while the derivation of linear regression was done, right? So पहली चीज क्या है ना, हर फॉर्मूला मैथमेटिकली सेंसिबल हो ये जरूरी नहीं है. लेट मी आल्सो टेल यू व्हाई. आप पहले सुनिएगा ध्यान से और समझने की कोशिश कीजिएगा और फिर मेरा तर्क समझिएगा कि मैं क्यों ऐसा कह रहा हूं. एक मैथमेटिकल डेरिवेशंस में क्या होता है, जो डेटा होता है, जो नंबर होता है, वो किसी फॉर्मेट में होता है. जैसे एक आपको एक एग्जांपल देता हूं मैं. हमने इनिशियल एग्जांपल जब किसी डेरिवेशन का लिया तो वो डेरिवेशन में हमको बहुत सारे अजम्पशंस लेने पड़ते हैं. लेफ्ट हैंड साइड, राइट हैंड साइड को 10 से डिवाइड कर दिया. लेफ्ट हैंड साइड को लॉगरिदम, नेचुरल लॉगरिदम से डिफरेंट बेस लॉगरिदम में कन्वर्ट कर दिया क्योंकि वो नंबर्स मैच नहीं हो रहे हैं. तो क्या होता है, इवेंचुअली हम किसी डेरिवेशन को जब स्टार्ट करते हैं, स्पेसिफिकली ये लीनियर रिग्रेशन की जो डेरिवेशन है ना, आपको अगर मैं पूरा डेरिवेशन सिखाऊंगा तो आपको समझ में आएगा कि क्या हो रहा है. कि इनिशियली जब हमने स्लोप को लिया था, जो स्लोप का एक्चुअल फॉर्मूला है हम उसी को कंसिडर करते हैं. बट इवेंचुअली जब हम इसको ना सॉल्व करते हैं, मतलब सॉल्विंग फॉर द लेफ्ट हैंड साइड एंड राइट हैंड साइड, जब हम सॉल्व करना स्टार्ट करते हैं ना, तो हमको रियलाइजेशन होता है कि मे बी लेफ्ट एंड राइट में ना कुछ और ऐड करना पड़ेगा ताकि वो बैलेंस आउट हो जाए. करते 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 जाते हैं तो इवेंचुअली वो जो फॉर्मूलाज हैं वो थोड़े डिफरेंट फॉर्म में कन्वर्ट हो जाते हैं. फिर हमें क्या करना पड़ता है, एम के लिए ऊपर वाली वैल्यू को नीचे लेके आना पड़ जाता है. तो क्या हो जाता है कि आपका ये जो समेशन ऑफ एक्स माइनस एक्स बार द होल स्क्वायर है ना, ये लेफ्ट हैंड साइड में आता है और ये जो समेशन ऑफ एक्स माइनस एक्स बार ये राइट हैंड साइड में आएगा. तब क्या होगा, ओवरऑल जब हम सॉल्व करना स्टार्ट करते हैं ना, तो ये समेशन वैल्यूज जो है, जो ये आपको ये फॉर्मूला दिख रहा है, इट स्टार्ट्स सॉर्ट ऑफ फॉर्मिंग इनटू दिस पर्टिकुलर फॉर्मूला. जो आपको ये दिख रहा है ना, ये इस फॉर्म होना स्टार्ट होता है. एक काम करते हैं, व्हाई डोंट वी सॉल्व द डेरिवेशन आल्सो सामने ही. इफ यू रियली वांट टू अंडरस्टैंड मशीन लर्निंग, yeah, the point is, if you want to deeply understand machine learning, like when I'm talking about deep, because here is the thing, when I started machine learning, right, I have implemented each algorithm, every algorithm in machine learning from scratch. I have done that. That is when my knowledge in machine learning increased 10 times. Because when you do not use any packages, any libraries, understand the core mathematical concepts, you should be able to like build anything because you now understand the basis behind it, right? Just like that, learning the core mathematics is important. The reason I am not going ahead with the derivation and explain you logically how did we arrive at this conclusion is because it will end up taking a lot of time. Number one. Number two, the mathematical reasoning that it takes to arrive at this solution is also going to be very, very complicated for few people. So that's why I said, if you start with machine learning right now, you guys are just starting with machine learning, right? Focus on how to apply machine learning, then learning the foundational logic. But because if the question is, how did we arrive at this conclusion? We can always go back and learn the derivation also. So it's up to you guys. I mean, if derivation is also something that we can look at, we can also look at this. The derivation will make sense. Why are we taking this area x minus x bar the whole square will start making sense because it is directly related to residuals. So now that we've understood, right, slope of the line using the data point or variable, which is one independent, one dependent, we are able to calculate the equation, slope using this particular formula. Now that we've understood how we calculated that using the slope, the next thing that's pending is for me to calculate the y-intercept, okay? Because y-intercept cannot be calculated directly, I need to manipulate my equation slightly differently, like y is equal to mx plus c. because we don't have M and we don't have C, right? We don't have Y and X. We calculate Y bar and X bar. X bar is already given to me as 3 and Y bar is already given to me as 4. So tell me, what is the value of Y bar? Is it 4? Is equal to, what is the value of M? 0.6. What is the value of X bar? Is it 3 plus C? So mathematically, if I solve this, 4 is equal to, what is 0.6 into 3? Is it 2.2? Okay, that's good. 2.2 plus C. Now, listen to me. In mathematics, when you jump equal to signs, you convert the sign from positive to negative or negative to positive. Meaning, if this 2.2 needs to jump to the other side of the equal to, what will it become? Will it become 4 minus 2.2 is equal to C? Yes or no? Whenever you change the number from one part of the equation to the other part of the equation, if it is a, so what will be the value of C? What will be the value of C? 2.2. Wait, 0.6 into 3 cannot be 2.2. I don't know if it makes sense to me, because 6 threes are 18. It should be 1.8, right? If I'm not wrong, 6 threes are 18. Point difference is 1.8, right? Yeah, this should be, I think the difference is 2.2. I think this is what you mean. Yeah, I think I got the concept. Okay. This is C.2. Yeah, it's D is 2.2. Exactly. So tell me, did you get the equation y is equal to mx plus c, and now you have an equation for the line 0.5 into x plus the value of c will be 2.2. Did you get the line equation for your data using the steps that we have done so far? We got the equation called y is equal to mx plus and we got the line. But our job is not yet done. Until here, is everyone clear? Until here, is everybody clear? What exactly did we do to solve until here? Everyone got the concept until here. 0.5 or 0.6. But there is so much more to achieve. Meaning, you got the line equation 0.6x plus 2.2 something, something, something. My people, based on the linear equation graph that you see that I have plotted for you like a while ago, which is this. Okay, give me 1 second. Let me copy the graph. Give me 1 second. Let me just go ahead and copy this and paste it here. Give me 1 second. Copy this and paste it towards the bottom. My people, we got the equation of the line equation as y is equal to something, something like this. Like, so we got a line equation that passes the data like this. But observe very, very carefully that the distance between your actual data point, is this my actual data point? AP is my actual data point. AP is the actual data, the real data. And the line is the prediction. Agree or disagree? This is my predicted data and this is my actual point and predicted point. Can I say it like this? Do you see there is some difference between it? Some distance, some error? Yes or no? This error exists here also. This error exists here also, here as well, and here as well. There is some distance between this, and this. The data points are distance. This distance or difference is called as residual. What do we call this? What do we call this? Residual. Tell me, the point is very simple. When you make linear regression line happen, or when the linear regression line has been calculated, do you want the distance between data point and the actual point to be the least as possible or to be the maximum as possible? What should your intention be? Your intention should be to minimize, right? Your intention should be to minimize the residual, but your life and your job is not that simple. Let me explain why. Let me explain why this is not simple. Listen to me carefully. I'm going to erase these data point, okay? The line point, and I'm going to show you guys an example. Mathematically, also sensibly, it should make sense to you. Okay, give me 1 second. Let me copy this graph and paste it so that I don't ruin the graph. Give me 1 second. Why am I not able to copy? Okay, this is the copy, is it? Okay, fine. Yeah. So listen to me carefully. I'm going to erase the middle line for a second so that you guys don't get confused, okay? X bar, Y bar, I'm going to remove. My people, now we have a line that passes through the data like this, okay? It is passing through the data point like this. Listen to me carefully. And it is passing through the line like this. Like this is the line that we have calculated, okay? This is the distance between the predicted data point. This is the predicted data point, and this is the actual data point. Okay. So tell me, isn't this data point the data point which is predicted versus this is the actual data point? This is the data point which is actual, that is, this is predicted, that is actual, this is predicted, that is actual, this is predicted, that is actual. So listen to me carefully. This is the error, also called error number 1. Can I call this difference as error 1 E1? Yeah, can I call this error as E1? Okay. Can I call this error as E2? Can I call this error as E3, this error as E4, and this error as E5? Can I call this E1, E2, E3, E4? So the best possible line for me to claim that the line that I have has the best fit. It's fitting the data points in the best possible way. So shouldn't that be possible that E1 plus E2 plus E3 plus E4 plus E5, this number should be the most minimum number as possible? Yes or no? The number E1 plus E2 plus E3 plus E4 plus E5 should be the most smallest number possible. But the problem here is some data points are following in the positive direction, meaning in the bottom, and some number are at the top. So isn't it possible that E1 and E2 will also cancel each other out because the directions are different? Does that make sense? See, from this data point to this red data point, it is in the negative direction, but E2 is in the positive direction. So if I don't square them, won't they also cancel each other out? And the actual answer will be terribly wrong. So rather than combining E1, E2, E3, E4, E5, do we not take E1 square plus E2 square plus E3 square plus E4 square plus E5 square? Agree, disagree? Now listen to me carefully. Listen to me carefully in a most simplistic sense. Okay. If I take this line and rotate it a little bit more, the line that we have calculated it just for practical purposes, just to test something, can I rotate it a little to the left and a little to the right? And when I rotate it 2 times to the left, one left, one left, one right, I got the value of error, ERROR, TOTAL, total error as 1.6, 1.2, 1.9, and 2.3. When I rotated the line, which line gave me the least amount of error? In this 4 rotation that I did, 2 to the left, 2 to the right, did this give me the least amount of error? That line is your best fit line. Did that logically make sense? Did that logically make sense? Okay. Can I show you an example? Can I show you an example practically to show you how in reality, in linear regression, how it works? You guys want to have a look? Have a look at this, okay? Linear regression, best fit line, okay? Fit line. Look at this, my people. This is my linear regression data. Can you see what's happening to the line? Did you see what happened? Did you see what happened? See, I'm going to rotate the line, okay? I'm rotating the line. Is the error increasing and decreasing? Are the errors increasing and decreasing because of the rotation? Have a look at this also. See, this is the best fit line. Do you see the mean of X and mean of Y? Do you see the mean of X and mean of Y? We took the red color line. On that point, are we rotating the line that we just calculated Y is equal to mx plus c? When the rotation when we do that rotation, isn't it possible that we can get the value of multiple different error types? And whichever error has the least possible error, that line is the best fit line. Did you understand the logic behind how linear regression is able to calculate the least amount of error? And that line is going to be the best fit line for your example. Is everyone clear what we did in linear regression? First, we plotted the data. Then we took the X bar and we took the Y bar. Sir, we have to code for this. It's too long. The entire linear regression code is 15 lines of code. 15 lines. Without any library. Without any library, it's 15 lines of code. Do you think it's too much? Point being, first we plotted the data, then we took the mean X, mean Y. From that point, we passed the problem or we passed the line, and now we are rotating the line a little bit to check whether the data or the line is the best fit line. Did you get what exactly I was saying? What line rotation is showing exactly? Line rotation shows you the distance between the error. Meaning, suppose if this is the graph that I have, okay, this is the graph that I have, this is line number 1. Is it not possible for me to rotate the line slightly and have another line like this? If I rotate the line, the distance between actual data point and your prediction data point, does it not change? And your job is making all the errors together, E1 plus E2 plus E3 plus E4 plus E5, all the errors together. Don't we want a number, a value of the line where all the errors together is the least number possible? That is why you rotate the line. Rotate the line. The only thing you need to change in your equation is M, right? Because Y will remain the same. Or no? To rotate the line, what do you need to change? Both M and C, right? You need to change both M and C together for the line to rotate, right? So multiple values of M and multiple values of C will give you the answer. Isn't this like the initial guess of the line? The initial guess of the line, is it the best fit line? The first product you buy, is it the best product? No. We just made a guess on the Y, axis equation. We did that. But is that line the best fit line? Are you sure that is the best fit line? Can you be sure? No, right? In order for us to understand which is the best fit line, we take the line that we just calculated and we rotate it a little bit. Based on the rotation, whichever error value has the least error, that is the best fit line. Now, my question is, how many of you got this and how many of you did not get it? Let me take up a quick poll. How many of you got it? Yes, yes, yes. How do we calculate it? How do we do it? I'm going to teach you all of that. How many times to rotate? The higher you rotate, the better chances of best fit line it is. The higher you rotate or the longer you rotate, the better the chances you will find a best fit line. If we rotate, are we not changing the C 2.2 which we calculated? Yes, we calculate both the L, M and C, we change and we check for multiple C and M. Okay, let me explain. How do we rotate? How do we rotate? Let's understand. Let's understand the rotation. Is this my line with some value of M and C? Yes or no? You first please tell me that. Is M is equal to, is the value of M 0.6 and the value of C 2.2? Yes or no? If I want to rotate, this is the line, okay? This is the line which will give me this y M is equal to 6.6. If I want to rotate it by 1 degree, 1 point, increase M and decrease Y, can I do this? Or decrease M, increase Y, can I do this? Are you getting what I'm trying to say? This is my XY graph. This is my Y point on which the line is plotted. And this slope of the point is 0.6. Make it 0.5 and make the intercept here. Will the line now rotate by some point here? Increase point number 1 by 1 more point, decrease the slope by 1. Will the line rotate now? Same thing, keep doing. Increase the point by 1 and decrease the point. Did you now rotate the point slowly, slowly, slowly by changing this decrement by 1, increment by 1? And now if you do the reverse operation, it will go in the opposite direction. Agree, disagree? Am I making sense? In this part, at least in this part, 1.1 increase. Won't you be able to calculate for multiple values of Y, like the line will rotate? This is the line equation that we calculated. Listen to me carefully. Based on the data, what did we do? Based on the data, what did we do? Did we calculate the y is equal to mx plus c equation? That was the first thing that we did. Yes or no? Y is equal to mx plus c was the first thing that we calculated. The line equation that you calculated, y is equal to mx plus c. How sure are you that that line is the best fit line? Can we be sure that the line equation that I calculated, y is equal to 0.6 into x plus 2.2, this is the line which is the best fit line. What do you mean by best fit? The line passes through all the data point in the most perfect way. Are you sure that this is true? Should you not validate that? We are not sure. Should we validate? The answer is yes. You need to validate. In order to validate, how do we validate if something is good or not? Mathematically, we need to have some foundation for it, right? How do we identify somebody is a good ranker, somebody is a bad ranker? Shiv Kumar, who spoke to me a while ago, is a Bihar topper. How do we know he's a Bihar topper? He must have gotten good score. His percentage would have been higher. The number would have been bigger. If the number is smaller, does it equally mean that the person did not score well? Yes or no? This is called mathematical quantification, meaning some number is trying to give us the idea. So tell me, suppose I have a line called line number 1. This is my line. This is the line. My people, this red color point, is it my actual data point? Is this the actual data point that was available in the data? Good. But using the line, did you predict another data point, which is your prediction? This point on this line is your prediction. This is not the actual data. This is your prediction. Yes or no? Can I say the distance between the prediction versus the actual value is -2? Example. For example, it is -2. Can I say this? Good. The distance between this data point, the red actual data point, and this data point is +2. The distance between the red data point and this data point is +3. The distance between this data point and this data point is -3. And the distance between actual data point versus this predicted data points is -2. Example. So far, the total error in the program is nothing but the difference, right? Difference between the actual and the predicted is what the error will be, right? So -2 plus 2 plus 3. Okay, so -2 plus 2. Let me expand it and write this, okay? So let me say -2 plus 2 plus 3 plus -3 plus -2. If I add them together, will this not be the actual difference, the error in my program? Isn't this going to be my error? But -2 will cancel 2, plus 3 will cancel 3, and the answer is -2. Is the answer actually -2? No. Even if they are not equal, even if the numbers are not equal, okay? The problem here is mathematically, if this number was -2 and this was -2.1, won't the answer be 0.1, which is also not correct? The numbers don't need to be equal, but they cancel each other. They take a portion of each other. We don't want that to happen. So rather than taking errors like that, don't we square them, the errors? Yes or no? So rather than taking the answer like this, if I want to quantify the number, can I not take -2 square plus 2 square plus 3 square plus -3 square plus -2 square? The answer will be 4 plus 4 plus 9 plus 9 plus 4. Can I say now this will be some number that represents the error? Are we clear until here? Dipankar, even if it's not equal, it does not matter, my dear, mathematically. It won't make difference also. If one direction it's -2, other direction it is unequal number, errors will still get added together, right? At the end of the day, you're adding the errors together. It does not matter if you have 10 rupees, 15 rupees, 19 rupees. It does not matter what number you have. The errors at the end of the day are getting added together, but you're trying to nullify them. I am not nullifying them. I am taking the difference between the actual data point and the predicted data point and square them. I am saying that you should square it. I am not saying nullifying it. I am saying square it so that nullification does not happen. I know positive and negative predictions. That's why I'm saying squaring them will convert it into a positive number, and all the positive numbers you can add together. You got, this is a very simple thing, my dear, not a very complicated thing. -2 and +2, if you square, -2 square is 4, +2 square is 4. If you add them together, did you get the value 8? 8? Agree, disagree? Yeah, okay. Even if you have 15 points, 1500 points, whatever points you have, the distance between the actual versus predicted data point, you need to square them in order to get the error. So tell me, what is 18 plus 12? What is 18 and 12? So 8, 9, 10. This is going to be 30. So did we get the error? The total error using the line is 30. Yes or no? We are not nullifying anything. We are trying to get some number. Okay. Now tell me, I'm asking a very simple question. Very simple question. Are you sure this is the best possible line in the entire data that you have? No. If I rotate the line slightly to the bottom, isn't it possible that that total error now will be 29? Slight rotation gave me the error as 29. And we want the error to be as minimum as possible. So will you choose line number 1 or will you choose line number 2 as the best fit line? If this is my line, okay. Do you guys know that in mathematics, you can take a range between 0 to 10? I can take 0, 1, 2, 3, 4, 5, 6, 1 point at a time. This also is possible between to reach 0 to 10. Okay. 0 to 10 can be reached by 1 unit distance, meaning between 0 to 10, I can reach 10 by exactly how many steps? 10 steps, correct? Taking 1 at a time. Agree? Yes or no? If I want to count from 0 to 10, but I want to take 1 step at a time, so can I take from 0 to 10, making only 1 step at a time? I'll be able to reach 10 times. But same 0 to 10, you can reach in 20 steps by taking 0 0.5, 0, 0 0.5, 1, 1.5, 2, 2.5, 3. Can I say you can reach from 0 to 10 using also 40 steps by taking 0. I don't know, 25? How much to rotate? Should it not depend on how much you want to increment your MNC? Am I making sense? Your y is equal to mx plus c. Your value of m was 0.6 and your value of c was 2.2. Your m can be 0.65, meaning 0.05 times your increment, one step, one step, one step, one step, one step. Or you can also do 0.1. So 1, 1, 1, 1, 1. Does it not depend on the user how much you want to rotate? Does that make sense? And because it is a computer program, we can make it do millions of rotations. That line could be rotated in the positive direction and in the negative direction. And let me ask you a question. Let me ask you a simple question. Did we not calculate the mean of x and the mean of y like this? Did we not calculate the mean of x and mean of y? Should you even rotate it beyond this and beyond this? Meaning, should the line go beyond this point and beyond this point? It should be between the points, right? If it goes beyond, are you even calculating anything? I hope you got the concept. Did you get the concept of rotation? How exactly linear regression is able to do that? How are we able to find the best fit line? Exactly. Exactly. Thank you. Are we clear with what exactly is the definition of linear regression? how it is able to do it. It is a very simple machine learning algorithm that's able to do it. And based on that, and based on the best fit line, we will be able to make a prediction in the future because that line has the least amount of error. So if the prediction in the future is that for 4,000 square feet house, it is 2 crore, meaning it actually in reality is 2.2, but R isn't 2 crore nearer to 2.2? Meaning, with some error, we were able to very closely identify the answer. That is why linear regression is used. Concept of what is R square, okay? My people, in linear regression, R square represents a very simple information. And that information is R square tells us how well the line predicts or fits the actual point, or how well the line predicts the actual point. This is technically more correct. So R square tells us, okay, R square tells us how well, how WELL, the line predicts, okay, predicts the actual points, POINTS, okay. R square is a way to tell yourself that your model is doing a good job, or your model is doing a bad job, or your model could do better. Okay. This is a way to quantify it to yourself. Now you can ask me one thing, sir, why don't we have a quantification already with something called residual error? We do. The problem is linear regression has a very big problem, and that problem is outlier. If you have a line of a linear regression where you have one data point here, one data point here, one data point here, one data point here, and one data point here, this is known as the best fit line. Okay, the red color thing is gonna be my best fit line. But by mistake, if your point is somewhere here, right, then your best fit line would go somewhere like this. So tell me, does outliers affect the output of your linear regression model? Does having an outlier create problems? Sir, 100% it will create problems. If you don't know, I'm telling you this right now. So removing outliers from your data should be an essential part of your EDA. Have you all heard of something called EDA? Has anybody heard of the concept called EDA? The full form is called exploratory data analysis. It's called exploratory, okay, data analysis. Are we clear? So now that we have spoken or learned about R square, what exactly is R square? Take a line. Listen to me carefully. Take a linear regression line. Okay. So for example, if this is like the y-axis and this is like the x-axis. Okay. If this is my x-axis and this is my y-axis. And suppose you have data points like 1, 2, 1, 2, 3, 4, 5, right? Like this. One. Suppose if you have a data point like that. R square, most simplest form I'll explain. Okay. It is nothing but the distance between and the distance between. Okay. There are two distances we will calculate. The actual value minus mean value, the estimated value minus mean value. When we did linear regression code, okay, when we wrote this graph in front of you, right? I'm not sure if I can copy this, but I'm gonna try my best. Give me 1 second. Oh yeah, I can. Control X. Yeah. Okay. You see this graph? We did this graph. Whoever does machine learning well, their level will be the best, is what I meant. You know what I think? Listen to me. Listen to me. Okay, listen, because this is a very important concept. Here's what I think. I think all of you need to make a Google sheet. A Google sheet. In that Google sheet, just write down your name and your address. Your name and your address. And what I'm going to do is I'm going to have a deal with Swiggy. And I'm going to be like, look, 7 o'clock I start my class. 6:45 I want you to send tea. or coffee based on whatever preference you have to all my students so that they wake up. But before delivering the copy, take a hot water and just like on their faces so that they are up. Yeah, we'll speak about that. I think this is a good startup idea as well. It's a very simple idea. I am teaching you the concept of R square. R square tells you how good your model is or how good the estimation. What do you mean by estimation? Prediction only, right? Estimation is prediction only, right? You have some actual data point. You having actual data point is called ground truth. Remember, in machine learning, this is a very important term. Ground truth. GROUND. TRUTH. Ground truth means your actual data. It is a very important technical term. Just like how in marriage, I am sorry works every time. It's an important keyword. Ground truth is an important keyword. It represents all your actual data point. Okay. So now your ground truths are your actual data points and your line is the estimated data points, basically the one that you have estimated, right? So tell me, do you have something called the Y bar? This thing is called as the Y bar, the mean of the Y, the Y mean, okay? On this particular plane, what two things do you see? One is the Y bar and the other is the actual data point, correct or not? There are two things on the graph right now. One is the Y bar and the actual data point. Can I plot a line, a regression line like this? So now what do you see? You also see the predicted line. Now there are three things on this particular graph. Make sense? Now there are three things in the graph. The distance between actual data point and mean. Listen to me. The distance between actual data point and the mean value. Is this the actual data point? The red dot? The distance between actual data point and mean. So can I say this is the distance between actual data point and mean? This is the actual distance between data point and mean, and rest is on the same tribe. So this distance is what we are calculating first, the actual distance between data point and mean. Yes or no? Good. Then the next difference we calculate is estimated minus mean. Meaning, can I say these is the actual data point, the red one, and the yellow one is the estimated data point. This is the estimated data point. This is the estimated data point. And this is the estimated data point. The next thing you do is you calculate the distance between estimated minus mean, estimated minus mean, estimated minus mean, which is this much, okay? Estimated minus mean and estimated minus mean. Did you get what I'm trying to say? The distance between actual data point minus mean data point and estimated minus mean. And when you want to do their comparison, this comparison is what we call as R square. Are we clear? It's not a very complicated topic. Everyone got the concept, right? You got the concept very, very well. So tell me, can I expand your knowledge now on how to do this mathematically? Again, I am not showing you how the formula has come up into picture, but like we have to take y-axis mean only because y is enough base for comparison. You got what I'm trying to say? Y is also an axis, which is a mean value. X is also a mean value. Taking from y makes more sense because you are doing y prediction. I hope you got what I'm trying to say. Your equation is y is equal to mx plus c, right? So y becomes a solid base. Okay. R square is the distance between the actual data point minus the mean data point. You compare against the estimated data point minus the mean data point. No confusion here, right? It's a comparison, simple comparison. It does nothing else. I'm going to show you mathematically what it does. Okay, good. I am going to take the X and the Y from the code. Give me 1 second. The X and the Y. Copy. Is this the value of X and Y that we have? Tell me, what will it mean if I do this? Y minus Y bar. What do you mean if I do Y minus Y bar? Is this line actual minus mean? The actual data point minus the mean is going to be called as Y minus Y bar, yes or no? This is simple logic. You guys must have learned that by now. So tell me, what is Y minus Y bar? 2 minus 4. What is 2 minus 4? 4 minus 4. 5 minus 4. 4 minus 4 and 5 minus 4. What is the answer, everybody? What is 2 minus 4 minus 2? What is 4 minus 4? 0. 1. 0. 1. Can I say this is the answer for actual minus mean Y minus Y bar? Can I assume my understanding is correct? Because the numbers could be both negative and positive, we don't want that. What do we do with those numbers? Whenever the number starts becoming negative, very good. So do we take Y minus Y bar the whole square? So does it become 4, 0, 1, 0, 1? Now, tell me, if I sum the number up, if I calculate its summation, what will be the answer? If I sum them up, 4, 5, 6, 6. Let's calculate something called Y hat. Y hat is nothing but, what was the equation that you got? What was the value of M that you got here? 0.6 and 2.2. 0.6 and 2.2. 0.6 into X. What is the value of X? 1 plus 2.2. Can somebody tell me what is the answer? 0.6 into X is 2 plus 2.2. 0.63 plus 2.2. 0.6 into 4 plus 2.2. 0.6 into 5 plus 2.2. Am I predicting the estimated data point here using the Y hat? Yes or no? This would be 2.8. 1.2, 2.2. What? This should be 3.4, right? If I'm not wrong. Right? 4, 4.6. Yeah, that's true. And that would be 5.2, right? 4.6 and 5.2. I'm assuming this is correct because it is at a very standard difference. Is it correct? Is my Y hat prediction correct? 2.8, 3.4, 4, 4.6 and 12, 5.2. Correct? Okay, good. Did you all understand what is Y hat? Y hat is the estimated data point. Using the equation only we calculated the estimated, right? Using the equation only we will calculate estimated, correct? So tell me, my people, I have actually taken something called actual data point, actual point minus mean I have taken. What am I remaining with? What is remaining? What is missing here? Which point is remaining? Estimated minus mean, correct? See, actual data point minus mean is taken. Estimated minus mean is not taken. What is your estimated value? Y hat. What is the mean value? Y bar. So what is the estimated value, my people? 2.8 minus what is the Y bar? Is it 4? What is Y bar answer? Negative 1.2. 2.8 minus 4 will be negative 1.2, correct? You know what? You do the hard work. 3.4 minus 4. 4 minus 4. I will write the answer. It is easy. Minus 4 and 5.2 minus 4. Come on, give me the answer for all of these. What should be the answer? Negative 1.2, negative 0.6, 0.6, and 5.2 minus 4 is going to be 1.2 because similar answers. Aren't these answers in plus and minus? Do we like answers in plus and minus? Do we like the answers in plus and minus? No. So what do we do? Y hat minus y bar the whole e square. What is whole e square? Everybody, what is 1.2 the whole square? It becomes 1.44. What is 0.6? 6 twos are. Nah, it's not done like that. It's going to be 0.36. Yes or no? 0. 0.36 and 1.44. Now what do we do? If I sum the number, what answer do I get? What is the answer? If you sum them together, 3 point. Is it correct? Is the summation going to be 3.6, everybody? That's good. That's good. Once you have calculated this, your R square formula is very, very simple. Your R square formula is summation of y hat minus y bar the whole square divided by summation of, what are you comparing it against? Estimated minus mean is compared against actual minus mean. What is the actual minus mean? The actual minus mean the whole square. So tell me, what is the number that we got? Is it 3.6 divided by 6? What is the answer? What is 3.6 divided by 6? What would be the answer? About 0.6. Remember one thing. R square is a number between 0 and 1. What is the number R square? R square is a number between 0 and 1. If your R square is closer to 1, the fit is good. If your R square is closer to 0, the fit is bad. What R square did we get? What R square did we get? Closer to 1. So what does it recommend? Is it recommending something that my fit is good? But R square has a problem. You know what is the problem? I'm going to show you what is the problem. R square formula. You are going to be very much confused when I show this formula, right? Have I taught you the formula like this? Okay. Did I teach you the formula like this? Y minus y hat the whole square, y minus y bar the whole square. Is my formula different from this formula in what way? Copy image and paste it here. Okay. What's the difference in my formula and this formula? Please, somebody tell me fast. Nope. Look at the numerator and look at the denominator. Y minus y hat. And here I have y hat minus y versus y minus y bar. Okay. Actual minus predicted and estimated minus mean. Okay. Two things. I'm also going to show you guys one more formula. Okay. I'm going to show you guys it like this. Okay. Give me 1 second. Copy image and paste it here. Is this visible to all of you? Is this image right there visible in front of you? Listen to me carefully. Do you see this thing called SSRES? SSRES. The full form of this is sum squared residuals. Residuals. And the third is SS tot. Sum squared total error. Okay. TOTAL. Now, I don't want you to get very much confused with this concept that, oh my God, what is this new thing? It's nothing. It's nothing. Literally nothing. Okay. The formula that I gave you. Okay. The formula that I have given you, which is this formula. Here, R square is nothing but sum of squared residuals divided by sum of squared total. Sum of square residual divided by sum of square total. You have to think of it like this. In R square, okay, while calculation of R square can be expanded in multiple different forms, like sum of square residuals by sum of square residuals plus sum of square error. Okay, that becomes sum of square total. When you rearrange the terms, you get an answer like this. 1 minus, okay, summation of y minus y hat, which is the actual minus estimated actual minus, actual minus predicted, which is y hat, and actual minus mean. When you say you're comparing, you're basically dividing one comparison with another comparison, and you're taking something called as a ratio. Now, I am going to ask you guys a very simple thing. Do you know what is the meaning of the word ratio in mathematics? Let me give you guys a very simple example. Very simple example. Tell me, if you had 4 chocolates and 2 people to share it with, per person will get how many chocolates? 2. Reverse the situation. You have 2 chocolates, but 4 people. How many will each person get? About 0.5. Agree, disagree? Okay. This number represents the power of the method. Meaning, when you divide a larger number by a smaller number, you get a number which is significantly different. When you divide a smaller number by a larger number, you get a significantly different result. What do I mean by that is, does the answer of the division represents the equal parts for that particular division? For 2 people, you get 2 chocolates. For 4 people, you're going to get this chocolate. Division of A divided by B will give you some value called X. B times X is always going to be A, right? X into B will always be A. It will always come back to A. The value X represents equal portions. Equal portions for the value at the top, or equal portions with the value at the bottom, meaning sum of squared total, right? You will get some answer called X. Has a relationship with this number. This X number represents the equality among the equation, or equality among the among this particular division. Meaning, whenever you take R square and the number is larger to 1 or closer to 1, whenever your R square is closer to 1, what does that represent with numerator and denominator? What should it represent? Under what condition will be the number closer to 1? If the numbers are closer to each other, or if the numbers are far away from each other. Meaning, you have a value called A, you have a value called B. Between A and B, if the number of A and B, if they are closer to each other, will that become 1? Or if they are far away from each other, will that number be 1? Please think and answer, okay? Please think and answer. If the numbers are closer to each other, meaning, let's take the example 3.6 divided by 6. 3.6 divided by 6. What is 4 divided by 6? Very much tell me, what is the answer? What is 4 divided by 6? This is not a very hard calculation. What is 4 divided by 6? 2 2s are 4, 2 3s are 6. What is 2 divided by 3? 0.67 approximately. What is 5 divided by 6? What is 5 divided by 6? 0.83. What is 5.5 divided by 6? 0.92. Let me ask you guys a simple question. When your sum of squared residual error, which is sum of square residuals divided by sum of square total, when both the errors are very close to each other, is your R square saying that the model is a good fit? Listen to me. But what does that mean in the graphical format? The closer the lines of estimated and minus mean or actual minus mean are, the better the R square. Meaning, when all the distance between the actual minus mean and estimated mean is as less as possible, the numbers will be closer to each other, and hence the R square will be bigger. You got the concept? If the distance between the actual minus mean and the estimated minus mean is as closer to each other, the numbers will be as closer to each other, and the R square will be equal to or closer to 1. And that will represent a good fit in the model. Did you guys get the logic behind it? You got the concept behind it, right? Why R square is preferred for the choosing or for the recommendation that my model is good or not. Are we clear? Is everyone clear until here? You guys got the concept? Okay. Now listen to me. Do you see this formula? Do you see this formula right in front of you called adjusted R square is equal to 1 minus R square into n minus 1 by n minus p minus 1. You see this formula a lot? Okay. So just listen to me, okay? Just listen to me. If you do anything wrong in your house, do we get punished? I'm not sure if the kids nowadays or the parents nowadays even hit their kids, but yeah, I mean, I was the champion at my time, right? Like anybody used to just, but you do anything wrong, you get punished, right? In machine learning, this technique is called penalization. What do we call this? What do we call this technique as? Penalization. I have a very simple question I want to ask you. This question is going to come in your interview. It's going to be asked in your interview. This is not a 5-star. This is a 100-star question. My people, what is the difference between a machine learning model where you have A, B, C, and D and a target column? How many independent columns exist here? In technical term, they are called as features. Features. So from now on, do not call it independent column, call it feature. How many feature columns are there? 4. How many target column are there? 1. Correct or not? If I want to run machine learning on a model or on a data where the number of features, features, is 100 columns and the target is 1. Do you think that machine learning should have no problem in running 4 feature, 1 target, 100 feature, 1 target? Or do you think the machine learning model will get a problem? My question is, if the number of features increase, listen, this is a very important question I'm asking you. Trust me, this is very important. If the number of features increase in linear regression or any machine learning model, okay, not just linear regression, if the number of features increase, does that cause problem in the machine learning modeling? The answer is yes. The answer is 100% yes. I'll tell you why. Listen to me why. For the prediction of some answer, for the prediction of some target variable, I'll tell you why this is a problem. Listen to me. Listen to me. I'll tell you why this is a problem. Suppose you have a column called age. You have a column called salary. You have a column called blood group. You have a column called civil score. You have a column called DPDs, days past dues. Oh, XYZ, XYZ. And the target column is whether this person should be given loan 0 or should be given loan, yes or no. Tell me, for the prediction of the loan, will the age column also will be like a person? Hey, you should consider me also for your prediction. Then there will be one more person called salary. Hey, you have to also consider me for the prediction. Then the background will be like, hey, I am also existent. Sibyl say, I am also here. DPD say, I am also here. More the column, won't there be more chaos because so many people are saying prediction should be 0, prediction should be 1, and the machine learning model will be confused. More the columns, more the people are talking. All the columns are saying, you have to listen to me, you have to listen to me, you have to listen to me. Won't the model be confused? Who do I listen to get my prediction? Right? And it is good to be wrong. My people, when I started machine learning, okay, and when I learned machine learning from my instructor used to also ask me questions the way I'm asking you. And I used to also say no, and then I used to say yes. It's okay. It's a fun part of the game. That's the beauty of learning together, right? The point is, the more the columns you have, the higher the chances of something called overfitting. Okay, I have not taught you what is overfitting, underfitting, but more the chances, more the overfitting. So tell me, does it not mean that by default, if a model, a machine learning model with 4 columns exists and a machine learning model of 100 columns exists, because the numbers of columns are higher, R square will always be closer to 1 because the number of columns are so many. So don't we want a true measure of R square? Even if the columns are 2000 tomorrow or 100 or 4, you give me the proper value of R square. Yes or no? You got what I'm trying to say? If the numbers of column increase for a linear regression model, higher the columns, R square will always be pointing to 1. But is the real value of R square 1? No, sir. It's because more the columns, more the representation. So don't we need to adjust our formula in such a way that even if the number of columns are higher, it will give us the right value of R square. That formula is called adjusted R square, because the R square formula that I taught you, is it adjusted? No, it is not adjusted. It is not fixed. This is the formula that is fixed. So what is the formula of adjusted R square? Is R square nothing but your sample R square that you normally calculate the way I calculated? Yes, absolutely correct. But you divide the equation by total sample size. Can you see I'm dividing this by total sample size n? The sample that I have taken for the consideration of R square, that sample. At the same time, can you see number of independent variable here? This is nothing but the number of features. If your data is working with 100 features, am I not dividing and subtracting it with n? So I am penalizing the model, saying that if you take more number of features, your division also will be larger. You got what I'm trying to say? If your column is 100, suppose if your feature set is 100, I will divide you by 100. So the number also will be that much smaller. But if your column is 10, I will only divide by 10. So be careful. Don't get overconfident and take too many columns. You got what I'm trying to say? That's the logic behind the R square formula. If the number of features are higher, R square is likely to be near 1. Of course, 100%. If the number of features that you have taken are very, very large, what happens in your R square? Because each individual column will start saying that you have to listen to me, you have to listen to me, you have to listen to me. What happens in that situation? What will happen in that situation? I mean, think about it. More the number of dimension, more the number of models complexity increase. What will happen with that? If the model's complexity increase, what happens to the model? Will it get confused? So closer to 1. That is your answer. It will basically overfit itself. It gets so overconfident on the training data. On test, it basically performs nothing. Is everyone clear until here? This is the formula for adjusted R square, meaning you penalize it more. If you want to take more columns or features, I will divide you by that number of size, and you will be equally reduced in your R square. For more number of data or less number of probability of getting a good fit is high. See, let me answer this in this way. Sometimes when you do machine learning, listen to me, I'm asking you a simple question. Sometimes when you do machine learning, do you want more and more columns, more and more features? That is the requirement of my machine learning modeling, but are anyway trying to get R square closer to higher. How is it a problem? We never try to get the R square closer. And just focus on this part of the piece of code. Just be here, okay? I want to ask you guys a very simple question, okay? What data did we take for our prediction? What answer did we take for our prediction? Or what answers have we take? What data did we take week versus something, right? So what I'm going to do is import pandas as PD. Can I do this? Import numpy as NP. Can I do this? Import matplotlib.pyplot as PLT. Do I say these are the most basic kind of, I don't know, the most basic kind of approaches whenever we are writing any code? Okay. Exactly. That representation of R square is not good, because anyways, more the columns are adding and making the R square closer to 1. That is not a true reading. I'll give you guys a knowledge. Okay. Give me 1 second. So tell me, when you cook tea or when you make tea, you don't cook tea, you make tea. TEAT. For 4 people, the amount of sugar you add is 2 cup or maybe 2 spoons or 3 spoons. Agree, disagree? When you make a tea for 100 people, will the amount or the quantity of sugar that will go will be larger? This behavior is normal and is common in the human system, ecosystem, right? If you are making a tea for 100 people, of course, the sugar is larger. You make a tea for 4 people, the sugar quantity will be lesser. If you reverse this situation, what happens? Disaster. For people, you want to make 4 cups of tea, adding 100 cups of sugar. And for people, 100 cups of tea, you make 2 cups of sugar. Is it disaster? Okay. So according to the size and the quantity of the data, should you adjust the sugar size? Larger the feature set, do I need to penalize it, control it, maintain it, so that the R square value that I get is not a number closer to 1 by default? That is not the true number. That is not the true representation of the number. I hope you got what I'm trying to say. That R square is not the true representation. The actual R square should be adjusted, because automatically when the number of features are larger, it becomes overconfident and says that R square is 1. But in reality, R square is 60, 0.60, 0.70. It shows 0.9. Not good. Penalize. The logic is clear. Why we do this? That's why we do this. Have I taken all the packages? Matplotlib, NumPy, Pandas, and all of that. Weeks underscore data. Tell me, how many cars do I get to sell in a week? 1 week, 2nd week, 3rd week, 4th week, and 5th week. I only took till 5th, right? If I'm not wrong, I only took till 5th week, correct? Right? Okay. Then the sales underscore data. Sales data is, what did we take? I don't even remember the code. What was the sales value? 24545. Okay. 2, 4, 5, 4, and 5. Is this my weeks data and my sales data that I have taken as per what we did in the coding? Very good. So tell me, listen to me carefully. df equals to pd.data frame. If I want to convert all of them in data frame, do I take it in a dictionary format like this? Like take a dictionary like this, a single dictionary? Can I say it like this? Weeks, colon. What do I pass? Weeks data. Bracket, sales. Now listen to me carefully. Everything will start making sense a little bit more to you, okay? In machine learning, whenever you do in the production, whenever you're writing code, how you cut your birthday, right? How you cut your birthday cake. Just like that in machine learning, you need to do 2 cuts, okay? 2 cuts, C-U-T-S. Sir, what are those cuts? I'll tell you. Imagine this is your data. Okay, this is your column data, your Excel data, your good looking, beautiful looking Excel data. Okay. The first cut you need to do is separate target and feature separately. Suppose I have a column called feature 1, feature 2, feature 3, feature 4, and target. Where is the first cut you will draw? Okay. Where is the first cut you're going to do? You are going to separate your target and your feature separately. Am I making sense? Your first cut should be to separate your target and your feature separately. Usually in machine learning, target is taken as X and the feature or your actual feature, your feature is taken as X. Okay. Your feature is taken as a variable called X and your target is taken as Y. Did it become clear? Your features will be separate, your target will become separate. So tell me here, can I take something called X equals to df of, specifically df at weeks? Can I say all the values of the weeks will be converted to X? So if I print X, all the 1, 2, 3, 4, 5 value of the weeks are separated in X. Yes. And your Y value will be, your value of Y will be df of sales dot values. So what did you do? Did you take your X and Y separately? Did you take your X value and your Y value differently, your variable separately? So you have done that. The second cut you're going to make is separate something called as training versus testing. I'll explain the concept. You make a cut like this. Okay. This much data is training data and this much data is testing data. Okay. I'm going to explain this concept a little later to you. I'm going to keep this graph in the next. Did I first make the first cut as per what I had done? X and Y is separate. The first step that we do is calculate the mean of X and mean of Y, correct? In the mathematical example also, I calculated the mean of X separately, then mean of Y. Mean underscore X equals to NP dot mean of, what do I pass? X. Mean of Y is going to be NP dot mean of Y. Did I take the X separately and the Y separately? The mean of X and mean of Y? N is equal to length of X. Basically, I am taking another variable called N, where I am understanding how many X parameters do I have, meaning how many independent feature sets number do we have. N will represent that. NUMER, numerator is equal to 0, denom is equal to 0. What have I done here? What have I done here? What is the concept here? Numer is equal to 0, denom is equal to 0. Have I taken something called as a counter? In Python programming, this is also called as a counter. This is counter. I have initialized the number to 0, correct or not? This is a counter that I have taken. Okay. In the mathematical terms of doing the R square calculation, sorry, in the calculation of Y is equal to MX plus C calculation, numerator is nothing but X minus X bar into Y minus Y bar. Agree? X minus X bar into Y minus Y bar. X minus X bar into Y minus Y bar. Please tell me, for I in range of N, how many data points am I going through? All the values of X? Am I looping through all the values of X? 1, 2, 3, 4, whatever values of X is, I'm going to calculate its X, X bar, Y, Y bar. I'm going to calculate all of that. Okay. Can I say numer, NUMER, plus equal to, numerator plus equal to, keep on adding that number is X of I, which is the actual value of X minus mean of X. Is this X minus X bar? Is this code, as simply put, nothing but X minus X bar into Y minus Y bar? So Y will be taken like how? Y of I into mean of Y. Is this X minus X bar into Y minus Y bar? I am simply looping through the code. I am simply looping through the code. How many? First, I will take row number 1, then row number 2, then row number 3, then row number 4, then row number 5, then row number 6, then row number 7, and it goes on and on and on. I'm sorry. What? Isn't it minus? What is minus? What did I do? Where did I make mistake? X minus X bar into, oh, sorry, Y minus Y bar. Yes, sorry. X minus X bar into Y minus Y bar. Correct. Okay. So X minus X bar, Y minus Y bar. Numerator is done. What do we need to solve for next? What do we need to solve for next? X minus X bar is done. Denom. Denominator plus equal to, what is going to be denominator? Look at the formula. Denominator was X minus X bar the whole square. X minus X bar the whole square. So how do you write X minus X bar? X minus X bar the whole square. Can I say this? This is X minus X bar the whole square. Okay. If I come outside the loop to calculate the value of M, do I need to divide numerator by denominator? Numerator divided by denominator should give me the value of M, correct? M should be equal to numerator divided by denominator. Agree or disagree? Okay, that's good. And what will be the value of C, my people? What will be the value of C? I have written the formula right here. Can you see? Y bar is equal to MX bar plus C. Y bar, sorry, give me 1 second. Y bar is equal to MX bar plus C. So can I say C is nothing but MX bar, sorry, MX, Y mx bar plus c. So if I move y bar minus mx bar, can I say it like this? Can I say this is going to be y minus mx bar? So if I write it like this, mean of y minus m, whatever value of m I have calculated from top into mean of x. Can I say it like this? If I print f double quotes of m is this. And the value of c is this. Did I get the value of m and c? Now we make plots. So now I'm going to do some plotting. Why plotting? Because we just calculated y is equal to mx plus c. Yes or no? We have the value of m and c. We just need to put the value of x. So if I say max underscore x equals to, just try to understand the code I'm writing, okay? np.max of x plus 1. Min of x. np.max, np.min of x. Because it is the min value, I'm going to take minus 1. Okay. Who knows what this np.linspace? Have you all used the method called linspace? Have you all heard of something called linspace? Comma max of x, right? You guys have heard about something called this, right? Mx plus c, correct. That would be 1, 2, 3, 4, 5, 6, 4 and 4, and then mx plus c, right? That should be fine. That's my equation, correct? From min to max, which is correct. Okay, fine. See, I'm very sure you must have studied something called linspace you guys did do something called NumPy, right? You guys have studied something called NumPy, correct? I'm assuming that NumPy is done. Okay. Or maybe, I don't know. Let's take a little maroonish color like this. Yeah. Let's come to this part of the code and change this to hashtag this. Color is done. I can change the label also. X and Y in color. Okay. And you guys have studied matplotlib, correct? So what I'm doing here is I'm writing a label because this is going to be sort of like my regression line. Okay. Regression line that we have just calculated from that particular thing. Okay. Line style will be, I'm going to keep it actually dashed so that you guys understand dash. That's more than enough. I will take no alpha if you guys don't want it. Plot.scatter. Okay. Inside the scatter plot, I want to plot the original values. So I'm going to take x comma y, the one that I had originally. Okay. So the color is equal to, let's take sky blue. And the label I want to add, because I want to add a legend, later on. Label is equal to the actual scatter point or the actual data point. You can call whatever you want. POINT, right? Actual data point. And actually, I can make them bigger or smaller. I think I can make them bigger. How do you make the points bigger? Actually, there is something called width. Yeah, I think I have to check it. So plot is done, plot.scatter is done. I have taken two specific plots. Okay, so plot.x label. So let me first take an x label. On the x label, I will say the number of weeks that have elapsed. Okay, weeks. And plot.y label will be, the actual sales of the cars that have been done. So I will say sales. And plot.title. I'm going to take the title of the plot to be, demo of linear regression or whatever it is. Linear regression demo. Okay, demo. And then we are going to do plot.grid. Let's make it true because we want it to look good. And we will say plot.legend and the location will be equal to best, right? So the lock will be equal to best. Upper left, upper right, depends on how you do it, right? Okay. Let's not make it sky blue. Let's make it black. Yeah, okay. Not even black. It's not looking good. How do I make it lighter yet darker? Oh, I think this is darker color. This is like a good looking dark color. So I'm gonna take this copy. I'm gonna come to this code. We're gonna go to hash and paste. Let's make the grid a little less uh, lighter. Alpha 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 equals to, let's make it 0.5. Now let's make it little 0.3. Let's also make it line style is equal to, let's make it dashed, right? Let's make it like this. Please tell me if you're, better. Looks good. Now let's make the alpha better, 0.4. Good. Okay. Do you see what has happened here? We have 4 data points, 1, 2, 3, 4, 5, 5 data points. The red color line is what is actually called as the fit line that we have observed. Yes or no? The red color line is the actual y is equal to mx plus c line, and the blue dots are the actual data points. You got what I'm trying to say? Let's make it a little bigger if you want. Please tell me if the code is correct. No. Is it capital S? I'm not sure. S is equal to 40. Oh, I think I'll get an error. Small s equals to, let's make it 70. Yeah, okay. Now listen to me carefully, okay? What have I done here and how am I basically printing these values, okay? See, predominantly, I want you to understand just one thing, okay? I have taken something called max of x is equal to np dot max plus 1 and minimum of x is np dot min minus 1, okay? The largest number of the value of x, is it 5? Plus 1 will be how much? And the most minimum number in x is what? 1. Minus 1 is 0. I want to make a plot. I want to make a plot where the x-axis will start at 0 and end at 6. Did you get it? Limitation on the x, the direction of x. Okay. Now what did we do? X equals to np dot linspace min x and max x. Do you know what does linspace method do in NumPy? Everybody? Do you know what linspace does? Everybody? You guys are clear, right? What linspace or this line space does? It's actually spacing. It's for spacing. You guys are aware. So I don't need to teach you this, correct? I don't need to teach this x equals to this, create equal spacing. Very good. I have taken something called y is equal to mx plus c. I plotted x comma y with a different color with a label and a line style. I plotted the scatter plot x and y, the actual data point, color, label. I did the x label, y label, title. I've put the grid in the background. Alpha is the intensity. How do you want the intensity to be darker or lighter? Line style is the style of the line. And then legend is basically regression line and data point. And I plotted this data. Yes or no? Are we visually clear on how this particular thing works? Are we visually clear with the concept of something called how does the whole thing work? It's good. Very, very good. You got what I'm trying to say? You don't know what is grid and legend. Okay, so you don't know what is grid and legend. Do you see the background grid? Okay, let me make it alpha 1. Alpha 1. Alpha equals to 1. Okay. Do you see the grid in the background image? Let me show it to you like this. How about now? Is there any grid in the background? No. Correct. But the minute you say plot.grid and pass inside the parameter called true, it will make the grid for you. If I run this answer, this red color line is what? The blue color points are what? We don't have that information. If I don't have that information, then the plot looks incomplete, right? I want to label it in the plot. So if you do plot.legend and print it, can you see the red color thing is called regression line and the blue color points is called data point. This difference is what we call as legend. How it figured out without giving figure size. Matplotlib has everything by default. If you don't give any figure size, it won't give you error. It will still run. I thought you guys knew this by now. Nobody takes figure size. Nobody in real practical applications takes figure size. Figure size is very illogical and also irrelevant, because if you take more than 5 plots, subplots will take care of by itself. What max x and min x does is a very simple thing, right? When you plot any graph, you want to know how long do you want your x axis to go, and where do you want to start your x from. You want your starting point for the x axis to start at some value. Now it so happens that not every time the x and y graph will start at 0, 0 only. Sometimes a graph can also start like this, right? A graph can start -3, -2, -1, 0, 1, 2, 3. Sometimes graph can start like this also, right? Not necessary that every time they start from 0 to 0. So what I did is I took the X column, which is this weeks column, and I calculated what is 5 plus 1, because the maximum of weeks is 5. Plus 1 will be 6. So it will plot a graph where the ending point will end at 6. And the starting point will be minimum value, which is np.min. The most minimum value of x is 1. 1 minus 1 is 0. So it will start at 0, go all the way till 6. And then I can plot whatever y value I want. So to restrict the columns, the values on x, I did that. So now tell me, let me ask you guys one more question. Sir, if I do it like this, 100%, let's take -10 plus 10 and run this. What is your axis value? What is your axis value here? -15 to 15. You got what I'm trying to say, right? Plus 10 and -10 were added to your data. So your actual data point got shifted below. Can you see the points are now closer to each other? Let me copy paste this. Sorry, not copy paste, and move this. And do you see the answer called 2.2734, 2.34, 2.42, 2.49? Okay. Y is equal to mx plus c. You will be like, there are so many values in this, right? There are so many values. Is that the question that you have? That y has so many values? Tell me, okay. Print length of y. Okay. Length of y. Tell me, what is the length of y? 50. Okay. How many data points does y need if I calculate y is equal to mx plus c? In actual y predicted value, what answers am I supposed to get just for the prediction of y hat? Y is equal to mx plus c is supposed to give me 5. Okay. Tell me one thing, right? When you print y is equal to m into x plus c, okay? Did I break my actual x into multiple different data points here? This is not the actual x, the capital X. It is the small x. You didn't understand. Okay. Is this y is equal to m capital X, which is the actual data point, plus c, or I had to take linspace because I had to plot the value for line also? You didn't get it. I had to print the value for each individual line, correct? So have I not taken x is equal to np.linspace, and it divides the whole data into 50 different points. And that's how I got a straight line. You got what I'm trying to say, or is there confusion? Did everybody get the concept or no? Okay. How many data points do we have in weeks? Okay, listen. How many data points do I have in week? 5. The name of the variable, is it capital X or small x? Is it capital X or small x? It is capital X, not small x. When I did y is equal to mx plus c, is it small x or capital X? When I wanted to plot the point, I wanted to show the line for the entire data point, right? For all the 0 to 6. For all the values of 0 to small value, I wanted to show. So tell me, if I did x equals to np.linspace, if I print x, how many values of x did I get? Equal portion. 0 to this is one portion. This to this is one portion. This to this is one portion. This to this is one portion. Haven't I divided my value also into multiple small points? Meaning your x-axis also got divided into so many smaller points, equal spaced value. Yes or no? Now, don't I need to do a line equation for all small points? So that is why I have not taken capital X, I have taken small x. That's why the line will go from the 0 all the way till 6, longer line. Why are we doing it? If you don't do it, will you be able to plot a line? If I don't do it like this, will I be able to plot a graph like this? Like the line going all the way from here to here. That line, that red line going from left to the bottom, will it go? No. Line will start here, it will end here. Correct or not? The regression line will be so small, it won't be visible. That's why we are doing it. If you don't do that, you're pretty much done. You will not be able to plot. Then you will be having only y is equal to mx plus c. That's it. Like you will have 5 different answers. You will get this answer. Y predicted is equal to this, but you will not be able to plot it. This value, y hat. 2.8, 3.4, 4, 4.6, 5.2, and you're done. So what it did is it created some values and then connected the dots to create a line. Yes, that is what it is doing. If I take the values to be more and more, the line will always be visible. The line will not become shorter and longer. It will always be visible. The regression line will always be visible. That's why we did that. I hope you got the concept. In reality, it's only calculating 5. That's it. That's all it does. It's not a very complicated thing. So what if we have only 7 data points and not 50? Still, we will be able to plot. You can do it, Piyush. It's not a very complicated thing. If you want to plot only is equal to y mx plus c, write a loop, write x of I, and you'll be able to calculate it. Shouldn't be a problem. It's not going to be a problem at all for you to calculate it. What value of x's do I have? Do I have the value of x's like this? X is equal to, let me show you. What is the value of x do we have? Is it an array? So if I do x of 0, will it give me the value 1? So tell me, for I in range of, listen to me, for I in range of length of x, will this run the loop 5 times? If I print x of I, will this give me the value of each number 1, 2, 3, 4, 5? Now that you have 1, 2, 3, 4, 5, can I do this? Y is equal to m into x of I plus c. Can I do it like this? And close it and close it. And if I go ahead and print y, each time that the y happens, I print it. So 2.8, 3.4, 4, 4.6, and 5.2. Can you not take this in an array and plot it? You can, sir. Of course. It's a simple method. You know how to plot this, right? You guys know how to take 2 array values and plot them, right? You must have done that like multiple times. If you take another array, ar underscore new is equal to an empty array, and take this ar underscore new dot append. Okay, inside that append, what do? We append the value of y. If I run this, what is my ar underscore new value? Did we get the answer? Take this and plot it. Done. Now, my people, let's talk about the calculation of R square. How did we calculate R square? What did we do in R square? Sum of square total, sum of square residual, all of that stuff. We'll be talking about that. Okay. So as you guys already know, we calculated something called R square, right? To calculate R square, sum of square total, SS underscore TOT total. Okay. Is it going to be empty? It's going to be 0. Sum of square residual is going to be 0. Okay. I have taken 2 separate counters, sum of square total, sum of square residual. Listen to me. For I in the range of how much do I need to run the model? How many times do I need to iterate? N times, because I've already taken the value of n on the top. Y underscore pred. For calculation of R square, I want the value of Y predicted values. Yes or no? For the Y predicted values, I want the values of Y pred. So can I say Y pred is mx? X is nothing but x of I and plus c. Can I say it like this? So sum of square total plus equal to, based on the formula that we wrote, y minus y bar the whole square. Listen to this. Y minus y bar the whole square. The whole equation is reversed. That's why we do 1 minus. I'll show you. Y minus y bar the whole square. So can I say the equation will be written like this? Y of I minus mean y the whole square. Y minus y bar the whole square. This is my sum of square total. My sum of square residuals value plus equal to y minus y pred the whole square. Opposite. Y minus y pred the whole square. So y of each individual point, actually this is capital Y, okay, because we are taking from the actual value. Y minus y of I minus y pred the whole square. I have taken the value of sum of square totals and sum of square residuals. Based on this, my R square answer that I got is 1 minus sum of squared residuals, right? So sum of squared residuals divided by sum of squared total. If I run this and print, go ahead and print F double quotes R square is going to be R square. If I run the answer, what answer did we get? What answer did we get? 0.6. What answer did we get here? The only difference in this formula and that formula is sum of square total and residuals are opposite. Agree? They are numerator is denominator, denominator is numerator. So if you do 1 minus the reverse case, is it the same thing? In mathematics, when you want to reverse A by B with B by A, you just take 1 minus of sum of square total by sum of square residual, and your answer is pretty much the same. I hope you got what I'm trying to say, everybody. So tell me, did we use any library in this? But we got the value of R square and Y is equal to mx plus C. Can we validate? Do you understand what is validate? If I would have used a machine learning library like sklearn, scipy, what answers are they saying and what answers do we get? Can we validate it? From sklearn dot linear model, I'm importing something from sklearn dot linear model. I will import something called linear regression. Can you see I'm importing something called linear regression? I'm importing a model called linear regression. I've imported x equals to, now remember, the problem is when you use a library like linear regression, sklearn, stuff like that, it needs the data to be in two-dimensional format. So your x value should be reshaped. I'm going to reshape the value to -1 or n comma 1. So if can I take it like this, n comma 1? What does this do? Do you guys know what reshape does? N comma 1. The value that we had, was it not a single array like this? The x value was a single array. If I print x here, is it not a single array, one-dimensional array, one bracket open, one bracket close? But in sklearn, you cannot run like that. You need to have the data, even if it's 1D array, it should be in what format? It should always be in what format? 2D format. So this reshaping, I converted the entire form into a 2D array. Are we clear? We converted the whole thing into a 2D format. Now that the whole thing is converted into 2D format, let's take this as a small x, not a capital X, because there will be a lot of confusion. So let's run. Okay, x value should be equal to this. The problem is what you need to do. You need to call the library. Regression is equal to linear regression. Close the bracket. Regression is equal to regression dot fit. And inside the fit, you will pass something called the actual value of x and the actual value of y. Did I make a mistake? I did make a mistake. I think there is a shape. Oh, I took it as a small x, correct? I did take it as a small x. Yeah. What did I do here? This 2 lines of code has run the model. The model has run, meaning linear regression has occurred. You don't need to do anything else now. Your value of y pred, y underscore pred value, the predicted value that I want to calculate is going to be m into x plus c. If I do, you know what, let's take it in x format only because I'm taking it separately. So there is no confusion here. Okay. Mx plus c. My people, if I calculate the y pred value like this, mx plus c, right? And if I run that value directly, suppose if I want to just run the value of y pred straight up, because I'm using the package directly, if I have reshaped the value or maybe, maybe I'll do it like this. Until here, is everyone clear? Let me run this once again. Until here, is everyone clear? I have run the linear regression part. This part is called linear regression. I have just used the method. Why do we need to reshape y? We never reshaped y. We only reshaped x. We only reshaped X. We never reshaped Y. Where in this code do you see reshaped Y? Where in this piece of code have we reshaped Y? Why not? Okay. When we run machine learning or when we run machine learning code, Y is only for prediction, right? But the actual mathematics is happening with the feature numbers, right? Y is not even getting involved there. Does that make sense? Your X value, which is the feature value, your X is being crunched. Your mathematics is only operating on X. Y is just a number that can be compared. Suppose if the Y value was 4, Y pred is 3, the maximum you do is Y minus Y pred. Agree, disagree? The entire operation is running y is equal to mx plus c. The x is being multiplied with m and then added with c. All this operation happens on the x value, correct? So the reshape has to happen only on x, never on y. All of you got the question that features are the one that goes through a lot of mathematics. Target just sits. It has no operation. The maximum it will do is y minus y pred. Done. Everyone got what I'm trying to say? What did I do here? I took a value, I reshaped X, and I'm running linear regression. Basically, this value here is running linear regression. Agree, disagree? This particular value is running your linear regression. That's it. You've run. Now, if I say y pred value, whatever is your y pred value that you want to score or you want to calculate. So if I want to calculate the value of, say, r square, you want to calculate the value of r square. If I say r square is equal to, just r square is equal to reg, because I have taken everything in the small reg dot score, score, pass x comma y directly. And if I print r square like this, what answer did we get? What answer did we get? 0.59999. Is it 0.6? What answer did we get for r square? We got an error of 0 or 10 to the power of minus 12 with least significant digit of 10 to the power of minus 12. Did you understand? I ran a model, a linear regression model. By the way, this is not modeling. Modeling, I will teach you how to do that. But when I ran the algorithm, the actual library versus our code, we got the same exact answer. You got the concept, my people, on how we wrote linear regression from scratch, how we implemented it from library, the numbers match. If r square is matching, m and c also is the same answer. The point and the plot is also the same answer. Everything that we've done is calculated. Did we get the concept clear? Now, in the formula of r square, did I not take the value here, the formula? Y hat minus y pred the whole square. This formula, I have taught you this formula. This formula is already given. All I did, sum of squared total was y minus y bar, the whole square, and y minus y pred the whole square. We had taken opposite, but in actual r square formula, we take 1 minus of this value. When we take it like this, whatever formula we get on, whatever answer we got then, we got the same answer here. Validate part is confusing. It will be confusing. Have you ever used a method called linear regression or linear model ever? No. This is not for your understanding. This is only to show you that the answers are same. Even if you don't understand the code, it's okay. This is to show you the difference. Linear regression formula, library, and our way of written, we got the same answer. Is going to be a very simple thing, right? I'm going to be importing something called import pandas as PD. Now, I'm going to ask you all a very simple question. This is not the first or a very new library for you, right? I'm very sure you must have implemented this library and you have learned this library, so I don't have to teach you. Okay. Hiding internal implementation and use of existing libraries as and when needed instead of rewriting the code. Yes, absolutely correct. The abstraction in object-oriented programming is different from the abstraction that I am talking about, but you got the logic correct, right? So encapsulation, polymorphism, injection of control, dependency injection, adaptee, adapter. These are all object-oriented principles, SRP, single responsibility principles. These are all object-oriented principles. They are very technical in nature. What I'm talking about is the basic concept of abstraction, but I'm very glad that you got it. Knowing object-oriented skills, programming skills is very important, right? So now what we've done, we've imported pandas as PD. I want to load a data, right? So I'm gonna keep this thing as import all other OTHER libraries here. Okay, import all other libraries here. Here, I'm gonna load the data set. I'm gonna load the data set. Okay, let's load the data set. Data is equal to PD dot. Now, I already have an API or a method which is given to me, using which I can load the data set, right? So PD dot read CSV. And my people, I'm going to give you guys certain tricks. I'm not sure if you know them or not, but I'm going to do it. See, in pandas, you have a trick of loading the file directly, right? So if I want to load it directly, I have this. See, now my data is loaded. Okay. So I have loaded pandas and I have loaded the data set. Now, let me tell you the trick I use to load a certain file faster. Okay. Every computer has a structure called folder. Yes or no? You create your own folder. You can create your own folder. Inside that folder, listen to me carefully. Inside that folder, how many files are there? To find that out, you can use a trick called dot and forward slash. A dot and a forward slash. When you use dot and a forward slash and press on tab, you can see all the files. So you see this headbrain.csv. Now I have loaded this file. So basically, a method called dot read CSV reads the file called CSV. Now, what is CSV? It's comma separated value. Now, let me tell you two different things. You guys are currently learning machine learning on a tool called Jupyter Notebook. Like Jupyter Notebook, there is something called Google Colab. Like Google Colab, there is another tool called Visual Studio Code. These are platforms on which you can write the program. This CSV is the format of the file on which you work. Sometimes you work with Excel format. So the extension will be .xlxs. If you work on something called Apache Parquet, so you will have Apache PARQUET, Apache Parquet, right? If you work on Hadoop distributed file systems, then you will have a different kind of data set that's given to you. If you work on Carrot file, it'll be different for you. Remember, in machine learning, you can use as many different kind of structures as you want. Depends on what is the file structure that you have, okay? It is so if the same folder available to no. Dot slash only gets you the file from the same folder on which your file ml_ff is written. Your folder needs to be same. If the folder is not same, it's not going to go beyond that to get it for you. Okay. What is the difference between Jupyter Colab and Visual Studio? See, Visual Studio is something that you will appreciate a lot. Like, if I show you a Visual Studio code, I'm not sure if I have it with me. I mean, not here, Visual Studio Code. Okay, I'm going to show you the difference between Colab and Visual Studio Code. Actually, you should really know the difference between Visual Studio Code and this. So you see, right now, this is inferential stats that I was teaching a while ago. This is extension. Give me one second. Let me go ahead, and I think I had a folder somewhere. I'm going to open it up for you guys. Give me one second. Desktop. And I have A to Z. I think I was teaching. Yeah. Let me see if this is the, yeah. So this is like a small data structures code that I was teaching to a recent batch right now. So see, this is written in an IPYNB file. this is how Visual Studio is going to look like for you. So you see, it has a certain theme. So I'm just going to expand it a little bit, right? So I'm going to, yeah, show it to you. So what happens is basically, if you run a portion of this, so for example, how do you find the second largest and the second smallest thing from an array? So you have a certain way of doing this. So what happens in Visual Studio Code is, Visual Studio Code can help you write any kind of program with a proper and a beautiful file structure. So you can maintain and work on the database together, files together, multiple different stuff like Docker, Kubernetes. If you want to build a Docker container for your, code, if you want to do a blue-green deployment, so you can do all of that in one place. Jupyter Notebook is more like for beginners. If you are a beginner, you're just starting with your machine learning journey or starting with your programming journey, people usually prefer Jupyter Notebook. But Jupyter Notebooks are not predominantly used for deployment, meaning you don't take a Jupyter Notebook file and you're going to be use it for deployment. Some people do that using Amazon Web Services and Kubernetes services, but usually it's not preferred because you have to do load testing, stress testing, pen testing. It's like regression testing. That's like crazy amount of stuff you have to do. Okay. For VS Code, we need to create environment for Jupyter, or do we? You can use it directly. It's directly. All you need to do is just download Darwin. So VS Code Darwin, if you just just download Darwin, you should be able to work on it. Or just write Visual Studio Code, right? Like VS Code, depending on your computer, MacBook, or whatever it is, download. That's it. Just download, install the kernel, you're done. Okay. Colab is just like that. Colab is exactly like Jupyter Notebook, but it works on cloud. So uh, if I go to Colab for you guys and show you just one example, I have a pro version. So I'm going to show it to you differently. So see, this is the code of large language model like GPT. If you want to make your own GPT, this is a code for that. I'm using something called Microsoft 5 3.5. So see, for example, if I want to chat with my model, so if I ask a question like, like, hey, can I extract some image information from the from a given image or something like that? So see, I use something called as Google Colab Pro. The difference in Pro is I get an opportunity of connecting with something called A100. A100 is a very expensive GPU. So you will not have this option. I have this option. You will only have CPU or GPU or TPU. In Google Colab, what happens? You are able to load your data in a separate file called file structure to the left. So you have files here, so you can load your data there. That's the only difference. It's just like Jupyter Notebook, but the way it is done is slightly different. Okay. So Jupyter Notebook is same, Google Colab is same, and all of that is same. It's just that you can use a lot of, you can do a lot of fancy stuff with Google Colab. GPU for image processing. GPU for large language models, for inferencing. When you write a query to a GPT model, you need the answer to be as fast as possible. For that, we use GPU. Okay. So now coming back to the point, right? I have loaded the data set. I want to test my data set. How do I do that? Data.head of 5. And if I run this, what data do I have right in front of you, my people? Let's look at it. I have 4 columns. Those 4 columns are, I have gender, I have age, I have head size, and the size of the brain in weight. Okay. So this data set that is available right in front of you, you guys are able to see the, okay, how about now? Is this more clear? Much better? I've zoomed in for a better clarity. Okay, good. So the data set that I have right in front of you is a very simple data set. It has 4 different columns: gender, age, head size, and brain weight. Basically, I want to predict using linear regression that does increase in the size of the head increase the weight of the brain? Basically, if the size of the head is larger, does it mean that there exists a relationship between the weight of the brain? Meaning, larger the head, larger the brain, smaller the head, smaller the brain. To us, it looks like, I think it's common sense, but I don't know. There must exist a relationship, and we will calculate that using linear regression. So in order for me to implement it using linear regression, I need to identify one thing, understand one thing. Okay. And I want to teach you this very, very clearly. Okay. So see, I have taken this example right in front of you. Gender, age, rank, whatever, X, Y, Z, right? I'm going to come over here and I'm going to paste it in front of you. Okay. So give me 1 second. Cut. And I think, why don't I paste it in the view sheet? Okay. Are you guys able to see this original data set right in front of you? Okay. This data set is what I would like to call the OG, the original data set. Okay. Now I will tell you how important is data scientist's job. My people, look at the data and observe carefully. How many variables or columns are categorical variables and how many variables are continuous variables? How many variables are continuous variables and how many are categorical? First of all, let me ask you all one question. See, my people, in statistics, you guys must have learned something called continuous variable, categorical variable, ordinal variable, nominal variable. I'm going to revise that concept to you, okay? See, whenever a number is continuous in nature, for example, temperature, can temperature be 47 degree, 37.19 degree, 97.26 degree, meaning it can belong to any range of negative infinity to positive infinity. A number that exists continuously and can be any number between negative infinity to positive infinity. This kind of variable is called continuous variable. What do we call this? What kind of variable do we call this? This variable is called continuous variable. Let me show you an example. Between age, gender, head size, and brain weight, which number is any number that is continuously going on? Isn't head size and brain weight continuous? I'm asking everybody, whoever I taught you, both head size and brain weight are numbers between 4512, 3738, 4261, 3777, 4177, 1530, and all of that, and all of that, and all of that. Listen to me carefully. Data of just gender, if I just take gender, dot value counts, okay? Dot value counts and run this. The gender column has only two kind of people. If you are one, it means you are a male. If you are two, means you are a female. So tell me, in the column of gender and age, let me also take age very, very quickly. Paste, remove gender and say age. And this. Do I also have the same category like 2 and 1? It's like category. Either this or that. Is it continuous by any chance? Everybody, whoever did not know the difference between categorical variables and continuous variables. So, head size and brain weight are continuous variables. You will find numbers which can belong from negative infinity to positive infinity. But when you go to columns like gender and age, do we have infinite amount of genders available in this planet? No. So this value becomes categorical variable. What variable will it become? Categorical variable. So now that you have the clarity, this variable and this variable, gender and age, is it categorical? And head size and brain weight, is it continuous variable? And the answer and the distinction is clear. Am I making sense to everybody? What is the difference between a continuous variable and a categorical variable? Did you guys get the clear, your differences clear, everybody? In the most simplistic sense, I hope everyone is clear. Is there yet anybody again who has confusion? I don't believe there should be, but I am asking. No. Okay. The answer is clear. Okay. For implementation of linear regression, we have no use of gender and we have no use of age rank or range. We don't need them. It's not needed for my analysis. They are not helpful in any perspective. So I need to remove them from my original data. Now, here is what I want you to know and listen to me carefully. Sir, does that mean whenever I implement linear regression, I should never take categorical variables. I should only take continuous variable. The answer is no. If you want to implement linear regression, listen to me carefully. I'm telling you, this is very important. If you want to implement linear regression, your target variable should be continuous in nature. What variable it should be? Your target variable, whatever you're trying to predict, should be continuous. Your features could be a combination of continuous, categorical. That's okay. Did that make sense? Whenever you want to implement linear regression, the rule is, the law is, the target variable that you will take will follow what variable, should be of what kind? It should be a continuous variable. You cannot take a target variable where the data is categorical. This is not allowed for linear regression. Very good question. See, this is what I want to know. But gender and age might also have an impact on the head size and weight. It does. But the problem is, in machine learning, can I say that your gender, age, and head size is going to be my feature data set and the brain is my target? Can I split my data set like this? Can I do this? Okay. Meaning, using head size, I can predict the brain weight. Okay. Given the size of the head, I can predict the size of the brain. Okay. In machine learning, you can do something called feature engineering. What do you mean by feature engineering? Is gender important for my calculation of brain weight? Is age important for the calculation of brain weight? Or head size is important for the calculation of brain weight? And then the machine learning will only tell you, don't give me gender, don't give me age. They are not adding any value. Just give me head size. And when I did that and when I ran that, it says only head size has more correlation with the prediction of brain weight versus gender. Now, why am I not showing you feature engineering? Because that code is very, very large and you haven't yet come to the concept of feature engineering. So now did everybody understand why am I asking you to drop gender and age? Because these are not adding any value to the final prediction. Hence, we are going to be dropping these columns. But I will be teaching you how to do this calculation all by yourself. How to take a feature set of multiple different columns and identify which columns are important and which are not. In specifically linear regression, what variable cannot exist for target? Tell me, if you are implementing something called linear regression, your target variable should be not of this type. What is that not? Categorical. What it should be? What it should be? It should be continuous. Number one. So tell me, what do we do? What do we do here? First of all, I took something called gender. I took something called age. I got something called head size. I will be only using the data set from the original data set. What I'll do, I will take my original data set, okay, which is this, and I am going to, I'm gonna duplicate, okay, come to the bottom. And what I'm going to do is I am going to remove these two columns, age and gender. And now I will be left with this two columns. So originally, what did I do? I had this data, but what did I do in between? I dropped dropped some columns and I got the answer called, I got the data set as head size and brain weight. Agree, disagree? This is my original data. Now, this was my original data, but this is my data now because I no longer have needs of these two columns. Taught you the concept of something called as in machine learning. Okay. Just listen to me carefully and everything will make sense. Just like how we humans need to be shown some things for us to understand, machine learning also requires training. When I say training, it needs to go through something multiple times for it to get the idea. So tell me, my question is very simple to you. If I teach you 4 plus 5 is equal to, that's correct. 3 plus 2 is, reinforcement is different, Kalpesh, right? Reinforcement will be a different thing. But yeah, reinforcement also is like you have to train the model and get the idea. It's absolutely correct, right? So it's also going to be, it's also going to be same. You will get the concept. Okay, so imagine you have you have been taught how to do addition. 4 plus 5 equals to 9, 3 plus 2 equals to 5, 1 plus 2 equals to 3, and 2 plus 2 equals to 4. I taught you this. I taught you mathematics, okay, addition, where 4 plus 5 is 9, 3 plus 2 is 5, 1 plus 2 is 3, and 2 plus 2 is 4. I taught you this. If I now want to test, have you learned mathematics or not? Or have you learned how to do addition or not? What two numbers will I take? You didn't understand. Let me explain. I taught you how to add two numbers, 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. I taught you how to add using these numbers. Okay, good. If I want to test your mathematics skills, if I want to test your mathematics skills, should the numbers be different from what I taught you? Because if I give you the same number 4 plus 5, 3 plus 2, 1 plus 2, you can also cheat. You can also cheat, right? You can also memorize. My question was very simple. I said that when I taught you mathematics, I taught you using four numbers, 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. If I give you a number called 2 plus 2, wouldn't that be cheating? Because you can always memorize what was 2 plus 2, 4, and write it down here, but you did not really understood math, correct? You can cheat like this. So what if I, for testing, give a number like this? 3 plus 6 equals to whatever this answer is, right? I think it'll be 9. Yeah. You understood what I'm trying to say? And then if you're able to answer 9, then I know you have learned math, correct or not? Agree or disagree? Machine learning works exactly like this. I'll tell you why. Imagine you have an entire data set of all these numbers. 4 plus 5 equals to 9, right? 3 plus 2 is 5. 1 plus 2 equals to 3. 2 plus 2 equals to 4. And 3 plus 6 equal to 9. This is my entire data set. Okay? This is my entire data set. To train my machine learning how to do addition, what will I do? I will divide my data set like this. All this from the top will be used for training my machine learning model, but I will keep this number separate. Why will I keep this number separate? Because I want to test my model also. Hey, model, did you learn mathematics? The model will say, yes, sir, I learned mathematics. Okay, let me give you a question. But the question I'm going to give you, you have never seen it in the training. This question is unique, one of a kind. You have not seen it. But because you say you have learned everything from the training, you should be able to solve the problem. Is this logical? Is this a logical approach to test whether something who says that I have learned, to test whether this person has already learned or not, actually learned or not? If I want to test your mathematics skills, if I want to test your mathematics skills, should the numbers be different from what I taught you? Because if I give you the same number 4 plus 5, 3 plus 2, 1 plus 2, you can also cheat. You can also cheat, right? You can also memorize. My question was very simple. I said that when I taught you mathematics, I taught you using four numbers, 4 plus 5, 3 plus 2, 1 plus 2, and 2 plus 2. If I give you a number called 2 plus 2, wouldn't that be cheating? Because you can always memorize what was 2 plus 2, 4, and write it down here, but you did not really understood math, correct? You can cheat like this. So what if I, for testing, give a number like this? 3 plus 6 equals to whatever this answer is, right? I think it'll be 9. Yeah. You understood what I'm trying to say? And then if you're able to answer 9, then I know you have learned math, correct or not? Agree or disagree? Machine learning works exactly like this. I'll tell you why. Imagine you have an entire data set of all these numbers. 4 plus 5 equals to 9, right? 3 plus 2 is 5. 1 plus 2 equals to 3. 2 plus 2 equals to 4. And 3 plus 6 equal to 9. This is my entire data set. Okay. This is my entire data set. To train my machine learning how to do addition, what will I do? I will divide my data set like this. All this from the top will be used for training my machine learning model, but I will keep this number separate. Why will I keep this number separate? Because I want to test my model also. Hey, model, did you learn mathematics? The model will say, yes, sir, I learned mathematics. Okay, let me give you a question. But the question I'm going to give you, you have never seen it in the training. This question is unique, one of a kind. You have not seen it. But because you say you have learned everything from the training, you should be able to solve the problem. Is this logical? Is this a logical approach to test whether something who says that I have learned, to test whether this person has already learned or not, actually learned or not? Okay. Do we need to clean data by removing any duplicates? We don't want to do that yet. The point I'm saying is, you will take your entire data set and divide the data set into two different portions. One data set is going to be called as training data set, and the other data set is called as the testing data set. Is this concept clear to everybody? Now listen to me. From the original data set of 100% data set, can you control how much percentage I want to use for training and how many percentage I want to use for testing? I can control that ratio also, meaning from 100% of the data set, can I use 80% of the data for training and 20% for testing? Should you have this control? Yes or no? Very good. Very good. Now listen to me carefully. Everything will make sense. This is my original data set, correct? Head size, brain weight, and all of that stuff. Yes or no? You should always do how many cuts in a data set? How many cuts will you do in the data set? Two cuts. The first cut will separate the feature from the target. So can I say that head size is the feature X and brain weights is the feature or target Y? Sorry, feature X and target Y. Can I say this? So the first cut I'm going to do is where the first cut I'm going to do is on my original data set, which is this data set. So how do we cut it? Duplicate it. Give me 1 second, my people. You know, I am not very fast. Give me 1 second. So what I'm going to do is I'm going to make a cut. How do I make a cut? Actually, let's copy and let's make a copy of it somewhere here safer later on. Okay. So what will I do here? I will make a cut here. Basically, this is going to be my feature. I'm going to say, okay, my feature set is separate. And now I am taking another cut, which is going to be called as crop, which is going to be my target variable separately. So what did I do? I separated my feature and I separated my target. I did this. I separated them together. The entire feature set has the name of the variable as x equal to. So this is x equal to this, and this is y equal to this. Agree, disagree? This is called as the first cut, separating the feature from target. The second cut you need to do is in the X and in the Y. You know why? Because between this data, you need to decide how much percent you want to take for training and how many percentage you want to take for testing. So can I do this? Listen to me. Okay, so let me explain. First of all, the data set that we have loaded has what? How many data do we have in it? 234. Okay, this is only 5 for example. It has about 200 data set. So tell me, the first cut I made was this cut, separating the X and the Y. And the second cut I made was separating this. You know why did I do the separate cut? Because this entire data set is going to be used for training, and this entire data set will be used for testing. Did you understand what I did? I first separated the X and Y, and then I separated the X separately and Y separately, and I called them training and testing. Okay. For example, I have taken about 80% for training and 20% for testing. Agree, disagree? My people, this variable here, this variable, does it belong to X or does it belong to Y? Does this belong to X or does this belong to Y? This belongs to X. Underscore. Does this belong to training or does it belong to testing? So this variable is going to be passed in machine learning model as with variable X train. This part of the data 4512, 3718 and 426 will be going to the machine learning model as X train. Now tell me, is this Y or X? Is this Y or X? Y. Y. Underscore. Is it training or testing? Training. So this will become my Y train. What is this? This is X. Is this training or testing? This is testing. So this is X test. What is this? This is Y. This is Y test. Did you understand? What did you do? You divided your data into 4 separate parts. X train, X test, Y train, Y test. Is everybody clear? We will be doing this in the example. But is the concept clear? Why do we do this? Is everybody following with me? You need to do this. You cannot escape this in your life of deep learning, generative AI, machine learning, statistics. You have to do this. So did you just divide your data set into 4 parts? Training, X training value is different. Y training value is different. X test value is different. Y test value is different. Agree? Once you divide all this data like this, how do you know your model has performed good or not? So I am asking you a simple question. This part of the data will be used for training. Agree, disagree? This training part of the data, both X and Y will be used for the training. Agree, disagree? The one that I have highlighted, both X and Y will be used for training. Whatever model has learned, machine learning model has learned, should I not create another folder or another column called Y underscore predicted column? Meaning, using the training example, if I give it the test example 37774177, it will predict some number like 1200, 1500. This is the actual value 1282 and 1590. This is the actual value and this is the predicted value, yes or no? And comparing the difference between these two columns, I will be able to say that, oh, okay, I am off by 2%, 3%. This is your entire machine learning. Is this concept clear to everybody? If the concept is clear, remember one thing. I am coming over to my data set right now. Is this my original data set with which I'm working on? This data set called data.head of say 10. This is the data that I have. My people, your machine learning model has done a good job or bad job. How do we know this? How do we know if the machine learning model has done a good job or bad job? By seeing the results, correct? But to see the result, you need to be able to compare it with something, right? Let me give you guys an example. When we were young, our parents used to tell us how good the neighbor's son is. Because neighbor's son got 90% and you got 80%. Example, I'm giving you an example. They had a comparison to do it with, right? Like you had somebody to compare it against. If you have nobody to compare against, can you do comparison? And by the way, I am Sharma. So, you know, Sharma ji ka ladka. So you get the concept. You have something to compare it against. So tell me, in the entire data set, how many data set did we take for testing? How many data set are we taken or have we taken for testing? 2 points. 80% is training, 20% is testing. Agree? 80% of my data will go into learning the module, meaning for training the machine learning model. For training the machine learning model. The machine learning model will learn from the training data. But now I want to test my module. I want to test my module. Okay. I want to test my answer. To test my answer, don't I need to give it the value of X for it to give me the prediction of Y? If I give it the value of X, it will give it, the machine learning model will give me some prediction. Oh, I think it will be this much. Correct or not? If I give the value of X test, it will give me some Y value, no? That Y value is called Y predicted value because this prediction is actually from the machine learning model. But the prediction is 1200 grams, 1500 grams. This is the prediction of the model. But don't we have the real value, the actual value that the model, the actual value in the data set, which is the Y test value? So won't you compare Y test with Y pred? You are comparing the Y test value with the Y pred value to compare and see. Oh, okay. My algorithm is off by 80 points in this data point and 30 points in this data point. This will let us know how the algorithm is performing. Did you get it now? How you got Y test value? It's good, dear. Y test value comes from the original data, my dear. This is my original data set. I split the data into 4 different parts. So can you see what I did? The Y test value came from this part. I took the value of Y, I took the value of X, I split Y into 4 parts. Part 1, part 2, part 3, part 4. The fourth part is the Y test value. We need why do we need Y predicted value is, for example, Anaga, you work in a very big bank, example, bank, PDFC bank. You want to build an algorithm by yourself there so that any customer can come to your bank's website and can ask and add the details like what is that person's age, what is that person's salary, what is that person's CIBIL, and you will give the prediction. Your machine learning model will give the prediction that, hey, come over to the bank, we'll give you up to 5 lakh rupee loan. Example. To build this model, you must have used 10,000 data points to train the model. Model needs to do prediction for millions of customers for the future use of also from the same data set, the model, how well did it learn? How good of a job did it perform? To test that also, you need to hide some questions from the model. That data set is called testing data. Because we already know in real life, in actual life, for somebody whose brain size or head size is 3,700 centimeters square, the actual answer that we got using the using the calculation, actual answer was 1282. But because our model has made prediction, our model will make prediction, the model's prediction is this and the actual answer is this. So can we also not compare and see how good our model has performed on the data set itself? My question is, we don't have actual y-test data in real time. We always have y-test value. I think you guys are slightly off by some points. Let me explain. Let me get the clarity. When you're training your machine learning model on 10,000 data points, you can only test on those data, correct? Okay, let me explain. Suppose you have 10,000 data set. Your data size is 10,000. How much is it? Ignore everything. I want you to answer my question. I have 10,000 data points, Baba. कितने data points है मेरे पास? 10,000. What is 80% of 10,000? What is 80% of 10,000? Is it 8,000? And what is 20% of 10,000? 2,000? Now tell me, is my model good or bad? I can only test on the 2,000 data points and validate, correct? Yes or no? If I make future predictions, my future predictions, I don't care if I have the y-test value for that or no. I am testing for the given 10,000 data point. How did it perform on the 2? That's it. My accuracy, my model's performance will be judged only on the 2,000. On the 2,000, if it did a good job, I will use it for feature prediction because I know it's going to perform well. Did you understand why do we take test data? Test data is only to test. If it performs good in test, the point is it will perform good everywhere else also. You got it? Everybody? If the model performed good on the 2000 testing data, meaning while I tested from the 2000, it answered 93% correct. So isn't the chances if I use it for future 93% it will do good? That's the point. So is it the test data the basis of y-pred? Yes, of course. If you give it the X test value, it will perform Y test. That's it. If prediction is not accurate, do we not give it more data to train? Yes, if that's exactly the point. If the testing is not good, we try to feed more data or we change the algorithm. You got it? If the answer that you want is not arriving well, then you either change the algorithm or add more data. Are we clear now? This graph is clear to everybody. Have any confusions? You please let me know now. Is it clear? Okay, now listen to me carefully. This is my data.head, how we arrived at ypred. Yeah, I'll show you how ypred is calculated. I will show you how ypred is actually calculated. I'll show you how ypred is calculated. Is that cool? In the practical part, so that your knowledge will be clear. Is this my data that I want to run machine learning on? Okay. I want to take a variable called x equals to data of which variable do I want my x to be in? I want the head size to be my x variable. Agree, disagree? I have already taught you this. I want my x to be the head. I want my y variable to be what? Or let me take it one point at a time. Values, okay? Dot values. If I run this and if I print x, have I taken x separately? All the values 4512, 3738, 3261, whatever all the values of x is now separate. Now it is in the format of an array, a single array. It is become an array. Agree? Okay. What do I do next? I take another variable called y. Okay. I take another variable called y. Which portion of the y do I need to pass? Do I need to pass data of something called as, what do I specifically pass inside the y? I pass brain weights. I copy this and I paste it here. Dot values. So what kind of answer did I get? I got all the values of y as an array. Agree or disagree? So have I separated the x and the y now? Have I separated all the values of x and y now? I did. Now, to implement linear regression, I need to import some libraries. These libraries are already given to us from sklearn dot linear model. Using sklearn.linear model API, I'm importing something called linear regression. Did I import linear regression also? This function will help me run linear regression. I don't care how it is written. I just need to call it. Agree, disagree? Yes or no? From sklearn.model selection, import train test split. Have I done this? From sklearn.model selection, I'm importing something called train test split. From sklearn.metrics, import mean square error. Okay. Import mean squared error. And I'm also going to import R square error. All right. R2 score. So tell me, what did I do? Did I import the libraries? I'm not even using them. I have just called them. I have just called them. I am making them sit on the chair. I have not asked them to do anything. Agree, disagree? So far, I have only called them. I have not done anything with them. Okay. Because I have taken the x value separately and I have taken the y value separately, the x value currently is in what dimension? Is it in one-dimensional data or two-dimensional data? One. That for sklearn, your data should be what dimensional data? Two. So can I say x equals to x dot reshape? Inside the reshape, if I pass this comma this, and if I print x again, did it become 2D? If I print x dot ndim, the answer is 2. The number of dimensions have become 2. From one dimension, I converted that into 2 dimension. Remember, you don't need to do this with y, only x, because x is the data that is being crunched by the model. Y is only for comparison. Only x needs to go through this process. Are we clear? Yes or no? Until here, is everybody clear? Oh, you don't know how reshape works? Okay. Have you ever done something called reshaping in NumPy? Have you ever performed something called reshape in NumPy? Okay. Okay, sure. Okay, listen. Array is equal to, listen to me carefully. Array is equal to np.array and pass any number inside it. 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever it is. 1, 2, 3, 4, 5, 6. There is a name of a method called array.reshape. So if you change that like okay. Did you understand this is how you declare an array in NumPy? This is how a NumPy is declared. Array is equal to np.array 1, 2, 3, 4, 5. This is an array. Okay. What is the dimension of the array? Is it a 1D array or a 2D array? Is it a 1D array or a 2D array? Okay. The shape of the array is 1D. Agree? If I want to reshape this, reshape bit array is equal to reshape RESHAPED underscore array is equal to r reshape. Whatever you want to reshape it on, if I pass like this 2, 3, and if I just print reshaped array, okay, and run this, did I just convert my original array into a different array format? Did I do this? Did I just reshape the array into a different format? Okay, let me show you one more example. Array.reshape of, if you add the number -1, 2, what happened in the original shape of the array to this? What does -1 do? What does -1 do? Let me explain that clearly for you. What is the concept of -1? Why do you use -1? No. Listen. In NumPy, if you are not sure about the shape of the array, meaning if you don't know whether the conversion of the shape will happen properly, meaning you don't know if the conversion of the columns or the rows will happen properly. So first of all, when you say 2 is what? 2 is the row order. Agree? 2 is the row order and 3 is the column order. Is this clear to everybody? 2 is the row order, 3 is the column order. If you're not sure about the row order or the column order, you don't know. You just want to make sure that the row should be 3. Because tell me one thing, depending on 1, 2, 3, 4, 5, 6, if I take one more number called 7, can this happen? Will the answer pop up 7? No. But because you don't know how many numbers exist, even number or odd number, I don't know. But if I do it like this, what happened? Array.reshape cannot reshape array of size 7 into shape 2 because you have given the column order 2. Yes or no? Agree? If I cross and put -1 and -1 here, it will still not be able to do. But what if I do 7, 8, right? And if I come over and do it like this, okay, let's change this to maybe 3. Right? Give me 1 second. 1, 2, and 3. What happened here? -1, 3 cannot reshape an array in the size of 8. 8 values, can it have some number of row which we don't know, but 3 columns? If I change this to maybe 2, 1, 2, 3, 4, 1, 2, 3, 4. But automatically, did I tell it how many rows it wants or how many rows it should have? But did it do it automatically? At the same time, did it convert the dimension from 1D to 2D? Just like that, how many number of data point does X have? Do we always know? Will we always know the size of the X? No, because we don't know. And also we want no errors and we want to convert it in 2D. Always put -1, 1. So have I put only one column and one row, which automatically it gives, but in 2D format. So this is reshaping the whole array. So what did we do now, right now? Did we reshape the array? What if we have more than one feature? So do we have to make all the feature into 2 dimension? Always. Does not matter you have 100, 200, 300, 800 features. It will always be 2D. It should be nested array. It will be nested array. Does not matter. It has to be 2D. Otherwise, sklearn does not consume this. Are we clear until here? Are we clear until here? Now that we have reshaped the array, if I take it like this, x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test. Call this method called train test split. and inside this pass the value of x and y. Okay, so the values of x and y you can pass inside it directly. At the same time, I can say test size is equal to 0.20. What happened here is, did I import a method, a function called train test split here using the library called sklearn.model-selection? Am I using the library's method called train test split? I am. I have just called that particular function here called train test split, and I'm passing the original value called x and y. And I'm taking the 100% of the data, but for testing, how many percentage will I use? 20%. If I make this 0.30, how much percent will this be? So training will be how much percent? Training will be how much percent? 70%. Testing will be 30%. Tell me, how much will be the training percent now? Did you get it? What happened? It automatically, this function called train test split automatically calculated the value of x train, x test, y train, y test in the data and gave the test data set to be 25%. Are we clear? I'm going to keep it only 20% and split the data. Also split the data. So did we get the value of x train, x test, y train and y test? Just what I taught you a while ago. Run this code. Your answer is done. That's it. That's all you had to do. The concept I had to take was so long, but it happened in one single line. Done. Now you want to implement logistic regression. Okay, some random and nums. Okay. Return nums. Okay. Okay. Some random of 1,2, 1 minute रुक जा हाँ just give me 1 second 2, 3, 4, 5, 6. Okay. Or I can do this. Okay, I can do this. Some random function of a comma b. Okay. Return a plus b and return a minus b, return a into b and return a divided by b. Okay. मैंने एक function लिखा है. I wrote a function called some random function. ठीक है? In front of you. If I call this function called some random function, and if I pass in the number 4, 5, is it giving me 4 different answers? Can I say that addition is this, subtraction is this, addition is this, subtraction is this, multiplication is this, and division is this is equal to some random functions, and I will pass the value of 4, 5. If I write the addition, 4 plus 5 is how much? 9. Subtraction kitna hua? -1. Multiplication 20 and division in Python. Yeah, good. No, you got what I'm trying to say. And write functions that can return 4, 5, 6, whatever values. This function called train test split is returning x train value separately, x test value separately, y separately, y test. So when I wrote all the variables, each variable got its own answer. So did we take the x train value, x test value and all of that stuff? Okay. So I'm going to take linear regression is equal to linear regression. Did you all implement something called classes and functions in Python? I am using something called object, a variable LR is equal to linear regression, and I'm calling a class called linear regression. I will use, or I will tell the Python program that, hey, I'm using a variable called LR. It is nothing but my model. Your model, your machine learning model is called what? What is the name of the model? LR. But what have I called the variable name? What have I called the variable name? LR. So I will tell the model that take the model, dot fit it. What do you mean by dot fit? Run the model. But will it run now? No. Because did I pass the train data? No. Did I pass the Y train data? No. Now it will run. Now I have passed the data, it will run. Do you see this blue color box in front of you? This blue color thing? This shows that the model has run. Your model has run, and the name of the model is called what? What is the name of the model? LR. You can give it whatever you want. I have named it as LR and your model has run. Are we clear? Your linear regression has run. Now, I want to know how my model performed on the testing data. So I will take another variable called ypred equals to, don't you want to make prediction on the test data to compare? What is the name of your model? LR dot predict. LR dot predict. This dot predict comes from sklearn only. You don't have to program it. It comes predict. So will I give it all the values of y test? Because all the y test value will tell me what is the y predicted value. No, you can't do that because y test is for comparison. You need to give it the value of x test for it to give you the value of y test, which is y pred value. So I need to, rather than x, test value, I need to give it the value of x test. Now I have all the values of y predicted, calculated for me. See, the values of y predicted values that the model has calculated for the test data is now created. So basically, I have created one more column called ypred in front of you. It's right there. Agree, disagree? Now I want to know whether my model did a good job or a bad job. So can I say R2, R square is equal to R2 score of what do you pass inside it to compare whether your model did good or not? Won't you pass ypred and ytest because you want to compare them together? Ytest and ypred will be passed to see how good they are, how close they are to each other. Yes. So tell me, in the R2 square, will I say y underscore test comma y underscore pred and we will get some answer R2 is equal to 0.71? Is the model closer to 1 or farther away from 1? Closer. So did our model do a good job in prediction? Is our model doing a good job in prediction? 100% it is doing a good job. I will show you how it is doing a good job. Plot. Inside this, I will pass x test comma y test value. Just the x test value and the y test value comma, you can take whatever color you want. So let me take color is equal to black. Okay, BLACK. And the label that you can give this is the actual data. Okay, the actual data point. Plot, because you want to also print your x test value with the y pred value. I'll tell you why. Okay, I'll tell you why. X test value with your y pred value. What will this give me? X test comma y test will tell me the actual data point. X test with y pred will tell me the predicted data point. So I will say color is equal to, I don't know, you can take red, black, whatever you want. I have taken red. Label is equal to predicted value, right? Predicted value. I have taken two different plots and I'm going to run this. Okay. I'm also going to give you, give me 1 second. Did I make a, tell me before plotting, what should you make sure for? Your x test and y test value are scatter plot, not an actual plot value, correct? Yeah, this makes sense because this is the data point that I wanted to plot. This data point, the black color line that you see, the black color dots that you see, that is your what data point? So if I plot.legend, okay, plot.legend, legend. Okay, if I do this, what are the black dots? Oh, you can also do grid. Plot.grid. And inside this, pass the parameter bool called true. Yeah, plot.grid. Let me make the alpha as 0.3. Yeah. The black points are the actual data point and the red line is the predicted line. Yes or no? Do you see that the fit is good? Are we able to see that the fit is good? Please listen to me carefully. The machine learning model has learned from so many different data sets that if your head size is 3,777 centimeter cube, how much is the weight of the brain? 1,282 grams, meaning 1.2 grams, 1.2 kg. Agree, disagree? Yes or no? Sir, I want to give my number. I want to give my number. I want to give weird number. I want to know if my machine learning model is able to predict my number or not. If you want to do that, use only one function, lr.predict. Now, you know that machine learning model like sklearn can only take a two-dimensional data. So give me a number like this, like if the head size is 4,177 centimeter cube, the answer is 1590. Give me a number like that. I will make the prediction in front of you. 6,000. 6, 1, 2, 3. What answer did I get? If your head size is 6,000 centimeter cube, what will be the weight of the brain? According to the linear regression model, it will be 1,883 grams. If you want me to give 4123, 4123, what answer did it give? If your weight is 1,406, it is 4,123, it's 1,004. We did take that. Did we not take all the values of X test here and we calculated Y pred? This is how we took, right? Did we not take all the X test value and created Y pred value and then compared Y test with X test? Now you got the concept. We took the values from the model itself and we tested how good it performed from the original data. And that's why the answer of R square came up to be 0.71. Can we try 377? Oh yeah, 100%. See, 3777. What is the answer? 1282, correct? 1282 is the answer. See, look at this. 1318. Is it closer to 1282? You got what I'm trying to say? For the answer 37777, see, look at this answer. 3982. What is the answer? 1375. Okay? 1375 is the answer. 1375 is the answer. The prediction is 1370. You understood what happened? The R square that I made you do was from scratch. The R square that I did teach you was from scratch. Will you be implementing things from scratch in life? No. You will be using the function that is being called here. Can you see I have called a function called R square? You don't need mean square error now. R square. Do you see I have used this R square? That's it. That's all you need to implement. This is the machine learning code to predict whether somebody's weight will be given or not. How many lines of code minimum did we use here? Not even 10, 15, maybe 12. This is the power of Python. This is the power of abstraction. You don't need to worry about anything. Everything else is taken care by itself and you're able to use the library and build your machine learning model. Some of you were asking me question, but sir, how will we predict? How will we predict? Did you see? Call the model and call the method called .predict and you will be able to get the answer. Are we clear? Did we get the concept? Is it clear until here, everybody? How did we learn the machine learning code and how did it implement and how did we write it? Okay, okay, good, good, good. My question to you is very simple. If we take one value from X train and it should predict exact Y train because we feed the value. What I taught you doing the concept of machine learning using actual prediction code was from scratch for your idea. But this is how you actually implement. Can you explain about lr.predict? Okay. Y is equal to mx plus c is the equation of the line. Agree? Some value of m must be calculated like 0.8. Some value of c must be calculated for 9. So won't the lr.predict do nothing but the actual value of y will be 0.8 into what is the size of the head did we take? 3982. So it will take 3982 plus some value of c, 9 will be taken. That's why the answer came up to be 1370. Did you understand? lr.predict is doing nothing complicated. What it is doing, it has created some equation called y is equal to mx plus c. It knows the value of m, it knows the value of c. The minute you take 3982, it is able to calculate the answer 1370. This is what this function is doing. This is what that prediction is doing. Same code can be used for Swiggy. This code is reusable wherever you want to use it. Is it also fitting best possible line? Yes, Ravish. The model fits the line to the best of its abilities, and then it gives the answer. Are we clear? It will automatically do all of that for you. Linear regression code runs that and gives you the most optimal answer. Don't you see the line passing through exactly in the middle, meaning the most optimal way fits? It's not even off by certain points. So it does. Because you had question in reshape, my dear, if you want to convert a data or any dimensional data into two-dimensional data, one-dimensional data into two-dimensional data, dot reshape. When you want to reshape your answers into something, you have to first pass the row and then you have to pass the column. Are you clear? The two will represent that create an array of size 2 and the answer 3. May you share the data set? Answer the row value and the column value and it will reshape the answer. The concept of -1 is you don't care about how many rows it will form, but you for sure want only 2 columns. And I want NumPy to take care of how many ever rows it will give me, you give me. But I want only 2 columns. If that happens and you don't care about how many rows will form, just put -1 there. Can you guys do some research and on the same data set print the value for adjusted R square? The answer will be same, by the way, because one feature, one target. But still, will you give it a shot? Will you guys give some try? Okay, let me tell you something. Do you think 2 hours of machine learning with me is more than enough for you to learn machine learning? I don't think so. This is possible forever. Don't you think you want to do your own research sometimes? Maybe validate whatever I teach. Hey, is Rudra teaching correctly or not? I want to check. He taught me linear regression. Let me learn linear regression from somewhere else also. Oh, no, no, no. Rudra is correct. Should you not do this? Should you not validate? You should not have faith in me. Make sense? You should always get it validated. So don't you think whatever code I taught you, you will implement it on your own? Also print extra value like R square, adjusted R square, and see if you're getting the answer. Do your research. If you guys are incapable, I'm not going to say incapable, but if you have a problem, let me know. Can we look into examples where multiple features are invoked? Sure, Reena, if you want to do that, I can also do this. Since it's almost 9, I will take care of that example also. But it's not going to be very challenging, Reena. You will understand once. I mean, not multiple, like I can take hundreds of columns. It's not going to be a very complicated thing. Why don't you give it a shot, Reena? And let me know if you face any trouble. If you want to implement machine learning algorithms, right? I have a folder created for guys like you. If you go to my GitHub page, right, you will find a repository called ML codes, right? In this ML codes, you will, under the ML folder, you will find something called linear regression. See here, how do I teach you? Yeah. Can you see multivariate linear regression? Can you see? I'll show you the example. See, do you have area of the house, bedroom of the house, age of the house, and price of the house? Is it multivariate, meaning multiple features? If you go to my code, look at what I did. Listen to me. Just have a look at this data. Is this the bedroom? Yeah. Do we have this equation? Listen to me carefully. Do I load the data? df is equal to df.read CSV? Yes or no? df.read CSV. I'm going to zoom it. Yes. Okay. Do I have something called linear regression is equal to regression.fit? Can you see? Regression model dot fit, but I am dropping price as the part, meaning I am taking area, bedroom, and age in my regression model, but my y variable will be what? What will be my y variable? My target y. That's it. You just have to do regression is equal to linear model. X will be equal to area, bedroom, and age, and price will be separate. Now, what did I do? I run the coefficient. See, I'm doing regression.predict. If my house is 3000 square feet, what is the next thing? 3 bedrooms and 40 is my age. What will be the price? 4,98,408 rupees or dollars. Did you get the idea? See, I'm able to predict also now. Did you get what I'm trying to say? Here, what I did is I have just dropped y variable because I don't need y variable. In X, I have taken both area, bedroom, and age. Doesn't need to be in caps. It just, you can do it in small also. Can I confirm my understanding? There are R2 here, test train, and they indicate the line is best fit or not. But none of them tell us that we have selected all the right features or not. No, that isn't feature selection, Kishle Sinha. That's different. That is using chi-square and different techniques to validate that. That is not dot by R square. R square tells you how good the fit is. But data can have null values as we are working on data before data cleaning. Will the ML give issues? Yes. If your data has null values, your answers will be wrong. Fortunately, whatever data I'm teaching you today with has been cleaned with any null and none values. So you don't have to worry about it having null or non issues, right? So you see, gender has no null value, age has no null value, head has no null value, and brain weight has no null value. So basically, if you run this method called data.isNA.isNull anything.sum, it tells you the null values. It has 0 because I cleaned it before for you. Because I'm thinking first you guys should learn how an algorithm works. Then slowly we'll go to EDA, make the data, clean the data, fix the data, mend it, and then we will do implementation of that. Everything happens step, step.
Guys, I have a special announcement for all of you. For all of you dedicated individuals who are looking forward to master data science, we are offering a straightforward 20% discount on our data science course, which is in collaboration with iHub IIT Roorkee. So do make sure to check the link given in the description and fill the inquiry form. Shortly, our team of course advisors will get in touch with you to activate the offer. Don't miss this chance and take your career to the next level. Click on the link given in the description right now.
Imagine there is a data where you have a column called column A, column B, column C, column D, column E, and you want to predict column F. Versus you have another data, column A, column B, column C, you have to predict column D. Now tell me one thing, does linear regression become a little problematic when the columns increase or not? Try answering this logically. When the number of columns increases, जैसे column A, column B, column C, column D, column E, these column A, column B, column C, column D, column E, they are all extra data. That means your feature space. Imagine guys, you have two columns, column A, column B. Or you have one column, column A, and you need to predict column B. So one independent variable, one dependent variable. Does it not become a two-dimensional data? Column A here and column B here. It's two-dimensional in nature. Now listen to me, listen to me. If you have column A and column B as an independent variable, you need to predict C. Did it just not become a three-dimensional column? A three-dimensional problem? Column A, column B, and column C. So that must mean more the columns I add, higher the feature space becomes. Dimension. This is 2 dimension. This is 3 dimension. And the more columns I add, higher the dimensional space becomes. This is called feature space. Remember this. If you want to become a Gen AI engineer, Chat GPT engineer, prompt engineer, you need to know what is feature space. Listen to me very carefully. So that must means more the column, higher is my dimension. Is this a true statement or not? Vector spaces are like feature spaces, but they are embedding layers. So they are basically like you push it down, narrow it down with a smaller embedding size. But yes, feature space and vector space to an extent can be called the same. Transformers embeddings are higher dimensional feature spaces. So it's the same thing. Higher the dimensions, higher is the feature space. Agree or disagree? Do you all agree? Do you know what is the problem that happens in linear regression? Do you know what problem happens in linear regression? The problem is the more columns you add, the more bias my algorithm becomes. Let me explain this concept of biasness in just 1 second. My algorithm stops performing that well. There is a reason behind it. We'll come to that topic. Don't worry. Did you get the context? The idea? Why? We'll talk later. But you got the idea? Imagine you have just learned how to ride a car. I am telling you, don't press clutch too much. You don't know why, but I'm telling you, if you press clutch too much, there's going to be a problem. We are in that situation. I am saying, while implementing linear regression, more the columns, there's a bigger problem. There's a challenge. I'll tell you why in about a second. But did you understand why there is a, did you understand that there is a challenge? Let me show you something. Copy image and paste. Yeah, is this, see my people, whenever you do linear regression, you calculate the formula of R square using this. R square equals to 1 minus sum of square residuals divided by sum of square total. Now, brought in a concept called sum of residuals. You remember we learned a concept called residuals? Whenever you have a linear regression problem, this is the actual data and this is the line. The line is here. This difference is called residual. Do you remember? I called this error as a residual. Sum of square residual means take all the errors, square them and add them together. That's called sum of squared residuals. Sum of squared residuals, okay? It's also called as sum of square errors. What they are? What are they? Very simple. Just listen to me very carefully. Whenever you calculated sum of squared residuals, did you not take the difference between the errors? You've taken up all the errors, you added up all the errors together. Because they are scared, they don't cancel each other out and they get added together. Okay. Do you see this thing called sum of squared total? Okay, I'm going to write something down. Tell me if it makes sense to you or not. Okay, I just want you to tell me if this makes sense to you. Sum of square residuals can be written as sum of each individual y subtracted with, or let me write it like this. Sum of square total, sum of square residual. Try to understand what this formula says. If I say summation of each individual data point minus its mean, the whole square, versus the predicted data minus individual data, the whole square. Does this make sense to you? So tell me one thing. This is the formula for R square and this is the formula for adjusted R square. Can somebody tell me why did we need to adjust it? Why do we need to adjust R square? Why do we need to change the R square? Why should this R square formula be changed? Reason is R square, N is the total sample size. So this N is the data size. How long or how big is my data? Number of independent variables. Aren't you dividing the whole R square by something called P? You're dividing something by P. Whenever you divide something from numerator with denominator, won't the number become lesser? Okay. I have a number called numerator. I have a number called denominator. I have a number called 4. I have a number called 2. What is 2 divided by 4? Can somebody tell me what is 2 divided by 4? 2. What is 4 divided by 3? 1.83. 1.33. Now tell me one thing. When I divided 4 by 2, the number was 2. When I increased the denominator, did my result not become smaller? Because the numbers of columns are higher, don't we want the model to be not very confident and just come down, reduce your excitement a little bit? Don't we want the model to just like calm down a little bit? Don't get too bigger in number. We want that number to go smaller and lesser and lesser. We don't want it to be exploded with the values. In order to do that, when the column size is bigger, this value of P penalizes means it reduces the output of R square in such a way that it becomes between 0 and 1. The value of output of R square is between 0 and 1, because what if you have a 30 column data and if you solve it using R square, you know what? Your output will be bigger than 1. But always we want the data to be between 0 and 1. If you're closer to 1, good. Closer to 0, bad. because the number of columns are increasing, we add this penalizing term called number of variables also, so that it reduces and is always between 0 and 1. Why this is important? If somebody asks you from now onwards, sir, why do you need to do something called adjusted R square? Your answer should be something like this. Due to higher feature space or higher dimensional space of the problem or the data, we need to reduce the model's output to a deliberate number between 0 and 1. And because R square says higher you are, the better confident you are in the fit, we want the number to be deliberate fit between 0 and 1. Hence, we penalize the R square with something called n minus p minus 1. We consider how many is the total data size. We subtract it with the total independent variables and we subtract it with 1. Hence, that penalizing term lets the data between 0 and 1, and hence R square, adjusted R square is a necessity. Are you clear? Did you measure something called RMSE? It's called root mean square error. Did you do that? Okay. Can I tell you an important part about this? And we are done with linear regression. Can I tell you one thing very, very important? Tell me one thing. Have you ever heard of something called loss function in machine learning? Ever encountered a term called loss function? Have you ever encountered a function called loss function? Okay, let me tell you something. एक बात बताओ, थोड़ा. I had a linear regression problem. There was a data. I fit a line. My mean square error was 31.246. I was like, okay, good. I shifted the line a little bit. My line shifted a little bit. My mean square error became 20.694. No problem. You shifted the line a little bit more. My mean square error became 15.114. Very good. I shifted the line a little bit more. My mean square error became 9.114. I shifted the line a little bit. My mean square error became 10.1161. I made one more shift. My mean square error became 21.619. Now, each time you change something in linear regression, what do you want to reduce? You want to reduce this mean square error, yes or no? You want to reduce, actually, if you see, you want to reduce an error. This error is called mean square error. Zara dhyan se sunna mujhe. You guys will fall in love with this beautiful thing. You ran the algorithm how many times? Iteration number 1, iteration number 2, iteration number 3, iteration number 4, iteration number 5, iteration number 6. The algorithm ran to make itself better 6 times. This is called as an iteration or epoch. In technical terms, I'm telling you in terms of technicality. These are called epochs. Epochs are basically in neural networks, front and back, forward and backward pass. Let's not worry about it. These are also called epochs or iterations. You can actually call them iterations. No problem. You had to run the algorithm 6 times. But tell me one thing. You had one thing which became your foundation, right? Your mean square error, which reduced, and you will pick up only the fourth one line. Fourth one will be the best fit line because it was the lowest. Every algorithm in this universe, every algorithm of machine learning, deep learning, natural language processing has a loss function. In this case, in our example, the loss function is mean square error that you want to reduce. Your aim of the algorithm is to reduce it such that the output is the best. Did you now understand the concept of loss function? Loss function is a function who you want to reduce. The one that you want to reduce in number so that the output is the best. Did that make sense? Can I give you a small assignment, if I may? If I have, I just taught you something called loss function. Do you know that there is also something called cost function? Will you guys please read up on the concept of what is loss function, what is cost function? You guys will be shocked to know the difference between loss function and cost function. And can I tell you something? Any algorithm in machine learning that you want to implement, you cannot implement it either without loss function or cost function. ऐसे हवा में linear regression के बारे में बात करने से you will not be able to learn. You need to talk every algorithm with respect to loss function and cost function. From now onwards, change your mentality a little bit. Don't think how the algorithm works. That's not the main point. From now on, whenever somebody tells you linear regression, suddenly it should hit your head that root mean square error, mean absolute error, mean absolute percentage error. There are so many different types of loss functions available in linear regression. You should think it from the loss functions perspective. So far, tell me this. Does anybody know how many times we have to actually run linear regression to get the relevant output? Do you know how to do that? Did you observe something? The error was the highest. It became lowest, lowest. It became lowest. And suddenly it started increasing again. And it is not becoming lesser until that. It's called global minima in gradient descent. You have to make sure that your loss constantly decreases. If your loss decreases and then suddenly starts to increase, that's a problem. Mathematically speaking, it depends on the size of the data, number of columns you have, but this is the general idea of what you have to follow. Do you remember yesterday I told you there is a topic called gradient descent? A concept called gradient descent? You remember I very broadly gave you a concept of idea called stochastic gradient descent. It's called SGD. That decides with a parabolic function using a tan function, which is basically a tangent, it tells you that your global minima is the most effective algorithm. Let's not go there. It decides somehow that this loss function has to be at this peak and then your output comes. So I want to actually take you guys through a concept called logistic regression. Now, before I jump into logistic regression, I have a question I want to ask. My questions can be more of a brain fry, but I promise you, if I fry your brain now, you will thank me later. Can I do that? Since you've already learned linear regression and logistic regression, have you ever encountered a problem where I wanted to classify a problem? For example, you give me the input data and I will classify whether this item is belonging to category A or category B. Isn't this what we call classification? Have you ever heard of something called multi-label classification and multi-class classification? One of the most interviewed question. Do you know that classification also is of two different types? One classification is called multi-label classification and the other is called multi-class classification. Did you know this? Imagine you have a category, okay? Things like love, hate. You tell me the name of the movie and I will predict whether people love the movie, hate the movie or don't know the movie. So tell me one thing. How many categories do I have of classification? 3, right? Number 1, number 2, number 3. These are called categories, right? So-called buckets. What if my problem statement is under love, also there are 2 categories. Really love it? Okay, love it. Did I make the problem statement more complicated? First, you predicted whether you love it. Under love, do you really love it or not that much love it? In real life scenarios, have you not seen that this is more predominant? When you have a classification problem called you love some movie, under love, is it not possible that you can really have another category between them? But in logistic regression, you only know it is a classification problem. That is very good in theory. What in practical life, if you want to implement something like this, will you be able to do with logistic regression? Imagine you give me your age, you give me how much salary you make and what is your CIBIL score. And I will tell you either you are a high risk person, low risk person or moderate risk person. Is this a classification problem or regression problem? Is this a classification problem or regression problem? Classification problem. Okay. Under high, if I want to predict that you are a very high performer or moderately high performance, under low, very low, moderately low, and under moderate, you just say moderate. This is the problem statement. When I predict, given your age, your salary, and CIBIL, first I want you to tell me which category I belong into. And in that category, I want you to tell me which subcategory do I belong into. Acha, tell me one thing. Whatever I've told you, isn't it very practical in real life? This must happen. Whenever people are doing classification, they must be going through this problem. Okay. My question to you is, you guys know logistic regression a little bit. Do you think this is possible using logistic regression? This problem? Can you keep this question on the top of your head for about a second until I introduce the topic and then we will talk about it? So my people, from calculating continuous values, I take you to another topic called logistic regression. Now, let me tell you, do not underestimate the topic of logistic regression. Logistic regression is going to become your foundations for learning very complicated algorithms like naive-Bayes classifier, k-nearest neighbor, decision trees, and random forests. If you don't understand logistic regression really well, you will not be able to learn naive-Bayes classifier, k-nearest neighbor, you'll not be able to understand random forest, and you'll not be able to understand decision trees. And if you don't understand decision trees and random forest, you will not be able to learn an algorithm called XGBoost. So everything is connected. Everything is like a dot by dot connection. So you need to learn the topic of logistic regression. And what I'm going to do is I'm going to take you guys through a journey which will be a little mathematical in nature, but also important for you to understand it theory-wise. What concept did you learn in logistic regression? Okay, let me ask and you tell me yes and no. Did you learn the concept of log of odds? Did you learn the concept of maximum likelihood estimation? Did you learn log of odds only on the top level or did you go deeper? Okay, what about maximum likelihood estimation? Was this concept introduced? Maximum likelihood estimation? Okay. Did you also learn the concept of sigmoid? Were these three topics introduced? Okay. 1 by 1 plus e to the power of minus x. Remember? You guys know the concept of 1 by 1 plus e to the power of minus x? Okay. So tell me one thing. If I ask you how the data comes, what steps happen and how you get the output, will you be able to tell me? What will be step number 1? What will be step number 2? What will be step number 3? Do you know at that much level? This much level of clarity? Okay. Tell me one thing. When we do linear regression, we fit a line. But does the line go beyond infinity? And this line can also go beyond positive infinity and negative infinity? ये possible है? 100% it is possible. Line का कोई अंत ही नहीं होता. Line has no end. Whenever you do logistic regression, you want to give a probability as an output, right? For example, you have a category called cat and dog. Whenever I input an image, don't you think I will get something called probability, like cat is 92% probability and this is 8% probability. But always the probability of cat and dog together add up to 100. They don't go beyond 100. Whenever you do classification, unlike linear regression, where the line can extend up to positive infinity and negative infinity, in classification, we don't have the luxury to do that. Numbers cannot go beyond positive infinity and negative infinity. They need to be probabilities. And guess what? The probability of a cat and the probability of a dog, all the probability should add up to 100%. Let me give you one more example. If your output was, are you possibility of a high input person, low input person, or moderate input person? Suppose if the probability, I have a given person's data, I pass it through my algorithm, the probability is 92% high, 6% low, and 2% mode. You see, no matter how many categories you have, the probability for one input, the one input that you've passed, you always have a probabilistic output in the output. And whichever has the highest probability, 92%, that is my output. For the given input, my output is, yes, the person is a high performer. Even though low has some percentage more, moderate has some percentage, but because high had 92%, my output of this classification is high. Did you learn the difference between linear regression and logistic regression? Linear regression is a continuous value. Logistic regression is a probability value. Do you know what happens in logistic regression? Because when we have an equation like this, or when we have a data like this, we want the data, or we want the output to be between 0 and 1. Yes or no? 0 means 0 probability. 1 means 100% probability. The reason we get this output is because we have a function in mathematics called sigmoid. What do we call this function? It's called logit function or sigmoid function. What it does mathematically is, no matter how big a number you give it, it will convert the number between 0 and 1. Did you get it? You want to feed it 1,060,048 something rupees. No matter how big of a number you give, it will always convert that number between 0 and 1. Did you now understand why we choose sigmoid function? We want to bring down every data between 0 and 1. Got the concept between why linear regression and logistic regression is not preferred? But let me tell you an example and then we will understand. Let's take this example. Okay. You have a data 0 and 1. Okay. You have a data 0 and 1. Okay. I'm thinking of a good example for you. Is logistic regression a supervised learning or unsupervised learning? Is it a supervised learning algorithm or unsupervised? You guys already know that supervised learning means the data is labeled. Yes or no? What do you mean by labeled data? You have a column A, you have a column B. The column C will be the answer is label 0 or 1. 0 or 1. Yes or no? This is how the label is. This is your target variable C. This is your independent variable A and B, predictor variables. You have a label 0 and 1. In machine learning, you are only going to be given two kinds of data. Listen to me very carefully and everything will make sense. Imagine you work for a finance company like mine. Okay. Let's say you work in a finance company. Okay. You want to predict whether the person should be given loan or not. Is this a classification problem or regression problem? You just want to predict whether the person should be given loan or not. Isn't this a classification problem? Yes or no? So what do? We take the person's age because age matter करता है, right? Your age matters. अगर आप 70 साल के लोन तो नहीं दे सकता मैं आपको. Age will matter. Okay. आपका CIBIL score will matter. Higher the CIBIL score, better is the chance you will pay the money back. How much money you make? What is your salary per month? Which company do you work for? Make sense? Based on all these variables, I will predict whether the person should be given loan. Give loan, L-O-A-N, loan. Answer is yes or no. No and yes. Imagine my age is 23. My CIBIL is 600. Okay. My salary is 15,000 per month. And my company is some XYZ company. I will say no. You will not be given loan. Imagine my age is 40. My CIBIL score is 875. My per month salary is 1,50,000 and I work for say Google, example. Yes, I will give you a loan. Ek baat batao, and I want age, CIBIL, salary, company. They all are helping you to predict something, yes or no? To predict whether you will give somebody loan or not. Labeled data का मतलब होता है, labeled data meaning your independent variables like age, CIBIL, salary, company, all are helping you to predict whether the person will be given loan or not. This is called labeled data. Label meaning you always have a target variable. Have a target variable. अगर मैं ये target variable को ही delete कर देता हूं, is this data labeled or not labeled? कोई label ही नहीं है. There is no more label. I just have age, CIBIL, salary, and company. This is called not a labeled data. Remember one thing. Whenever your data is not labeled, you will always use clustering algorithms here. Problem statement learning, where you have no label. Do you know what you can do with that data? Nothing. Only and only clustering. That is the only solution to that data. Whenever you have label, you can run regression, you can run classification. But if you don't have label, it becomes unsupervised. It means you need to do clustering. Does that make sense? Sir, how will you decide a company's weight to decide whether the company should be given a preference or not? Have you heard of a concept called encoding in machine learning? You have not heard the concept of encoding? Okay. What if Google, Amazon, Meta, and Adobe, all these companies get a label 1? So suppose every company that is a good company gets a label 1. Every company that my bank does not recognize gets a label 0. Did I give machine learning a value mathematical saying that 1 means it's a company that we prefer? 0 means it's a company we don't know, we don't prefer. Did you just encode the information? This is not one hot encoding. This is label encoding. But did you just encode the information? How machine learning solves problem? Does machine learning understand 15,000? Yes, it does. It's a number. Machine understands numbers. But does machine understand age 20? Yeah. Does machine understand the word path? It won't. Rudra, no. Joseph, no. Anubu, no. You need to convert that. So you have to follow something called encoding. Okay. Imagine I have a problem statement where the data is labeled. Okay. And I have data between 0 to 1. Suppose I have some data points here and some data points here. Now tell me one thing. Is it possible to fit a line here in linear regression? No, it's not possible for you to fit a line, right? It's not possible because the problem is I want my data to be clipped between 0 and 1. But linear regression takes me beyond 1 and lesser than 0. Do you know what logistic regression has in its backend, in its engine, in its hood? It's a very simple concept. My people, when you have a data between 0 and 1, your data labels between 0 and 1, the problem statement with this is you need to account for all the data between your left and your round. You need to account all the data. You just can't encounter one data to the top, one data to the left and fit a logistic regression curve because the problem statement is this logistic regression curve the best? Is this logistic regression the best? Which curve is the best? You don't know. You don't know that problem. So I'm going to give you a slight idea and I will make a lot of sense into it. Okay. I promise. What logistic regression does, whenever your data comes, whenever your data has arrived, it will first put your data between the label of 0 and 1. Tell me one thing. This above example, have we not labeled the person that whether this person will get a loan, yes and no? Yes means 1, no means 0. Now that the concept 0 and 1 is given to me, right? I have segregated my data, yes or no? I have put my data. My people, you know what we do? Once this data is given to us, you know what I do? I apply a concept called log of odds. Now listen to me carefully. It will be a little confusing. I apply something called log of odds. What it does is it will convert this data that is between 0 and 1 and it will convert and make this data go between positive infinity and negative infinity. And your data will go here and your data will go here. And you actually fit a line. Do you see this part? You had a probability distribution data. You applied something called log of odds. It became negative infinity and positive infinity. And you are actually trying to fit a line. Now you must be very confused. Why are we doing this? Right? We already have a number between 0 and 1. Why do we need to convert our data into a negative infinity and a positive infinity value? And we are trying to fit the line. I have a small question to ask you. Just listen to me. In regression, what is the best thing about regression, linear regression? Linear regression tells me, is this line better? Is this line better? Or is this line better? Yes or no? Basically, the concept of linear regression tells me which line fits best. Yes or no? Imagine I take a data that is between 0 and 1, convert it between positive infinity and negative infinity. Suppose my data is here in the positive infinity. My data is here in the negative infinity. Can't I draw a line, drop all the points to the line and make some judgment later that from this line is better? For example, line number 1 in green and line number 1 in red. Which line is better? I can make a judgment. Don't worry how. We'll talk the how later. Just Imagine, listen to me very carefully. My data is in positive infinity and negative infinity. I have two lines. One is green line, other is red line. Can I not drop all my data points on the red lines and green lines and make a judgment that maybe line 1 and line 2 does a better job? Can I not make that guess? After I decide between line 1 and line 2, which line is best, and I drop all the points, can I not apply something called sigmoid function, which is to this data, I applied the logistic regression 1 by 1 plus c to the power of minus x, and I will get 0 and 1 output again. The value is between 0 or 1 again. And this is the entire operation of my logistic regression. And we will learn everything in depth. Just giving you guys a hint, subtle hint. Are you understanding the overall perspective of logistic regression? Only 4 steps are performed. Data is given to us, is converted between 0 and 1. We convert that data between positive infinity and negative infinity using log of odds. Via log of odds, we fit a line. Whichever line is best, we apply sigmoid function to it and we get the output between probabilities. You kind of got a subtle hint. What steps are involved? Once the data comes, you actually apply something called log of odds. On log of odds, you apply something called sigmoid, and then you get a probability value. With the chain of process, what happens? Okay. Imagine, I tell you there is a fruit in the world called fluorobomba. Have you ever tried this fruit? Fluorobomba. The reason you have not eaten this fruit is because this fruit does not exist. I just made up the word. But did I give you an idea that there could be a word like this that could be a fruit? My point is, I know you did not understand what is log of odds, what is sigmoid. Ignore that. Can I at least tell you what the fruit tastes like and you can get an idea? I know you've not eaten the fruit yet, but if I explain at least 5%, you'll have an idea. What is the fruit? It is sweet. Is it sour? Is it huge? How do you cut it? Are you understanding what I'm trying to say? Point number 1. Did you get the process of what logistic regression steps are? Step number 1, you get the data. Step number 2, you apply log of odds. After log of odds, you need to convert it back again into probabilities. Hence, you apply something called sigmoid functions. Actually, you apply something called maximum likelihood. And after that, you get the output. So step is clear. Now, let's go in depth. Now, let's try to understand in depth how this particular thing works. Okay. Before I do that, did you learn the difference between probability and odds? Do you want me to reiterate it once or should I proceed forward? Listen to me very carefully and look at this problem statement, okay? A guy went fishing 5 times a week. How many times did he go fishing? 5 times in 1 week. Remember this number, 5 times in 1 week. He caught fish twice and he failed to catch 3 times. Okay. He caught fish twice. So twice he got success and thrice he got failure. This is the data, the current situation, the scenario. Probability is how many times did he get success divided by total times. So 2 times he caught the fish divided by how many times did he actually go out for fishing? 2 by 5. What is 2 divided by 5? What is 2 divided by 5? 40% success ratio, right? Can I say that this guy had a 40% success ratio? Every time he went for a fishing, the chances, the probability that he will get a fish or catch a fish is 40%. Have you heard in English, what are the odds of that? In English, you must have heard of this question. Hey, what are the odds of that? You encounter a problem. Suppose you are going into a, you're walking in a mall, you encounter or you meet your friend who you've not met after 5 years. Your first thought is, hey, what are the odds, right? Like, what is the odd you met me now? Listen, the concept of odd is different than the concept of probability. Odd is not the success of total event. Odds are 2 divided by 3. It means it is not the total time. It is the success by the total failure. And odds are higher than probabilities. So what is 2 divided by 3? What would be 2 divided by 3 in percentage? 60%, approximately, higher than that. that whenever you do probability, you divide it by the total values inside it. But odds don't happen like that. It is your success by your failures, which is called P by 1 minus P. Listen to me carefully. You got 90% in your marks. You got 90% marks in your 10th standard. What did you fail to get? Isn't it 100% minus 90%? The 10% you did not get? Am I now making sense? 100% may say it. 1 minus P, matlab 100% can also be called as 1. So it is called P divided by 1 minus P, success by failure. That makes sense to everybody? Let me ask you one more question. I just want to get a clarity. Imagine there is a ball. Imagine there is a bag. In this bag, you can't see the bag. There are 2 red balls, 3 black balls, and 4 green balls. Have you heard of something called conditional probability? Let me explain. Everything will become clear. If I remove 1 red ball, 2 black balls, and 1 green ball, what is the probability of getting the red ball? Can somebody tell me the answer to this? It will be how much? It will be 1 divided by 5, yes or no? Because only 1 red ball exists among all 5. Did you even consider the 1 that are not in the bag anymore? Did you not divide the whole category by the total data? Did you now understand? Any kind of probability, you always divide by what is left with you, total what is left with you. But odds don't work like that. Now that you have understood the concept of conditional probabilities, okay, let me tell you, why do we apply log? You must have heard of this thing called odds. I just taught you odds. But why do you need to apply log? Have you ever heard of, encountered a word called logarithms in your mathematics ever? Let's break it down. What are logarithms according to you? Yeah. This is better. Okay. Let me also take this because ये भी सही ही है and paste it. Okay. Guys, can I say that 2 to the power of 8, or hold on, what is 2 to the power of 3? Can I say 2 to the power of 3 is 8? 2 to the 4, 4 to the 8, which is basically 2 to the power of 3. Can I not write this equation as 2 to the power of 3 equals to 8 as log to the base 2 of 8 is equal to 2 is equal to 3? Am I making sense? Based on the given definition that I just showed you, logarithm helps us identify the power, right? The power x, the exponent, what we called as. Logarithms help us identify the calculations of exponents quicker than any other mathematical function. Can I also tell you something? Logarithms also have a base of natural logarithm e, or a natural base 2, or a natural base 10. Have you ever heard of this? Log to the base e, log to the base 2, log to the base 10. Okay. Now, look, e is called Euler's constant, okay? Euler's constant. It is 2.7 something something. I don't want to get into it, okay? My people, what logarithm does, let me tell you something. Logarithm is a clipping function. What function is it? Clipping function. If you are suddenly increasing, I will make your increment like this. Imagine it like this. You are a very excited person. What logarithm would do is, it will make you less excited. It doesn't ask you to curb your enthusiasm. It will say, let your enthusiasm go over a period of time. Somebody whose growth has been happened exponentially, the opposite of exponents is logarithm, right? So it will ask that person to go steadily but more longer. Do you see that increment here is shorter, but the increment here is longer, but both are increasing? So the data is not lost, but it's just that it is expanded like a clipper. Making sense to some extent mathematically? Let's do this. Does y is equal to mx plus c happen for line equation? Is this called a line equation? when the number of variables are higher, suppose there is a column called age and column called salary, and I want to predict something like loan amount, example. So can I say that age and salary is another variable? So I can say y is equal to m1x1 plus m2x2 plus c, or you can call it m1 into age plus m2 into salary plus c. Can I call this as the line equation to solve this problem? This is mathematical way. If you talk from a mathematical visual way, it means that there are three equations, right? This is my loan amount. This is my age. This is my salary. So there will be a line rather than two dimension. Let's make it one dimension. So can I say that I can, whatever value of X I have, I drop that value of X on this line, and the corresponding value of Y is my prediction, Y hat. I change the line, I take the value of X, plot it on the line, and whatever is on the Y is my prediction. So listen to me carefully. What is the equation of logistic regression? It is 1 by 1 plus e to the power of minus z. Yes or no? This is logistic regression. Yes or no? Do you know what is this z, guys? What is this z? What is this z? This z is nothing but, imagine you want to do logistic regression problem where you have age, you have salary, and you want to predict whether somebody will be given loan or not. LOA and loan. So suppose my age is 23. My salary is 1,50,000. Should you give loan? Yes. My age is 45 or 40. 15,000 is my salary. Should you give a loan? No. This minus z is nothing but g of x is equal to 1 by 1 plus e to the power of minus of m1 into age plus m2 into salary plus c. That's it. You're done. Plus c. This is what a logistic regression will be like. That line equation I told you that we are going to fit in positive and negative infinity, right? That line you just have to simply put here. Now, whichever value you will put, logistic regression will convert that between 0 and 1. See, guys, logistic regression is not very complicated. Okay, I'm just telling you guys an idea. It's not very complicated. How we get this equation is log of probability of x divided by 1 minus probability of x is equal to mx plus c. This is the core equation of logistic regression. When you do mathematical, movement and change it and all of that, you arrive at this equation. That is why. Does it not look like logistic regression? One sigmoid function 1 by 1 plus e to the power of minus x. Your z is nothing but the line equation that you're trying to solve. And if you apply the value, you'll get the output. Can I tell you some more idea? The value, how do you get the coefficient m1 and m2? You cannot use ordinary least square here. Can you? Suppose there is a line equation. Can you use ordinary least square here? No. Remember one thing, my people. To calculate the coefficient on m1 and m2, you use a technique called maximum likelihood estimation. Did you get the idea? In ordinary least square method, we calculated the value of m and c. In logistic regression, because we also fit a line, but this time we fit a line on a sigmoid, we calculate m1, m2, and c using a method called maximum likelihood estimation. If I write down a formula, if I write down the variable, can you write the equation for me? Imagine I want to take, imagine I have a data called area of the house, low height, low ground clearance, okay, ground clearance, low ground clearance, longer body, and 3000 cc, greater than 3000 cc or not. Probability that this is a supercar. Can you write the logistic regression equation for this particular example? Can you write the logistic equation for this? The logistic regression equation for this? 1 by 1 plus e to the power of minus of whatever you want to write. I want the answer. Did you guys know how to write the sigmoid equation? 1 by 1 plus e to the power of minus of m1 into low ground clearance plus m2 into longer body plus m3 into greater than 3000 cc plus c. Did you all write the same equation? Did you now get it? It is that simple. That's it. You take a line equation, you convert the line equation. Boss, listen to me very carefully, people. When this is how our data looks like in logistic regression, all I'm doing is taking this logistic regression line, this linear line, and converting it into a squiggle. That's all I am doing. And I am doing this using the help of this function. That is it. Up, agar mathematically also, if you code this up, you only need one equation, and that is this much. Done. To calculate M1, M2, M3, C, you cannot use ordinary least square. You have to use a method called maximum likelihood estimation. Linear regression. Acha, tell me one thing. According to you, which is one of the most important library in Python? Import NumPy as NP. Import pandas as PD. Yes or no? Import matplotlib.pyplot as PLT. Okay, pyplot as PLT. See, these three libraries to boss are needed. Told you there are two kinds of data, right? Weekly data and sales data, right? So week underscore data and sales data. Sales underscore data. We had a weekly data like first week, second week, third week, fourth week, and fifth week. And give me 1 second. First week, second week, third week, fourth week, and fifth week. This is properly equal with spaces. 2, 4, 5, 4, 5 if I'm not wrong. If I would have written here also NP, would I have gotten any error? Import NumPy as Rudra. Can I do this? df equals to pd.dataframe. Do you understand what is this data frame? Like how do you actually implement a data frame? So you can say things like week, right? Week or weeks, anything is fine. And you can pass something called week data. Okay. And you can take up another variable called sales, and you can take up sales data. Yeah. Is this clear? This is the data. So when we practically took the part, do we have the same exact data? Okay. From this, in machine learning, don't we divide our algorithm into two parts? Suppose I have a weekly data and I have a sales data. Won't I divide this into X and Y? Y is my target and X is all my independent variable. X can be equal to, what can I say? df of, right? X equals to df of, I want weeks, right? So I will say X is weeks, right? And I can even take values, like all the values of the data, values. Yeah, this is my X value. What could be my Y value? My Y value could be sales. So if I run this and print X, not small, but the capital one. This is my X and this is my Y. Can you see that I've taken two data, X and Y separately? When I was doing something manually, what was the first thing that I did in linear regression? Do you remember I told you, whenever you have a linear regression, you first need to calculate the mean of X and mean of Y so that you know where you want to pass from? Yes or no? So let's calculate it. Mean of X equals to and mean of Y equals to. So if I want to calculate the mean of X, can I not say NP dot mean of X and NP dot mean of Y? And if I calculate print mean of X and mean of Y is 3 and 4. This is basically all my mean values of X and Y, basically, right? I just wanted to print it, didn't want to take it. I'll take another variable called N equals to length of all the variables X. So how much data set do we have? What is the sample size do we have? 5 is the sample size. Okay. Now, what was the formula that we calculated in the machine learning class? What was the formula? Hold on, give me 1 second. Let me try to find that number that we did. To calculate linear regression, to calculate the value of m1 and x1, did we take x minus x bar into y minus y bar by x minus x bar the whole square? And to calculate y, then we used that equation to calculate it. So x minus x bar into y minus y bar by x minus x bar the whole square. If I want to write this in mathematics, can I say numerator equals to 0 and denominator equals to 0? This is like assigning the value. And now I will loop for I in range of the total sample size, which is n. Numerator plus equal to, now tell me one thing, each value of x minus x bar, which is each value of x minus its mean into each value of y minus its mean. Yes or no? Each value of x, independent value of x minus its mean into y independent minus its mean. So can I write it something like this? X of I, because I will loop, minus mean of x into y of I, independent values of y minus mean of y. Can I do this? X minus x bar into y minus y bar. This will be my numerator. And I can take something called denominator, right? So denominator plus equal to, I'm also calculating for that. What is the value of denominator? X minus x bar the whole square, which is basically x of I minus mean of x the whole square. Yes or no? This completes my calculation for my m value. You remember m value? So if you want to calculate m, the value of m, is it not numerator divided by denominator? And if I calculate the value of m, what value of m did we get, my people, when we calculated the value of m? 0.6. What answer did I get? Now we need to calculate the value of c. What is the formula for c? If you look very carefully, c is nothing but, see, look at this formula, okay? Listen to me very carefully. Y bar is equal to mx bar plus c. If I rearrange everything properly, isn't c equals to y bar minus mx bar? Just rearranging. Y bar, which is mean of y, minus your value of your m that you have calculated into mean of x. So if I replace that exact same equation here and call this as c, like you call this as c, right? C is equal to mean of y minus your m value multiplied by mean of x. And if I calculate c, did I get 2.2? The same exact thing that we got yesterday. So tell me one thing. Did we implement any library in this to calculate the coefficients? We did not. We didn't specifically need any library to calculate that value. We did not do that. Okay. How about we look at the data? We visualize the data. Can we do that? Let's observe how does our linear regression look like. Okay. Plus 2. Let's take a range of mean. You can call it max of x also, actually, and mean of x or min of x. Okay, min of x, max of x, min of x, np dot x, np dot min, and yeah, that could be the range. So sorry, I'm getting a call. Apologies. Yeah. Okay. Have you ever encountered a function called line space or linspace? Have you ever had the opportunity to work with this? Do you know what in NumPy this is? You guys already know this, right? M into, okay, mx plus c. So you can call it as a, can you tell me among m and c, which remains constant no matter how many variables are added? Which, see, usually this m is also called as b1 in the equation, right? Like, and this thing is also called as b0. Like b1 and b0. You guys know that this is also called b1 and b0. Like there is no confusion there, right? So if you actually think about it, right? So let's say I have written my equation called c plus, okay? Let's say c plus b naught x, which is m into x. So say m into x, or x value could be anything, but I'll just write it down here. Which equation does not change at all? in mx plus c? C does not change. What happens to m? Does it change every time there is another variable added, another target variable, another independent variable added? Will you keep this in your mind while I'm doing this code? Will you keep this in mind while I'm doing this code? Okay. Okay. Tell me this. If I pass in x comma y, okay, and give it some color like hex code online, okay. Let's take like a good hex code. Let's take darker color, or maybe, yeah, let's take like this magenta pink sort of a color. Yeah, this is good. Let's copy this and paste it for this color. Yeah, this is, I think it's going to be neater, but it's okay. Label equals to regression line. Actually, regression line, but okay. Copy this and paste it here. Yeah, I can paste this, and I can even change the line width and all of that stuff. But okay, label equals to my data. If I want to use something called line style, would you understand what line style is? Suppose if I want to implement something called line width, width is equals to 4 maybe. If I run this example, basically this is the data point that we had, and I'm basically plotting this data. So do you know that I can also do something called plot.legend, plt.legend, and I can do location equals to best, loc equals to best. And if I do this, I now have, what does this line, see initially, observe to the left. This line is regression line, red, green is the data was not there. If I comment it, run it, see my graph is not very good. But the moment I print the legend, my graph is much more neater. Clear, like see, if I want to make it alpha, for example, alpha, ALPHA, alpha equals to 2. Do you see that my line, matplotlib alpha. Okay, a matplotlib alpha plot, dot plot, dot plot. Yeah, give me 1 second. ALPHA, ALPHA. Okay, my spelling was correct then. ALPHA equals to something. What is the value? 20, yeah? Okay. You're not supposed to have a, you're supposed to have a fraction values. Yeah. Do you see that my line became very light? You saw that my line, the red line became very light, right? Like, hold on, I'll show it to you. Wait. I want a jhatang red color, like a red color that should just make us feel like what are we doing in our life? Give me 1 second. Like ultra bright red I want. Hold on. Yes, let's take this. Copy and paste it here. Give me 1 second. Yeah. This is good. Okay. So if I change this 0.2 to 0.9, do you see it is ultra bright now? Full. So what I'm doing here basically is, guys, do you see that the range in the bottom, I wanted the range to be smaller. That's why what I did is I created a max range +2, min range -2. So that on the left and the right, I have ranges for the line to plot. So if I do see, look at this, +10, -10. Can you see that line is being extended and the points? This line, I want to make it bigger. That's why. Can you see the range starts at -10, range ends at +15? Do you see that the range is -10 and +15? So I wanted the range to be good. That's why I did it. Let's keep it to only 2 because that's the best one. But do you see how my data is plotted and how my first logistic regression graph is plotted? My data points, like what I'm doing here. First, we implemented the ordinary least square method. We calculated and we fit the line. Basically, this is the linear regression line that we fit using the y is equal to mx plus c that we calculated. See, I am replicating the value of C and M, whatever we calculated on top, and I'm calculating the answer correctly, directly from the value. Can we implement R square now? Do you see the R square formula that I implemented here? Y minus Y bar, Y minus Y bar minus divided by summation of Y minus Y bar the whole square. To implement R square, can I say sum of square total is equal to 0? and sum of square residuals, the one that you want to calculate, is equal to 0, because I'm sort of creating a counter and then later update it. For I in range of, how many times do you want to iterate? N times, because that is the number of samples that we have in our data. Y predicted value, all the Y pred value, the Y hat you called as C plus M into X, yes or no? Rather than calling it X like this, can I not call it X of I? Each data point. See, here you have B naught, right? Which is C plus M into X. But each value of X means each value of X of I, right? Because that's how we will be able to implement the value. So what will be sum of square total is equal to plus equal to, according to the formula, it is each value of Y minus its mean, the whole square. Yes or no? This is the formula. Sum of squared residuals plus equal to, what is sum of square residuals? Same exact thing, but here instead of instead of mean of I, we calculated with predicted, Y predicted. We just changed this with Y underscore pred and same exact whole square. Now tell me one thing, what is the formula of R square? What is the formula of R square? Look at this, look at this. 1 minus residual sum of squares, which is called sum of square residual. See, RSS is residual sum of squares, which is sum of square residuals. It's the same thing. Divided by total sums residuals. So hold on, let's take it like this. Where is the formula? This is the formula, right? So taking this formula, can I say R square value is 1 minus sum of squared residuals divided by sum of square total. And if I print R square, what answer did we get? 0.6. Did we get the same exact answer? These are not my formulas. We are just implementing them. So are we getting the same exact output? Yes or no? We are. Okay. We have done ordinary least square method. We have fit the line equation. We've even calculated R square. Do you want to test the actual library from sklearn and see how good are we matching? Can we try that? Okay. To do that, from sklearn, okay, dot linear model, import linear regression, okay, import linear regression. But what I'm also going to do is from sklearn dot metrics import. Do you know there is something called mean square error, my people? Mean squared error. We have MSE mean square error. I told you it is a loss function. Okay. Let's do this. Can we also calculate mean square error quickly? Let's calculate it. To calculate root mean square error, can I take root mean square error is equal to 0, a counter 0, for I in range of n? Yahan tak clear hai? Okay. Root mean square error formula. Can I show you the formula for root mean square error? What is the formula? Predicted minus actual. You need to calculate predicted value minus actual value, square it and divide it by the total sample size. Each value of Y subtracted with the predicted value, whole square and divided by the sample size. So this is a very simple formula. अब इसके लिए मुझे क्या करना पड़ेगा? I need to write something called Y pred equals to, okay, यहीं से ले लेते हैं. Y pred is equal to this. Copy and paste. Y pred is equal to this much. What will I do? Root mean square error plus equal to each value of Y subtracted with Y pred and the whole square. Yes or no? Root mean square is equal to each value of Y subtracted with Y pred and the whole square. After I am done with this, what do I need to do? I need to come outside the loop because I don't want it to be in the same iteration. Root mean square error is equal to np dot sqrt. I want the square root. Do you see? There's a square root here. This big square root. The entire big square root. Now, square root of what? Square root of what do I do exactly? Root mean square error divided by sample size. So root mean square error is how much, guys? 0.7. Approximately 0.7. See, we print the value right in front of you. If I want to implement linear regression from my library, so can I not do something called x.reshape? Okay. The reason I have to do reshape is because the problem with sklearn's package is it does not give me array directly. The X variable, the X from data frame does not give me a array directly. So I need to convert that into an array. Okay. Regression is equal to linear regression. I'm calling linear regression. I'm passing no hyperparameters whatsoever. Regression dot fit. And I'm passing in the variable of X comma Y. Okay. Run. This tells me my linear regression has already been printed. This particular thing tells me that my linear regression has already been printed. My linear regression algorithm has run. That's what it means. So tell me one thing. What is the equation of y pred value? What is the equation of y pred? So can I say y pred equals to c plus m into x? M into x. Is this my equation for y pred value? So mean square error equals to mean squared error, the one function that I've imported from top, and I'm passing y comma y underscore pred. Y underscore pred. The same exact equation that I've done. Okay. And let's also take r square. Score equals to, you can just say reg dot score, which is the same function that we've just implemented, pass comma x and y. Okay. Just x comma y. So r square score. What is the r square score we got and r square score we have from the library? Is it almost same? 0.59999, which is 0.6, which is what we calculated. Okay. How about the mean square error? The mean square error is np.sqrt of mean square error. Did we get 0.6928, 0.6928, the exact same mean square error? When we've implemented something called mean square error function C, I have imported something called mean squared error. I have called mean squared error and I got np.square root mean square error exactly the same. So there is no difference. We got the same exact fit, same exact output. We got the same exact r square and root mean square error values. You got the concept, my people. It's just the formulas converted back into the code. That's all I'm doing. I'm not doing anything fancy, right? I have just implemented root mean square error from code, and then I'm using the same exact line. It's just that the number of lines are lesser for implementing the package versus I had to write a longer code. How good is your pandas? Do you know why do you have to reshape? Kernel, restart and clear output. I have cleared my kernel, okay? My kernel is dead. I've created it from scratch. 1, 2. This is my data. I'm coming directly to here, okay? Is it giving me an error? Acha, where is x? Acha, we did not define x, right? Yeah, just 1 second. 1, 2, 3, 4. X and y. X और y. हाँ, ये print कर दिया हमने. ठीक है? हम यहाँ पे आए. हमने इसको रन किया, इसको रन किया. n कहाँ पे भाई? अच्छा, length of n भी बताया था ना कहीं पे मैंने. हाँ, चलो n is equal to length of x. ये भी ले लेते हैं. 1, 2, 3. x, y. इसके नीचे ले लेते हैं length of x. इसको वापस रन करते हैं लेंथ ऑफ x के साथ एंड लेट्स रन लीनियर रिग्रेशन वाला पार्ट एंड डू इट एंड रीशेप नहीं करना है, सॉरी, लेट्स जस्ट टेक इट x एज इट इज, राइट? सो x को एज इट इज लेंगे हम एंड कर्नल रीस्टार्ट एंड क्लियर आउट. ठीक है, रीस्टार्ट एंड क्लियर आउटपुट. कर्नल मैंने वापस रीइनिशिएट किया 1, 2, 3, 4, 5 n and all the way from this and this. Acha, tell me one thing. The x variable that you just see here, ये array में इसने इसको convert कर दिया. Not always this x variable is converted into an array. मैं आपको output दिखाता हूँ इसका. Am I getting an error saying that your array is not of proper shape? बहुत ध्यान से सुनना, okay? Listen to me very carefully. Whenever you pass a data in a linear regression model, it needs to be a nested array. एक array के अंदर जो array होती है. Have you ever seen it in Python that you need to pass something like this? My name is Rudra. And then another array called Alankar. This is how a linear regression model or any machine learning model expects. But what it gives is this. Rudra, Alankar. So guys, how do you find linear regression so far? The programs that I showed you right now, The programs and all the problems I showed you right now was just a warm-up. Can we actually implement a linear regression on an actual data and show you? Can we actually run a regression on a real life scenario? And then let's see what we can do with that. Can we do it? Import pandas as PD. Data equals to np.read CSV. Okay, READ, read. See, even we are foolish. People like me. People call me as somebody who has good knowledge. Data.head of 4. You have a gender. 1 means male, 0 means female. Your age range, 1 means greater than 30, 0 less than 30. What is your head size and what is the brain weight? If I want to drop gender and age, it's of not important to me. If I tell you my head size, can you predict my brain weight? Can we make this linear regression model? I want to understand if I give you the size of my head. Acha, tell me one thing. If I want to do that, shouldn't I not divide my data into two categories, X and Y, just like how we do it in every machine learning model? So tell me one thing. What will I do with the head data of, right? What do I keep as an X variable? What do I keep as a Y variable? What do I keep as an X variable? The head size in centimeter cube dot values. All this can be my X variable. Yes or no? I don't care about gender or age. I don't need no gender, no age. It's of not importance to me. I am taking this as my X variable. What will be my Y variable, my people? What will be my Y variable? Brain weight in grams. Before I run a linear regression model, what did I tell you to first validate in a linear regression model? What did I tell you? You should always validate. Import matplotlib.pyplot as PLT. Did I not tell you to check linearity first? Yes or no? So can I say plot.scatter of X comma Y, okay, X comma Y, and run it? Does it not look like it is possible through linear regression because a line can be passed through them? It's not curvy. Make sense? I have just plotted the data and I've shown you that. But what do you need to do with the X? You need to reshape it. Yes. You can reshape it -1, 1 also, n, 1 also, whatever you want to do. It's up to you. Yes or no? Pehle ye batao. Am I saying the right thing or am I saying the nonsense things? I want to run linear regression. Have I imported all the packages properly in linear regression? How do you call linear regression? From sklearn dot linear model import linear regression. इतना समझ में आ गया आपको? You have to remember this. From sklearn dot metrics. What do I want to import? Two things. Import mean squared error and R square error, which is R2 score. Basically, आप उसको एक ही चीज बोल सकते हो. And from sklearn dot, you must have not heard of this, but this is called model selection. Import beautiful thing called train test split. This will become your life. If you don't do train test split, you can't do machine learning. I'm telling you this right now. Whenever we run machine learning models, don't we split the data into 4 categories? Suppose this is my head, kya tha ye? Head size and brain weight. हाँ. I have a column called head size and brain weight. अब एक बात बताओ, head size और brain weight में हम क्या ले रहे हैं? Head size is X, right? Brain weight is Y. Yes. We have split the data into 2 parts, X and Y. We've done this, see? X and Y. Here the splitting happened. But guess what, my people? You even need to split this data into train and test. Are you clear? You need to split this data into training data and testing data. Don't your machine learning model need some training? After the training is done, you need to test on the test data. So you need to split this data as train and test. X train, X test, Y train, Y test. So you will get X train, X test, Y train, Y test. This concept in machine learning will never leave you. I'm telling you, this is needed. So tell me one thing. This should happen, yes, and this should happen in a sequence. Can I take it x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test. X train, X test, Y train, Y test. Who do you call train test split? What will you pass the data? X, comma, Y, comma, test size. How much do you want your test percentage to be? Let's keep it 20%. So 0.2. My training data is 80%. My testing data is 20%. Linear regression equals to call linear regression just directly. Linear regression, make it callable. Simple. What do you do later on? LR.fit. That's it. Linear regression dot fit. Pass X train, comma Y train. Any confusion? You run this. My linear regression model has run. Mera model run kar gaya. My model has run. My head size is 4,512, 3,738, 4,261, 3,771, whatever the value is, whatever the value that you want to predict. Can I help you understand how to predict? Can I show you a prediction right in front of you right now? How to predict? LR.predict. I told you, how should you pass the data? Nested list or not? Can you give me a random number between 4,000 and 3,000? Some number, 3,000. Can we take 3,004? Okay, 3,788. What did it tell me? The weight of the brain will be? What is the prediction it gave me? It says that for a weight of head size of 3,788, your brain weight will be 1,317. Did we get the output the way we expected? And see, the output is correct. For 3,000, approximately 400 something range, we are getting 1,297 as the brain weight. So this is approximately doing a good job. What? Did you just predict? Now, let's calculate mean square error. Can we calculate R square mean square error just to know how good are we performing? So y underscore pred equals to, what is the equation? LR.predict for all the values of X test. For all my test functions, my Y predicted values are calculated. The values that are there in my test set, all the values for test set that I have calculated, I have. The predicted values that I have. How do you calculate mean square error? Mean square error equals to, call mean square error. What will you pass inside it? Y test, Y pred. And remember one thing, this will never change. This will remain, this Y test, Y pred will remain Y test, Y pred for all algorithms in the world. I'm not changing it according to what I am doing, okay? Root mean square error is equal to np.sqrt of mean square error. Can I say this is true? R square is equal to R2 score of, what do you pass? Y test, Y pred. Whenever you want to test something, you pass Y test, Y pred. That's it. You're done. Sorted. Can I print the values? Print f of root mean square error value is, how much is the root mean square error value? Root mean square error value slash n. What is my R square value? Sorry, R square value is R square value. Okay, R2 value. If I run this, do you see that my root mean square error and my R square value is close to 1? It's close to 1. That means the model has done a good fit. You can even plot it. We can even plot the data. Hold on. Plot.scatter. What will you pass inside the scatter plot? X test and Y test, right? Because we're doing it on the test. Yes or no? Are you understanding the logic, my people? COLOR is equal to black. Let's take it very simple. I'm not going to do very complicated stuff. I'm just taking it in a very simplistic sense, okay? And you pass in the Y pred values, and you can take the color equals to red. Label equals to data. ठीक है? और label equals to क्या है ये? This is line. हाँ, okay. Do you see how a data runs? We have fit, how good we fit the data. See, it's going exactly in a way which is fitting the data approximately well. We can increase this better. We can make it more better. We will talk about that later. But do you see any difference in how practically we've implemented a linear regression model? We got the R square value. We've just implemented it on a practical data set. I showed you how to download the data, upload the data basically to Jupyter Notebook, how to plot it, check for linearity, run it. That's it. It's no magic. There is nothing fancy that I'm doing that you're doing different. I would have done the same value, the same thing. You need to do it exactly in the same way. In logistic regression, we are not fitting a line, but we are fitting something called as a curve or called as a squiggle. That is nothing but 1 by 1 plus e to the power of minus z. This z is nothing but m1 x1 plus m2 x2 plus c. Does this make sense? Does this make sense? That we have a line equation. Initially, the logistic regression data might look like this, right? The data looks like this. Now a line cannot fit into it. So what do? I convert that all the entire line into positive and negative infinities. I fit a line. All the data points fall into the same line, right? And that, what do? 1 by 1 plus e to the power of minus z we apply. What happens? A squiggle is fit that fits all the data point properly. Yeah, this is the flow of the logistic regression code or algorithm. Not a very complicated thing. But now, let's look at it practically. Shall we? Can we look at logistic regression program practically? How does it work? Okay. Before I actually do that, point number one, I have a couple of questions I want to ask you. They say, right, before jumping into, it took me 2 months to even start punching the bag. For the first 2 months, they made me do workouts, which was uh, all warm-ups. For 2 months, I was dying to make my first punch on a punching bag, but that never happened. The reason is you have to first get your headspace clear before you jump into the actual stuff. You guys tell me one thing and tell me one thing very clearly. In logistic regression, okay, or any machine learning problem that you're ever going to get in any organization, tell me, will you not do this in your practical career that whenever you have a data on and the problem statement is either classification or regression, first you need to understand whether my problem statement is a classification problem or a regression problem. Example, it's a classification problem. So for the same data, won't you apply multiple algorithms at the same time? You will apply logistic regression also. You will apply support vector machine also. You will apply XGBoost also, decision tree also, random forest also. Suppose you've implemented all these algorithms, won't then you decide which algorithm is performing best and select that one? This is how the industry works. This is the reality of the industry. You as a data scientist will be given a data, correct? You're not going to apply one algorithm then second algorithm second time, then third algorithm third time. You don't have enough time like that. You have one data set. You apply all the algorithms at the same time, which you think are good, and select the best one out of them. But how do you decide which one is best? Support linear regression, sorry, logistic is best, support vector machine is best, XGBoost is best. How do you finalize? Don't you need some kind of an evaluation? Don't you need some kind of an evaluation? Oh, yeah, I think this is good. But what? Do you prefer accuracy score, F1 score, AUC ROC score? We don't know. You don't know. So let me tell you one thing, guys. In linear regression, we decide the model is performing best on terms of root mean square error. If my root mean square error is lower, I'm saying it is good. But in logistic regression, specifically classification, there is a concept called confusion matrix. How many of you know what is confusion matrix? Let me help you understand. Now listen to me very carefully. Imagine there are two actors in a movie. I am about to play a movie in front of you. There are two actors. Actors are very simple. One is a doctor, other is a patient. Okay? One is a doctor, other is a patient. Imagine a girl walks into a clinic. This girl is actually pregnant. In reality, in truth, in all the truthness, she's pregnant. The doctor says, hey, my diagnosis is you're pregnant. So is this a good thing the model did? This is a good thing the model did, right? Or the doctor did. Forget model, doctor. The girl had a reality. The doctor also said the same thing, the same reality. The both sentences are true. The girl was pregnant. The doctor says, yes, the diagnosis is you're pregnant. In machine learning, in specifically classification problem, this is called as true positive. When something was really true, you predicted it to be true. Good thing. The girl in reality is not pregnant. She's not. The doctor says, don't worry, you're not pregnant, you're not carrying. Isn't this also a good thing? The top example was a positive example, but the bottom example is a negative example. She is not, the doctor says, don't worry, you're not. Isn't this also a great thing that the model does or the doctor did? This is called true negative. So true positive and true negative are all the labels which were predicted correctly. Yes or no? If something was 1, my prediction is 1. This is called true positive. If something was 0, I predicted it 0. This is true negative. So tell me one thing. Higher the true positives and true negatives, better is the model's performance. Yes or no? But where do we go wrong? Where do we mess up? We mess up in type 1 and type 2 error. Example. A guy walks into a clinic. This guy is, of course, not pregnant, correct? But what does the doctor predict? Hey, you are pregnant. The reality is the guy is not pregnant, but the doctor's diagnosis is you're pregnant. Isn't it the reverse case? When the guy is not pregnant, the prediction says you are pregnant. Isn't this what we call false positive? Did that make sense? You were not 0, but you were predicted 1. 0 and 1, opposite cases. Ulta, 0 ko 0 hona chahiye tha, but 0 is 1. Not good. This is called false positive. This is what we called as a type 1 error in the program. What do we call this? Type 1 error. False positive error. It's also called as false positive error. Are you clear? Very nice. What happens in the other scenario? The girl is actually pregnant, but the doctor says, no, you are not pregnant. Isn't this also the reverse case? The girl is label number 1. Your prediction is label number 0. Opposite case. Isn't this false negative? Yes or no? So tell me one thing. I have a question to ask you. Imagine you have a 300 dataset data. 300 dataset data. If you want to write confusion matrix, if you want to write real, that is correct. That is correct. Did you understand the concept of false positive, true negative, false positive, and false negative? Did you guys get the concept of what confusion matrix does? Can I show you guys an example of confusion matrix? Let me show you an example of confusion matrix. Now listen to me very carefully because you're gonna love this fact. Okay, give me 1 second. Copy image and paste. Give me 1 second. Yeah. Look at this particular graph. Okay. Do you see actual versus predicted? Can you see this? Actual versus predicted. This is actual. This is predicted. Yes. Can you see? This is an actual no. Matlab 0. Actual yes meaning 1. Actual no meaning 0. Actual yes meaning 1. What is 50 plus 5? 55. Can you see down right? If you sum them, 50 plus 5 is 55. 100 plus 10 is 110. Now add them sidewise. 50 plus 10 is 60. 100 plus 5 is 105. Let me tell you one thing. In confusion matrix, there are certain things you need to know. If you add 50 plus 10 plus 5 plus 100, all 4 values will be the total data set size. Try adding it. What is 50 plus 100? 150. Plus 10, 160. Plus 5, 165. Did you get it? If you add all the values of true positive, true negative together, that is the actual size of the data. In this part, what did the model do correct? See, no ko no bola, so this is good. Yes ko yes bola, so this is good. No ko yes bol diya, this is bad. Yes ko no bol diya, this is bad. This is where your model is doing bad. Are you clear? But this is where your model is doing super good. This is how you evaluate the model. Now, let's learn something super critical. True positive, true negative, false positive, false negative. True positive by true positive plus false positive. If you come down like this, TP by TP plus FP, that is called as what? Precision. How precise was your algorithm? how good, how precision, how much precision your algorithm had. Okay. You have also something called recall. Do you see this? TP by TP plus FN. TP by TP plus FN. Can you see this? TP divided by TP plus FN. Do you see this? It's called sensitivity. People call it recall also. Do you see this? TP by TP plus FN. Actual versus predicted. Yes, that's correct. How many actuals are actually actual? Only the true positive are actual actuals, right? The one that were true, I predicted it true. False positive is the positive ones, but are wrongly positive. They are not true positives. They are falsely positive. Yes or no? Imagine from the 300 data set, from the data set of 300, you predicted 190 correctly. All the 190 truths were predicted truths correctly by you. Okay. Divided by this 190 plus what are the other wrong ones you predicted as false, predicted as true, galat say maybe 20 more. Do you understand when you divide the actual value by the total value, you get a probability value, a percentage number? Does that make sense? The actual ones divided by the actual and the false, all the total, मेरे को नहीं फर्क पड़ता है false है correct है नहीं है, but the total one that you divide, that you get a probability value, that overall how good you did with positive numbers only. All the positives were how much percent positive? Did that make sense? Every formula that you see here, precision, accuracy, specificity, sensitivity, recall, they are all very logical. If you just sit and listen, if you look at the code, everything will start making sense. There is two more metric that you need to understand. One is called Cohen's kappa. You know Cohen's kappa for now. Let me tell you what AUC ROC is. Do you see this curve, this graph? In classification, whenever you want to show your output to the management, will the management understand all the mathematics, precision, recall, true positive, true negative? Will they understand? People who've done MBA, people who are CEO, CTO kind of people, they only care about business. They don't care about technology. So tell me one thing, will they listen to you? When you say, sir, I got a Cohen's kappa score of 0.86, he's like, so one of the biggest problems we data scientists face is also to make sure to convert a technical concept into a very simple concept and tell them, we are choosing this algorithm because it is performing best. To help your life make much more easier is a concept called AUC ROC. Okay. We need to present that topic to the remember one thing, and this is your interview question. I can tell you with 110% guarantee AUC ROC is going to be asked in any classification problem. Aapko logistic regression they will ask. I don't care what classification they will ask. They will ask you what is precision, what is recall, uska formula पूछेंगे, what is AUC ROC. ये question तो 100% guaranteed है, and this question is also relevant to your practical life. See, my people, AUC ROC score is a very simple score. You have a false positive rate and a true positive rate. False positive rate is a formula. Okay, let me false positive rate. Do you see this formula? False positive rate is false positive by false positive plus true negative. FP by FP plus TN. This is a false positive rate. Now what they do is basically they plot false positive rate divided by true positive rate. We will get this lines, we will get these algorithms. Imagine you've implemented multiple algorithms, okay? Whichever algorithm, can you see this red dotted line, the red line, the dotted line, red. This is called as a random classifier. It means even if you close your eyes and select randomly, this will be the best output you will get, this random line. From this line, from this red line, how much ever farther your algorithm is in curve, that is the best algorithm. Suppose you implemented algorithm called logistic regression, support vector machine, and XGBoost. If your logistic regression curve is the farthest from this thing, you are proving once with accuracy you've proved, but again, you're proving with a graph that this is the best that the algorithm can do. This is the best algorithm among all algorithms. Nothing is higher or lower. Can you see the area it is covering is higher than all other areas? See, the algorithm that is farthest from this red dotted line, the algorithm which is farthest from this red dotted line, won't the farthest algorithm cover the highest area? That's why it's called area under curve. So the farther the algorithm is, the more area it covers, the better precision, recall, true positive, true negative it has. The better confusion matrix this algorithm had. That is what it proves. What does a random classifier means? Random classifier means one को randomly 0 या 1 डाल देना. Randomly. If a true label is 1, randomly putting a 0 or 1 using a random function, that is called random classifier. Can we jump into some practical aspect? In order for us to even jump into the practical example, what do we do good, or what do we do first that we even start doing something? What do we do for that? Don't we import some libraries? Like for example, import pandas as PD. We also do matplotlib. Import matplotlib dot pyplot as, yes or no? I've imported all the relevant packages that I needed. I have a very awesome data set. It's called HR dataset. Okay. I'm going to show you how this dataset is. Can you see this thing called df.head of 5? Yeah. Do you see this data in front of you? I am somewhat representing an HR data, human resource data, correct? I have every employee's satisfaction level, the last evaluation, how much percentage he got, the number of projects the guy did, the average monthly hours he has performed, the time he spent in the company, the work accidents or any fault he did, he left the company or not, did he get any promotion in the last 5 years, what department he worked for, and was his salary low, medium, or high. This is what the data represents, yes or no? My data represents very simple things like, Bhaiya, what is the satisfaction level of the employee? What is the last evaluation? What is the number of charges? Listen to me very carefully. Do we have the guy's name? Do we have people's name? No, it does not matter. This is what I want to tell you guys. In data science, you don't care for individual person, but collectively the results. So your name, sometimes your age won't make much of a difference. Your phone number, absolutely worthless. Okay. It's called PII. Personally identifiable information. If you work for a banking company like me, that information will not be even visible to the most senior data scientist. I have it, but some of the most senior data scientists also will not be able to see the PAN card number of the loan account holder, the PII information like Aadhaar card and all of that stuff. It is a very secure environment. You can't, look at even the client's data. So you will have such restrictions. But in this case, we don't have a restriction, and we don't even need the name. So what is the first thing that you want to do? Don't you want to know how long the data set is? How many people are we analyzing for? So when we do df.shape, what do we know? There are 10 columns and almost 15,000 people. Yes or no? Agree, disagree? If you look at this record, if you look at this data set, one thing will be amazing. Don't you think the most important part for any company is how many people left the organization, how many people are with the organization? This thing in machine learning or in actual analysis is called attrition analysis. Have you heard of it? Have you heard of it? Attrition meaning if 100 people were in a company, 100 people were in a company and 5 people left the company, attrition rate is 5%. People who left the company that year is 5%. It comes under HR analytics. So we are basically doing attrition analytics using logistic regression. So you just have to focus using logistic regression. But we will do EDA also, exploratory data analysis. We will see what the data is, how the data is. We'll try to match, we'll try to make sense of the data. यार 15,000 record एक एक देख सकते हैं क्या? Can you see all the 15,000 record at once? नहीं ना, नहीं possible है. So we'll have to see through some data visualization. Okay. Because we are doing attrition, aren't you interested in how many people actually left the company? So can I say left the organization is equal to df of df dot left? मतलब जो people who've already left equal to 1. For all the people who've left 1. So I will say left dot shape. Okay. How many people have left? Did I do anything? Indexing column length is Do you know that in pandas, indexing cannot happen outside the array? Matlab, it cannot happen outside, right? It happens only inside, right? How many people actually left the company out of 15,000? 3,571 people left. That much means, just for example, I know it's a very simple math. How many people did we actually retain? So can't we say df of df dot left equals to 0? And I can say retained dot shape. Yes. So tell me one thing, 11,428 are the people. Acha, tell me one thing. Let me ask you a very basic math question. How much is the percentage of attrition rate? Itna bata do. What is the attrition rate formula? Should it be retained by left into 100, retained by total into 100, left by total into 100? How should I calculate attrition rate? Tell me that. How do I identify how much percentage people left? Attrition by total, are you sure? Number of percentage people left. Shouldn't it be with respect to the total people we had? Left divided by, okay, 14,999 into 100. Is this not the formula? Oh, yeah, of course. What was the formula for left? 3571. Shouldn't this be the formula? Whenever you calculate attrition, don't you calculate attrition on overall people and not the people who left? Making sense? So tell me one thing. What is the first understanding? What is the first data analysis that you did? Hey, 23% people left the organization. 23% people left the organization. P-E-O-P-L-E, people left the organization. Left the L-E-L-E-F-T. Left the org. Left the org. What does this tell you? Point number one, it's a toxic company, leave. Agar 23% people are leaving, you should also leave, right? There's no harm in leaving. 23%, almost 1/4 people left the organization. That is your first analysis. If I write this, will you understand what I'm doing? You know, there is a clause called group by in SQL. Exactly the same happens in pandas. No difference. Same. Group by based on the categories. We have only two, 0 and 1. And I am group buying basis on the people who left. That's correct. Now see, people who left the company, did you see that they had lower satisfaction level on average? On an average, people who left the company had a lower satisfaction rate. So did we now know that people who left the company had on an average a lower satisfaction rate? So this is a good variable to look out for. The last evaluation, what they did, and the evaluation for the people are almost same. So evaluation has nothing to do with people leaving. Yes or no? Making sense? The number of projects that were given to people who left was considerably higher with the people who are not leaving. So the work stress is also adding up. The more projects we gave to the people, the more chances are they left. See, this is only 3.7 and this is only 3.8. Now, please don't be stupid and tell me, sir, only 0.10 ka farak hai na? It is a mean, it's an average. Doesn't mean ki only 0.10 काम दिया है. नहीं, ये mean है. इसका मतलब somebody got work extra harder and somebody got work extra softer. Somebody who got softer decided to stay. Somebody got more work, he left the company. So be very smart. This is dot mean. Don't look at percentage value or 0.10 value. Look at it's an average. So there will be a range. Tell me, the average monthly hour worked by the person who left is higher than person who. इसका मतलब ये है, the person who was the most worked is the person who left. They made a person work so much that he left. Isn't it a very important insight? Aren't you giving this a beautiful insight that the more overworked the people are, the more chances are they will leave? The time that they spent in the company is also higher. Can you see? The people who did not leave on an average spent only 3.3, and the people who actually left have on an average spent more time. Make sense? What about work accidents? People who left had the lowest amount of work accidents. And do you see one of the main criteria is because in the last 5 years, they were not promoted. Is it not logically making sense to you in your brain that people were not promoted? They are working extra long hours. They have had not work accidents, which is positive. They're spending more time in the company, yet their satisfaction level is low. what do you think they'll do? They'll take a thali and they will do puja of the CEO, or do you think they will drop the paper on the face and leave? Of course they will leave. But we just prove that with analytics and only one line of code. Do you see? Do you now understand? You don't need a longer code. You just need the right functions to help you understand what it is. Are you guys understanding what we did? Satisfaction levels are considerably lower for the people who left the organization. You can even write it down. See, you can write it down. Analysis number one, analysis. Number one, satisfaction level is low for employees who left. What is the second analysis, my people, that we can give? Number of projects were considerably higher for employees who left. Analysis number 3, average monthly hours were kitne percent higher? What is 199 divided by 207? What is that percentage? You have to tell the management percentage. You can't give numbers. Kitna percent higher hai that these guys are working? From 199 to 207, what is the difference percentage I'm asking you? How much percentage? Let's just take, for example, maybe 5% higher. Okay, 8%. Chalo. 8% high than non-leaving or retained employees. Do you understand? You now have a percentage value. You are telling your management that, bhaiya, people who are leaving are overworked 8%. Isn't that amazing? So the management knows that, yaar, the amount of people who are leaving are getting overworked. 8% overwork ho raha hai, right? What is the fourth analysis? Promotion in the last 5 years were considerably higher for employees who left. Okay, for employees who left. For example, this is your analysis. You're done. Acha, now that we are done with this analysis, now I want to visualize few things. Okay, I want to visualize how certain things reacted in a certain way. What was the impact? So let's try to understand something like that. What was the impact of salary on retention? Have you heard of something called crosstab? Have you heard something called crosstab? I want to compare the salary with the people who left, but I want to plot. But what kind of plot I want to plot? I want to plot a bar plot. अब आप एक मुझे बात बताओ, क्रॉस टैब का मतलब, the meaning of cross tab is take one data, take one column, take another column, combine the columns together and read them side by side. That's cross tab. Taking one column, taking another column and reading two columns side by side. It gives you more clarity. Now listen to me. What is the impact of salary on employee retention? We saw that, of course, satisfaction lower level hoga, people will leave. Number of projects you will give them more, people will leave. Average monthly hours they are doing more, people will leave. Promotion in the last 5 years not done, people will leave. But what about salary? Isn't that also main criteria? People who left the company. So salary is divided in 3 range, correct? High, low, and medium. Among which category of salary people left the highest? Isn't the people who had the lowest salary left the highest? Can you see this? The orange is the people who have left for the salary low. Did that make sense? People who had lower salary are the highest to leave. Aren't you going one step deeper? People who have medium salary did not leave considerably. People who have high salary, the attrition rate is the minimum there. So more money you pay, they ignore how much you're giving them projects, how much satisfaction level you have, how much work accident, how much promotion. If you give them good salary, people are usually tend to not leave. Does that make sense? Because the attrition rate in the highest salary is the lowest. And the group by that we did was a mean, right? That means this must apply to everybody, right? Average value, they are almost average. They have worked out too much. They have not been promoted. So it must also apply to the high people, right? The high salary people. But see, the attrition is rate. So that means paisa bolta hai. If you give good money, people are deciding to stay because you're paying them according to the value. Did that make sense? Now, let's do one more example. Okay, pd.crosstab. If I want to do dot plot, okay, kind equals to bar, what will this tell me, my people? Won't this tell me what department most people left in? People left, we know. But which department was the most affected department? Which department people decided to leave more? Which department did they leave more? Is it surprising for you that they left sales? Because people who work in sales know it's a very terrible job, right? Sales job has a terrible aspect to it, right? You have per month, you have a target to achieve 100 people should have been converted. You will get 5% commission on sales. So what is the first department that was the highest? Which is the lowest attrition department among all? Management. Can you see? Management, not HR, management. Can you see? Management सबसे छोटा है. R&D and management is the lowest because that's where the pay is high. How can you do it? Can you not do PD dot cross tab of department and salary? Did you get it? If you do PD dot cross tab of department and salary, won't it tell you which department gets the highest money? So won't that give you an idea that why people are retained? Are you understanding how analysis is connected to each other? You guys got the concept of what I'm trying to say, right? Okay. From all the analysis that we've done, can I say that satisfaction level is a very important variable? Satisfaction level from the group by function was a very important variable. The average monthly hours also was an important variable that caused a change in the algorithm, that caused a change in people's perception. Okay. Can I say promotion in the last 5 years was also an important category? And salary, of course. Salary to bhaiya is the most important. So rather than taking all variables, can I just take these four variables as one of my main criteria? Okay, so let's do one thing. Let's create sub data frame. Inside this, what we'll do is first we will take something called satisfaction level. Okay, so first let's come here and let's take satisfaction level. Okay, let me copy this. Let me paste it here. Okay, I am not taking all the variables. I am only taking satisfaction level. What is the second thing that we'll take? Average monthly hours, correct? So where is average monthly hours? Average monthly hours. Okay, we will copy this and we will paste it here. After average monthly hours, what do we do? Promotions in the last 5 years that the person has gotten, right? So where is the promotion in the last 5 years? Here, we'll take promotion in the last 5 years. Copy it and we will paste it here. Promotion in the last 5 years. Which is the last variable that we will take? Salary, correct? So we will copy it like this and we will come here and we will paste it. So what did we do now, people? What did we actually do right now? So what we've done is, rather than taking all the variables which are not important for me, I have only decided to take specifically these 4 variables that are resulting in the output. What is your satisfaction level? What is the average monthly hour? And what is the promotion? Everything else is just fog. It is not important for my analysis and I'm not going to consider that. Did that make sense? Did that make sense to you? Simple as I can. Guys, let me tell you something. Do you see the same data set that you see here? The same HR analytics data set? I have taught this same data set to data scientists who come with 4 years of experience. I'm teaching it to the same, which is you guys who have very less experience in data science. I can go much more complex in this data set. There's more analysis to be drawn. But at a very simplistic level, you need to understand how you need to get started, right? I am doing this because I know. Don't you think you also need to analyze some things more that I may have missed out? I have missed out so much more. Actually, department-wise bhi maine calculate nahi kiya hai. You need to do that on your own, but do that. Now tell me one thing. Can I feed this data directly into the machine learning code? Can I feed this data directly into the machine learning code? Can I just like put this in, push it in, and our answer will come? Why? Why can't I do it? Which column is going to cause me problems if I do that? Column is going to cause me problems. Salary, right? Why salary? What's salary going to do that's going to cause me problem? Salary is a column which is a string type, yes or no? We call it as a text. Does computer understand text? No, sir, it does not. Don't you need to convert text into a number? Don't you need to convert a text into a number, yes or no? So tell me one thing. I am telling you to convert text into a number is a technique called encoding. What kind of encoding exists? Label encoding, target mean encoding or mean encoding. Okay. आप बोलो one hot encoding or dummy encoding. Your salary is low, medium, and high. Correct or no? If I convert or make low as 0, medium as 1, and high as 2, this is a problem. You know why this is a problem? Because machine learning will consider 0 as a lower number and 2 as a higher number. So it will give more preference to high. Agree or disagree? The weightage issue will come into picture. Yes or no? So which is the best kind of encoding? One hot encoding is the best kind of encoding. So what is low, medium, and high will become 0, 0, 1, 0, 1, 0, 1, 0, 0. In pandas, how do you do that? Okay. I'm going to write something. You will have to understand what I'm basically trying to write, okay? In pandas, we have a function called getDummies. We have a function called getDummies, okay? So what I'm going to do is I'm going to take the sub data frame that I've taken, all the salary that I have taken from that particular thing, because only salary needs to be converted, and I'm going to make the prefix as salary only, okay? I'm going to keep the prefix as salary only. This code, what it does is it converts this low, medium, and high, whatever the function is, it converts that. I need to reconnect the data that I just created back into my sub data frame. So can I say df with dummies is equal to, have you heard something called pd.concat? Have you heard of something called pd.concat? Okay. Sub df salary dummies, if I take it, but once they are added, the data is ruined. Don't you think I need to make it change and say that the axis that you want to connect itself with is the columns? If I run this, what happens is if I run df with dummies, dot head, for example, just say dot head of 5. Do you see that my salary low is converted to 0, 1, 0 encoding? And okay, answer this to me. How good is your pandas between 0 to 5, my people? All of you in the class, how good is your pandas? Do I need to explain this code to anybody? Salary dummies, pd.getDummies, pd.contact. GetDummies is only and only converting the number low, medium, and high into encoded value. But because it is not directly added, I need to concat it. I hope you guys understood this simple logic. In PD, didn't we have a function called pd.concat? But pd.concat do not add row wise. It adds column, it does not add column wise. It adds row wise. You remember? pd.concat function adds row by row, not column by column. It made sense. That is why 0, 1, 0 for low is coming. Can you see? Low is 0, 1, 0. Our data set is prepared, but there is still one problem. What is that problem? df with dummies dot. What do I need to drop from this? I don't need anymore. What do I need to drop from this? I don't need anymore. Isn't it salary? Isn't it salary? Axis equals to columns. Or you can also write it once. Does that make sense? Does that make sense? In place equals to true. Okay. df with dummies dot head of 5. Dot head of 5. What did I do wrong? What did I do wrong here? What did I wrong here? Jupyter Notebook has a cache. You remember, right? Tables are all cached in each columns. You need to rerun it once again to set everything so that the cache is updated. You can't run the table again and again. Are you clear, right? Like once you do df.drop, it is dropped. If you go from top only, then it will come back again and drop again. I hope you know this in Jupyter Notebook. If you drop something in the column and that operation ran, you can't drop it again. See, if I run it again, is it not giving me error? Because it is already dropped. The cache is already done. You got the concept. Once you drop something, there is nothing to drop. So if you run the cell again, it will give you an error. That's what I wanted to say. Anyways, yeah, no problem. Is the data clear, everybody? We have satisfaction level, average monthly level, promotion level, salary high, salary low, salary medium. Yes. Now tell me one thing. If I want to predict an algorithm, or if I want to make a prediction of the algorithm, don't you need to divide the data into X and Y different categories? X will be my target, X will be my predictor variables and Y is my target variable. Yes or no? All the X variable is nothing but the DF with dummies. Yes or no? So if I do x dot head of 5, this is my target variable. Sorry, not target variable. This is my predictor variable. Yes or no? But what is my target? Yes or no? All the people who left, not left, people who left the company here. Can you see this variable called people who left the organization? This is my target, right? We need to predict, will the person leave or not leave? Yes or no? Will the person, given this prediction, will the person leave or not? That's what I need to predict. So isn't this going to be my y variable? And if I do y dot head, actually, I will not be able to run head in this. It's not an array. Yeah, it's not a data frame. But yeah, you guys get the idea. I've taken my segregation as my x and my y. My feature variable and my target variable. My predictors and my target. My feature and my target. Here is where the machine learning starts. From sklearn, what do I need to import first? Dot model selection, import, what am I doing? Linear regression or logistic regression? We are actually doing train test split. First, we need to split, right? X train, what do we do next? X test. What do we do next? Fast. Y train, next, Y test is equal to. What do I do here? Train test split, I call, and what do I pass inside it? X comma Y. Yes. How much test size should I keep? Let's say 20%. 20% रख लेते हैं. For from sklearn. If I want to import model, how do I import it? We did that same thing exactly in linear regression model. Dot linear model import logistic regression. Are you clear? What do we do? Model equals to call logistic regression, make it bracket because it is a callable function. We called it. Now what do we do? Model dot fit. Okay. Model dot fit. What do I need to pass? X train, comma. What do we pass in training? Y train. Yes or no? This is what we do. If we run it, did the logistic regression work? Did the logistic regression just work? I want to predict a value. I want to predict some number. Say, for example, suppose you have a function called x test. Okay. In x test, you want to take a specific number called 12:13. Let's take this value. A guy whose satisfaction level is 0.61, his average monthly hour is 245. He did not get promoted. His salary is 001 category. If I want to predict for this particular value, whether he got the answer correct or not. So how did we do it? Y test of 12:13. What is the output that we get here? The person has already retained. Can you see it is 0? If I want to do model.predict, what do we pass inside this? X test of this guy, 12:13. Did it give the prediction 0? Actually, the guy did not leave. Our model is also predicting, bhaiya ye nahi jayega. This is what we call true negative. 0. Sahi hai na? I've shown you how to predict also in front of you. How to predict a particular category. See, I showed you what reality it was. 4191. In reality, he did not leave. 12:13 का मतलब है 12th row and 13th row के बीच वाला, मतलब 12th row basically. See, in pandas, if you want to take certain rows, say for example, 14/15. So you see, it gave me only one. Did you get it? But if I do 18, so it will give me 2, 3, 4 actually, correct. 14 से लेके 18 तक के सारे दे दिए. From the test set only I have taken the data. I have not created the data on my own. गलत हो जाता. You got it? So if I exclude 18, it will give me all from 14 onwards. If I just take 14, it will give me everything from 14 to the last. Okay. So anyways, just for simplicity reasons, I wanted to teach you this, that see, the model is doing as it's supposed to, right? There will be some true positives, some true negatives, right? That's what we want to predict. That's what we want to get an output for. We need to understand what did our model do good. Now, to get the model accuracy, don't you need to do something called model.score? And tell me one thing, do you need to calculate the true positive, true negative yourself, or the code will do it for you? The code will take care of that for you, right? You don't have to do it. What is the accuracy that we got in our model? Our model is 77% accurate. From all the 15,000 records, 77% of the record positive or negative, I am able to predict. Agree, disagree, my people? Now tell me one thing. Have you seen an accuracy matrix here? The one that I used to tell you, that confusion matrix. Have I plotted that yet at all? Have I plotted AUCRC score? Yeah. So do you think our job is done? No. You need to create another column, another thing called ypred, and that is model.predict. Okay. Model.predict. What do you need to pass inside this? All the X test value, right? The ones that are actually to be frankly predicted, zeros and ones, we need to now categorize. From sklearn dot, does classification not come under matrix? So we have to use something called matrix. Import, use something called classification report. What will you use? Classification report. Specifically start using something called classification report. Just say print classification report of what do you pass when you want to test something? Y test, ypred. Remember one thing. Y test, comma, ypred. If I run this, did we get a precision, recall, and average value? Do you see 79% precision I'm getting in calculating 0 and 0 properly? And 1 is lower. Can you see? All the people who are categorized left, my precision is lesser in that. My recall is much worse in 1. You thought 77% came, so my algorithm is performing well. But is it? Is it? No. Do you see? You have 2 categories, right? 0 and 1. You need to do a good job in 1 also, right? दोनों में अच्छा करना है, not in 1. Are you understanding me? Let me give you an example. Imagine you're a good husband or a good boyfriend or a good brother. To be a good brother, you need to be empathetic and you need to be kind, but you also need to be very strict, right? You're only and only kind. You're not strict. You don't have empathy. 100% kind you are, but that doesn't mean it's your overall 100%. Only one category or 100%. All 3 you need to be good at, right? Empathy also, kindness also, but a little strict also. All 3. Your classification model gave us 77% accuracy, but that accuracy is only in calculating the people who left. We are very bad, or the algorithm performs very bad in calculating people who've already left or will leave. Yes or no? Can you see our precision is also small? Recall is also small. Does that make sense? Does that make sense, my people? Sometimes what happens, one category is so confident that it undermines the other category. You need to make sure both categories are important for you. Does that make sense, my people? Did that make sense to you? Both the categories are important for you and you need to give equal category, equal importance. Okay. I have a small question I want to ask you. Can I? To test your skills. In medical industry or in medical science, is type 1 error more important or type 2 error more important? In medical science, is type 1 important or type 2 more important? Who do they give more focus on? It's the type 2. You know why? Let me tell you. This is actual, this is patient, this is actual, this is patient, this is actual, this is patient, this is actual, this is patient. Not sorry. Doctor, patient, doctor, patient, doctor, patient. Okay. A guy has cancer. Patient also has cancer. Doctor says you have cancer. Did you save this guy's life? True positive? Yes or no? The guy does not have cancer. You predicted you do not have cancer. Did you save this guy's life? Yes, sir. True negative. You saved the person's life from mental trauma. From mental stress, you save this person. The guy, the patient actually does not have cancer. You say you have cancer. Type 1. Did you just make his life a living hell? By giving the person stress? But more than giving stress, which is actually problematic, giving harm, right? Patient says actually he has cancer. Doctor says you do not have cancer. Is not type 2 error much worse? So tell me one thing, whenever you're doing classification problem, is 0 more important to you or 1 more important to you? Which is more important to you? That depends on your data. In our data, people who are leaving, to identify them correctly is more important than the people who are retained. Yes or no? Did that make logical sense to you? To my logic, I wanted to predict people who are retaining or people who are leaving. I want numbers to be higher and more confident there. If the numbers are terrible in the 0, I am okay. It's okay. I don't want that high answer in the 0, but I want high predict and possibility in the 1. Did you understand? Category wise also you can change the algorithm to give you better output. You are my students, my people. You go to a job, your manager should be impressed by you, that how deeply this person is observing. And this is how you're supposed to professionally work. In our case, can we say we built a successful model? No, no. 77% accuracy means nothing. Kuch bhi nahi hai. When the actual data point that we want to predict, which is important to us, aren't people who are living catching that more important than people who are not living? So categorizing one is more important, but you see the precision is also bad. Recall is also bad. And you know what? This accuracy is not supposed to be seen. You're supposed to see the macro average. What average are we getting? 59%. Did you get it? We are getting a 59% of macro average percentage of the classification algorithm. Are you clear, my people? My AUC ROC graph and then move forward. ये जो macro average है, don't learn about it now. I'm telling you guys, you will get confused. Don't give a single anything when you want to do this. Just know that macro average is a much more true reading. Don't care what it is now. Don't read about it now. Macro average hai. Can we see how AUC ROC is performing? Okay. From sklearn, okay, dot metrics, I want to import something called ROC AUC score. Okay. It's called ROC AUC score. अब आपको समझ में आएगा. You will understand the meaning. Again from sklearn.metrics. Okay. sklearn.metrics. You can import ROC curve directly also here. Comma करके. Comma ROC curve. Because you see, I'm importing from both sklearn.metrics only. You can do it like me. I do it because I like my code to be readable. Do you understand? Whenever I write code, my people, I have a habit. I always write my code in such a way that people are able to read it easily. That's why my codes are a little longer, but they're easier to read. Okay. I'm going to say logit ROC AUC. Okay. Just because we are using logistic regression. So I'm calculating the logistic regressions ROC AUC curve. Did you understand the full form of ROC AUC score? This is called receiver operating characteristics and area under the curve. That's the same thing. Okay. I'm going to pass in white test, ypred. Do you remember I told you that whenever you calculate something, you pass in white test, ypred? Same thing. Can you see this? Ypred model dot predict x test. Rather than calling it ypred, I can even pass it like this. It's basically y test, ypred, nothing else. See, this is y test and that is ypred. Model dot predict all the x values of test. Rather than calling it like this, let me call it like this. False positive rate, true positive rate. Okay, false positive rate, true positive rate. And there is also something called thresholds. Okay, or you can even write it thresh. Okay, thresholds basically help you calculate. Whenever you calculate AUC ROC score, it calculates multiple confusion matrices, right? So we call it ROC curve of passing the value of y test, same exact thing. What do you think you need to pass next to it? Model.predict x test. Actually, here you will pass something called predict proba. It's called predict probability. Here, what you're doing is you're passing all the x test value, okay, which is this. But do you know in logistic regression, we calculate something with a threshold? If more than 50% 1, less than 50% 0, we have a threshold set, like, for example, something like if it is up to 50%, less than 50% 0, up to 50% 1. Don't we work on that categorization? By default, have I passed any probability to the logistic regression function? 50% ke above 1, ke lesser 0. Did I pass it here? We did not. So what it did is it automatically calculated a probability by itself and it added. But shouldn't we add it ourselves and make the algorithm tweak better? And that is how we will make this one perform better, to tweak the probabilities. That maybe 80 ke upar say 1, less than 80 say 0. Make sense? The false positive rate, the true positive rate, all of that. How many of you actually love matplotlib, guys? You guys have actually worked on matplotlib. You guys actually love it. Actually understood what this particular value is. You guys know this, right? Okay. Have you also tried something called now Imagine I want to draw a vertical line. How do I do that in Matplotlib? I have a graph. I want to plot like a vertical line. How do I do that? Where do I start? What is this called as? Is it called 1, 0 or 0, 1? If I write it like this, will you understand? Comma, from 0 to 1 to 0 to 1. And I want it to be all dashed. So you can give it like a dashed line. So something like read line dash dash. So do you understand that I'm getting like a dash dash line? Like you can also make it diamond, but like you get it, right? The dash 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 line that you get. Do you see how our logistic regression is performing? Is it beyond the dash line? Is it beyond the dash line? Is it better than a random classifier? 100%. Do I have any other algorithm I can compare it with? No. But this is my AUC ROC score. The farther it is from the line, the better it is considered. Yes or no? So is this not giving me an output? Now tell me one thing. I need to calculate its area. Okay. To do that, write it here like this. Area equals to, do you know, I can write float point values like this, 0.2f like this. If I run this, is it giving me any output here? Is it giving me any output? No. Plot.legend, legend and location equals to best. If I run this, how much area it is covering? 60% of the area. Did you get it? See, 0.59. The area this graph is covering is about 60%. Did you get it? We always prefer the graph with a higher area. I just calculated and show you how to calculate area also. Right there, simple. Did that make sense? See, I've passed in something called logit AUC ROC here. See, ROC AUC score mein, I have just passed in the area that it is covering. That's it. This number is the area, this 0.59. That's what it is. Did you understand? And you know what? No matter what algorithm you implement, the code for AUC ROC will never change. If you take my code, this code, and apply it on any algorithm you want, you have the freedom. It will not change. Same exact code will work. Just the model will change. We just completed logistic regression. I want to show you one thing. This is called documentation. Yes or no? The company that created sklearn has a documentation on logistic regression. Inside logistic regression, what have I passed? Can you see? I have passed nothing. It is absolutely empty. Can you see? It's absolutely empty. But what options do I have? I can pass penalty. I can pass dual flag. I can pass something called C, fit intercept, solver, random state, weight, intercept scaling, worm, number of jobs, L1 ratio. Did I pass anything inside? Are you wondering why I got a bad result? Are you now understanding why we are getting terrible results? Because nothing is tuned. Did that make sense? This values that are passed inside, okay, are hyperparameters. What are they called as? Hyperparameters. Now, I also did something called crosstab. In crosstab, what I decided to do is I also wanted to know, because my common sense tells me salary is one of the biggest factors. So I did a crosstab of salary. The reason why you cannot, can somebody tell me why I had to take salary separately and group by separately? Because you cannot take a mean of string value, correct? Yes or no? If your data set has a department or a column called salary, क्या आप उसका mean ले सकते हो? Can you take a mean of it? Can you do group by? Example दिखाता हूं मैं आपको. How many columns do we have? 10. Can you see 10 columns we have? If I do df.describe, and if I run this, sorry, it's a callable function. Yeah. How many columns am I only getting in the description? Can you see how many? 1, 2, 3, 4, 5, 6, 7, 8. बाकी के दो किधर गए? Describe में, info में आ जाएगा, describe में, group by में, and all of that में कभी भी you will never find a column with the string value, because उसका क्या करोगे आप? Understood? Can you see which is the highest promotion somebody got in the last year? Somebody has gotten 100% promotion. somebody has gotten no promotion at all, ये भी हुआ है, ठीक है? The highest amount of satisfaction level somebody has recorded is 100% satisfaction level. The lowest somebody has recorded is 9%. Can you see 9%? So you can find descriptive statistics here. Min, max, standard deviation kitna hai, mean, average kitna hai, how much is the average working hour 201. There is somebody in our data who has worked 310 hours. There is somebody in the company who's worked only 96 hours. See, ye bhi difference hai. So when you do describe, you get all this information also. So that is why when I did group by, I did not have the information of salary. So salary I took using a function called crosstab. Does that make sense? I did a crosstab of salary with all the people who left because that is my aim. That is what my intention is. And I got an output which says high, low, and medium with compared to salary. Okay. PD.crosstab, administrative experience. So when we do PD.crosstab of department and the people who left, we also get how many people left department-wise. That is an important analysis for us. What we realized is HR and marketing and management and R&D were some of the lowest. Some of the highest were sales, support, technical, and of course, IT. IT is IT infra. I think it is IT. Yeah, IT infra. Okay. Then after creating an understanding of all of this, what I did, I created another data frame. And in this data frame, I had satisfaction level, average monthly hours, promotion, and salary. These are important data sets. These are important features for that matter of fact. What I did from all the original features, I've taken the important features, I've kept them separate. After I've kept them separate, I have taken something called get dummies. Now, remember one thing, one hat encoding is get dummies in pandas, but you can't directly apply because they get concatenated. Row by rows, they get added. So what do you need to do? Once you create them, it creates a number called 010. For example, I should have shown you this salary dummies. Okay, notice this. Can you see it's becoming 3 separate columns? 010. It is not connected to the actual column, which is this, right? Sub df. Yes or no? This is creating a separate independent 3 columns. What do you need to do? Because these are creating 3 independent columns, I need to concat with the sub df at salary dummies, but I want it access not to be row, but columns. So now rather than getting added left by left, it gets added row by row. So basically column wise it gets added because access equals to columns. You can even replace this with 1 or 0. 1 is column, 0 is row. What I did after that is I have taken a separate data frame called df with dummies. From df with dummies, I decided to drop my salary because salary is still a string character. Once everything is said, this is my feature, left or not is my target. The most easiest thing, I've imported train test split, I've imported logistic regression, I fit my model, and I've even taken a record and did model.predict on it. I got a right output on that. The biggest change in the code is at this part. Okay, now please allow me to explain something here. Guys, you must have heard of something called model.predict. It's not a very complicated thing. You must have not heard of something called model.predict probability. Tell me one thing. When you use model.predict, do you not get the output whether it could be 0 or 1? Yes or no? Agree or disagree? But when you do model.predict probability, it does not return 0 or 1. It returns the probability. Then based on that probability, you can decide output will be 0 or 1. Are you clear? This predict probability function prints all the probabilities it has. Suppose for line number 1. Guys, do you remember I did this model.predict for 12,13? Then I got the output 0. Okay, look at this. Model.predict probability for X test 12,13. What answer did I get? Do you see I am getting probabilities and not the actual output? This is the probability. This is the count threshold. Let's ignore that. Did you get, we got 80% probability that something is 0 or something is 1. Favorable, not favorable. Yes. You guys got the concept, right? Model.predict returns the output. Probability lets you play around with the probability. Whether you want the threshold to be 50%, 60%, 80%, you can change it. If I do 0, is it returning the probability to me? Can I say if model.predict probability is less than or equal to 60 or greater than or equal to 60, what do? Print I am 1, else print 0. Can I even do this? You got what I'm trying to say? You can tweak the probabilities like that you can set up a threshold like this. Now, what I do is I print another variable called false positive rate, true positive rate, and threshold. If I run FPR, okay, or if I say print, I will say print FPR /n TPR /n and thresholds. Okay. Let me basically copy this and paste it here. Did I write /n wrong? Yeah, I got it, right? What is the length of this? Hold on, let's first calculate the length. Then we will know if we got the FPR correctly. 992, ठीक है, okay. Comma, true positive rate, okay. And let me also say thresholds, okay. So false positive rate aa gaya, true positive rate aa gaya, and all the thresholds have also been printed, okay. My people, let me explain what this is, okay. To draw a graph, to plot an AUC ROC graph, suppose if you want to plot it like this, suppose this is my graph, okay? I want to plot it like this. Don't you think for every line you need a point? Did you get it? Like you need a point in every line. This entire line is of 992 points. And what I did is I connected the lines. Does it start forming like a ROC curve? Did you understand what it is doing? It's calculating AOC, ROC points for X, Y, X, Y, X, Y. See, this is TPR, this is FPR. Let me remove threshold, okay? Let me remove threshold. This is true positive rate versus false positive rate. So 0, 0. Okay, you see down at the bottom. Yeah, 0, 0 point, 0, 0, then 0, 0.00 something. Are you understanding? Each row is corresponding to its each point, and that's what we are plotting, isn't it? See, this is what we are plotting. Yes or no? Let me comment it out. Do you see that point itself becomes like an ROC curve, and we take the area under them. I hope that makes sense. That's what I'm doing. What about the red line? See, red line is considered the baseline. Do you see 0, 1, 0, 1 here? This represents diagonality in matplotlib. If you don't know, here is how you represent 0, 1. In a number line, what is 0, what is 1? What comes first, X or Y? We always do X, Y, correct? So 0, 1 यहाँ होना चाहिए ना? सही है ना? According to our XY. एक diagonal को बनाने के लिए, to make a diagonal, what property do you need to have to make it diagonal? But to make a diagonal, how do you do it? How do you make a diagonal? You need an equal slope, yes or no? Start point and end point. Okay.
Guys, I have a special announcement for all of you. For all of you dedicated individuals who are looking forward to master data science, we are offering a straightforward 20% discount on our data science course, which is in collaboration with iHub IIT Roorkee. So do make sure to check the link given in the description and fill the inquiry form. Shortly, our team of course advisors will get in touch with you to activate the offer. Don't miss this chance and take your career to the next level. Click on the link given in the description right now.
What a decision tree looks like. Like, for example, I had a node at the top, and then there was two lines. One was a yes, and the other was a no. And then I had a node again, and then I had a node again here, right? And then I had another output, and then I had another output. So see what happens is, yes, in a decision tree, the most important part is this part, and this part, and this part. They are called as nodes, okay? If you actually visualize it in a normal sense, the way trees are written, you will find them like this, okay? You will be finding them like this. So you see, the circular things are called nodes, okay? This is what you call as nodes. Now you see, at the end of the list, at the end of this particular tree, you're left with certain small options which have no branch. they are just the end, right? They are leaves. Okay, they're called leaf nodes. So I will just show you guys a little simplistic understanding of how a decision tree is sort of looks like. Okay, give me 1 second. I'll just take you guys through some complex understanding of decision trees, and then maybe we'll sort of proceed forward. Hold on, give me 1 second. That is correct. Okay, so now see, the thing is, you will have things like a root node, a leaf node, splitting, a branch or a subtree, or pruning. Now, a branch or a subtree is let's address it one by one. Okay, let's talk about it one by one. Give me 1 second. Decision tree. Okay, let's visualize it one by one. Give me 1 second. Yeah, let's take this. Yeah. See, now listen to me very carefully. This is a very, very important concept, super critical for your understanding on things. Okay, listen to me. The first root node of a decision tree. You see this? The first root node of a decision tree, my people, the entire fight that you're going to do for decision tree is to decide which root node you have to take. I'll give an example. Imagine, guys, I ask you to make a classification algorithm. Okay. Let's say I ask you to make a classification algorithm that given the age, given the salary, can you predict will the person get a loan or not? So answer will be yes or no. And suppose the age is 23, your salary is 12 lakh rupees per annum, okay? Or 12,000 rupees per month, for example. And your age is 40 and you get 1,65,000, example. So you see the output for the loan would be yes and no, right? Like, so no and yes. So actually no and yes. Example. Suppose I ask you to do this. Now tell me one thing. Will age be used as the top node or salary will be used as a top node? Which node will decide how the tree will be made? Are you understanding? Will age come at the top and then salary go to the bottom and then loan is decided on that, or age? So see, that decision is not based on visual understanding. Like you can't say age or salary. That's not how it works. Whichever value has the highest information gain, only that root node is selected. Are you clear? You have to calculate the entropy of the entire data set. Then you have to calculate the information gain of the age, then information gain of the salary. Whoever has the highest information gain will be selected as a decision node. Are you clear? We'll do the exercise. Don't worry. I'll show you guys the mathematical understanding. Remember one thing. This question is an interview asked question. In decision tree, how do you select a decision node or the root node? It is also called as root node. Okay. Your answer should be, in decision trees, root node is decided based on the concept of entropy or information gain. What will you say? Entropy or information gain. Are you clear? Any one, not both. Any one is used. Okay. Either you can use entropy or you can use information gain. Most algorithms use entropy. Okay. But we will teach both entropy and information gain. Okay. In decision tree, when splits are happening, they are called branches. So every line you see is a branch. Cool. Every line that you see being split is called as a branch. Again, once the decision node is taken, this is called root node. You can call all other nodes as decisions node. And remember one thing, my people. Tell me one thing. If the information gain or entropy was good for decision node 1, the second best will go here. The third best will go here. Did it now make sense? The second most important information goes to the left, the other third goes to right. And if you have more columns, then depending on whichever is the best, second best, third best, fourth best, the split keeps happening. And you, at the end of the day, are left with leaves. Leaves are something that has no branches. It's the end of the decision tree. Okay. Can I tell you guys something? You will be amazed. Decision tree can be used for both regression and classification. This algorithm is so versatile, is so awesome that if you want to solve regression problems, you can even use it. If you want to solve it for classification, you can use it. Look at it. Decision tree classifier. So see, I will file decision tree classifier, okay? But if I say decision tree regressor, you will find decision tree regressor also. You will find decision tree classifier also. So do you see you have a decision tree classifier for classification, and you can even use it for regression. So decision tree is a very, very versatile algorithm. Okay, it can be used for both regression and classification, and it can do both the jobs incredibly well. Okay, so just for your understanding, I was telling you that this is such an important algorithm everybody needs to understand. You remember the formula I gave you? Entropy was E of S. S is what, my people? The class. All the classes. Elephant. What did we take? Tiger, monkey, and giraffe. All four classes is this S. Okay, mathematically speaking, is equal to summation of I equals to 1 to all the classes minus P of I log of base 2, actually log to the base 2 P of I. This is the formula for entropy, and I even showed you how to solve that, right? Do you remember? We actually did this example. We actually did that example. Okay. After entropy, Gini impurity. More the classes, higher is the impurity. Yes or no? The more you will add multiple stuff together, the more the impurity, sort of arrives. So Gini impurity could be G of S. S means all the classes included. 1 minus summation of I equals to 1, including all the classes, all the probabilities, you square them. This was the formula for Gini impurity, right? Very simple concept. We actually did this. We actually got an idea. So now tell me one thing. Entropy and information gain. See, the concept of entropy and information gain, they are inversely proportional. Are you clear? If entropy increases, the gain decreases. And if the gain increases, the entropy decreases. Now, I haven't taught you information gain yet, so just keep one idea, but it should give you an idea. Tell me one thing. If the entropy, the chaosness, the randomness of an order is higher, won't the information in that system will be lower? Because it is not giving me a proper system, proper understanding of things. Okay. Now listen to me. Information gain. What is it exactly? See, information gain is a measure of how much information a feature provides about a class. Okay. Information gain is a measure of MEASURE, measure of how much a feature, provides information about a class. Now give me 1 second. I will explain you what this particular thing means. In this example of age versus salary, you have how many columns? 3. How many feature? How many target? 2 feature, 1 target. Imagine, for one understanding, I add one more column. Area. What area does the person live in? Good area, bad area, okay area. For area, there are 3 classification: good, bad, okay. How well does good area relate to the target? How does bad area relate to the target? Okay area relate to the target. How much information is a subclass providing to the entire target? What is causing that variable to cause change in the target? Did you get it? The information. If you don't want to think it like this, think it like this. How good does age provide information to predict a target? Did that make sense? How much is age important in the prediction of the loan? How important is this variable? Did that go inside your head, seep inside your head? What did I tell you? I told you information gain is a measure of how much a feature provides. Okay. See, correlation is a different concept. Okay. Correlation is when column A, column B are correlated. They both provide the same information. I am basically trying to tell you the importance of A for the prediction of target. Okay, I want you to think of it like this, not correlation. Correlation happens only in the feature space, not feature versus target space. Have you heard of something called correlation and covariance? Point number one. Never ever get confused by the concept of correlation and covariance. Correlation happens when you have a feature called A, B, and C, and you have to predict a target. How related A, B, B, C, and AC are is correlation. Okay. Covariance is when A changes, how much B changes. When A changes, how much C changes. When A changes, how much B and C change. That is covariance. One thing changes, what causes the change in another? If I move 1 centimeter, how much the column B moves? 5 centimeter. This is covariance, clear covariance. Okay. We don't check it with respect to the target, the information it holds to the target. Okay. Anyways, no problem. Information gain is a measure of how much a feature provides about a class. Everything will make sense. Give me 5 minutes. Okay. Information gain, it calculates the difference between entropy before split. Okay. Entropy before split and average entropy after split. And average entropy after split. This statement is not going to make any sense to you. Even if I teach it to you, it's not going to make sense. So allow me to jump into a mathematical exercise and you will understand everything. But let's write down the formula first. Information gain for the class S as a function of F is equal to entropy for that class minus summation of, because I want to take an average, the class feature that maps to function F S nu by S. And this is a mod function. That means you cannot take a negative function, entropy of S nu. Now tell me one thing, what the equation tells you. When I initially learned decision tree, when I was going through the concept of information gain, entropy, and all of that stuff, right? It was, of course, complicated for everybody to understand. But then what I did is I solved a problem statement. I actually solved a problem and everything started making sense. So do you see this data set right in front of you? Okay. This data set is very, very simple. Okay. What this tells you is, what was the outlook of that day? Was it sunny? Was it rain? Or was it overcast? What was the temperature that day? Was it hot, cool, or mild? What was the humidity? How was the humidity like? Was it high, normal, or high or normal? And actually both. Wind was weak or strong. Depending on all your feature variables like outlook, temperature, humidity, and wind, did you actually decide to play tennis? Yes or no? This is the prediction that we want to do. This is the prediction that we want to do. If it was rain that day, the temperature was mild, the humidity was high, and the wind was weak, you actually went ahead and played tennis. So this is my actual data set on which I'll be working on. Let's start solving manual exercise. Okay, let's do this. What is the first thing you're going to calculate before even jumping into anything? What did I tell you? The first thing you calculate in the entire data set is the entropy of the data set, isn't it? We calculate the entropy of the entire data set, yes or no? 100% yes. Let's calculate the number of no's and yes. How many no do we have? 1, 2, 3, 4, 5. How many no's? 5 no's. So in the entire data set, how many classes do I have? I have 9 yeses because this is 14. So I will have 9 yeses. And how many no's? 5 no's. Yes or no? Because remember, we have to calculate the category of our output, which is 9 yeses and 5 no's. So if you calculate the entropy E of S, how will you calculate this? Minus of 9 by 14, because the overall data set size is 14, right? Log to the base 2 of 9 by 14 What is the next sign? If you keep minus outside, then you will get plus. But if I don't keep minus outside, I'll still get minus. 5 by 14 log to the base 2, 5 by 14. If you solve this particular example, you'll get an output called 0.94. What is the entropy of the data set before even doing anything that we got? 0.94. This is the chaotic, the most mixed answer that we can get, the most highest entropy answer that we can get, 0.94. Answer has come, arrived. Okay. What is the next step? Next step is you are supposed to select each column and test how good is this column, because after calculating entropy, what is the second biggest fight that we do? The next biggest fight that we have to do after calculating entropy, what do we have to do? To decide what? To decide who will be what? Root node. The next biggest fight is, bhaiya, who will be root node? If you don't know how to calculate right after entropy, who to decide as root node, kuch nahi kar sakte aap. You can't even make a decision tree. The second first thing that you have to do, I'm saying second first, because entropy needs to calculate first, is to calculate who will be root node. Will outlook be root node? Will temperature be root node? Will humidity be root node? Or windy be root node? Which node decides the best way to split my data, to create my decision tree? So tell me one thing. Can we take outlook as an example? First example, we will take outlook since it's a part of the beginning. So tell me one thing. Outlook. What do we do about outlook? Now tell me, outlook has how many categories? Sunny. Sunny. What is the next thing? Overcast and rain. Yes or no? So outlook has 3 categories inside it. Let's calculate each category. So what is S of sunny? S-U-N-N-Y. Sunny. My people, only and only consider sunny. 1, 2, 3, 4, 5. How many sunnies are there? In sunnies, how many yeses and how many nos are there? So in sunny, we have 1, 2, 3, 4, and 5. So basically 2 yeses and 3 nos. Yes or no? 2 yeses and 3 nos. Yes or no? For S of sunny, for class sunny, we have 2 yeses and no. Now, why are we taking yes and no? Because the target is yes and no. Agree or disagree? If the target was 3, we would have taken 3. But the target is only yes and no, so I'm only taking 2. So my people, how do you apply entropy for sunny? Now you have to calculate, okay? Entropy for S of sunny is how much? Minus 2 by 5 log to the base 2 by 5 minus 3 by 5 log to the base 3 by 5. Are you clear? You will get an output called 0.971 entropy for class sunny. Okay? You will get this output 0.971. We will keep it as this is for now. What is the next category we need to calculate? S of overcast. Yes or no? Now tell me, how many overcast yeses and nos do we have? So overcast 1, overcast 2, overcast 3, overcast 4. So together 4. So you will have 4 yeses and 0 nos. All yeses, right? So we will say 4 yeses and 0 no. Let me tell you one thing, my people. If any of the answer is either yes or no is 0, the entropy for that variable becomes 0 automatically because log is added. So multiplication of anything with 0 is a 0. So if any of the categorization either on the left or either on the right is 0, the answer is 0. You don't even have to calculate. The answer becomes 0. It summates to 0. Okay. What is the next category? S of rain. Now, my people, for rain, how many yeses and nos? 3 yes and 2 no. So tell me one thing. Entropy of S rain, okay, for category rain is minus 3 by 5 log to the base 3 by 5 minus 2 by 5 log to the base 2 by 5. Yes or no? Shouldn't this be the answer? If you calculate this, okay, let me help you calculate. 971? Okay. Okay. Tell me one thing. What have you calculated so far? You've calculated entropy for the entire data set before the split. Okay. Can you have a look at this example? Before the split, after the split, it'll all make sense now. This is the entropy of the data for the entire data set. According to the information gain formula, did I not write it like this? Information gain, which is gain of class S for Outlook category as a function of Outlook. Did it now make sense? What is this F? What is this F? Is your class. And S is all the subcategory of the class. For example, Outlook mein sunny, overcast and rain. So this is sunny, overcast and rain. And this is Outlook. Did that make sense? Chalo, my question, मैं formula ही लिख देता हूँ. Everything will make sense, no problem. Entropy of S minus, can you see I've taken minus? Summation of, tell me one thing. I am categorizing for how many subclasses? Sunny, overcast, and rain. So mu, the mu or the nu has to repeat for how many classes? Sunny, overcast, and rain. S of nu divided by S, entropy of S of nu. Okay. If I replace the values inside this, sir, I want to replace the values inside it. Okay, no problem. What is the entropy of S means the entire data set. What is the entropy of the entire data set before the split? 0.94. 0.94 minus. Okay. Now I'm going to write down this formula. Okay. How many times does Sunny repeat? 1, 2, 3, 4. And where is one more? 5. How many times is Sunny repeating itself? 5 times. 5 divided by, what is the total data set size? 14. Into entropy of Sunny minus how many overcast is that? Or how many overcast do you have? 1, 2, 3, 4. So minus 4 divided by 14 into entropy of overcast minus how many rain do we have? 1, 2, 3, 4 and 5. Minus 5 divided by 14 entropy of rain. Did you understand the formula? Because it belongs to all categories. So their calculation is important. So is equal to 0.94 minus 5 divided by 14 into what is entropy of Sunny? We just calculated 0.971 minus 4 divided by 14 into overcast is 0, correct? We had nothing. Minus 5 divided by 14 into 0.9 something, 71, entropy of rain. If you replace all these values, you will get a gain of 0.2456 or 64 something, 2464, 2465 something you will get like this. This is the gain for what category or what variable? Only and only Outlook you got for. So you got for Outlook. If you repeat the same exercise for temperature, humidity and wind, whichever value has gain higher, that will be selected as root node. Did it make sense? I'm not going to repeat it again and again because it's a longer exercise. If I do it by hand, trust me, it's going to take us more hours. I just taught you how to do it for one category. And I'm very sure you guys, if you want to try it out on your own, you can do it for multiple categories. But do you see, we used the concept of entropy, and we calculated something called gain at the end. And gain told us how important this feature is in predicting target. Hence, this should be selected as root node. Remember one thing, my people. It never happens that gain of one variable and gain of other variable are always equal. Ye kabhi nahi hoga. Okay. Let's pretty much take it like this. Okay. Okay. How many variables are there? How many variables are there? 4. Imagine for simplicity reasons, the gain of S comma outlook is equal to how much was it? 0.2464. 0.2464. For simplicity reason, let me say the gain of S comma, what is it? Outlook के बाद temperature. Gain of S comma temperature के बाद क्या है? Humidity. Humidity. ठीक है? Gain of S के बाद क्या है? Wind. Comma wind. Okay. Imagine for simplicity reasons, okay, this is 0.0289. हाँ मतलब some random values I'm giving. 0.1516 and आप इसको ले लीजिए कुछ भी ऐसा 0.0478 example. Which gain is the highest number among all? Which one will you select as a root node? Outlook. Remember one thing, my people. Decision tree is like a blueprint. Yes or no? Once the tree is made, every decisions will be taken based on the blueprint. You remember the giraffe exercise I showed you? I pulled a giraffe, it goes to the left, then it goes to the right, it goes to the right, and it comes to the bottom. Decision tree is like a pratha. Once it is established, everybody has to follow it. And then you will be segregated in the bottom. And any tree that you make should only have one root node. You can't have two. Okay, hold on. First of all, when you have two root node, is it a tree or is it a graph? A root node decides the flow. Two root node decides. Okay, how do I say this? Like it's a part of data structures. Have you seen a single linked list which is connected to another list? Then you have something called doubly linked list, which has a single and two pointers. Then you have a circular linked list, right? The flow is unidirectional, correct? When you open the tap, the water flows. Or do you pump water through the tap? Are you understanding what I'm trying to say? A decision tree is called a decision tree because it's a unilateral flow, one flow. The input comes to the top, output goes to the bottom. If the decision tree actually will not be called decision tree, has two different nodes, it's not a node, it's a graph. Okay. You have to calculate the process of information gain for outlook, temperature, humidity, wind, and for each of it category unless you exhaust all your feature space. Until the feature space is exhausted, until all the feature variables are taken with respect to the tennis of yes and no, until then you have to do this exercise. You have to keep repeating this manually. Okay. How about you want to see this example in real life? And you know what? Just for fun, I mean, not for fun though, like for proper understanding of things also. What if we take the same exact data set like we did with tennis DF and we solve and see how that works? Then we'll take one more data set. The one that I just taught you right now, this tennis data set. How about I teach you a decision tree classifier? How will it be done in practical with this? And at the same time, we'll take another data set for practical purposes. Let's look at both the data sets, okay? So that you guys will get a pretty good idea. Now tell me one thing. Import pandas as PD, yes or no? Import numpy as NP, yes or no, my people? Hey, Pansas, sorry. I don't know about Pansas, but I know about pandas. Happens. I'm a really fast, I type so fast that sometimes my Pansas library is not to be seen. No problem. No issues. df equals to pd.read csv. Okay. If you guys didn't know this, I'm just letting you know, you can do this. Am I getting the output? Sunny, hot, high, false, no. Sunny, hot, high, weak मतलब false and no. मतलब मैंने weak नहीं लिया है. Weak strong को true false ले लिया है. Sunny, hot, high, false, no. Sunny, hot, high, false, no. Data वही है. If you do df dot shape, how many columns did we have? 5 columns and 40 row. Yes or no? Agree, disagree? Okay. Now tell me one thing. Before I even do anything, will I be able to run machine learning or any analysis on this? high, low, good, bad, true, false. इस पे कुछ कर सकते हैं? Can we do something on it? Is it possible to even approach anything? You need to convert. You need to encode this yes or no. Otherwise, how will you run a decision tree classifier? From sklearn, what do you need to do? From sklearn, because this is a part of pre-processing, you have to call pre-processing. And you have to import label encoder. We are going to import label encoder. Now let me give it a function. Label encoder is equal to label encoder. Say example like this, right? Label encoder. But this function needs to be callable. Are you clear? You need to put a bracket inside this. Here you have no bracket because you're importing a part or module. Here you need to put a bracket because you are calling that function. So df is equal to df.apply. You know what apply is? Apply lets you run the output, the function on entire columns one by one. If you know, in pandas, we have a function called apply. Apply runs it on the columns. Okay. le dot fit the model and transform the model. Basically fit transform. We call it fit transform. And if I run df dot head of 5 again, is everything converted? Okay. Can I tell you guys one thing and you should take it as an important interview question? If I tell you, will you please agree what I'm saying is an important question? In your interview, this person, your interviewer, is going to ask you this question. What is dot fit in machine learning? Okay. What is transform in machine learning? And bhaiya, what is fit underscore transform in machine learning? इन तीनों का डिफरेंस बताओ. ये क्वेश्चन इतना इंपॉर्टेंट है. I cannot even tell you the importance this question carries in your life. If you are not able to answer this, don't even talk about decision tree. वहां तक नहीं जाएंगे. Can I give you guys a small assignment so that you read it up on your own? I don't be your hand holder every time. I don't become your stick. I tell you in 2 seconds, you're like, अरे हाँ ये तो आता है. Can you guys do a research on this? Why have I only applied fit transform? Why did I not do label encoder dot fit and then transform? Actually, answer ही दे दिया मैंने. But will you please finish this as an assignment? कि in machine learning, why do we do dot fit? Why do we do dot transform? Why do we do fit transform? Label encoder will give it 0, 1, and 2, right? This is going to give it a label encoding. Why don't we do one hot encoding? You can even do one hot encoding. That's not a problem. Because the numbers of subcategories are so low, label encoding works well. It has no problem. The machine learning model does not get biased when it is categories. Let me give you an example. Have you heard of something called nominal categories and ordinal categories, my dear? What is a nominal data as an ordinal data? Which data order matters? In which category order matters? Ordinal or nominal? Example, if you rate your food 1, 2, 3, 4, 5, will the order matter? And suppose I tell you car like Mercedes-Benz, Audi and Ferrari, example, does the order I rank them in matter? Okay. Coming back to the same topic, does the order matter here? So it's nominal or ordinal? Nominal. The encoding that you can apply to this is both one-hot encoding and label encoding. Because the categorizations are so small, it won't make any difference for the machine learning to give a bias. Okay, so label encoder is like a good choice. Not a problem. You can apply it here. What is my feature space? If I just drop, what do I drop? Just the play part. Okay, just the play part for all the axis as 1. And if I take x dot head of 4, did I just get my variable outlook, temperature, humidity, and windy, which is my target variable, the one that I want? And if I want to take y, I just need to take df dot play. That's it. Done. If I just take this part, my y category is set, right? My y dot head is 5. Yeah. I got my feature and my target. Agree, disagree? Now we will split the data. From sklearn, what have I taught you? Dot model selection. What do we select? Import xtrain, xtest. Y train, Y test. From sklearn dot tree, because you're doing a tree based classification, dot tree, import decision tree classifier. The classifier is equal to decision tree classifier. And remember one thing, you want the tree to be split on based on entropy or Gini entropy, Gini impurity. What have I taught you? That we split the tree based on what? Entropy, right? I have taught you that we split the tree based on entropy, right? Like we calculate entropy. Yeah, that's nice. Thank you so much. So what will you write? Criterion is equal to entropy. Classifier dot fit. What will you fit inside it? What two variables need to fit inside a variable? X underscore train and Y underscore train. Yes or no? Did I get a classifier run? Is my classifier basically done? It's running, it's getting the output. Okay. How do you predict the output? Ypred equals to what do we say for Ypred? Classifier dot predict X underscore test. Yes or no? This is all my Ypred answer. Yes or no? Okay. From sklearn dot metrics, okay, import accuracy score of what do you pass? Y test Ypred. What answer did we get? Oh, 100% we got. Imagine 100% accuracy we got. If you do this, are you starting to get an error, my friend? You see, we got an output. Okay, first of all, I got an X test, comma Y test. I've added. ठीक है, मैंने X test डाल दिया, Y test डाल दिया. But why is it giving me error? Can you tell me? The reason why accuracy scores only work on Y test, Ypred is because for the Y test result and the Ypred results, aren't we comparing what we got? Aren't we kind of getting an understanding that, okay, what did I do to get an output? What did I do to fix this output? Basically, all the test set that I've taken, how many test set have I taken? If I take 20%, does it change the answer? Let's teach you something important, okay? Decision tree classifier, come here. My people, I have used criterion equals to entropy. What if I use criteria equals to Gini? Then kya hoga? Let's try. Am I getting an output called 33%? Okay, so here I changed it to Gini impurity. Okay, I told you one thing, you remember? Either we decide on the basis of entropy to split the data or Gini impurity to split the data. Any one can be chosen. Yes or no, my people? Agree, disagree? Okay. Tell me one thing. Initially, I chose the entropy as the criteria and I ran it. What was my output like? 100%. But suddenly I changed the entropy to Gini and Gini to impurity. Now it is giving me 66%. Isn't it weird? Let me show you once again. Hold on. Cell, run all. Okay. It's giving me 33 now. Okay. Cell, run all. It's giving me 100% now. Cell, run all. It's giving me 100% now. Now see what happens. The moment I change this to Gini, cell, run all, 66%. Okay, cell, run all, 66%. What's happening? What do you think is the reason for all of this? See, coming over here, okay, or coming and trying to teach you how to use a classifier syntax is not my job. My job is to make you think deeper. Okay. My job is to make you think the things you would have never thought of thinking. That is my job. What makes you think this is okay? Let's do one more thing. Let's make you think more weirder stuff. Give me 1 second. पूरा confuse करते हैं आज तुमको रुको. Okay, give me 1 second. Give me 1 second. I don't want any class weights. I don't want max features. I want to not touch this. Default is 2, which is fine. Min sample weight, max features. Max features are actually fine. But actually, you know what? By default, it is, let's take it as square root, I guess. Okay, let's try to change the hyperparameters a little differently, okay? Let's take this to Control Z, entropy. Cell run all. If I run this and I have taken entropy, okay, my criteria, cell run all. Give me 1 second. Okay. What is the final output that we are getting? 100%. Agree or disagree? It is overconfident in its output. Okay. Let me tell you the problem that this decision tree faces, okay? My people, remember one thing. Decision tree is an important algorithm. Very nice, very good. But do you know what is the biggest problem of decision tree? It usually tends to overfit very easily. Depending on the sample size, the data that you have given it to train, if the training set is so small, it usually will overfit. Do you understand, my people? Imagine I have 14 samples and I only gave it 10% of test size. What is 14 of 10%? What is 10% of 14? 1.4. Usually Python takes a lower record size, which is 1. I am only taking one as a test set and the other as a training set. Are you understanding what's happening here? Did you understand what's happening? Hold on. Let's make the test size as, I don't know, 40. Cell, run all. Look, the output is 0.16%. What did you understand from this? Point number 1. Decision tree is a terrible, terrible algorithm if the data set size is lower. Are you clear? It will overfit and it is usually an algorithm that tends to overfit. Decision tree is a right algorithm if you have a large quantity of data, you have a good equation for test and training. If you have such a small data of 14 records and you're trying to fit decision tree, you think that's a good option? For a minute, logistic regression would have worked better, but not decision tree. Are you clear? There is nothing to be confused here. It's common sense. I wanted to just run it through you and tell you the answer. That just because I gave praises to decision tree in the beginning, that it can do both regression, it can do both classification, doesn't mean you use it for everything. Decision tree usually tends to overfit. It is usually overconfident. अरे मेरे को तो सब आता है. एक बात बताओ. Do you all understand the concept of overfit का मतलब क्या होता है? आप समझते हो? Do you all understand the meaning of overfit? Let me go through the concept. Give me 1 second. People, imagine you have exams to give. Okay? You have exams to give. I will give you a question paper, a test paper. 1 plus 1 equals to 2. 2 plus 1 equal to 3. 3 plus 1 equal to 4. Example. In the exam, if they ask what is 5 plus 4, aren't you supposed to solve that problem? Because you're supposed to understand the basics, the pattern of the test. Yes or no? Okay. What is overfitting, underfitting, and right fitting meaning? The meaning behind it is whenever you are asked the question 1 plus 1, automatically you will say 1 plus 1 is 2. Because all you saw is 1 plus 1 in the test. Yes or no? In the training of your mathematics class, you saw 1 plus 1. But the moment I will give you 2 plus 3, you will not be able to do it because that was not taught to you. You will be able to do 1 plus 1, 2 plus 1, 3 plus 1 because you've memorized it so much. You've memorized the data so much that the moment something comes, you've memorized it so well, the output comes. That is overfit. Are you clear? Overconfident, overfit. Only what training comes, I'll able to answer that. The goal of machine learning algorithm is only to pick up patterns, right? And not memorize anything. Correct or not? The goal of machine learning is to understand the patterns behind the data, not to memorize the data. When you overfit, you memorize it so well that you become overconfident. अरे मेरे को तो मैथ में सब आता है. अब पेपर आने दो, फाड़ दूंगा मैं. That is the overfitting problem that decision tree usually has. Can somebody tell me why? Because decision tree are once finalized, will be finalized forever, correct? एक बार decision tree बन गया, it is not going to change, correct? Did that make sense, my people? Once a decision tree's root node is finalized, another nodes are finalized, will it automatically adapt itself or change, or will it remain constant no matter if the data changes also? That is the problem. It is constant. Let's plot it. Let's try to visualize it. Okay. But did you guys get the concept which was important? I'll show you. Okay. I'll show you. Import matplotlib.pyplot as PLT. Okay. As PLT. Okay. As a PLT. From sklearn, skimage nahi, sklearn, import tree. Okay. Here, I've just taken matplotlib as pyplot as PLT. From sklearn, I've imported tree. Figure comma axis, or not this, figure comma axis. You guys remember, right? In matplotlib, we have an option of taking sub figures also, multiple sub figures if I want to take it. Like if I do like this, subplots, subplots, like this. Like I have the options of taking subplots. Okay. N rows equals to 1. N rows equals to 1. I hope I'm taking it right. I've not done it since a long time. I don't remember. I may not remember the syntax, so apologies for that. What is the figure size or figure size? Let's take it a minimal 5,5 figure size. Oh, let's take it smaller actually, not more. 4,4. Let's take it 4,4. Yeah, I mean, and let's keep the DPI to a minimum of 150, 200. Okay. 3 dot. Okay, let me just basically run this. 3 dot. Okay. So if I say plot tree and if I pass in the value of a classifier like this, okay. So I think it should run. Okay. Okay, let's keep the DPI smaller. Let's keep it 100. How? Do you see the tree it created, my people? See, you can visualize the tree. The class is outlook, okay, which is less than equal to 0.5. The entropy was 0.811 according to its calculation. Okay, the entropy was this much, the entropy was 0, and it basically created a tree for you. So can you see I'm actually plotting the tree that the classifier actually made. If I would have taken Gini, it would have given me a different tree. You can even plot a decision tree and validate the results. It's not that you just run it and you have to accept it. See, this is the plot that the classifier built from the code side. Okay. There is another library called GraphViz. Decision tree. Remember one thing, my people. There is another library called GraphViz. I actually learned about it a little later because I never implemented a decision tree in production. To be frank, no company would have deployed decision tree as a production in their company because there are better algorithms like XGBoost, multiple other better algorithms. So see, this gives you a much prettier result. So this is a library called GraphViz. You can even try this out. See, this is a GraphViz library. So I have imported the tree package from, sklearn package. But if you want to make it appear more beautiful, more pretty, you can do that using that also. As in, you can do it prettily in a nicer sense also. That was the point. Okay. Now coming back to this question, okay, you make this test size as 30. Don't make it higher. Okay. Usually, if you take a test size of 30, you get a decent score of 40%. Okay. Remember one thing, my people, there's a thumb rule. If your data set size is smaller, make sure that your test and test size are almost nearer. So 60-40 split is usually taken, or maybe 70-30 split is taken. You don't take more. If your training size is bigger, then you take 80-20. Are you clear? If your data set size is smaller, usually people prefer 60-40 or 70-30. But if your data set size is larger, you prefer a set of 80-20. Okay? The tree that I have now is a little different from the tree in the past. Why is that? What did I change that it ran? Okay, let me run it again. Okay, cell run all. Is the tree now not different? Let's change the DPI to 150. Yeah. चलो 100 ही रख लेते हैं. Kernel restart and clear output. Okay, restart and clear output. Kernel cell run all. Okay. Look at the tree now. Okay. Is it slightly different from the previous tree? This is happening because, The test keeps changing. Also, I have not used any randomizer here. Here, I would have taken some seed function, which you called as a random state function. If I would have kept it same, it would have been same. You guys got the concept, right? Like whenever you work on decision tree, you fix the data, the sampling of the lowers and the rights, the test and the train, so that they don't get sampled again and again. Okay? Because they get sampled again and again, the value changes, because what would have been in training now goes in testing. Okay, so this was just to give you guys an idea about what we solved here versus what we got here is kind of similar, and it also gives you an understanding of how important this library, this package is. But tell me one thing. I want to ask you guys one thing. In your real life machine learning, will you implement multiple algorithms, or will you take one data set and on that you will implement multiple algorithms? What do you do? The second one, yes or no? Can we try that? Can we take one data set, implement logistic regression, implement decision tree, for fun, implement a dummy classifier, and print AOC ROC score, print accuracy score, print confusion matrix, and then decide it would be amazing or not? Should we do it on a different practical data set? This was just to make you guys understand few things in life, but this was not like the actual data set that I wanted to start with. This was just like, so it's for fun. Okay, anyways, df is equal to pd.read CSV of, now here I want to take another, how do I say this? Okay, let's think of it like this. Okay, see, I want to basically take like a different data set for you. I think, हाँ यही करा देता हूँ, चलो आपको ये data set भी अच्छा लगेगा. You guys will like it because it's very numeric in nature. You guys will understand. You guys will love it. Okay, I think this data set will teach you a lot in life. Listen to me carefully. Okay, this data set is all about a person's age. Okay, a person's age, a person's you know what? Give me 1 second. I'll make it easier for you to understand. Give me 1 second. पहले data set समझते हैं. Come here. ठीक है? This is a column called person's age. 63, 60, 37, 41, 56, 57. Any confusion? Second is by sex. अगर 1 है तो मेल है, 0 है तो फीमेल है. CP is nothing but just chest pain. आपका chest pain किस टाइप का है? Do you have asymptomatic, atypical angina, non-typical angina या typical angina pain? ये भी हमें पता नहीं है. But 0, 1, 2, 3 लिखें. Label encoded है. This is label encoded. Thresh BPL is the resting blood pressure of the person. Then you have the cholesterol, the fasting blood sugar, echocardiogram result. Okay, this is the heart rate of a person. Okay, this is the included exercise angina. This is old peak slope, and basically बहुत सारे medical values दिए हुए हैं. Did you understand? You see target is equal to 1. आपको यहाँ दिख रहा है क्या? Target heart disease 1 मतलब नहीं आया, 0 मतलब आया. Given somebody's age, his, her sex, the chest plate and all of that, did the person get heart attack or no? The possibility did the person get heart attack or no? Isn't this a logistic? Isn't this a classification use case? तो अपने को clearly पता है कि अपना target ही target है. The target itself is a target. Yes or no? Okay. This is my data set. What is the things that you usually do? पहले तो देख लेते हैं how big is a data set, right? So when we do df.shape, how big is a data set? How large is our data set? 303 rows, 15 columns. 303 rows and 15 columns. Now tell me one thing. If I want to split my X and my Y separately, what do? Won't I just go ahead and drop? What will I drop from that particular thing? I will drop target. Yes or no? I just want to drop target from the column and axis equals to 1. Okay. And axis equals to 1. If I do this, I will get the value of X. Agree or disagree, my people? Yes or no? And if I take Y, can I not just take df dot target or df of target, anything? You can take it however you want, right? So if I do Y dot head of 4, did I just get my X and Y separated properly? I have no issues. Everything is proper and sorted. Very nice. I have my X and Y sorted. But you know what? In machine learning, there is one more problem. Let me ask you what that problem is. My people, imagine you have a person whose column is age and another person whose column is salary. Now tell me one thing. Age is of what limit? Maybe 18 से लेके 70 max. Agree? The salary range could be ranging from 15,000 to 1.5 crore. Now listen to me very carefully. Because the column age has a different range and salary has a different range, won't machine learning give preference to the salary column more than the age column because the numbers tend to be higher? Look at the data. Cholesterol is between 200. Age is between 63. CP is a variable which is 0, 1 and 2. And old peak is 1.2, 2.3. Aren't we seeing multiple ranges here? Won't it be amazing to convert everything between 0 and 1? Age also between 0 and 1, salary also between 0 and 1. If everything becomes standardized, my machine learning model won't get confused and will be able to do a better job. I have taken an X variable, I have taken a Y variable because X features and target needs to be separate. Agree, disagree? Now tell me one thing. Can we split the data? Can we basically go ahead and split the data into multiple different types? Like basically, can we do this? Can we say X underscore train, comma X underscore test, okay, comma Y underscore train, comma Y underscore test? Can we do it? Is equal to train test split is equal to train test split of X comma Y comma test size equal to, let's keep a test size of 20%, not more, okay? Let's not keep a test size higher. मैंने X train, X test, Y train, Y test कर दिया. But now I will take something called scalar is equal to, do you know or do you understand that in Python or specifically in our libraries, we have a scalar called standard scalar. Have you heard of it? I'll show you. See, yahan pe, before importing the package, let me also do import statement, okay? From sklearn dot pre-processing import standard scalar run. Okay, what I did, I have imported something called standard scalar. So मैं यहाँ पे क्या करूँगा? I'm going to call standard scalar. What standard scalar is going to do for me? What did I just tell you right now? What standard scalar does? What will it do? X underscore train equals to scalar dot fit transform. Okay. What? Fit transform what? X train data, because this is what I want to basically transform. I will take similarly X test is equal to, what do you do? Scalar. But यहाँ पे आप fit transform नहीं करोगे, यहाँ पे आप transform करोगे. That's why I told you we need to know the difference between the test, the fit, the transform, and the fit transform. Are you clear, my people? I run it. I'm set. I'm sorted. And don't worry, इतना कोई complicated चीज नहीं है वो. Fit, transform, fit, transform. It's a sequential process. Can we have like a dummy classifier? Do you know what is a dummy classifier, my people? A random classifier, a random guesser. वो guess करके ही अपना output निकाल लेता है. That is called as a random or a dummy classifier. Okay. It's like a random classifier, no problem. From sklearn.dummy, okay, import dummy classifier, okay? I've imported a dummy classifier and I'm running it. How do you call the dummy? See, what dummy classifier will become is, it will become like a baseline for us, okay? So let's say dummy underscore CLF underscore classifier is equal to, now how do you call dummy classifier? You call it like this, dummy classifier, or you know what, एक काम करते हैं, छोड़ो, dummy को नहीं लेते हैं. I don't want to confuse you guys anymore. Then you guys will be unnecessarily confused. Let's not take any dummy classifier. Ignore करते हैं, no problem. पहले logistic ही लेते हैं, no issues. ठीक है? I don't want you guys to get confused later on. Okay? Logistic. What is the use of dummy classifier? See, dummy classifier is like a baseline model. Okay? What happens is when you choose 3 different models, you need to know the worst. How worse are you performing? मतलब if you are performing worse randomly, how terrible are you performing? It tells you the baseline कि इसके नीचे तो खराब होना ही नहीं है. If you have a data set and if you have a problem statement, how worse can you perform? The worst accuracy you're getting is 45%, and below this it's not possible. So minimum efficiency that you are allowed to reach, or you're reaching even if the worst case happens, that is dummy classifier. Very nice. Okay. Let's call logistic. Now, how do you import logistic, my people? From sklearn, what do we call? Dot linear model. Import logistic regression. Yes or no? I'm just calling logistic regression. Acha. Lage haath. Let's also import decision tree. How do we call? From sklearn dot tree. What do we call? Import decision tree classifier. Agar now that we've imported it also from sklearn dot metrics, what do we import, my people? First, let's import confusion matrix. आप लोगों को आज confusion matrix कैसा होता है वैसे दिखाता हूँ. Okay, import confusion matrix. Point number 1. Let's also import something called accuracy score. Let's also import something called classification report. You remember I've shown you how classification report looks like. Let's also import F1 score. और अगर AOC ROC स्कोर करेंगे तो वो भी निकाल लेते हैं. चलो ROC कर्व एंड ROC AOC स्कोर. ओके, और AOC ROC स्कोर. ROC कर्व ले लिया, ROC AOC कर्व भी ले लेते हैं. ठीक है, because we'll also run AOC ROC at the bottom. So we've imported all the packages. Yeah, most of the packages I've imported, no problem. Now tell me one thing, how do you import logistic regression? Can I say something like this? Log reg is equal to logistic regression callable function, which is a callable function. What do you usually do once the log reg is done? Do we not fit it? Log reg dot fit the model. अब हम fit के अंदर क्या डालेंगे? X test, Y test, Y pred, Y test, और what? X train, Y train, है ना? Yes or no? The log output, log reg dot predict. What do I pass inside it usually? Isn't it the function X test that gives me the prediction of all the Y prediction? Okay. Logistic regression accuracy score. So logistic regression accuracy score is nothing but accuracy score of what do I pass inside it? Y test and what do I pass? Y test and Y pred log. Yes or no? ये वाला जो हमारा पार्ट है, this is for accuracy calculation. Let me call it metrics. Metrics. अरे यार, somebody should gift me a good keyboard soon, otherwise I'm going to break my laptop. Okay, I got an accuracy score. Okay, LR underscore F1 underscore score is equal to, what are we calculating here? F1 score. So can I call F1 score? What do I pass inside this? Y test, comma, Y pred underscore log. Logistic regression confusion matrix. I'm just printing confusion matrix equals to. I'm going to call confusion matrix, and what I'm going to pass inside this? Y test, Y pred log. कोई भी accuracy parameters are all the same. Y test, Y pred log, Y test, Y pred log, Y test, Y pred log. That's nothing else. Let's make it a little neat. Let's make it a little nice. Okay, print. How do I print this? Print. First, F. What am I printing? Accuracy score. What do I pass? LR underscore AC underscore score. This is my accuracy score. Yes or no? Print. F, double quotes. F1 score. F1 score is always on a test set. I hope you know. F1 score doesn't happen on a training set. ऐसा नहीं होता है. LR underscore F1 score. ठीक है? Print. अच्छा, accuracy और F1 हो गया. चलो थोड़ा better print करते हैं. Star star hyphen star star into 8. ठीक है? इसको भी ऐसे ले लेते हैं. Star and star. हाँ, I'll give a better output. Okay. Print confusion matrix. If I want to print confusion matrix, what do? Just print LR underscore conf underscore matrix. Yes or no? And take the same exact code, paste it here. But do you remember I also taught you a beautiful concept called classification report? If you remember, I also told you there is something called classification report. Print classification report of same thing, Y test, comma, Y pred underscore log. If I run this, Are you getting all uh, 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 matrix, all the matrix that we need to print? So can you see I am printing something called pehle to accuracy score. Oh baba, 100%. Look at this. F1 score is 100% overfitting. Data bhi acha khasa hai. Why is it overfitting? We'll come to that, no problem. Do you look at the confusion matrix? Look at the precision and recall. 0, 100%, 1, 100%. Result to terrible aaya. Yes or no? Agree or disagree, my people? Okay. We all agree the results are terrible. I have run logistic regression. Can I run decision tree on it? Can I copy the whole thing exact as it is, because I don't have the energy to run it again, and I'm going to implement it here. Instead of calling logistic regression, can I call it decision tree classifier here directly? And rather than calling it logreg, let me call this tree. Yes. So instead of logreg.fit, can I say tree.fit? X train, Y train will remain same. Y pred log ke badle Y pred tree. Yes or no? And this will be tree.predict. Did I just change the line number, the first 3 lines as is? Tree is equal to decision tree classifier. Tree is equal to tree.fit. X train, Y train मैंने डाल दिया. Y pred tree को मैंने बोल दिया कि this is tree.predict X test. भैया first 3 lines are sorted. What do I change here? LR के बदले what do I pass here? Tree accuracy score is equal to accuracy score Y test, Y pred tree. Yes or no? अच्छा, ये LR के बदले हम क्या लिख सकते हैं? Tree F1 score. तो यहाँ पे हम क्या पास करेंगे? Y pred tree. LR confusion matrix के बदले हम लिखेंगे tree confusion matrix and we will pass Y pred tree. Is this done? So LR के बदले हम लिखेंगे tree accuracy score, tree F1 score, tree confusion matrix, and classification report will have tree. Agree or disagree? If I run this, भैया ये भी overfit कर रहा है. This also is overfitting. What is the problem? है ना? See, we have a good enough test site. हमारे पास data तो अच्छा खासा है. Why is it still overfitting? You know why it is overfitting? I'll tell you. My people, the moment something overfits, what is the thought in your data? What is the thought in your brain? Something must be wrong in the way I must have run the algorithm, isn't it? Your first thought process is maybe something I have imported is wrong, maybe something I've done is wrong. You forgot the most basic thing here. What is the most basic thing I did while importing the data here in this particular part? See, I have taken this data here, correct? I have taken this data here. df is equal to pd.read csv. I have taken this. Do you see another column called unnamed equals to 0, which is 0, 1, 2, 3, 4, 5, 6, 7. It's increasing, increasing, increasing. And the machine learning thinks that's also a part of the label. Did that make sense to you? So if I put a column here, I say index call equals to 0. Listen to me very carefully. If I run this, did I just drop the column index call equals to 0? That 0, 1, 2, 3, 4 was there. The column that you had, see, this column I'm talking about. If I run this, do you see unnamed equals to 0? Do you see this column unnamed equals to 0, my people? Yes. If I paste it again and run it, it's gone. Let's run it again. Did we get a different accuracy? Now my accuracy is 77% and my accuracy for decision tree is 67%. So tell me one thing. You must be thinking the problem is such a big problem, but where did the problem actually turn out to be? Where did the actual problem turn out to be? In the way you imported the data. So listen to me very carefully. As a data scientist, shouldn't you keep every step in your brain what I'm doing? You think about it, you plan it, and you know exactly what you're doing. Am I making sense? The moment you got 100% as your accuracy metric, overfitting both logistic and decision, you got confused. You thought maybe your program is wrong, maybe the data is wrong. You must have done one thing. You must have ran to your manager. You must have ran to your senior and say, sir, data acha nahi hai, it's overfitting. And if your manager or your senior sees this, what do you think he's going to make your, what do you think he or she is going to do after they see this is the silly mistake you have done? Yes, that's why I thought that this example was very relevant. That's why I got excited in the beginning. Because I have so many data sets, I randomly choose any one data set and I start teaching. Luckily, you guys got a data set like this today, and I thought maybe I'll make an example and teach you guys that it is very important to pre-process the data, to know exactly what is going in your X, to know exactly what is going in your Y, and you print the output absolutely accurately. I was at a point where I told you that you have to be very careful of the data processing that you do before you even start adding the values to it. Now, chalo, rest aside, let's try plotting AOC ROC's curve. But before we do that, let's have a proper formatted and a very nicely documented thing, okay? So let's take another column called model evaluation equals to. Now I want to convert this into a data frame, okay? So pd.data frame. What do I pass inside this? You can take it as an array, right? Like the model versus its accuracy. So we can say something like the model that we chose were of this type and the accuracy, okay? Accuracy was of this category. And if you also want to plot an F1 score, you can also plot an F1 score against it, right? So what model did we implement? Logistic regression, yes or no? We also implemented something called decision tree. What was the accuracy of logistic regression? LR underscore accuracy underscore score. Then tree underscore accuracy underscore score. Then for F1 score, what did we have? Tree F1. So LR underscore F1 and tree underscore F1. If I run this, right, and if I print model underscore EV, is this giving me like a proper analysis of the things that we've gotten, like a proper neatly arranged data frame that gives me an idea about, okay, you know what looks like that you have properly and very neatly arranged the accuracy and the F1, and you have a comparative advantage of proper printing the whole thing out in a nicer way. Now tell me one thing. If I want to plot the ROC curve, so don't you think we need to have false positive rate and true positive rate, if you remember? So false positive rate for logistic regression and true positive rate for logistic regression, comma, what was that another thing that we did? thresholds, thresholds underscore logistic regression. Remember, we've done this in the last class, and I used a function called ROC curve to pass in y test comma y pred log. Do you remember we did this? Y test y pred log. Okay. If I copy the same thing and if I paste it here, instead of log, I'm going to call this tree. Instead of log, I'm going to call this tree. And instead of log, Control Z, I'm going to call this tree. And what do I need to pass here? Yes, false positive rate, true positive rate. For logistic regression, I'm crossing the ROC curve. Any confusion in this part? What error is it giving me? Give me 1 second. Let's see. For input variables with consistent number of samples. Give me 1 second. I think I've changed something. FPR, DPR, ypred log, ypred tree. Did I have ypred tree? I had ypred tree, right? Tree.predict x test. Oh, tree.predict log reg.predict x test. Tree.predict x test. I have that. No problem. What seems to be the error? The error seems to be generating from FPR, this thing. Okay, hold on. Give me 1 second. Ah, okay. Right. Wrote it right. I did, right? Give me 1 second. I'm getting the same error. FPR, PPR, thresholds log, ROC curve of ypred log. Hold on. Let me just check the syntax, okay? ROC curve, sklearn. Yeah. Sometimes what happens is when I'm basically trying to print the values like this, I have to sort of be very validated with if the results have been coming out right or not. Maybe sometimes I have issues with it. So y true, which is y label, right? I've passed in the y label properly. Y pred is correct. I'm so sorry. Do you see the mistake that I did here? It's y test, which is the y true. And I already have a y score. So yeah, that happens. Oh my God. Yeah. Give me 1 second. Let's see. You have pause label as none and sample weight and drop intermediate. Acha nahi. Haan, ji, we don't need that, right? We don't need that since it's a very simple. Hold on. Metrics.roc curve and y and scores and pause label equals to 3. We don't need pause label for that. Yeah. Y test, Y pred. है ना? Y test, Y pred. Y true with the Y score value. I got that right. ROC curve for that. Okay, cool. Got it. Yeah, I know. Because I usually have the habit of saying Y pred, so I passed in Y pred twice, not knowing Y pred log is the Y pred. So that happens, right? So plot dot plot. How do I plot a diagonal curve? 0, 1, 0, 1, and then you have an R dash, like a dash line. Or you can change it later on if you want to. I'll show you how you can actually do it. Plot dot plot. What is the first plot that I want to do? FPR log, comma, TPR log, right? Like true positive, comma, false positive rate log. What do you pass inside it? You pass label. What is this algorithm that I'm passing through? Logistic regression, right? So logistic regression. What is the next data that I've taken? Plot dot plot. What do I pass inside this? FPR underscore tree, TPR underscore tree. What do I pass inside it? Sorry, LABEL, right? Label. Yeah, LABEL. Label equals to decision tree. And we will do legend and we will do X and Y axis later. No problem. What am I doing here? You guys understand? What do we do properly here is plot dot X label. Okay. Pass in plot dot Y label. Plot dot Y label. And what I'm going to pass in on Y label. And I will also do legend because legends are important, right? Because I have already passed in the level. I'll say location equals to upper or lower. I think let's keep it best. Okay, location equals to do. I don't need to do plot dot show because you just don't have to worry about it. Let's also take a title. Plot dot title. What title do we take? This is AUC ROC curve for what algorithm I have taken? Logreg and decision tree. Okay. X label. What comes on your X label? The false positive rate, right? And this is the true positive rate. ठीक है? अब हम इसको पूरा ही ले लेते हैं जैसे तो copy, paste, and apart from false, true positive rate. If I run this, which algorithm would you prefer for the output? Which algorithm is giving you much considerably better results in terms of accuracy in F1? So tell me one thing. For now, I have taught you how to implement only two algorithms, correct? Eventually, when I start teaching you 5, 6 algorithms, can you implement even 10 algorithms together, map them together and choose the best? My people, what I've taught you today is a practical way of doing things in your career, in your professional career. This is how you solve a problem. When you sit in a company, your company is going to give you data. This is how you run the test. This is how you actually implement the algorithm. Are you clear? I've just shown you guys a simple example, but I hope you got the concept of what I meant. Okay. See, मैंने आपको क्या क्या implement करके दिखाया. We have done implementation of logistic regression. So, we basically did logistic regression, correct? We did linear regression. We did in classification. We've also done decision trees, like specifically decision trees. What we've done. Okay.
Guys, I have a special announcement for all of you. For all of you dedicated individuals who are looking forward to master data science, we are offering a straightforward 20% discount on our data science course, which is in collaboration with iHub IIT Roorkee. So do make sure to check the link given in the description and fill the inquiry form. Shortly, our team of course advisors will get in touch with you to activate the offer. Don't miss this chance and take your career to the next level. Click on the link given in the description right now.
Let's get started with the first algorithm in clustering. Now we know what clustering is. So let's understand different algorithms in clustering. One of the algorithms is k-means clustering. K-means clustering. Okay. What did I tell you? Whenever you think about clustering, think about similarity. Right? Think about similarity. And specifically, when you think about similarity, machine uses distances to say whether the item is similar or it is dissimilar. How does it do that? How does it do that? If distances between 2 points, 2 data points or 2 items are very, very small, then they are said to be similar. Okay. If distances between 2 points or 2 items is very, very high, then these items or these data points are said to be different or dissimilar. Okay. That is how machine looks at it. That is how machine looks at this. And in k-means clustering, majority of the times we will be looking at Euclidean distances. We'll be looking at Euclidean distances. I'll come to that. What is, Euclidean distance? You must have studied this in really 7th, 8th, 9th mathematics, but we'll revise it. We'll quickly revise it. Okay. And what does this means in k-means word means? There's so many means there, but it is nothing but it is mean or an average. It denotes average. Very simple. Okay. This k, it denotes number of clusters. It denotes the number of clusters. If you have 3 clusters, k will be 3. If you have 10 clusters, k will be equal to 10. Okay. What is Euclidean distance? Let's understand this. What is Euclidean distance? Let's understand this. If there is a coordinate system, okay, this is your y-axis, this is your x-axis, and there are 2 points. Let's say this is A and this is B. This is A and this is B. Okay. And the coordinates of A are x1, y1. Coordinates of B are x2, y2. Right? What Euclidean distance is? Euclidean distance is the shortest distance between A and B. This is the shortest distance between A and B. Right? There are other distances also. You can calculate the distance to be move in the direction of y-axis first and move in the direction of b-axis or x-axis. You will reach there. Right? You will reach there. That is also a distance if you add this and this. But Euclidean distance is this blue line. Euclidean distance is this blue line. By the way, if you calculate this distance, red one, it is called Manhattan distance. There are different distances also, but we are 99% of the times we are going to use Euclidean distances. So let's understand what is Euclidean distance for A and B. Between A and B, it is going to be x1 minus x2 square plus y1 minus y2 square. Everyone remembers this now? Yes. This is the same Euclidean distance. That's how you will calculate the Euclidean distance. Okay. Now there are different distances. There is Canberra distance, Manhattan distance, okay? There is Mahalanobis distance, Euclidean distance. There are different formulas, but majority of the times you will be using Euclidean distances, okay? Majority of the times. Now, with that out of the way, what we are going to look at, is working of k-means. How is k-mean going to work? With our own hands, manually, and then in during hands-on, you will apply this in real world. By now, you must have already got the idea that in Python, when you're implementing the algorithm, it is hardly one line or two line of code, right? Importing whatever algorithm that you want to, right? Logistic regression, if you want to do logistic, linear regression, import that if you're implementing linear regression. And rest of the steps are same. You first have to do fit, transform, and then predict, right? So, but what is happening behind that one line is really important. How the algorithm is working is really important. So we are going to look at how the k-means will work actually. Okay, we wanted to look at the working of k-means. Okay, now before you are able to implement k-means, the k-means, you have to provide the value of k. This you have to provide at the start. You should know how many clusters you're going to make. This is one key caveat of k-means clustering. Okay. For now, imagine you know the number of clusters. You know the value of k, the optimal value of k. For now, assume that. Okay. We are going to look at it, how to find it, what is the best value of k. But before we go there, I want you guys to trust me and say that, okay, we are able to somehow find the value of k. And I am going to plot this data on one dimension data. This is one dimensional data or example. What do you mean by this? This scale that you're seeing, is the feature. Let's assume this scale is, or this feature, or this one dimension is distance. Okay, all these are the same thing. And we have data points denoted by these balls. 1, 2, 3, 4. And we have this on the scale. We have another few balls on the scale. Okay, cool. Now, can you tell me how many clusters are here? Visually, you and me as humans. 3. K is equals to 3. We have k is equals to 3. For all those who are still figuring out, this is the first cluster, this is the second cluster, and this is the third cluster. That is what we want. That is what it looks like also. Right? Why? Because the distances between these four balls is very small. So they are similar. Distance between these four balls and these three balls is high. So they are separate. They are different. Remember, what did I tell you? If distances are small, they are similar. And when they are similar in clustering, you will group them together. When the distances are high, they are different. If they're different, you want them to be in different clusters, in separate clusters. That is how you're finding 3 clusters here. Okay. Let me copy this. We'll be using this a lot. Okay. Now, let's start with our k-means algorithm. What is the first step? what is the first step? First step is to randomly select the centers, or more formally they are called centroids of the clusters. For all those who don't or have forgot what a centroid is, if you have a shape, centroid is the center of gravity or the center point. Okay, this is nothing but your centroid. It is also called center of gravity. Okay, you can also say center for your understanding. Okay, so now we had our data like this. Let me get rid of these things. This is also not required, at least now. Okay, cool. These were the 10 balls that we had. We are going to randomly select the centers. Let's say I'm going to say this is going to be the center or centroid of my first cluster. This is going to be the center of my or centroid of my second cluster. And this is going to be randomly, I'm selecting, this is going to be the center of my third cluster. Okay, that's the first step. Second step, what is step 2? What is step 2? Step 2 is calculate the distance of each ball from each centroid. Okay, till now we don't know whether this is the first cluster. We are trying to understand how will machine do it. Visually, you and me as humans, we can look at this and say, "Arey yaar, this should belong to the same cluster, this to the second and this to the third." But how is the machine going to learn? How is going to machine do it? What is the algorithm k-means? How will it say? That is what we are trying to replicate. And we started with a plain slate with all the data points in the space or in this dimension. And we are trying to identify how will machine come up with clusters. Okay. So this is the step 2. First is randomly select the centroids. Second is calculate the distance of each ball from each centroid. Let me copy this. The algorithm, so the second step is, let's do this for the first ball for simplicity. Let's do this for the first ball first. Okay. What is the distance of this first ball from the first centroid or the first cluster? This is the distance. Yes. Yes. Yeah, no units. We are not defining units, but visually. This is going to be the distance from the second centroid, from the red centroid. And this is going to be the distance from the blue centroid of the first ball only. Right? Right? Okay. Okay. Then in the algorithm, what is the third step? What is the third step? The third step is assign the cluster based on shortest distance. Okay, it says assign the cluster based on shortest distance. Now, out of this, which is the shortest distance? Yellow, right? Yellow is the shortest distance. So we are going to assign this ball also and we are going to say group it together or cluster it together with the yellow cluster. Yes. Then there is the fourth step also. There is step 4 also in the algorithm. What is that? What is that? That is update the centroids or centers of the cluster. And how are you going to do that? You are going to do that using mean. Remember, in k-means there was this word called mean. This is where it is going to use. What do I mean by updating the clusters? What do I mean by updating the clusters? Is that, can I say this is the centroid? This is the centroid of yellow cluster. This is the centroid of the red cluster. And this is the centroid of blue cluster. Now, before assigning, this was also the case. But after assigning, do you feel the cluster of the red, the centroid of the yellow cluster is correct? It shouldn't be here, right? It should be somewhere in the center of these two. For red, it will still be the same. For blue, it will still be the same. How are you going to update your clusters? You're going to take the mean distance between these 2 points in the cluster. The average distance between these 2 points. That is your centroid. Average between centroids. These 2 data points, now it is not average distance between centroids. This is one cluster, right? This is starting to form one cluster. This is one cluster as of now, and this is one cluster, right? And we are taking the center point of that, denoted with that C, that is centroid. Okay. Average between centroids. These 2 data points, now it is not average distance between centroids. This is one cluster, right? This is starting to form one cluster. This is one cluster as of now, and this is one cluster, right? And we are taking the center point of that, denoted with that C, that is centroid. If there is one ball, how do you take the mean? So if there is one ball only, the centroid is going to be the center of that ball, right? That's it. That is what you're seeing here in red and in blue. This is k-means. Let me show you a demo. K-means clustering. Yeah, here it is. Now stay with me. This is going to be super duper clear. How many clusters do you see here? 3, right? 3. Cool. Let me add centroids. This is randomly selecting a centroid. Randomly selecting second centroid. Randomly, I have added the third centroid. Random, right? What these lines visually, it is visually telling you that this centroid is closest to these points. This centroid, based on the Euclidean distance, is closest to these data points. And green, all these points on this green region are closest to green point, green centroid. Okay. What was the next step? Calculate the distances. First step was randomly select centroids. Second is calculate the distance of each ball from the centroid, which this region is already telling you. Third step was assign the points to the cluster. Go. All these points belong to blue. All these points which are closest to green centroid will belong to green. All these closest to red are going to belong to red. What was the fourth step? What was the fourth step? Update the centroids. Update centroids. You saw what happened? Blue came to be average distance between what it was updated as blue. Green shifted from here to here. Red also shifted from here to here. Then keep on repeating. Based on the shortest distance, you see the regions have also changed now. Based on the shortest distance, assign the clusters. You see this green part has been now turned to blue. Update the centroids. You see, again it moved. Reassign, update, reassign, update, reassign, update, reassign, update. Is it changing? No, right? After some time, it has stopped changing. Why? Why? Because now this has formed your cluster, and this is the second cluster, this is the third cluster. But like the example that we saw earlier, is this the right solution? No, right? This is not the right solution. Let's do this again from the start. Add centroid, centroid. Okay, randomly selected. Go, assign, update the centroid, assign, update, assign, update, assign, update, assign, update. It has stopped moving. Now are you getting the right clusters? Right? Let's do this once again. Let's do this once again. Centroid, centroid. Assign, move, assign, move, assign, update, assign, update. Now again it has stopped moving. Why? Because all these points are closest to red, so your centroid will stop updating. All these points are closest to green. Your centroid will stop moving, and you're getting the solution again. Let's do this once again. 3 randomly selected centroids. Update, 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 update. See, I'm doing this multiple times. I'm just clicking it, but things are not moving. Right? That is how k-means work. That is how k-means work. Okay? That is how k-means work. Why didn't it work in the first example? That is what we looked at here. Random selection of centroids can affect your clusters. Can affect your clusters. So what k-means does is, what k-means does internally, it will run the clustering multiple times. It will run clustering multiple times. Let's say it will run, for example, 10 times. For example, if out of 10 times, you'll be getting 9 times, 8 times the same solution, like this one. So it will say this is the right solution. Probably 1 or 2 times you will get the wrong answer, but majority of the times you will get the right solution, even with the random selection. So that is how it works internally. And it will say this is your final outcome. Okay. Other thing, notice guys. Our first selection of random centroids only decide the outcome, right? Our first selection. So every time it is going to repeat. It is going to converge to a solution. Then second iteration, it is going to start from step 1. It is going to start with initiating random samples, random centroids again. Then again, it is going to find one solution. Then third iteration, it will again start with random centroids. It will keep on doing this. And it will say that, okay, majority of the time I'm getting this example, this answer, this solution. So this is your final solution. That is how k-means work and takes care of the random initialization. It will be different, but majority of the times it will be same. Majority of the times it will be same. How many times we have to repeat to get the correct output? That is taken care of by internally. Internally, it is taken care of. There is also a hyperparameter called iter in k-means. Let me show you. Max iteration. See, what is this max iter? Maximum number of iteration k-means algorithm of the k-means algorithm for a single run. Single run means when you're doing a single fit, how many times you want it to run. So by default, it will run 300 times. 300 times it will run. 300 times it will initiate random clusters, and 300 times it will find one solution. 300 different solutions, out of which majority of them will be same. Okay. And in it is also one thing that is different centroid seeds. Okay. This is also the same thing, what I'm trying to explain. Okay. So that is how it is going to work internally. First, let's understand that. What are the possible values of k possible with this? Okay. Let me call this. Let me give a name to each of the ball. Let's say it is A, B, C, D, E, F, G, H, I, J. Okay. Okay. Can you tell me what is the minimum value of k? How many minimum number of clusters are possible? Minimum number of clusters. It is right or wrong, that is a different story. But minimum number of clusters. Okay, let me show you. Can I say I can club them all together in one cluster? That is right or wrong, a different story. But isn't this the minimum value of k possible? Right? So k is equals to 1 is the minimum. Right? Now similarly, can you tell me what is the maximum value of k? Now you've got the concept. Is 10? Why? What does it mean? Listen to my sentence really carefully. I can say that each data point is its own cluster. This is its own cluster. This is its own cluster, and so on. Can I say that? Each data point is its own cluster. That is wrong, right? A different story. That is possible. Here, what was the minimum value of k means? Minimum number of clusters possible is 1, where you're clubbing all of them together in one cluster. Here, maximum value of k possible is k is equals to 10, which is max. How 10? Because you have 10 balls. How 10? Because you have 10 balls. So can we generalize this? Can we generalize this? If you have n data points, in your data, can I say, okay, let me ask this. What can I say? What are the minimum number of clusters that are possible? Minimum number of clusters possible. Minimum is always going to be 1. Right? What is the maximum number of clusters that are possible. When you have n data points. So now you know, when you're looking for the optimal value of k, it should be between 1 and n. It should be between 1 and n. That should be the optimal value of k. How to find the optimal value of k? But these are the possible values that number of clusters or k can take. If k is equals to 10, then it means there is no cluster because all are different. There is no, you will not say it. Better way to say it is, rather than saying no cluster, say that each data point is its own cluster. Each data point is its own cluster. Say it like that. In reality, even with this data set, we know the right value is 3. The optimal or the correct value of k is 3. But we can still get 10. We can still get 10. Okay. How to come to that decision of 3, we will look at. But never say that no cluster. Say that each data point is its own cluster. That is the right way of saying it. Each data point is its own cluster. Say it like that. In reality, even with this data set, we know the right value is 3. The optimal or the correct value of k is 3. But we can still get 10. We can still get 10. Okay. How to come to that decision of 3, we will look at. But never say that no cluster. Say that each data point is its own cluster. That is the right way of saying it. I told you guys, didn't I tell you that majority of the things, okay, in clustering is somehow related to distances? Yes, there is a terms and conditions here. There are 1 or 2 things that are not related to distances, which I will tell you. And this is called cluster profiling. Okay. Right. Majority things in clustering are related to distances. Right. Before we go and understand how to find the right value of k, we need to understand one concept called WCSS. This is nothing but within cluster sum of squares is the short form for that. Okay. It is also called inertia. It is also called inertia. Okay. It is also called inertia. What WCSS is? What WCSS is? It is nothing but if I have my cluster like this, I'm just expanding the cluster. Okay. And okay. Okay. If these are the data points in my cluster, okay, this is the centroid, let's say. This is the centroid. Then what WCSS is? What WCSS is? You take the distance between each point from the centroid. Each point from the centroid. You can calculate this using Euclidean distance. Right? Right? Let's say this is D1, this is D2, this is D3, and so on. What you need to do is you need to square them and sum them all together. Square them and sum them all together. Okay. So this is your within cluster sum of squares. You have 2 data points here, this and this. Okay. Where these are your data points. These green color are your data points and red color is your centroid of that cluster. So when I tell you calculate or when I ask you, calculate the within cluster distance, WCSS for a cluster, will you be able to calculate? Will you be able to calculate for all the data points and sum them together? That is WCSS. Now, this is where we are going to connect what we studied here on generalizing, okay, for number of clusters that are possible. Let's say, let me draw one thing and then we will take it from there. Let's say I have my data points like this. Okay. If these are your data points, this is your data. Okay. How many clusters do you think they are possible? 3, right? 3 clusters are possible. We know it. We know it. Okay. We know it. Let us see how will the algorithm find it. Okay. Let us see how algorithm will find it, how the machine will find it. Let us see. So let's assume what was the minimum value of k possible? 1. Let's say if k is 1, if k is 1, what does that mean? What does that mean? It means, let me first copy this also because we will have to use this. K is equal to 1 means all this will be in one cluster, right? Right? Then what will be the WCSS of this? What will be the WCSS of this? WCSS would be, let's say, centroid will be somewhere here in the center of all three. WCSS will be sum of all these data points, summed, squared and summed together, right? Right? This will give me WCSS1 for case 1. Then what it's going to do is it is going to go to case 2 where k is equals to 2. Again the same data. When k is equals to 2, what do we mean? What do we mean? Yes, sum of squares. In case 2, we are going to have 2 clusters, right? Let's say these two belong to the same cluster and this belongs to the same cluster, right? Right? Then what is going to be your centroid here? This is going to be your centroid, and some centroid is in this cluster is going to be this. Again, do the same thing. Calculate the WCSS of this cluster. Calculate the WCSS of this cluster. Okay. And calculate the WCSS of this cluster. If the WCSS of this cluster is, let's say, WCSS A, and for this one it is WCSS B, what is going to be my WCSS 2 for the case when k is equals to 2? Not the mean, it is going to be the sum. It is going to be WCSS A plus WCSS B. Okay. If this is 100, for example, okay, and this is 20, then your WCSS will be 2 will be 100 plus 20. We are imitating how the algorithm will work and find the best value of k. Now, what is the next possible value of k? Case 3. K is equals to 3. If k is equals to 3, it's going to be this, right? These 3 clusters. What is going to be The next step, calculate the WCSS, right? If this is WCSSA, WCSSB, WCSSC, what is going to be my WCSS3? Let me give you. Let's say this is 30, this is 20, and this is 10. What is going to be my WCSS3? 60? Good. Good. Now, are you noticing one thing? Now, are you starting to understand where I'm going with this? Where I'm going with this? Look at this. Look at these white lines. What are these? These are distances, right? When your k is equals to 1, the white lines are very, very large. When you come to 2, the sum of these white lines is lesser than k is equals to 1. This and this. But they're still large. When you come to 3, these white distances or this WCSS is reducing. Right? Have you noticed that we are consistently getting WCSS 1, which is greater than WCSS 2, which is greater than WCSS 3? This is happening. So can't we use WCSS for calculating the right value of k? We can, right? If we calculate the WCSS for all the possible values of k, what will happen then? Do you see any flaw with this? I know WCSS is the right metric because I've already proved it to you, right? But there is one little problem with it. Can you see what that problem is? Just want to see if you are able to understand. So if k increases, decreases, WCSS because cluster gets smaller. Yes. Any problem with this that you've noticed? Case n. What is case n? When k is equals to n, we generalized it, right? Maximum number of clusters possible are when each data point is its own cluster. When that is going to happen, let me zoom this in. This is the centroid. This is the centroid. This is the centroid. Centroid. Because each of these data point is its own cluster, right? Right? That's what we said. This is its own cluster. This is its own cluster. This is its own cluster. So what is going to be the distance of this point from this center? 0, right? It is going to be 0. Distance of a point from itself is going to be 0. Similarly, all these points are going to be 0. Right? Right? So if you look at it, when k is equals to n, your WCSS n will be 0. So now in this equation, that becomes a problem. What we are saying is distance of this point from its centroid is going to be 0. That is WCSS for this cluster. This is also one cluster, no? This data point. Each data point is its own cluster. This is going to be 0. This is going to be 0. Right? If you sum all of them, what is your WCSSN? It is going to be sum of all the WCSS. Right? It is going to be sum of all individual. Sum of all the individual clusters, right? If all of them are 0, your sum is also going to be 0. So that becomes a problem. Then it says that your WCSS1 will always be maximum. WCSS2 will be smaller than it. WCSS3 will be smaller from it. And this will keep on reducing until you have reached n. If it will keep on decreasing, how will you find which is the best value of k? How will you find which is the best value of k? Because every time you increase the value of k, more number of clusters you have, the WCSS will go down. Right? Right? That is where elbow method comes into the picture. Elbow method comes into the picture. It is the same thing, guys. It is the same thing. What it will have is a curve, a graph. On your y-axis, it's going to have WCSS or inertia. Okay. On your x-axis, it is going to plot the number of value of k's. It is going to have value of k's. Let's say k is equal to 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, and so on. Okay. It is going to say that when I have one cluster, it is just plotting all these things that we calculated. It is just plotting on the graph. When I have k is equals to 1, my WCSS is, let's say, here. Okay. Then when my k is equals to 2, my WCSS is going to reduce. We saw that it will be somewhere here. Then when my k is equals to 3, my WCSS is going to further reduce. It's going to be here. Then 4, it is going to further reduce. 6, further reduce. 7, 8, 9. And it will plot it. It will plot it like this. Let's say all these points are on the line, okay? All these points are on the line. Now, this is what we have seen. The optimal value of k is this. Why? Because this is the elbow point. This is the elbow point. You see, when you increase the number of clusters from 3 to 4, the reduction in WCSS is very minimal, right? It is not worth it. It is not worth it. That is how you will say wherever I am getting the optimal value of k is that point where an elbow is being created in my graph, where an elbow point is being created in my graph. What is that elbow point? What is that elbow point? That elbow point is that point where if I increase my value of k, the reduction in WCSS that I see is not huge, is minimal, That is your elbow method. And that is how you will find the value of k. Let me show you. Let me show you. This image is clear, yes. Look at this. If my drawing is not clear, look at this. You see, the elbow is being created here. What do you have here? Values of k. What do you have here? Sum of square distances. That is nothing but within cluster sum of squares or inertia. And you keep on plotting. For my 1, when k is equals to 1, this was the WCSS that I got. For k is equals to 2, this was the WCSS that I got. Okay. For k is equals to 3, this is what I got. So you see, when you went from 1 to 2, what was the reduction? This was the reduction. When you went from 2 to 3, what was the reduction? This was the reduction in WCSS. But when you go from 3 to 4, what is the reduction? Very small. From 4 to 5, again, very small. 5 to 6, very small. After this point, the reduction in WCSS is becoming very, very small. It is not worth it. We know for a fact that our WCSS will keep on decreasing until it reaches 0. Okay, it will keep on decreasing until it reaches 0. But all those further reductions after a point, after the elbow point, is going to be very, very small. Let me give you the definition, not definition, but the formula also, just for completeness. Just for completeness. Do we still have to take couple of extra WCSS reading to find the elbow? Of course, of course, of course you will have to. What is the optimal value of K? What if the optimal value is greater than the WCSS? WCSS, what is WCSS ka formula? The formula is that you're taking distance between xi from Cj. Cj is nothing but the centroid. What are we doing in WCSS? We're calculating the distance of each data point. Xi is nothing but each data point from its centroid, right? And this we are going to repeat for all the clusters. So I'm putting a J. All the data points present in jth cluster get their distance from the centroid of the jth cluster. Square them, and sum this for all the points in that cluster where I is equals to 1 to n. If there are n data points in that cluster, in jth cluster, sum all of them and sum for all the clusters from j is equals to 1 to k. Let me not put k, you guys will get confused. Let me put n. Okay. Tell you what is this. This is nothing but distance square. This is distance square. What is the C? Cj is centroid of jth cluster. What is xij? Xij is ith data point in jth cluster. What is this m? M is number of clusters. That is what we did here, right? I have just summarized this. WCSS of A plus WCSS of B. If this J is equals to 1 here, J is equals to 2 here. Okay. And how are you getting WCSS A and WCSS B? By taking the sum of each xi from the Cj. That is what this formula is. That is what this formula is. Let me also bring it from here. Okay. Is the same thing. Distance from each cluster, from each centroid, sum it for all the centroids, for all the clusters, for all the data points, and for all the clusters. One thing you need to know what the concept is. What is WCSS as a concept? This formula is not important to remember, but is very intuitive. It looks big one, but it is intuitive. Now, in K means, you have elbow method, okay, to find the best value of K. Sometimes there might be a tie. There might be a tie between multiple values of k. Then you need other methods as well. You need other methods as well. One such method is Dunn's index. Let's say there are two clusters. Okay. And let me take this also. Okay. If these are the two clusters, can I say that I'm just changing because the color contrast will not make sense. Can I say for this point, each point from distance from its own cluster ka point, can I calculate this? Can I calculate all of this for each point? Can I call this as intra distance within the cluster? Can I call this as the intra distance, intra cluster? Similarly, I can also find the distance of this point from the points in the other cluster. I can calculate this also. Yes. And can I say this is the inter-cluster distance? Without the centroid, yes. Each data point. This is the blue point here. This is your intra distance. This is your inter distance. Okay. What Dunn's index says is it is an index. It is an index which is ratio of minimum. Let me color code this. Interdistance. Minimum interdistance divided by maximum intra cluster. This is what Dunn's index is. Very simple. What is it saying? It is trying to find whether your clustering is right or wrong. How? This intra distance is going to tell you whether your cluster is tight enough. All the data points which are within the cluster, they are very close to each other. They're very similar. If they're very similar, their intra distance will be small, right? And it is also checking, this one is also checking that the different data points or the different clusters, they should be far off from each other. So the inter distance should be very, very high. Okay. So what Dunn's index is saying is the minimum inter cluster distance divided by the maximum intra cluster distance. That is your Dunn's index. And higher the Dunn's index, better is your clustering. This is Dunn's index. And there is no range as such. It can take any value. All you want is, you want your intra distance to be very, very small. right? And you want your inter distance to be very, very high, right? If you are able to achieve this, then you say that in your clustering, you have very tight clusters and these clusters are well separated. These clusters are well separated. These, along with elbow, these methods can be used to find whether your clustering is right or wrong, or is it better? Because since you're dealing with what unsupervised learning, so this happens. Okay, these methods will help you to be much more confident about your clustering. Coming next, the other method, there is one more method which is called Silhouette score. What is this Silhouette score? This Silhouette score will tell you whether your clustering, your clusters are well separated or not. Are your clusters, are they well separated? It is going to give you that. It is going to give you the indication around that. Okay. Let me take the same thing here. Again, there are these 2 points. Again, these are 2 points. Okay. Here you have these 2 clusters. Okay. Which has these data points. Then you also have the other cluster, which is having these data points. What you're going to do is, you are going to calculate the distance of each point from each point in its own cluster, okay, and take the average of it. Take the average of all these distances. Let's call it A. Within its own cluster. Let's call it A. Okay. Then what you will do is you will take the distance of the point from the nearest cluster. Take all the distances. Okay. Take all the distances of one cluster to the other nearest cluster. Take the average of it. Let's call it B. Calculate all the distances and take the average of it. That is B. If this is there, then Silhouette score is nothing but, Silhouette score can be defined as B minus A divided by max of B comma A. Okay. This is what your Silhouette score is going to be. Where A is the average distance of xi from all the data points. This is a guaranteed question in your interviews. Yes, it has to be done for each point. What Silhouette score is going to give you? Silhouette score is going to give you how well separated your clusters are. Okay. For each data point, calculate the distance from the other points in the cluster. Take the average of that distance. Okay. Similarly, take the distance between a point with all the other points in the nearest cluster. That is the key thing. This orange line is the distance of this point with all the other points with the nearest cluster. Okay. Calculate all of this for all points. Okay. Calculate it for all the points. Take the average. That is given as B. If that is given as B, then your Silhouette score is nothing but B minus A, maximum of B comma A, where A is the average distance of Xi from all the data points in its own cluster, and B is the average distance. B is the average distance of Xi from all the data points from the nearest cluster. Okay. Can we take any point randomly within? You will have to do this for all the points. Okay. Can you give an example? It is a metric. An example cannot be given per se. This is the best way to explain this. Okay. With visually. Suppose I have 5 points in one cluster, 7 in the other. How to calculate the Silhouette score? Calculate the average of all those 5 points within the cluster and take the average of it, and then calculate the average distance between of these 5 points with all the 7 points in the other cluster. You will get B and take the average of that. This is A, that is B, and then you'll be able to get it. B and A means, see, this is why I'm saying I have entirely explained this. Is you are not focusing here. A and B is given here. A and B have been drawn here. The value, what the value? Is the average. Take all the distances, take the average. That average is A. Take all the distances, take the average. That average is B. And then this formula is for Silhouette score. You took 2 points, nearest is 1 point only. Nearest cluster. And this you have to do for all the points. That is why I've shown that you need to do this for all the points. You will get 3 values from Silhouette score. Look at this. If B, what do you want here? You want here B to be as high as possible and A to be as small as possible. So higher the value, you want the numerator to be maximum. You want the numerator to be high. So higher the value, better it is. You will generally get values of +1, 0, and -1. Okay. You will get +1, 0, and -1. When will you get +1? When, of course, B is very, 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 very large compared to A, right? What is going to be maximum in that case? Maximum again is going to be B, right? Between B and A. So it will tell you that it is well separated. So if you get a value of closer to 1, then your clustering is good. Okay. When will you get a -1 or a number or a Silhouette score which is closer to -1? You will get closer to -1 when A is very, very high compared to B. That is why this will become negative. And in maximum also you will get A. Then -A divided by -A will be close to -1. because some quantity is being subtracted also. What does that mean? It means that the intra distance, that this internal distance is much higher than the distance between the clusters. So in that case, your clustering is poor. Your clustering is poor. Okay. When it is zero, when it is close to zero, it can also be zero, right? When can it be zero? When B and A are almost same. In this case, you can have zero when these are two clusters, or when there is an overlap. This can also be possible. Yes, exact zero means it is the same. Not same, not exactly same, because these magnitudes can still be exactly the same. Okay, so when it is around zero, then you're having overlapping. So this is how you will decide for Silhouette score. Okay, now how are you going to use this? Priority. There are so many methods, right? First priority to find the value of k or to see whether your clustering is good is given to elbow method. Always give priority to elbow method. Okay. Second, with Silhouette score. Second priority is given to Silhouette score. Third priority is given to Dunn's index. 90% of the cases, you won't need to go to Silhouette score also. Only using elbow method, you'll be able to decide, okay, this is my good clustering. This is the right value of k. Let me give you an example here. But sometimes you will have a doubt, you will have confusion between multiple values of k. You will have some confusion between multiple values of k. Then you can go to Silhouette score. In very rare chances, there might be a case that both elbow method and Silhouette score, you are still confused. Which is the right value of k? Then you go to Dunn's index. Okay. Let's talk about example. Let's say in elbow method, you are confused between 4, 5, and 6. These are the values of k. You're confused between, okay, where is the elbow coming in? Probably 4 is the right value, 5 is the right value, or 6 is the right value. Probably you're seeing the curve like that. Okay. So you're confused between 4, 5, and 6. What should be the right number of clusters? Then you go and implement Silhouette score. Look at the values of Silhouette score. Okay. Out of 4, 5, 6, the one which is closest to 1, out of these three values of k, the one which is closest to +1 is giving you the right clustering, because over there your clusters are also well separated. Okay. But somehow in a rare case, even with Silhouette method, you are confused between two values of k, 5 as well as 6. Then go to Dunn's index. You'll be able to find what is the right value of k. You'll be able to break the tie. Okay. What have we understood? This is what is k-means algorithm, by the way. K-means algorithm is complete. And how are you going to evaluate your algorithm or your clustering? That is also complete. So what we've learned is k-means. What this meant average or mean while calculating or updating your centroids. You use the mean distance. What if rather than using mean, I updated using median? Who is stopping me? No one is stopping me. If you use median to update your centroids, then that algorithm is called k-median algorithm. Rest everything is same as k-means. If to update your centroids, you use mode, then that algorithm is called k-mode. K-mode algorithm. So with one algorithm, just changing that metric, you're getting a variance. You're getting variants, right? You're getting different variants. In k-median, right? In k-median, instead of Euclidean distance, because you're using medians, right? Instead of using Euclidean distance, you use Manhattan distance. K-mode, when are you going to use K-mode? It is more suitable for categorical data. Okay? All the centroids are initialized randomly. Do you remember? Right? All of them were initialized randomly. In industry, for some time now, instead of using, because of this, we were seeing what? We were seeing that it had to run multiple times, and probably the solution were also, sometimes coming out to be wrong. Out of 10 times, you will get one time which is wrong, because randomly initialized centroids were giving a different convergence. In industry, there is an improvement of k-means. It is called k-means plus plus. This plus plus is nothing but denoting the improvement. The name is like that. Okay. Here, in k-means plus plus, what is the improvement over k-means? Is that only one centroid is initialized randomly. Rest all of the other centroids can be calculated based on distance and initiated. For example, in k-means, if these are your two clusters, okay, if these are your two clusters in k-means, what it will do? What will it do? It will randomly initiate a centroid here and a random centroid here. This is also going to be initiated randomly, and this one is also going to be initiated randomly. In k-means plus plus, on the other hand, if you have the same clustering, you have the same data, it will initialize this one randomly. I agree, just one. But the next one is going to be initiated in such a manner that it is far off from this first centroid and is towards the data. You can do this. Where you have more of data, initialize it there. Why initialize it somewhere else randomly? You initialize first here, then when you want to initiate the second centroid, calculate the distance of all the points which are closer to the data and initialize, pick one of those points as your centroid. So this is initialized but not randomly. That is what is k-means plus plus. Rest everything, whatever we have studied in k-means, is exactly the same.
Guys, I have a special announcement for all of you. For all of you dedicated individuals who are looking forward to master data science, we are offering a straightforward 20% discount on our data science course, which is in collaboration with iHub IIT Roorkee. So do make sure to check the link given in the description and fill the inquiry form. Shortly, our team of course advisors will get in touch with you to activate the offer. Don't miss this chance and take your career to the next level. Click on the link given in the description right now.
So moving on with our first question. Explain the types of data science problems along with the datasets used for each problem. Data science problems can be grouped based on what we are trying to solve. For example, one common type is classification problems like fraud detection. Here the goal is to categorize data into classes such as fraudulent or non-fraudulent. The datasets here are usually highly imbalanced, meaning there are far more non-fraud cases than frauds. Sometimes these datasets can even have a time series structure. Another type is regression. This is where we predict a continuous value. For example, predicting house prices. Datasets here might have features like the number of bedrooms, location, and property size, and the target variable would be the price feature. Then there is time series forecasting. This is used to predict future values based on historical data. A common example is stock price prediction or sales forecasting. Another type is recommendation systems. This is where we suggest items like movies, products, or songs. The data sets often include user preferences, item characteristics, and sometimes behavior logs like clicks or purchase history. Lastly, we have clustering problems like customer segmentation. Here we group similar entities based on features like age, income, or spending habits. These datasets don't have labels, so we look for patterns. Each type of problem has its unique dataset structure and challenges, but it's all about understanding the data and the problem we're solving. Moving on to the second question. What are the common issues in raw datasets that require cleaning? One common issue in raw datasets is missing values. Some rows or columns might be incomplete. For example, in a dataset of customer records, you might not have some records in the contact number feature column. This can be solved by the following methods. For numerical columns, we can fill them with the mean where there are no outliers, whereas median in case of outliers. And for categorical data, we can fill with the mode. Another issue is duplicates. This is where the same data point appears multiple times. This often leads to skewed analysis. The duplicate function can be used to identify the duplicates. There could also be outliers in the data, like a few incomes could be way too high or way too low compared to the rest. This would again lead to inaccurate prediction. You can use scaling methods like standardization or normalization to deal with outliers. I have a separate video on standardization versus normalization. You can check it out in the description. Inconsistent formatting is another big one, like dates in different formats or text fields with varying capitalization. And then there's incorrect data where entries are just wrong. So say for example, a negative value in a column for age. All the above issues can be taken care of at the data cleaning stage itself. The data needs to be accurate, consistent, and reliable for analysis. Moving on to the third question. What are the different learning mechanisms in data science? So there are four main types: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In supervised learning, the model is trained on labeled data, meaning we already know the outcome. It's like teaching a child with examples. So say in email spam detection, we know which emails are spam, so the model learns from those examples. Next is unsupervised learning. This is where we have data but no labels. The model tries to find patterns or groupings by itself. A good example is customer segmentation, where the algorithm groups customers based on their purchasing behavior without knowing what each group represents. And then there is something known as semi-supervised. This is a mix of both. There will be a small amount of labeled data and a large amount of unlabeled data. The model uses the labeled data to learn and then generalizes to the unlabeled data. It's useful when labeling data is costly. Finally, we have reinforcement learning. Here the model makes decisions and gets feedback in the form of rewards or penalties. It's commonly used in gaming or robotics, where the model has to learn to improve its actions through trial and error. Moving on to the fourth question. Why is standard deviation often preferred over variance when analyzing data? Both variance and standard deviation measure how spread out the data is. But the key difference is that variance is in squared units, while standard deviation is in the same units as the original data. Let's say we're looking at the test scores of a class of students measured on a scale from 0 to 100. If we calculate the variance, it would give us the number in the units of squared points, say something like 25,000. Now this is not easy to relate to the actual scores. However, when we calculate standard deviation, it's in the same units as the original data. In this case, just points. So if the standard deviation is 50, it's much clearer because we can directly understand it as the spread of scores around the average score. Standard deviation just makes it easier to relate to real world values. Moving on to the fifth question. What is overfitting and underfitting, and explain how you can detect if your model is overfitting or underfitting. So overfitting happens when the model learns the training data too well, even the noise and the random fluctuations. It performs great on the training set but struggles with new unseen data because it's too specific to the training data. It's like memorizing answers to a practice test without truly understanding the material. On the other hand, underfitting happens when the model is too simple to capture the patterns in the data. It fails to perform well on both the training set and the test set. It's like studying just the basics and missing out on the important details. In order to detect underfitting or overfitting in your model, you need to look at performance metrics like accuracy or error rates and compare them between the training and the test sets. To deal with overfitting, you can either reduce the number of features or use techniques like regularization or cross-validation. Whereas for underfitting, you would want to make the model more complex. This might involve adding more features and increasing the model's capacity. Moving on to the sixth question. Explain the concept of regularization in machine learning and why is it important for improving model performance. Regularization is used to prevent overfitting by adding a penalty to the model for being too complex. Essentially, it discourages the model from relying too much on specific features or learning noise in the data. There are two types of regularization techniques. First is L1 regularization or lasso regularization. It adds a penalty based on the size of the model's coefficients, making some of them shrink to zero. This way, it automatically selects only the most important features and ignores the rest. For example, in house price prediction, if the number of garage doors has little impact, L1 regularization might set its weight to zero and exclude it from the model. The next one is L2 regularization or ridge regularization. It adds a penalty based on the square of the coefficients. This reduces their size but doesn't make them zero, so all features are kept but none dominate too much. For example, in predicting house prices, if the area feature has a large impact but the number of rooms has a smaller impact, L2 regularization will ensure that both are considered while preventing the area feature from overpowering the model. Regularization is important because it helps the model generalize better to unseen data by controlling complexity and preventing overfitting. Moving on to the seventh question. If a model performs well on training data but poorly on unseen data, what technique could you use to understand its generalization ability? This is a classic case of overfitting. To understand the model's generalization ability, we can use cross-validation. With cross-validation, we will split the data into multiple smaller sets or folds. The model is trained on some folds and tested on the others. This process is repeated multiple times and we average the results to see how the model performs across different subsets of data. It's a great way to check if the model is consistently good across various splits or if it's just memorizing the training data. Moving on to the next question. What is the role of activation functions in machine learning models like linear regression and logistic regression? Activation functions are used to introduce non-linearity into a model, which allows the model to learn complex patterns in the data. In linear regression, there's actually no activation function because the output is simply a linear combination of input features. It's used for predicting continuous values. In logistic regression, however, we use the sigmoid activation function, which squashes the output between 0 and 1, making it suitable for binary classification problems like predicting the yes or no outcomes. So the main role of activation function is to help the model make more accurate predictions by capturing complex relationships in the data. Moving on to the next question, what is the confusion matrix, and describe a situation where false positive is more important than false negative and vice versa. A confusion matrix is a tool that is used to evaluate the performance of a classification model. It shows how well the model's predictions match the actual outcomes by displaying the number of correct and incorrect predictions. It's basically a table with 4 values. One is true positive. These are the correctly predicted positive cases. Then there are true negatives. These are the correctly predicted negative cases. Third is the false positives. These are the incorrectly predicted values as positive, also known as type 1 error. Lastly, we have false negatives. They are incorrectly predicted values as negative, also known as type 2 error. From these values, we can calculate other performance metrics like accuracy, precision, recall, and F1 score, which give a clearer idea of how well our model is performing. False positives are more important than false negatives in cases like a medical test for a rare disease. A false positive that is incorrectly saying someone has a disease might lead to unnecessary tests, but it's safer because it ensures we do not miss any actual cases. Whereas for a spam filter, a false negative, which is a spam email getting through, is less risky because you can always delete it. But a false positive, where important emails are marked as spam, could cause you to miss important messages. Moving on to the 10th question, why do we prefer a decision tree over a random forest? A decision tree is a simple model that splits data into branches based on features, making decisions based on these splits. It's easy to understand and visualize and works well for smaller, less complex problems where interpretability is key. A random forest, on the other hand, is a collection of multiple decision trees where each tree is trained on a random subset of the data. It combines the results from all these trees, which usually gives better accuracy and reduces overfitting. You'd prefer a decision tree over a random forest when you need a simple, interpretable model or when computational resources are limited. But if you need better accuracy and robustness, especially for complex datasets, random forests are the better choice. Moving on to the 11th question, what is naive in naive Bayes theorem? Basically what we're trying to understand here is what does the term naive stand for in this naive Bayes theorem. So the word naive in naive Bayes basically refers to the assumption that all the features in a dataset are independent of each other. But if you consider real life scenarios or real life data sets, this assumption does not really apply. Why? Because say for example, you have a house price prediction data set. You will have feature columns like number of bedrooms, number of bathrooms, balcony, the area of the house and so on. Now in real life, if you consider the area and number of bedrooms, number of bathrooms, so are supposed to have some sort of correlation between each other. But what naive Bayes theorem does is, it is going to consider that these features are independent of each other, that is, they have zero correlation between each other. Now, this assumption will not apply in real life, but surprisingly, it works really well in many situations, especially for classification problems, right? So, naive Bayes has a major application in classification problems. Alright. So, naive Bayes basically calculates the class probabilities based on feature likelihoods, assuming no dependence between them. Clear? So, this is the formula for naive Bayes theorem. This is the posterior probability of the hypothesis. This is what the naive Bayes is trying to calculate. This is the likelihood probability, which basically is the estimated value for each feature, assuming that all the features are independent. Alright, so this is the assumed value. And then we have our hypothesis probability and our evidence probability. Alright, before we move to the next question, let me take you guys to my notebook and show you guys the implementation of naive Bayes. Alright, so the implementation in Python is very easy for any naive Bayes. So basically we have 4 types of naive Bayes theorems. First one is Gaussian naive Bayes. So this works well for continuous data. So the Gaussian naive Bayes basically calculates the mean and the variance, and then it goes for the probability. Then we have multinomial naive Bayes. So this works for the discrete data set. Like it is going to count the data and then it is going to go and calculate the probability. Then we have Bernoulli naive Bayes. This works for binary or Boolean features like yes, no, true, false. Then lastly, we have categorical naive Bayes. So the name itself suggests that it works for categorical data sets. So you can easily import your naive Bayes theorem, whichever one you want to apply from sklearn.naive Bayes, and then you have to call your function and simply train it using the fit method. Alright. So once that is done, you can go ahead and predict it, and this is what your output is going to look like. Alright. So basically this is how it has classified it as 0 and 1. So that is all about the naive Bayes theorem. Moving on with our 12th question. What is imbalanced data and how do we handle them? So I have already made a video on this particular topic and I have explained each and every concept in a lot of detail. So you guys can go ahead and check it out. But right now I'll just cover this concept in brief so that you guys get a basic idea. Alright. So Imbalanced data basically happens when one class in a data set has a lot more samples than the other. Now, what does that mean? So, consider this example over here. So, this is a balanced data set. Now, why is this a balanced data set? So, we have two classes over here, female and male. Let's call them A and B. Alright. Now, class A, that is female, has 51% of samples in a data set, whereas class B, which is male, has 49% of samples in the data set. Now, this is a pretty, you can say, balanced situation. Why? Because we have almost equal number of samples, right? 51% and 49% are not that far away. But if you consider this particular scenario, we have 98% of samples in class A, which is our normal, okay, so this imbalanced data is basically for the fraud detection data set. Okay, so we have a fraud detection data set where we have two classes, which is normal transactions and fraudulent transactions. Now, our normal transactions are obviously going to be in a higher ratio compared to a fraudulent transaction. So, we only have 2% of transactions which were fraud, which is our class B. Alright. So, the number of samples of class B is comparatively very less as class A, right? So, this is going to lead in poor performance in the minority class. Basically, our model is going to be biased towards the majority class, right? So, say for example, my model predicts not fraud or say normal each time. My model is going to be 98% accurate. Isn't that right? So now with a 98% accuracy, I can say my model is working pretty well. But the cases I am most interested in. Now, the entire purpose of training a model on fraud detection dataset is to detect the fraudulent transactions, right? But if my model is failing to do the one goal it was trained for, and it is giving me 98% accuracy, I can say my model is practically useless, right? So this is why we need to handle the imbalanced data sets using techniques like undersampling, oversampling, and lastly we have SMOT, right? So in undersampling, basically we take random samples from our majority class till they are equal in size with our minority class, right? So basically we are making our data smaller. So say we had 1000 samples over here in our majority class and 100 samples over here. Our final data set is going to contain 200 samples, right? We are randomly going to pick 100 samples from our majority class. Whereas in oversampling, if we have 1000 in our majority class and 100 in our minority class, we are going to keep duplicating these samples in our minority class until and unless they are equivalent to the size of our majority class. That is, initially we had 1100 samples. Now we are going to have 2000 samples in our entire data set, right? So this is how undersampling and oversampling works. Now over here in oversampling, we are simply duplicating the data randomly in our minority class, right? We are not exactly performing some sort of calculation. Now in our next technique, which is known as SMOT or synthetic minority oversampling technique, over here, instead of randomly duplicating the data, we are going to perform some sort of calculation using this particular formula, and we are going to create synthetic data points, and these data points have one rule, that is, they are always going to lie between the axis of two existing data points. Alright, so this is basically what SMOT does. So these are some of the techniques that you can use to handle your imbalanced data. Moving on to the 13th question, state the scenarios when the different tests can be used and also explain the p-test. So now the different tests that we have are z-test, t-test, f-test, chi-square test. Like these are some of the tests that we'll be covering in this particular question. So the first one is z-test. Now this is used for the large samples, generally greater than 30. So whenever we have more than 30 samples, we will be using z-test. Now keep this condition in mind. I'm sure some of you guys must be having a doubt regarding 30 samples. We'll be talking about this in a few minutes, but first let's cover all the tests, right? And your population standard deviation should be known. So say for example, you want to compare the average heights of two cities. So this is a scenario where you would preferably be using z-test. So this is the formula for finding the value of z-test. So you subtract your population mean from your sample mean and you divide it by your standard deviation divided by the total number of observations. Alright. Then the next one that we have is a t-test. This is used for small samples, preferably less than 30, and you don't know your population standard deviation. So say for example, you want to test a new teaching method, whether it improves your test scores in a class or it doesn't. Right? So this is the formula for your t-test. So the next one that we have is an f-test. This basically compares the variances of two data sets. So say for example, you want to check the variability in scores from two teaching methods. This is when you'll be using an f-test. So this is the formula. You divide your larger sample variance by your smaller sample variance, and then you can look up the f-test table to find the value. Then we have a chi-square test. This is used for categorical data to test relationships between your features. So say for example, you want to analyze whether genders impact the product preference, right? So for cases like that, you would be using a chi-square test. This is the formula for your chi-square test. C is your degree of freedom, O is your observed value, and E is your expected value. Alright. Then lastly, we have our p-value. Now the p-value is not particularly a test, rather it is used to determine whether the result of a statistical test is significant or not, right? So basically, a p-value is a decision rule that compares with alpha. Now, alpha is generally 0.05, right? This is the standard value of alpha. It could vary based on the problem, but in general, we keep it 0.05. Now, if our p-value is less than or equal to 0.05, we reject our null hypothesis. But if it is greater than 0.05, we fail to reject the null hypothesis. That is, we accept our null hypothesis. Alright, so say for example, we want to test a new drug, right, and its effects. So we'd be using a p-value in this case. Now before we go ahead, let me quickly take you to my Google Notebook. Alright, so we know the general rule of using a t-test and a z-test is whether a sample size is greater than 30 or less than 30. But if you take practical scenarios or real life scenarios, our data set usually has around 1000 samples. Right, whenever we go to train a model and we pick a data set, it is going to have at least 1000 samples. Now, out of those 1000 data points, if we try to take out only 30 samples, it does not make sense, right? Our data set is going to have at least 500 or 600 data points to be able to learn and have an accurate output, right? So, in a problem statement, whenever there is mean or average mentioned, we use a t-test. And whenever there is a percentage or proportion mentioned, we use a z-test. Clear? So theoretically, we take the 30 sample rule, but when it comes to practical scenarios, this is the condition that we follow. Alright? So let me quickly show you how it is implemented. So I am going to implement t-test. So this is my data set and I have taken a sample size of 1000. I have decided my new sample data. And what I'm going to do is I'm simply going to perform a one sample t-test. So I'm going to import my t-test from scipy.stats. I've declared my variables t-stat and p-value and I've passed my column purchase and I've given the sample size over here. And after performing that, I have got my p-value as 2.8. Right? Now this 2.8 is clearly greater than 0.05. This means we have to reject our null hypothesis. And over here, we have given a conclusion, that is whatever was our alternate hypothesis has become our conclusion now. Alright, so this is basically how we perform any test in Python using the libraries. So moving on to the 14th question, what are eigenvalues and eigenvectors and why are they important? So let me quickly explain a scenario where we have a data set which is in a 3D form. Alright, now if I want to make my model simple and understand the data better, my goal would be to transform this 3D data into a 2D data, while also being able to retain the maximum information out of this particular data. Now, in order to do that, I can compress my data from any one of these dimensions, either from my height, my width, or my breadth. But if my goal is to retain the maximum information, I'm definitely going to compress it from an angle that has the largest area. And if I feel this particular side is going to give me the maximum information out of my data, I'm going to compress my data set from this particular angle. So now what eigenvalues and eigenvectors are? Eigenvalues are basically going to tell me how much my data set has shrinked or stretched during my transformation, whereas my eigenvectors are going to define the direction from which my data sets have been shrinked or stretched, right? And the direction is always going to remain unchanged during that transformation. So I hope this is clear, and this is the basic formula that is used to calculate the eigenvector, which is represented with the x vector, and we have eigenvalue represented by lambda. Alright, so let's quickly look at the example. So we have a matrix denoted by A, which is 2, 0 and 0, 3. Now in order to calculate the eigenvalue, this is the formula that we'll be using. Alright, we need to calculate our matrix A minus lambda into I. Now I is the identity matrix and it is represented using this particular matrix. Alright, so now we know the determinant of this particular matrix is going to result to 0. Alright, now this is going to help us give the final values of the lambda. Alright, so now to calculate A minus lambda I, this is the kind of calculation we'll be performing. We've already multiplied lambda with our identity matrix and this is going to be the resultant matrix after multiplication. Right, so after subtraction, this is going to be our final matrix 2 minus lambda and 3 minus lambda. Once we equate it with 0, we get the values of lambda, which is 2 and 3. Alright, so we get two eigenvalues, which is 2 and 3. Now, in order to calculate the eigenvectors, we are simply going to multiply x with A minus lambda I. Alright, now we know the values of lambda, which is 2 and 3. So we are going to substitute these values in lambda, and once we do that, we're going to get a matrix like this, and after we multiply this matrix with x, our x value is going to be somewhat like this. Alright, so basically these are the steps that we follow in order to calculate the eigenvalues and eigenvectors. Alright, now why are they important in data science? So eigenvalues and eigenvectors are used for principal component analysis. Basically, they reduce the dimensions of large data and they're used to identify the important features using eigenvectors. Then they're used for graph analysis and stability analysis also. Alright. Moving on to the 15th question. How do you ensure that the sample chosen for a study truly represents the entire population? Now, in order to answer this particular question, first we need to understand what is sampling. So whenever we're conducting a study, it is not always going to be possible to include everyone in the population, right? So we're going to use sampling to study a smaller, more manageable group. So the first step is to define who or what you are studying. That is, we need to define the target population. So say for example, we want to know the opinions of college students for a particular study, right? So our target population is going to be only the college students, not their parents, not their siblings, right? So that is how we define the target population. The next step would be to choose the right sampling method. Now we have over here 4 different types of sampling methods. So the first one is simple random sampling. Over here, everyone in the population is going to have an equal chance of being selected, right? There is not going to be any particular bias towards any person. The next one is systematic sampling. So over here, every nth person or nth member from a list or sequence is going to be selected. So basically over here, we're going to apply some sort of algorithm or some sort of system that every third person that we meet or every third person that we interview is going to be part of our data set. Alright. Then what we have is a stratified sampling. Over here, we divide the population into groups, that is our strata, and take a random sample from each group. Alright. So say for example, I am interviewing college students. I'm going to divide the college students into groups, say depending on their streams, right? So maybe I make groups of computer science and MBA and other fields like that, right? So once I have divided the college students into groups, I'm randomly going to pick a student from each group. Alright, so this is what is known as stratified sampling. Then lastly, we have cluster sampling. Over here, we divide the population into clusters, randomly select the clusters and include all the members from those clusters. Alright, so over here I'm not going to select an individual from a group, rather I'm going to select the entire group randomly. Alright, so this is known as cluster sampling. So depending on our problem statement, we need to choose the right sampling method. Then third is to ensure sample size is adequate. What this means is larger samples are better because they reduce the likelihood of errors. So say for example, if we are polling 10 people to understand a city's preference, we are going to miss the diversity of opinions, right? A sample of 1000 is going to be much more reliable and much more adequate. So this is what ensuring the right sample size means. Then lastly, we need to avoid bias. Bias occurs when certain groups are favored over the others. So say for example, we only survey people from urban areas and we ignore the rural areas. So our result is going to be completely skewed, right? Obviously, the opinions of urban people are not going to match with the ones of the rural people. So this is basically how bias enters the sample. So we need to avoid bias in order to have a sample that truly represents the entire population. Alright, moving on to the 16th question. What is a gradient and gradient descent? So gradient basically measures the slope or rate of change of a function. Alright, this is the formula for gradient. Basically, we have a function and we have a gradient with respect to x and with respect to y. Basically, all the independent variables of a function. So we perform differentiation and we get the final value. Alright, so gradient basically points in the direction of the steepest increase. Alright, so if in this case we had our y value as say positive and x value also positive, then this gradient would be signifying that in whatever direction we are moving so far is the direction of the steepest increase. That is, we are going in the increasing direction, right? It is leading us to the maxima. Alright, but say in case one of these value was negative instead of positive, this particular value was negative. Now this would indicate that the direction that we are heading to is the opposite of the direction of our increase. That is, we are leading towards the minima. Alright, so basically gradient tells us how much the function is increasing or decreasing as we move in different directions. Alright, then we have gradient descent. Now this is a method to find the minimum of a function by moving in the opposite direction of the gradient. Now we already discussed gradient is going to lead us in the direction of maximum value. And now gradient descent is a method to find the minimum of a function. So obviously gradient descent is going to move in the opposite direction of the gradient. Alright, so say for example, this is our function. Alright, now in order to reach the minimum point which lies over here, what we are going to do is at every point we are going to calculate the gradient. Alright, now if the gradient is telling us that this particular direction is going to lead us to the minima and this particular direction is going to lead us towards the maxima, we are obviously going to move in the direction that is leading us towards the minima, right? And we are going to check that at each particular point until and unless we reach a point which is the global minima. Alright, so basically we are trying to reach towards the bottom of a value. Now this optimize the models by minimizing error. Alright, so this is basically what gradient and gradient descent means. Okay, moving on to the next question. Define confounding variables. Now, confounding variable is something that influences both the independent and the dependent variables. Alright, so confounding variables are often referred to as hidden variables, and they can make a relationship appear between an independent variable and a dependent variable even if there is none. Alright, so this is basically what confounding variables do. Now say for example, you're studying the relationship between exercise and weight loss. You find that people who exercise tend to lose more weight. But if you don't account for people's diet, it could be the diet causing the weight loss as well, right? And not just the exercise. So in this case, diet becomes our confounding variable. Alright, so this is basically how confounding variables work. Moving on to the next question, define bias variance trade-off. Alright, now in order to understand bias variance trade-off, we need to understand these terms separately. So bias is basically an error due to oversimplistic models that don't capture all patterns in the data. Alright, so this is an example of high bias in our data. So these are our data points, and since we have a high bias in our data, we are not really trying to understand all the data points. Rather, due to the simplicity of our model, we are just going to fit a straight line where we assume that most of our data points are being touched. But this is a case of underfitting. Alright. Then the next thing that we have is variance. Now this is an error due to models that are too complex and overfit the training data. Now this is the opposite of high bias. So basically, when we have a high variance or low bias, what we do is we try to learn each and every data point in the data set. This leads to overfitting, and this is also a case where the model performs really well on the training data but very poorly on the unseen data. Alright, so a simple example or simple analogy of a high bias would be a person studying for an exam, and the person is not really trying to understand the definition and the examples of each concept, rather he just looks at the headings of each concept. Right, this would be a case of underfitting. But if that same person tries to memorize each and every detail of a particular concept, so he even memorizes the numericals, the exact value of each numerical, the person is going to perform extremely well if the exact same questions appear in the data. But if the values of a particular numerical or a particular question are changed even slightly, the person is going to fail in that particular case. So this is an example of overfitting. Alright? And overfitting happens when there is a low bias or a high variance. And underfitting happens when there is a high bias or low variance. Alright. Now the entire goal of bias variance trade-off is to find the right balance between bias and variance. Now if we have a low bias and a high variance, our model is going to fit the data well, but it is not going to generalize it. Alright. Which basically means overfitting. But if we have a high bias and low variance, our model is going to be too simple and it is going to miss important patterns or even the general patterns, the basic learnings of the data. Alright. So the goal is to find a spot where the model is complex enough to capture patterns but simple enough to avoid the overfitting. Alright. So this is basically what it means. This is the kind of point that we're looking for, which gives us the optimal solution. Moving on to the 19th question, when do we use deep learning in a project? So in order to answer this question, we need to answer what is deep learning. The deep learning is basically a subset of machine learning which uses neural networks with many layers. Alright, so it can handle complex data which includes images, text and audio. Alright, so here is an image that indicates machine learning and deep learning. So in machine learning, we have an input data. Then we perform feature extraction and then we perform classification and then we get an output. But in deep learning, we have an input data and our feature extraction and classification are performed all together with the help of neural networks and we straight away get the output. Alright. Now, when do we use deep learning in a project? So, we use deep learning if we have a very complex and large data set. So when our data is large and unstructured, that is, our data includes images and videos, right? So this basically makes our data complex and it would be better to use deep learning in such cases. Alright, so say for example, we need to analyze the medical images. Alright, so say it is a cancerous cell data set. Alright, and we need to define whether the cell contains cancer or not. So we can use deep learning and basically neural networks in cases like this. Then comes the need for feature extraction. So whenever we need to automatically learn useful features from raw data, say for example, we need to identify objects in a photo. Alright, so we can use deep learning again. Then when our model needs high accuracy. So when a high level of accuracy is crucial for the task, we would go for deep learning. Alright, so say for example, self-driving cars will need precise object detection and in real time, right? So we would go for deep learning. So some projects that use deep learning would be image classification, speech recognition and natural language processing. Some other would be a chatbot, traffic sign classification, newspaper summarizer, image caption generator, human age detection and so on. Moving on to the 20th question, what is OOB error and how is it useful? So OOB error basically stands for out of bag error, which is a concept in random forest models. Now, this is a way to estimate the model's accuracy using the leftover data that isn't used during the training. Alright. Now, we have an original training data of size 5. Now, we are going to do sampling with replacement. So, we have multiple decision trees and we are going to use the sample size of 3 for each particular decision tree. Now, OOB error is basically when random forests build multiple decision trees, they train each tree on a random subset of data called a bootstrap sample. During this training, some data points are going to be left out. Now, these are called the out-of-bag data points or OOB error. Alright. So, once the random forest model is trained, the out-of-bag error or the out-of-bag data is going to be used to test the predictions. By aggregating the errors from all the trees, we calculate the OOB error. This is an estimate of how well the model performs on unseen data. Alright. So, OOB error is useful for internal validation, which basically provides an unbiased accuracy estimate without needing to separate validation data. Then it also saves resources. So it is going to eliminate the need completely to split the data set into training and testing sets. Right? Since we are already leaving out some data to be tested on, we do not need to split our data set separately. Then it also provides performance check. So it is going to help identify if the model is overfitting or underfitting. Right? So some examples of OOB error are suppose a random forest model trains on 70% of the data, which is a bootstrap sample, and the remaining 30%, which is our out-of-bag data, is going to be used to test each tree's prediction. Now, we aggregate these predictions to compute the OOB error in total. Alright. Moving on to the 21st question, define and differentiate between convex and non-convex functions. Now, as you can see in this image, we have two graphs. Let me tell you, this is a convex function and this is a non-convex function. Alright. Now, in order to understand convex and non-convex, let us recall gradient descent. Right. Now, the purpose of gradient descent was to find the minimum of a function. Right. This was used to minimize the error or loss of a model. Correct. Now, if we talk about this particular function, if we start from any point, say initially we have a point over here, or you can say we start from this particular point. We know that our minimum point or a minima lies somewhere over here. Is that correct? As you guys can see, this is going to be, or somewhere over here, this is where the minimum of our function is going to be located. Now, if we start from this particular point and we calculate the gradient, we are going to be led into a direction somewhere over here. Correct? Then when we calculate the gradient over here, we are going to be again led in this particular direction. And this process is going to be continued until and unless we reach this particular point. Now, in a convex function, it does not matter what our starting point is, because no matter from wherever we start, we are somehow or the other going to be led to the minimum point of our function. Right? So, convex functions are said to have one and only one global minima. Right? Now, if we talk about non-convex functions over here, so say my starting point is somewhere over here. Now, if I try and calculate the gradient, I could be directed in this particular direction or this particular direction. Right? Or I could be directed towards this particular direction depending on the exact slope of the function at that particular point. Right? So say if I'm directed in this particular direction, then I calculate the gradient in this particular point again, I'm going to be led somewhere over here. And once I reach this particular point is going to be considered my global minimum. But is that correct? Is this my global minimum? No, it is not. This point is supposed to be my global minimum. But since I do not have any lower point than this at this particular point, this point is going to be considered my global minimum. So basically, convex functions are said to have multiple local minimas. Alright, as you can see over here, this is another minima, this is another minima, this is another minima. So whether or not you reach the global minima depends completely on your starting point. Alright, so say if you start somewhere over here, there is a higher chance you reach the global minima rather than some other local minima. Alright, so these are your local minimas. Alright. So this is a basic differentiation between convex and non-convex functions. So a convex function is where the line segment between any 2 points on the curve lies above or on the curve. There is only one global minima, and it is easier to optimize. Alright. A non-convex function is a function where the line segment between any 2 points on the curve may lie below the curve. Alright. It has multiple local minima and maxima, and it is much harder to optimize. Moving on to the 22nd question, what is collaborative filtering? So collaborative filtering is basically a method that is used to make recommendations based on user behavior. It relies on similarities between the users or the items. So collaborative filtering is again divided into two types. First is user-based and second one is item-based. Alright, so user-based collaborative filtering is basically when items are suggested based on users with similar preferences. Alright, and item-based collaborative filtering is basically when the items are suggested similar to what the user has liked previously. Alright, let's understand this with the help of an example. So there are two users, user 1 and user 2. So both these users have several movies in common. That is, they have both liked these movies or they have highly rated these movies. Now, if user 1 has watched a particular movie that user 2 has not, there is a high chance that this particular movie is recommended to user 2. Alright, so this is basically how user-based collaborative filtering works. Then we have item-based filtering. So basically we have three users who go shopping. So user 1 has shopped for these particular items, whereas user 2 has shopped for these particular items. Now if a third user has shopped for this particular item, this user is going to be recommended items from the similar category. Now if this is not clear, let me give you another example. So say if you buy a book about machine learning. Now what the system is going to do is, the system is going to recommend similar books in the same category to you as well. Maybe you get recommendations of deep learning as well. Right? So this is how item-based filtering works. Based on your previous preferences, based on your previous likings, you will be recommended items in the future. Clear? Moving on to the 23rd question, what is a lazy learning algorithm? Now, lazy learning basically refers to algorithms that postpone generalizing from the training data until they receive a query, that is a new data point. Now, they don't process the data during training, but instead they store it for later use. Alright, so basically they delay generalization data until a query is made. Alright, so in the training phase, lazy learning training is almost instant because the algorithm is going to store the data set without building a complex model. Whereas in the prediction phase, when a new query comes in, the algorithm is going to compare it to the stored data to make a prediction. This step is going to take time because this is going to involve looking through all the stored data. Alright. So one example of lazy learning algorithm is the k nearest neighbors algorithm. Alright. Now what k nearest neighbors does is, so say you have 5 data points about fruits. Alright, let's say these are apples, some are oranges. Alright, they're already classified. Alright. Now say you have a new data point, which is basically a new fruit. Now in order to classify this new fruit, what KNN is going to do is, it is going to compare it to the stored data, right? These are your stored data points, right? All these are your stored data points. Now KNN is going to compare the stored data point and check the k closest neighbors for the new data point. Alright, so say if most of the neighbors of this new data point are apples, KNN is going to classify it as apples, otherwise it is going to classify it as oranges. Clear? So this is how KNN works, and this is basically what lazy learning algorithm works. Alright. Moving on to the 24th question, describe the differences between bagging and boosting algorithms. Alright. So bagging basically works by creating multiple subsets of the training data. So bagging and boosting are basically two powerful techniques in machine learning that are used to improve the performance of models. Alright. So both of these models are basically going to combine multiple models, but their approach and goals are completely different. Okay. So first let's see bagging. Now what bagging does is, it is going to create multiple subsets of the same training data, and it is going to train independently on each subset. Alright. So basically bagging works in parallel, whereas boosting trains the model sequentially, where each new model is going to focus on correcting the errors made by the previous model. Alright. So the final prediction is going to be a weighted combination of all the models. Clear? The basic difference is clear. So let's look at the approach. So bagging basically follows a parallel model training, whereas boosting follows sequential model training. The goal of bagging is to reduce variance, whereas boosting has the main goal of reducing bias and variance. Alright. The basic method of error handling in bagging is to have equal weights for all the models, whereas boosting corrects errors of the previous models. Alright, so bagging has a lower risk of overfitting, whereas boosting has a higher risk of overfitting if not controlled. Alright, so basic example of bagging would be random forest, where we have multiple decision trees working parallelly on each subset of the training data, whereas boosting algorithms would be ADA boost, gradient boosting, and XG boost. Alright. Moving on to the 25th question. Explain the central limit theorem and its importance in data science. CLT or central limit theorem basically states that the sampling distribution of the sample mean approaches a normal distribution as the sample size increases. Alright. So as you can see over here, as we increase the sample size, the distribution of our data approaches a more normal curve. Alright, so this basically enables the use of statistical methods that rely only and only on normal distribution. It's going to help make inferences about the population using sample data, and it is used in hypothesis testing, confidence intervals, and many more such inferences. Alright, so a basic example would be, say you want to measure the average height of students in a school. Now the individual heights might vary a lot and may not follow a normal pattern. Right? But if you repeatedly take random samples of students, calculate the average height for each sample, and then plot these averages, the graph will eventually form a normal distribution as the sample grows. Alright? So the importance of CLT in data science is mainly the foundation for statistical analysis. So stats plays a major role in data science, and CLT is a basic foundation of stats. Right? Many statistical methods assume normality, and CLT is going to ensure that we can apply these methods even when the original data isn't normal. Alright. Then comes sampling and efficiency. Alright. So instead of analyzing the entire population, we can work with smaller and more manageable samples and still get reliable results. Finally, we have hypothesis testing. Alright. So CLT is used to calculate confidence intervals and perform hypothesis tests, which are essential for making data-driven decisions. Alright, so this is the importance of CLT in data science. Moving on to the 26th question. How do you decide which learning algorithm to use for a given problem? Now, choosing the right learning algorithm depends on multiple factors, such as the problem type, okay, the size of the data set, then finally the outcome, that is the outcome you desire. Now here is how you can make a decision step by step. Alright, so you need to start by understanding whether you're solving a regression problem, that is you're predicting continuous values, or is it a classification problem where you have categorical data, or it could be a clustering problem where you have to group similar data. Alright, then comes the dataset size. So if you have a small dataset, you can use algorithms like logistic regression or SVM that go better with the smaller data. But if you have larger datasets, you need to use algorithms like random forest or neural networks that can handle the complexity and the big scale, right? Then comes your computational power. So if you have limited resources, you can use simpler models like linear regression or decision trees, right? You should not go for something complex like random forest. But if you have computational intensive tasks like image recognition, you have to go for neural networks, right? Then if you need high accuracy, that is your outcome. If you need a higher accuracy, especially if you have a complex problem, then you need to choose an algorithm like gradient boosting or deep learning, right? If your data is very noisy, you need ensemble methods like random forest that can reduce the overfitting. And if you have imbalanced data, you need to go for algorithms like SMART, that is synthetic minority oversampling technique, or you can combine it with SPM. Alright, so this is basically how you choose your learning algorithm. Moving on to the 27th question. Now this is a sort of scenario based question which have a very high chance of being asked in an interview. So the question goes, your features have values ranging from 1 to 10,000. how would you prepare the data for machine learning? Alright. Now, in order to prepare the data with features ranging from 1 to 10,000, you'll need to scale it. Alright, so machine learning models work much better when features are on a similar scale, especially when ranges vary widely. Now, a typical example of a dataset containing values from 1 to 10,000, basically a dataset containing outliers would be, say we are analyzing the salaries of various groups of people. Alright. Now, there would be people who would be earning in thousands, somebody would be earning in lakhs, and there would be a very few people who would be earning in crores as well. Alright. So now the people who would be earning in crores would barely be either 4 or 5. Right. These people are basically the outliers in our data set. Now, before we go ahead and train our model, we need to take care of these outliers or these values that range widely, right? So, some of the techniques that can be used in scenarios like this would be normalization or standardization. Right. So again, I have a separate video covering these topics of normalization and standardization, their implementation, the theoretical aspects, when to use which particular concept in complete detail. So you can go ahead and check it out. Alright. So normalization basically use methods like min-max scaling, which helps to bring the values between 0 and 1. Alright. Whereas standardization uses mean of 0 and standard deviation of 1. Alright. So this basically helps models perform more efficiently. Right. So again, you need to choose your right scaling technique. So if your data has outliers, normalization is going to work better. But if your data does not have outliers, you need to perform standardization. Alright. Let's quickly look at one small implementation. So I have a cricket data set, and when I plot the various aspects of my data set, like my innings, my not outs, my runs, and the high score and so on, I can see a lot of outliers in my data set, right? Now, to tackle this situation, what I'm going to do is I'm going to perform standard scaler. Alright. So I've imported standard scaler from sklearn.preprocessing. I've called my function, and then I've simply fit and transformed it on my data, right? So once my data set is scaled, that is the values are arranged between the mean of 0 and standard deviation of 1. This is what my data set is going to look like. And after my data set is scaled, I can go ahead and train my model for a better accuracy. Alright. Moving on to the 28th question, which is also a scenario based question. So the question goes, your data set has missing values. Now, what are the steps that you're going to take to handle them? Now, in order to deal with the missing values in a data set, you first need to understand the nature of your missing values, right? They could either be missing completely at random, or they could be missing at random, or they could be missing not at random. Now, what do these terms mean? So, missing completely at random basically means that there is no identifiable pattern. Alright. Missing at random means that the missing values are somehow correlated with other variables. Alright. And missing not at random means that they're related to the missing value itself. Alright. So, say for example, customers are not reporting low satisfaction scores. Alright. So, if a column consistently has missing values, that is, if a column has more than 50% of missing values, then the best option would be dropping the entire column itself. Alright. But if that is not the case, that is, our missing values do not exceed 50%, the other possible techniques would be ignoring the missing values. That is, we drop the particular rows or the particular columns. Now, when do we drop the rows or drop the column? Whenever we have minimal missing data, that is, our missing data is less than 30%. Alright. So, if a small percentage of rows or columns have missing data, we can consider dropping them without losing the significant information. Alright. So, in order to perform this step, all we have to do is, let's say our data is stored in df variable, all we have to do is call drop na function. So, this function is basically going to drop all the rows that contain the missing values. Now, the next technique is imputing missing values. That is, we can replace the missing values with mean, median or mode. Alright. So whenever we have a data set that contains outliers, that is, say if we are dealing with a feature like salary, where our salary could range from 0 to even crores or even billions, millions, alright? There is no end limit to this number, right? We could be considering the richest person in India, right? We could be considering his or her salary as well. So for features like this, we would have outliers, right? And if we were to take the mean or the average of this particular feature, our average would not be justified to the lowest and the highest value in this particular feature. So in cases like this, we would impute our missing values with something known as median. This would give us a more accurate representation or the more accurate imputation of our missing values. But if this is not the case, we are dealing with a regular feature, then we can go ahead and impute our missing values with our mean itself. Alright. And if we're dealing with categorical data, say we're dealing with a feature called fruits, right? We have apple, we have orange, and then we have some missing values. This is when we will use something known as mode. That is the most repeated value in that particular feature. Alright. So if we have minimal data missing, less than 30%, we just drop the rows or columns. If we have substantial data missing, then we impute the data. If we have categorical data, we use the mode or unknown for imputation. If we have predictive missingness, we create an indicator variable for missingness. And if we have mostly the entire column missing, that is more than 50%, we drop the entire column if it is non-critical. Alright. Moving on with the 29th question. An e-commerce website runs 2 designs for its homepage. How would you determine which one performs better? Now, this is a classic scenario of A/B testing. Alright. A/B testing is basically a method that compares 2 versions, A and B, it could be of a website or any other scenario, to determine which one performs better. Alright. Now, how does it work? So, A/B testing is basically going to split the website visitors randomly into 2 groups. So, group A is going to see design 1 and group B is only going to see design 2. Alright. So, after the groups have seen the 2 designs, we are then going to measure the performance of both designs using a key metric like conversion rate. That is the percentage of users making a purchase. Alright. So, we are going to separately calculate the conversion rate for group 1 and group 2. So, whichever conversion rate is higher, we are then going to classify as that particular website page as more efficient than the other. Alright. So, you need to define the goal. You need to identify the key performance metrics such as the click-through rate, purchases, and so on. Right. It could be n number of factors depending on what kind of website you are building. Then you need to split the traffic. So, you need to randomly divide the users into equal groups. Right. Then you run the experiment, that is, you show each group their respective design for a set duration. Alright. Then lastly, you analyze the results, that is, you compare the metrics, that is the conversion rates, the click-through rate, or whatever other performance metric you have decided to determine the better design. Alright. So this is how you determine which one of the 2 versions you have made performs better. Alright. Moving on to the last question for this particular video. Your dataset has 50 columns, but not all are useful. How would you choose the important ones? Alright. So this is a classic example of feature selection. So feature selection basically involves removing the irrelevant or redundant data, which is the main objective of our question over here. Right? Out of the 50 columns, we need to keep only the relevant ones and remove the rest. Feature selection basically helps improve the model accuracy and performance, and it also reduces the computation time, right? So say for example, out of 50 columns, only 10 are useful. This is going to reduce the data size significantly, right? So the basic methods for feature selection are correlation analysis, right? You need to identify the highly correlated columns and remove the redundant ones, right? So basically, if 2 columns are highly correlated, one of them may be redundant or basically useless. So say for example, if age and years of experience are strongly correlated, you can keep either one of these, right? You can also use correlation heat maps in Python using the Seaborn library and the heat map function. Then comes feature importance using models. So you can use models like random forest or gradient boosting rank features by importance, right? So say for example, in predicting the house prices, your location feature might rank higher than paint color. Alright, so there's a high probability that removing the paint color is just going to make your model better, right? Then comes statistical methods. So you can apply methods like ANOVA or chi-square to assess the feature significance. Then finally comes dimensionality reduction. So you can use techniques like PCA, principal component analysis, which, as we discussed, use eigenvalues and eigenvectors to reduce the features while retaining the key information. Alright.
Guys, I have a special announcement for all of you. For all of you dedicated individuals who are looking forward to master data science, we are offering a straightforward 20% discount on our data science course, which is in collaboration with iHub IIT Roorkee. So do make sure to check the link given in the description and fill the inquiry form. Shortly, our team of course advisors will get in touch with you to activate the offer. Don't miss this chance and take your career to the next level. Click on the link given in the description right now.